In the previous course, HTML, CSS, and JavaScript for web developers, we learned how to effectively use CSS to produce responsive websites that automatically adjust to any screen size, allowing the user to interact with the website on any device, from a desktop to a mobile phone. We also delved into JavaScript and Ajax, the technologies that bring our pages to life with functionality and external data. However, as I mentioned in the introduction to one of the modules of the previous course, we went beyond the simple basics and really dug deep to understand this most popular and perhaps the most misunderstood programming language in the world, JavaScript. But we didn't stop there and used all of our newly acquired skills to build a real website for a real client as part of the course curriculum. The course was wildly successful and became the #1 top-rated course on Coursera and stayed in the #1 spot for 3 consecutive weeks. In this course, we're going to build on top of those basic skills and take the student to the next level of web development mastery. AngularJS is the most popular framework for building single-page applications. It's open source and is backed by Google. Generally, this framework is not an easy undertaking. It's known to have a steep learning curve. However, in this course, I believe that students will discover a much easier experience learning this framework. This is because we go step by step, explaining not only how to do something, but the why behind it. We also explain concepts that don't only pertain to AngularJS, but discuss how these concepts apply to the general practice of software development. This approach will not only give the students the skills to quickly develop outstanding web apps, but will also enrich them with the knowledge of standard development practices and approaches. I have mentioned this before, but it's worth repeating, that what makes these courses special is that they're being taught by people who aren't simply skilled in teaching, but that actually work with these technologies in their day-to-day jobs. So what the students are getting is a real-world perspective of how to approach commonplace software development problems, especially in the area of web development. As I mentioned, one of the most fun parts of the previous course was our visit to a real client and then developing a real website for that client. In this course, we will not disappoint. We're going to take the website we built in the previous course and rebuild it from scratch using AngularJS, plus expand it with some more features. By building a real website in AngularJS that real users will actually use, the students will be able to see a real-world practical application of what we learned in this course. Anyone with the basic knowledge of HTML, CSS, and the JavaScript programming language can take this course and take their skills to a whole new level. Plus, as usual, we'll have some fun along the way. So all that's left is to enroll. In this module, we're going to start by going over how grading works for this course. We'll introduce some recommended books, as well as give you the information on how to find all the source code that you will see throughout the course. We will then dive into the development environment setup for both Mac and Windows. The core of this module will be the introduction not only to the basics of AngularJS, but more importantly, the concepts that back AngularJS as a good solution for developing front-end web applications. To become a good software developer, and not just with AngularJS, you will need to understand these concepts. But for becoming a good AngularJS developer, these concepts are essential because they will allow you to understand the issues the framework is addressing and therefore get a good grasp on the solutions AngularJS is offering. See you on the module. So in this set of lectures, we're going to speak about how to set up your development environment for the rest of the course. The first thing that you'll need to do is sign up for a github.com account. It's very straightforward. Give your username, password, and email address, and you're done. You're also going to need some sort of browser for the rest of the course. Now, I'm going to use Google Chrome, and I think that's a preferred browser. That's just my personal preference because it has the Chrome developer tools that are very advanced in terms of web development help. But that's not required. You could use any browser you want that you prefer. Also, you need some sort of code editor that you're going to use. In this course, I'm going to use the Atom code editor. It's free, it's very good, it has plenty plugins that you could put in to help you code, and it's actually also made by GitHub. However, you don't have to use that one. You could use Visual Studio Code, that's also free, brackets.io, that's free. Sublime Text 3 is also free, but kind of asks you to eventually pay for it. So basically, choose the editor that you like, and you're going to be productive in. The other tool that we're going to need is Git. We're going to need Git for a couple of reasons. Number one is if you're trying to become a little bit more of a professional web developer, you can't get away without knowing at least a little bit of Git. And in this course, we're going to do the bare minimum of Git commands. So we're not definitely going to get into the Git commands very deeply. However, the bare minimum of those commands is something you should know, at least get familiar with, and get your feet wet with that. We're also going to use a tool called Browser Sync, and I'll show you what that tool actually does, but it's going to help us develop locally in our machine, at the same time see all of our updates as we code them in the editor, live in the browser, automatically without having to click the refresh button. The Browser Sync tool actually is a Node.js component or Node.js package, and we will need to install Node.js in order for it to work. Now, next few videos, I'm going to split them up between the macOS and Windows. I'm going to explain everything on macOS, and then I will explain everything in Windows. So choose your operating system depending on what you're using. Throughout the rest of the course, I'm actually going to be using my own computer, which is a Mac, but just because the windows and the buttons are going to look slightly different if you're using Windows, don't be scared of that. There's really nothing else other than the slight look changes that's going to be different for the rest of the course once you type the 2-3 different commands that exist on Windows versus on the macOS. Other than that, they're really identical. There's really no difference between doing web development on Windows or on a Mac. Okay, so here I'm in my Mac, and nothing really is installed on this Mac yet except maybe a Google Chrome, which is, I'm assuming you're going to be able to install all by yourself, so I'm not going to go over that. I'm actually using right now the El Capitan 10.11.6, but your versions may vary, and it's probably not going to matter that much. So the first thing we're going to do is install our Atom editor. We'll open the Chrome browser, and we'll go ahead and go to atom.io. And it will give us the download button, really very straightforward. We'll download the zip file. And once that's done, let's go ahead and open it up in Finder. We'll double click it. It'll go ahead and extract the file for us. And all we'll need to do is drop this file into our applications folder like that. And we're done. We can actually even erase this one. We don't need it anymore. Okay, so let's verify that Atom is working. So we'll click on the Launchpad, and we can see Atom is here. When we click it, it'll start up, and hopefully it will show up without any issues. It will ask us whether we want to open it for sure, because it's from the web, downloaded from the web, and it's in fact starting up just fine. And we could close this welcome screen, and as you can see, we have our first file right here. Now, in order to pin it, I will just go ahead and drag it over here so I don't have to constantly open it up through searching for it. So I could quit this now. We're done with that. The next thing we want to do is make sure that we have Git in our system. So we'll go back to the Launchpad and we'll start typing terminal, and we'll open up our terminal. Now your terminal will probably look different. I customized this one so you could see it a little bit better. In fact, maybe we'll make it a little bit bigger as well so you could see it even better. We'll make the font bigger. If I type git space -- version and press enter, you'll see that it says that git command requires the command line developer tools. Would we like to install the tools now? So you could have a couple of options. One, you could get the entire Xcode from the App Store, or you could just get the command line developer tools only, which is what I'm going to choose. I'm going to click install. I'm going to agree to that, and the software is going to get found, download it, and installed. And once it's done, we could click the Done button. And now we say git space dash dash version. It's going to give us the version 2.7.4, which is pretty good. If you wanted to get the absolute latest one, you could certainly go and search for download git, and that will take you to this website right here, which you could go to download, and you could download the very latest version. But whatever version that came with this version of macOS is good enough. The next thing we need to do is download and install Node.js. Let's go and say download Node.js, and we'll go straight to the download page of Node.js. We could close this Atom tab, and we could scroll down and see that we have a couple of options here. We have the Mac package and the binaries. I'll choose the 64-bit package one and click to download. Once that's done, I'll tell Chrome here that it's okay, I could keep this file, I trust it. And I'll go ahead and open it in my Finder and double click it to install it. It's going to give me this wizard. Well, I'll just keep clicking continue step by step. We'll agree to the terms and condition. We'll finally click install. It needs our administrative username and password. I'm a regular user, not an administrator, so I'll type in my password, and it's installing the software. So it's done, and it's just telling us to make sure that user local bin is in our $sign path. And it's almost always is, but we're going to check it in a second. We'll just go to our terminal, and we'll do echo of $sign path. And you can see that user local bin is in fact there, so we're good to go. Let's switch back to that window, click close, and we're done. So the only thing now we need to do is make sure that Node installed. The way we do that is from the command line. Let's make that full screen so you could see it better. And from the command line, what's cleared, and say node -- version. And sure enough, we have Node 4.5.0. And the other command that we'll need that actually use more than Node is npm, stands for Node Package Manager, and we'll say -- version there too. And we'll see that we have that as well, 2.15.9. That's pretty good. Now, the reason we installed Node.js in this npm is because we want to be able to install these packages that are in the Node package repository. So one of them that we need is called browser sync. Let's go to the browser again, and we'll type in browser sync, and it will Google it for us, and that's the first thing that comes up. We'll click on that, and it's actually telling you how to install browser sync right here. You use the npm install -g browser-sync. And -g here is just to install it for all users of the computer, not just you. Let's copy that, and let's go back to our terminal. We'll paste that, and we'll install it. And it's erroring out, and the reason it's erroring out with permission denied is because it's trying to install it for all the users, and I'm not an administrator. So what we could do to fix that is just say sudo to act as administrator and paste that npm command and press enter again, and let's see if that works out. And since we've typed in the password of our own account, that will go ahead and give us the sudo privileges that are pre-set up with the macOS for your user. And that should go ahead and download and install browser sync. So it looks like we're done and everything went well, even though, as you could see, there were some warnings, I'm sure. There's one warning right there, but usually when you install npm, there's usually some sort of warnings and errors that show up, but if it finishes properly, then you're okay. So let's clear the screen and do browser-sync -- version. And you can see we do have browser sync installed. It's 2.14.0, at least at the time of this recording, and that's fine. Okay, so I'm back in my macOS where we left off. And the next thing you need to do is set up our GitHub account. So let's go to the browser. We'll actually make it full screen here, and we'll say github.com. And github.com will ask you to sign up for an account. It's very simple. Just give it the username, pick the username you want, give it the email address, and a password. And then you sign up. I'm already signed up, so I'll go ahead and click sign in. I'll use my username and password and click sign in. And I'm in. I don't want it to remember my password. Your view will probably look very different than mine. You probably have different repositories. If you've never done this, you probably have no repositories here. So the first thing you want to do is create your own repository, and I suggest you use one repository for the entire course. So you go to this top right here, you see this plus sign next to your icon here, and you click this down arrow and click New Repository. And I'm just going to name it Coursera-test, but you could name it whatever you want, Coursera or your course, whatever you want. And we'll give it a description, test Coursera repo. And we're going to keep it as public because private costs money, so we're going to go ahead and keep it for free. And we'll click here, initialize this repository with a README file, always a good idea. And all I have to do is click Create Repository, and the repository is created. Now, since you're going to be using this repository for your assignments in this course, the next thing you want to do is make your repository deployable, or make your repository such that it can be viewed as a regular website on the web. Luckily, GitHub provides this functionality for free, and it's actually very convenient. If you go to the settings, which is right here on the right, you could scroll down and you'll see that there's something called GitHub Pages. Well, it says here GitHub Pages is designed to host your personal organization or project pages from a GitHub repository. Now, it used to be you had to designate a special branch in your repository, and if you look up here and if you look back to the original, you could see that we are on the branch master. So let's go back to the settings. So it used to be you had to create a special branch for that, but GitHub simplified that. So all you have to do is, right now it says it's currently disabled. We'll click this down arrow and we'll say that what we want to be displayed on our GitHub pages is exactly what is sitting inside of the master branch. That is what I recommend you do for this course. We'll click that, we'll click save. When we click save, it will tell us that GitHub pages source saved. So if we scroll down again, you'll see that your site is ready to be published and it's giving us a URL. You can see it's a URL very close to what we have. It's my username.github.io / the name of our repository, which is Coursera-test. I'm going to go ahead and open it in a new tab. And you can see there's nothing here yet because there's nothing in my repository. We're going to change that in a minute. We'll close that. We'll go back up to our repository, and you'll see here it says clone or download button, the green button. If we click that, you can go ahead and copy the link, which is the link to your repository that you can actually use on a command line to clone it, or to copy it, or to download it from GitHub to your local machine. So we'll click this copy to clipboard, and we'll go back to our terminal. And now we could use GitHub commands to pull this repository down to our, or pull, otherwise known as download really, our repository to our local machine. So let's go ahead and say git clone. That's the command to pull it or to clone it or to copy it. And we'll go ahead and paste whatever we copied from the website. If we press enter, the whole thing gets downloaded. And now if we do NLS, you could see that Coursera test is one of the things that showed up. Now, if we go ahead and CD into Coursera test, what we would like to do is we would like to create a whole project that is based right here at pwd. You'll see I'm sitting inside of the Coursera test folder. So I'd like to start the entire project in my Atom editor straight from this particular folder, but I don't want to have to navigate back to it again. I'm already here. So one way of doing it is to call Atom with a dot, meaning this particular directory. I want you to go ahead and start Atom and place the project as being in this folder. So if I press now, it's not going to work. And the reason that's not going to work is because we haven't set up Atom to do that. Let's go ahead and click the Atom icon. And once it opens, we can go to the Atom menu and click Install Shell Commands. We're going to have to give it our password. And it says they have been installed, and you could call it Atom or APM. Both commands are installed. We're only going to need Atom for this course. So we'll click OK. We'll go back. We'll go ahead and actually quit that whole thing altogether. We'll go back and we'll say again Atom dot and press enter. And this time it's going to open our entire directory as the base of our project. So now we create new files straight inside the Coursera-test. Let's create a simple file called index.html. And we'll say that this is HTML. And we'll say this is hello Coursera. And we'll give it just a simple h1 tag that says hello Coursera. And we'll save it. Now, as we develop, we would like to see an immediate feedback as to what we're developing right in the browser. So one way of doing it is to use browser sync. So let's go ahead and open a tab here, and we'll make the browser smaller so we could see it side by side together with our editor. And we'll go back to the command line, and since we're sitting right now inside the Coursera test, we can issue a browser sync command that goes like this: browser-sync, and then we want to start the browser sync, and we want to start it in -- server mode, which means I want you to serve up everything that's in this directory. And we'll also start it with -- directory mode. And what that's going to do is it's going to serve up the directory. Even if there's nothing in it, it will at least show us the directory. And last but not least, we'll say which files do we want to watch for changes. And once those files changes, I want you to go ahead and reload it. And what we want to watch is we want to watch any directory, that's **/*, meaning any directory and anything in that directory. We'll close that quote, we'll press enter, and voila, it started up our browser sync. And if you look at our browser and our Atom editor side by side, you can see that here's our index.html. If we click on it, you'll see hello Coursera. And what's really cool about it is because I can actually now say hello Coursera students, and the second I save it, you can see that browser sync will automatically update whatever it is that is in your files and will reload the page for you automatically. So as you type, you can quickly see what's going on right in your browser, and it is very convenient. Okay, so the only thing that's left now that I've edited my file is to go back to the command line and go ahead and we'll quit the browser sync. We'll do an ls just to see what's in it. So we see our index.html. And then we'll do a command called git status to see what our git status is. And it's telling you that we have one untracked file here, which is index.html. And git is usually very good in telling you what you might want to do next. And what it says here, you could say git add and the file name to include in what will be committed. In other words, git add is a command to mark whatever it is that you're going to specify, in this case index.html, to mark it for committing it to the repository. So we'll say that to say anything in this directory, and when we press enter and do git status again, you'll see that now we have changes to be committed, and you can see the file is green and it says it's a new file. So if I'm committing this, this file is the one that's going to get committed to the repository. Now the way to commit it is to say git space commit -m for message, that's required, and the message I could commit with first web file, and press enter. And now it's giving you a whole long message here telling you that I never really told Git that I have installed here who I am exactly. Didn't tell it my name, I didn't tell it my email address, and that's really okay because at least in this version of Git, it's automatically configuring it for you, saying I'm just going to grab whatever it is you registered your account with and grab this really kind of meaningless email, yakov@yakovsmac.local. It doesn't really matter. This email is not really used for anything other than announcing to other users of your repository who you are and how to get in touch with you. So we're going to just leave it alone, and we could go ahead and do git status again. Let's clear the page. Terminal, git status. And we could see that we're on branch master, and your branch, meaning the one local to your computer, is ahead of the origin master by one commit, meaning we've committed something, but the master itself, the one that's sitting, or the origin master, the one that's sitting in GitHub, is actually kind of behind. So we are ahead of it by one commit. That means that at this point, I have code on my computer that is in my repository, but it is not in the github.com repository. In order to upload this code to github.com repository, it's actually giving you a hint here. Use git push, and that does upload. Git push. And this is the first time I'm using Git on this particular instance of this machine, and I never told it which type of pushing, which type of upload I want to apply using Git. Well, the one that's recommended is right here, the one's called simple. We'll go ahead and copy that, and we'll quit that for now so it doesn't bug us again about it. We'll issue that command and have the git dot or push.default be simple. Enter that, and we'll go ahead and clear it, and we'll do one more time git push. In this case, it's going to start asking me for my username. And I go ahead and enter my username and my password. Note, as I type in the password, nothing is actually showing up, and that's okay. It's the expected behavior. I'm going to press enter. It will go ahead and push the code changes that I made locally to the repository at GitHub, and it's telling you right here that it did that. And if you do the git status right now, it will say we're on branch master and everything is up to date and nothing to commit and working directory is clean. Now we can actually view this index.html back in GitHub. Let's go ahead and go to our browser again. Let's make this full screen again. And let's close these up. And we'll go to our repository. Let's do a reload. And you can see now we have an index.html inside of our repository, and that is what we committed and pushed to this repository just a minute ago. Now, suppose I forgot what my link is supposed to be because it's not github.com, it's actually GitHub Pages, which is github.io. Well, the way I could get back to that link is pretty easily. I could just click on the settings again, scroll down to where my GitHub pages are, right here, the configuration for GitHub Pages, and here's my link. I could click on that link right now. Let's open it in a new tab. When I open it, since I have index.html sitting in that directory, it will automatically go ahead and serve the index.html to me, and you can see hello Coursera students is what shows up. That's the file that we edited. Now for your assignments, what you're going to want to do is create subfolders in your repository like module 1 assignment or something like that. You go ahead and follow the particular instructions and put your applications in the subfolders that are specified in the assignment description. And then we could repeat this process as we keep developing. So if we go back to our Atom editor, we can update this file by saying, I am thrilled about this course, and save that. And now if we go to our terminal, and we are already here, we're in pwd, we're inside the Coursera test folder, we could say git status again. You'll see that it's showing us index.html as modified. And it's telling us again that we could use git add in order to mark it for committing. So we'll say git add, and instead of giving the index.html, we could just say dot, which means I want to commit anything in this folder and below. We'll press enter, and if I say git status, you can see now that it is marked as modified and marked green, so it's ready to be committed. So I'll say git commit -m, and I'll say new version of web file, and we'll go ahead and press enter. And now it's again telling me that it's committed, but it's complaining that I never identified myself officially. So I could go ahead and do that right now by copying these two commands that it's conveniently giving us. The first one is username, and that's just my name. I could say Yakov, I could say full name, press enter. And the second command it's telling us is user.email. Go ahead and copy and paste that, and the email could be anything. It's really there for other users of GitHub repository again to be able to see what your email address is. So I could say yakov@whatever.com, and let's make this a little bit bigger so you could see what I'm doing here, and press enter. And now I'm no longer going to be bugged about this whole lack of me setting the committer's username and email address. Okay, so now let's clear the screen and let's say git status again. And you can see once again my local branch, my local repository is ahead by one commit from the repository on github.com. So the way to do that, the way to upload all my changes to github.com is to say git push. Git push, that uploads everything to the remote repository. And now if I go back to even straight to my GitHub pages and just reload, right here, you could see that it says, I am thrilled about this course, exclamation point, which means kind of, things took. So I don't need to no longer do anything to upload to any other server. GitHub will automatically be my web server. And this is what you can use for the rest of the assignments in this course. Okay, so now I'm in Windows and we're going to go ahead and install the required tools for this course. So the first thing is we're going to need a browser, and if you want to just stick with Internet Explorer, you can, but I would highly suggest you get another browser, and for this course I highly recommend you get Google Chrome. Now, I'm not going to go over how to install Google Chrome. I am going to assume that you know how to install it. I already have it pre-installed here on my machine. So the first thing we need to do is install the Atom editor, or whatever editor you want, but I'll show you how to install Atom. And the way you install it is to download it from atom.io. Make this screen a little bigger, and we'll go ahead and click download. And once it's downloaded, I can go ahead and show it in folder and double click it. And it's showing us that Atom is being installed. And once it gets installed, it shows us the welcome screen. We'll go ahead and close that. We don't need that right now. So that's working. Okay, so for now, we could go ahead and close it. We'll close exit. And the next thing we need to do is install Git. So let's go to the browser and type in download Git. And we could go to this very first website that shows up. And we'll click the latest download for Windows, which it will go ahead and download for us. And we can actually just click it directly to start installing. And say, yes, we want to continue. And we'll press next, again, next. And we'll go ahead and click add an additional icon on the desktop. We'll click next again. This will create an item in the start menu. We're okay with that. We'll press next. And the safest option here is already chosen for us, which is to use Git from the Windows command prompt. Let's go ahead and click next. And we'll keep the default that it's giving us. And we'll keep that default as well. We'll keep the default for that too, and we'll click install. Once it's done, we don't want to see the view release notes. We don't want that. We could just click finish. And then we could go to the bar here and start searching for CMD, which stands for command prompt. And we'll open that up. We can even make it full screen. And now we want to make sure that Git got installed properly. So we could say git space -- version, and we'll press enter. And you can see that we have Git installed 2.9.3, which is fine. The next thing we need to install is Browser Sync, but before we do that, we need to install Node.js in order to install Browser Sync. So let's go back to our browser, and we'll type in download Node.js, and it will take us straight to the download page. We'll click that. And we have a couple of options here. We can have the installer or the binary. We want the installer one, and since I'm running the 64-bit version of Windows, I want the installer 64-bit. So I'll click that. It'll get downloaded, and I can just click it right here to install. And the install screen finally pops up, and we could click next, that we accept the conditions, next, next, and again, next. And finally just click install. And we want to go ahead and allow it to install it. And once it's done, we could click finish. And now we need to verify that Node.js actually was installed. So we could go back to our terminal or our command line, command prompt. And actually what we'll do is we'll go ahead and quit that first, and we'll start it up again. Always a good idea to do that between installs. So here's our command prompt. We'll start it up again, and this time, let's make it full screen. This time we'll say node space -- version. And sure enough, we have Node version 4.5.0. But what we're really after is the Node package manager. That's the thing that is going to allow us to install other packages like Browser Sync. So the way we check that that installed correctly is npm node package manager space -- version, enter, and you see that it is in fact installed properly. It's giving us the version number for it. So the next thing we need to do is go back to our browser and look for Browser Sync. So we could say Browser Sync and just Google it. And the first thing that will come up is the Browser Sync website. And as you can see, it's a very simple command that it's telling us that we need to install it with. It's just npm, which is Node Package Manager, install -g browser -sync. And -g is just there to say that I want to install it for all users on the computer. Okay, let's copy that. Let's go back to our command prompt. And let's go ahead and paste that command right here. We'll press enter, and the Node Package Manager should download things for us and install it for us automatically. Once it's done, it usually does come with some sort of warnings. And if you take a look here, there were a couple of warnings here. But as long as it finishes properly, you're okay. We'll clear the screen with the command cls. We'll try the Browser Sync command. We'll say browser -sync space -- version. We'll press enter. You can see that it's telling us the version number, which means it installed properly. So at this point, we've verified that we installed Atom, we verified that we installed Node.js, and therefore we also were able to install Browser Sync. Okay, so I'm back in my command prompt where we left off previously, and the next thing we need to do is we need to create an account on github.com. We'll go back to our browser and we'll type in github.com. And here, all you have to do is pick a username that's available, give it your email address and a password, and you're done. Since I already have an account, I'll just click sign in and provide my username and password. We'll click sign in. We don't want it to remember my password. Once you sign in, you'll see this front page of github.com, and your view will probably look different than mine, especially if you just signed up, it will probably look pretty empty. But I have a bunch of repositories, so that's what you see. The next thing we want to do is we want to create our own repository that we'll use for the rest of the course for all the assignments that you will do. So what we'll do is we'll go up here to the top right, and we'll click this down arrow next to the plus and click New Repository. And we'll call this repository Coursera-test. Obviously, you could call your repository whatever you want. And here we'll say test repo for Coursera. And we'll leave it as public because private will cost us money. And we'll check initialize this repository with a README file, which is always a good idea. And at this point, you can just click create repository, and repository gets created. Now, before we move away from this and go to our command line again, what we want to do is we want to make this repository accessible to the web like a regular website. And fortunately, GitHub allows us to do that with something called GitHub Pages. However, we need to first enable it. Notice that we're right now on this something called branch master. You don't really need to know too much about Git to know branch master, but just remember that that's where we are. In order to enable this repository to be like a website, we have to go to the settings, which is here top right, and scroll down and you'll see a section called GitHub Pages. And basically it's telling you here that GitHub Pages is designed to host your personal organization or project pages from a GitHub repository directly. However, right now it is disabled and we haven't picked a source for where it should look for the files to serve up as a server of your website. So we're going to click this down arrow and we're actually going to select master branch. Now, GitHub used to only allow this on a special branch that you would have to create manually called gh-pages, but now it allows even the actual main branch, the main repository, kind of part of your main repository, which is the master branch, to be the source of your GitHub pages. So as long as we choose that and click save, now we're done. If we scroll down, you'll see now that it says that your site is ready to be published at, and it gives us a link. So if we right click on that and open it in a new tab, you'll see that what it's going to give us is my username.github.io/Coursera test, which is the name of my repository. However, I'm still getting a 404, meaning page not found, and that's because I haven't really put anything into my repository yet. Well, we'll change that in a minute. The next thing we want to do is go back to our repository. We'll click on the name of it, and we'll go to this green clone or download button here. And you see here, one of the things you could do, you could download the whole thing as a zip file, but what we want to do is we want to clone it or copy it or download it directly to our machine using Git commands. So we'll click this button here that will copy this URL into our clipboard. We'll go back to the command line, and perhaps we can even make a directory here. We'll say Coursera projects. And now if we do a dir to see, you could see that Coursera projects is one of the directories that we just created. And we could do a cd, change directory into Coursera projects. We'll go ahead and clear the screen, cls. And now what we could do is we could say git clone, which is another name for go ahead and download the site or clone it, make a clone copy of it, and we'll paste the URL that we copied from the GitHub repository. We'll hit enter, and the cloned repository is now here. So if we go ahead and do a dir just to see what's going on, you could see that it created a folder for us called Coursera-test, which was the same thing as what we pointed it to minus this .git. So if we now cd into Coursera-test, it's very important to do that, to actually get inside of our repository. We'll do a cls to clear the screen. We'll go ahead and do a dir, and you can see there's really nothing in here yet. So what we want to do now is we want to start our Atom editor directly from this command line prompt such that it considers this Coursera test directory as kind of the project holding folder. The way we could do that is by issuing the atom command, atom with a dot, meaning I want you to start the entire project from this directory. Dot meaning the directory that I'm in right now, which is Coursera-projects, Coursera-test. If I enter, it's going to go ahead and open up atom. And now I could see that I'm inside the Coursera test as my project folder. Now I'm ready to create my first HTML page. I'll right click on that folder, say new file, and we'll say index.html. And it will open up a new file for me. And I'll say HTML. And here I'll just give it a title of hello Coursera. Inside the body, we'll just give it one h1 tag. And we'll say hello Coursera. And save that. Now, before we move on, it would be really useful if we can see the outcome of whatever we're typing directly on the web browser to see what effects everything we type has. Well, we could do that with browser sync. Let's go ahead and move this over a little bit and go back to our command prompt and start the browser sync command. And the browser sync command is browser-sync. In this case, we want to start it. And we also want to start in dash dash after a space, dash dash server mode, which means I want you to serve up all the files in a particular directory. And I also want to start it in the dash dash directory mode, which means that if there's nothing in that directory and it can't find index.html, it will still display a web page with basically a directory structure that it sees. The last but not least, with a space, we'll say dash dash files. We want to tell browser sync which files to watch for changes, that if any of those files change, we want browser sync to reload whatever is in our browser so we see the latest. So we'll say dash dash files space quotes, and in this case we'll say star star slash star and end the quote. And what we're saying is we want any directory, that's the star star, and whatever directory you find, we want any file inside of the directory, that is the single star. So once we're done with that, we'll press enter. Browser sync will start. It will tell us a whole bunch of warnings, but we'll allow it to access. And now we could see that our index.html right here is showing up together with README. Let's click on that. You could see that Coursera, hello Coursera is showing up. Let's make this browser a little bit smaller, not full screen, so we could see it side by side with our code editor, which is really convenient. Let's switch to our code editor and make this side by side. And now if I start typing hello Coursera students, exclamation point, and save that file, you could see that browser sync immediately refreshes the page and hello Coursera students shows up. That is really convenient for being able to develop things and immediately see the feedback from your browser sitting in a window next to your editor. Okay, so we're done with that for now. Let's go back to our command prompt and exit browser sync with Control-C. We'll say yes, we want to finish it. And the next thing we want to do is we want to do git status. Actually, let's clear the screen, CLS, and do git space status just to see what our repository status is. And you can see that we're in branch master, and my branch is up to date, and we have untracked files. And it's actually even telling you a hint as to what you might want to do next. What you might want to do next is do git add to include in what will be committed in the future. In other words, if you do git add and specify a file, it will mark that file to be committed when you commit to your repository next, meaning when you save things in your repository. In this case, I could just say dot, which means anything in this directory and below, and I'll press enter, and I'll do a status, git status again, and you can see that now that file shows up as new file and it's green, and it's telling you that changes to be committed are right here, and this is green file. So the next thing we want to do is actually save this file into our repository, or otherwise known as commit it. So we'll do git space commit -m for flag to specify a message with our commit, and that's required. And we'll say first web file and close the quote. We'll press enter. And you can see the first thing it's telling us is that we need to tell it who we are. We never even told it who we are. It needs to somehow identify the user I am, that I am committing this particular change. And it's actually very nice because it's telling us exactly the commands to run. So we'll go ahead and copy this first command, and it's called git config -- global user email with a space, and you could put whatever you want here. You could say Yakov at Coursera something.com, Really could give a fake email here if you want. It's really there not for any configuration, but really to identify you to other developers that are using this repository. And we'll press enter on that. And one more thing it's telling us to do is it wants us to give it our username. So we'll go ahead and copy that. And our username will be just Yakov at this point, doesn't matter. And we'll press enter. And now let's clear the screen. Now let's say git commit -m with the message first web file. Close the quote and press enter. And now it's committed. And if we now do a git status, you can see that what it's telling is that your branch, where I'm branch master, is ahead of origin master by 1 commit. Origin master is referring to the GitHub repository. We have 2 repositories at this point. One is sitting in github.com and the other one is sitting on our local machine. So what it's telling us is that our local one is ahead of the one in github.com by 1 commit, which makes sense because we committed 1 commit just now. However, all that did was record our commit or record our saving of a particular slice in time in our local repository. GitHub again is nice enough to tell us to use git push to publish our commits to the remote repository. We'll go ahead and do that. We'll say git push, and that will upload our commits and everything from our repository that is ready to go, and that's everything that's marked committed to the remote repository, which is on GitHub. We'll press enter. It will pop up the screen to ask us for our username and password. So we'll go ahead and give it the username and my password. You'll obviously have your own. We'll click login. And you can see it's counting the objects, compressing the objects, and finally it says we're done. We committed to this remote repository right here. The next thing we want to do is go back to our browser and see if we could see these commits in our repository. Let's go ahead and close this tab and let's go to our repository. When we refresh, you can see that index.html showed up. Now what we want to do is see if it actually shows up on GitHub pages, the github.io link, and looking like our real website. If I don't remember what my website's address is, it's easy to figure out what it is again. You just go to the settings, scroll down to the GitHub Pages section, and it will tell you the link right here. We'll go ahead and open it in a new tab. You can see here that what it's giving us is hello Coursera students. That's that index.html file that we committed and uploaded. You can see here it's again using my username .github.io Coursera-test is the name of the repository. Now, when you submit assignments, what you're going to want to do is you want to create a separate folder for each of the module assignments as it will be described in each assignment document. And you could repeat this process. We could go back to our Atom editor. We could say, hello, Coursera students. I am thrilled about this course, exclamation point. We'll save that. We'll go back to our command line and we'll say git status. And you can see once again, we have something in red because we've modified now this index.html. So we basically have to go through that same process again. We'll say git add to mark it for committal. And we'll say dot anything in this directory. We'll do git status again. You'll see now it is ready to be committed because it is now green. And we could say git commit -m the message next version of web file. And we'll press enter. So now that's committed, but that's only to our local repository. We once again have to say, we'll say git status just to see what's going on. It's telling us once again that it is ahead by 1 commit. So we'll go ahead and say git push to upload it to our GitHub repository. And it's done. Then we could go to our browser and we'll go ahead, even can just refresh that right here. And you can see it immediately shows up there. And that's because if I go back to my Coursera test repository, you could see that that's the commit that is sitting in this particular branch at this point, meaning it's the one that I already pushed or uploaded to this repository. So that's why you see the updated file right here, which makes it very easy for you to simply push, commit, and push your changes through Git, and then immediately see those results published as a regular website on the web. Before we jump into all kinds of Angular specific topics, like explaining scope, services, directives, as well as general programming concepts that Angular uses, like model view, view model architecture, I think it would be really helpful to take a step back and understand the why behind the whole approach. When you're learning something new, the more you can understand why things fit together the way they do, not only does it help you understand and retain information, but it also makes your effort meaningful. No one likes doing things that are pointless, especially if they're more complex, and Angular can get complex. But if you know and understand the value of your approach, you have a whole different view of things. You can appreciate the goal you're going for, as well as judge how close or far you are from that goal. In this course, I'll explain everything step by step, so you don't have to worry about the complexity so much. However, knowing the motivation behind making things less simple is still important. So what is that goal that Angular and other such frameworks are trying to achieve? Why not keep things simple? Why complicate anything at all? So what do I mean by keeping things simple? So you already know the core technologies from the previous course that we went over that drive the web. You know how to structure a web page using HTML, you can lay out and style that page using CSS, and you can add functionality that makes your page come alive. You can request data from the server and other services on the web. So the question is, why add anything else? Let's take a look as to what happens to your project code base as you keep adding more and more functionality as the project goes along. So you keep adding functionality, obviously the code base grows together with it. And the most important part is that the JavaScript, that's where the functionality lives, grows in size and complexity. If not in size, certainly it grows in complexity. So right off the bat, the answer to the original question is that we as developers are not introducing all these complicated frameworks and approaches to coding and therefore making things complex. No. Without such approaches, our code gets complex inherently by itself. These frameworks and approaches are here to help us deal with that complexity and keep it under control. The question is, how can we control the size to some extent, but certainly to a large extent, how can we control the complexity of our code base? And what does it mean, control complexity? What are we trying to achieve? What do we want out of our code? In other words, what code characteristics do we need our code to have in order to consider it not so complex and fairly easy to deal with? Let's go over some of the basic ones. So the first one is that we need some way to organize different parts of our code such that we find the code that's responsible for a particular part of functionality quickly. And don't forget that it's not just for you. You need to organize it in such a way that it is clear as possible for your teammates as well. A good rule of thumb to employ here is to think about what it would take to bring a completely new developer on board. Would it be fairly straightforward to explain to the new developer where the functionality lives in your code base? Requirements of apps change all the time. They change because customer wants something new, because the business rules change, but also because some requirements are misunderstood until later into the development process. So we need to prepare for that up front. If some business rule changes, we don't want to have to rewrite the whole application. In fact, we want to change as little as possible in our code in order to integrate the new change and have the rest of the code not even notice that anything happened. It also would be a huge waste of time to have to write the same functionality more than once, especially if it's in the same application. However, even worse than our original duplicated time, so to speak, think about what happens when we need to update the functionality. We would have to update it in more than one place. Of course, something like that is very prone to making simple mistakes and introducing hard-to-track bugs into your code. So when we start thinking of how we're going to write some piece of functionality, we should take at least a little bit of time to think if we need to make our code work more generically and write it in such a way that it can be used in several places in our app. And finally, how do you convince yourself that your code is actually working? Well, you test. But how? Well, you can fire up the entire system and see if quote-unquote everything works. But is that an efficient and good use of your time if you just edit a couple of small functions and don't even have the entire feature coded up yet? Probably not. Instead, you need to code your solution in such a way that small chunks of it can be tested independently without having to deploy the entire web application. That means that as you code, you have to keep this idea in mind and separate your functionality into smaller, testable components. So as a summary, the purpose of additional technologies and approaches is not to make things more complex. They're there to deal with an inherent complexity that our code brings as it grows in functionality. We also spoke about what it means to have an easier to deal with code. First of all, we need good code organization so we could find relative code we need to work on quickly. Second, updating part of our code shouldn't affect other parts at the same time. That will allow us to write smaller chunks of code and not have to deal with the rest of the system every time we update a small thing. We also want to write reusable code. We don't want to write the same code twice and certainly don't want to debug it in more than one place. And finally, we need to be able to write testable code, and that's code that's written in small enough chunks that makes it easy to test without having to deal with the entire system all at once. So why does code get complex? In other words, what makes it lose those good code characteristics we spoke about? Well, one of them is if people write hard-to-read code. And that can include bad or inconsistent coding style, so it's one way in one part of the file, a different way in another part of the file, and the spacing is all messed up and it's just simply hard to read. Another way it could be hard to read the code if people make up all kinds of very hard to read function or variable names. Another one if there's no comments or even API documentation. The hard-to-read code issue is fairly easy to fix. You just rewrite the code or format the code the way it's supposed to be according to some style guide. However, there's a much harder problem to address. And that is a problem that software engineering has kind of battled with for years. And that is the lack of high cohesion and low coupling. So what does high cohesion and low coupling mean? So let's take a look. High cohesion is when small pieces of functionality are strongly related to each other within some code boundary. Now, I say code boundary for a couple of reasons. One, because in some languages, the boundary that this principle usually refers to is a class. In some other languages, it's a module. In some others, it's a function. But another, perhaps more important reason is because it's really a question of what you're designing for high cohesion. You can try to design a whole module for high cohesion, or you can try to design a simple function for high cohesion. It's a question of how much you zoom in, so to speak, on some area of your code. So to say it very succinctly, high cohesion is how well does that one thing stick to doing just one thing. Now, one piece of high cohesive functionality can use other functions to achieve that. So for example, if you have one function that contains several other functions, the key component here is that all three functions are very closely related to each other. In the scope of that one function, they're trying to accomplish the same thing, just taking different tasks towards the same goal. So let's take a look at a fun example. For example, if you take a look at my daily schedule and basically map it out as a coding module, it has a whole bunch of things in it: wake up, brush teeth, caffeine, code, and so on. Now, if you take that same thing and then make the daily schedule of my Mac, of my computer, the schedule is much simpler. And if you take a look closely, you'll see that in my schedule, there's very low cohesion, and in the Mac schedule, it's very high cohesion. All it does is on, flash pretty lights, run the OS, sleep, and then it turns off. In my schedule, there are things that are conflicting with each other. You know, work and working in code at work, eating dinner, creating Coursera course, late snack with cookies, and losing weight are all very conflicting things. They don't really 100% belong to each other. So therefore, the schedule makes it a little bit more complex to deal with. Of course, it also makes it more fun to deal with as opposed to the boring computer, but computers are good at being boring, not so much human beings. So the low cohesion is what's making, our daily schedules as human being complex. On the other hand, we have this loose coupling. And loose coupling means that least possible dependency of one component on another component. Having loose coupling in software is a good thing, and it makes development much less complex because it allows you not to have to worry about the rest of the system when you're dealing with one small, loosely coupled piece of it. So to say it more succinctly, when we speak about software components, you have loose coupling in such a case in which if you change one component, you do not have to change the other. For example, if you have a shopping cart and it's working very well, and then you add another component that helps you charge credit cards. So the shopping cart calls the credit card processing component. If these two components are loosely coupled, it means that if we change how credit card processing is done, shopping cart code will not change. It will not care whatsoever how credit card processing component is working. It just needs to be able to call out to it, and the rest of the details it doesn't care about. If we take a look at an example of that in real life, for example, changing an iPhone battery is a fairly complex process as opposed to changing, let's say, an LG G5 battery. You just pop it out and pop it back in. And here's, by the iPhone battery, you have tight coupling, and therefore you have very complex things to do in order to pop it out and put a new one in. And in the case of LG G5 battery, it's loose coupling because all you have to do is press some button, it pops out the battery, and you pop the new one in. Okay, so how does this express itself in software? And for our purposes, how does this express itself in a web application software? In the second part of this lecture, we're going to take a look at a simple example that shows us these concepts. Okay, so for our example of really bad design, which will have low cohesion and tight coupling, we have this app where basically when you enter your name here, and as you type, it will tell you the numeric value of your name based on the ASCII character values that you enter. And as you erase, basically any press any key, the value will be updated. So let's go ahead and take a look as to how we did that. This is our browser sync, and our app consists of two things: the index.html and app.js. And this is located in lecture 02 folder, which is located in your examples folder of the Git repository that hopefully you cloned that has examples for the rest of the course. And in our HTML, we really need to pay attention to only a couple of tags. One is this input tag, which has an ID name that we're going to attach some behavior to. And the other one is a placeholder tag with an ID output. And now if we jump over to our app.js, which is, by the way, is included obviously in this page, so you could act on it. And in app.js, what we have here, we have a object literal student with a name at this point as an empty string, and the type of student is a student. In the next few lines, what we're doing really is just setting up some listeners for different events. The first one is DOM content loaded listener, and that listener basically, as you know from previous course, is just going to fire this function when the entire page is loaded and is instantiated inside the browser's memory. So therefore, all the HTML has been processed at the time that this content loaded function is fired. And the content loaded function, all it does is just looks for the ID or the element with an ID name. As you can remember, that's our input field right here. And what it does is it sets up a listener, key up listener, that says every time you press a key inside of that text box, I want you to fire this key up function. So the key up function does nothing more than call this calculate numeric output to calculate the numeric value of whatever has been entered into our input text box. So let's take a look at this calculate numeric output. What it does is, again, grabs the value of the input field in our HTML page and saves it into that object student.name. And what it does next is it loops over that student.name and basically looks at a character code at each position within the string. Once it kind of adds them all up, it creates an output string, total numeric value of a person's name is, and just adds to it the total numeric value. And then it goes ahead and pulls the element that has the ID output and sets its inner text property to our output. Well, what's wrong with this code? Well, quite a few things actually. Let's take a look at our index.html. Index.html is there to display things. It's there to present things. So therefore, it's a really separate piece from the functionality. We've learned about the three different core technologies, HTML, CSS, and JavaScript. Well, HTML and CSS is really there to present things. It's not really there to have functionality. So it would be really bad, in fact, it would be tight coupling, if I would change something in my HTML and that would completely break or affect the way I implement my functionality in my JavaScript. So for example, as a designer, I might decide that, you know what, I don't want your name to be here. I really want full name to be here. And therefore, name doesn't really quite distinguish it enough. So I would want to change it to say full name instead of just name. Well, what would that do? What that would do is it would break our application. So if we go back to our app and start typing here, obviously nothing will happen because our app.js is trying to attach the keyup behavior to this particular element with the ID name. Well, it's no longer the ID name. So what do we have here? We have tight coupling because our application code, our app.js, very tightly depends on how our index.html, our presentation code, is written. And that's a really bad thing. And obviously it goes not just for this, but it goes for other things inside here, like, for example, the output ID as well. We're directly accessing this output right inside of our app.js code. But let's take a look at this calculate numeric output function. This function should really do just one thing, or at least have very closely related things inside of it. But if you take a closer look, we're doing a whole bunch of stuff there that really seemingly completely unrelated to calculating numeric value of a string, because that's really all we want. And here what we're doing is we're again reaching out to our HTML, making it a tight coupling, but we're also at the same time calculating the total value. But we don't stop there. We go and take that value and insert some text inside of our HTML document. So really, this calculate numeric output is doing way too many unrelated things. It would be much better if this functionality of actually inserting our result into the page was really completely separated from this function. And the functionality of getting the value that we want to get the numeric value of, get that string, should also be a separate thing. And really the calculate numeric output really should just be calculate numeric, passing it a string, and then just getting the primary functionality and the single functionality of just calculating the numeric value, and everything else should be out of it. So this is in a microcosm. It's obviously not a big deal in a small application, but in a microcosm, this is an example of low cohesion, because in the same function, we have functionality that is really not that closely related to each other. And that is an example, at least in a microcosm again, of low cohesion. So to summarize, we spoke about why software gets complex as it grows. And one of the main reasons that we spoke about was the lack of high cohesion. In other words, how well does one thing stick to doing just that one thing? The other part was loose coupling. And loose coupling is when change in one component doesn't really affect another component. And we saw an example in a real web app, what happens when you have tight coupling. HTML, remember, is just presentation, and JavaScript is our functionality. So when things inside HTML or changes inside HTML directly affect and make us change things inside our JavaScript, that's an example of tight coupling that we would really want to avoid. And an example of low cohesion was when our one function really seemingly did three fairly unrelated things. So what we really want in our software is high cohesion and loose coupling. And as we go forward, you'll see how Angularjs lets us accomplish these goals. So how do we magically achieve this high cohesion and loose coupling? Hopefully it's starting to become clear that we need to think not only about what our code is supposed to accomplish, but also how to structure our code, how to break it up into several separate pieces of functionality that somehow work together to achieve the goal of implementing the business logic. We need a consistent approach. But what approach do we take? Do we go to the drawing board and start architecting, perhaps trying to implement our architecture to see how it would withstand the growth of our code base? Sure, you could do that, and you would do that if you were interested in research. However, if what you're interested in is getting the functionality implemented as fast as possible, you would turn to someone more experienced and ask them for advice for your particular situation. Luckily, since similar situations arise over and over, developers over the years have adapted a set of cookie-cutter approaches to those situations. Implementations of those approaches will differ from framework to framework and sometimes from one developer to another, but the general idea of how to architect such a solution is fairly standard. These approaches that developers came up with as a design and architecture solutions to problems that fit a certain pattern are called design patterns. In non-standard situations, you usually have to have some experience recognizing that the problem you're trying to solve fits a particular pattern that we have a cookie-cutter solution for, a design pattern. However, in fairly common situations, like designing a user interface with some functionality attached to it, there are standard design patterns that developers use. In our case, we have such a pattern. It's called model view view model. So let's look at some key components of our model view view model, or MVVM architecture. The first component is the model. It represents and holds raw data. This is something you would get directly from a database or from a REST API call from the server. Now, some of this data in some form may be displayed in the view. It doesn't mean that all of it is going to get displayed or even any of it is going to get displayed. It's very possible that given some values that are coming back from the server, you will take those values and add them or somehow manipulate them and actually display the result of that to the user. Now, this component can also contain logic to retrieve the data from some source. For example, it could basically make an HTTP call, an Ajax call, to the server to retrieve the raw data. One of the most important things to remember about this component, though, is that it contains no logic associated with displaying the actual model. It doesn't know how it's going to get displayed. It doesn't know who is responsible to get it displayed. It just contains the data. The other component is the view. Well, the view is fairly simple. It's the user interface. In a web application, the view is just HTML and CSS. It only displays the data that it is given, never changes that data. It just displays it. And on top of that, it declaratively broadcasts events, but never handles them itself. Now again, declaratively means that you don't actually write any JavaScript code in order to trigger or to raise an event from the view. It just declaratively states that if such an event happens, where should we go to handle that event? And it points to the view model, which we're about to discuss. The next component is our view model. The view model is the representation of the state of the view. It's the model, that is the data, that represents the view. It's kind of a backing, the backside of the model. It holds the data that's displayed in the view, and it responds to events. In other words, it does the presentation logic. If there's any business logic, like processing of some data, it usually calls other functionality to get that done. The most important thing to remember about this component is that it never asks the view to display anything. What that means is that it never directly manipulates the DOM. So it never calls getElementById. It doesn't even know what IDs are present in the HTML to begin with. It doesn't care. This allows us that loose coupling that we spoke about between the view, that is the HTML and CSS, and the view model, our JavaScript, that supports that view with presentation logic. There's one more crucial component to this design pattern, and that is the declarative binder. The declarative binder declaratively binds the model of the view model to the view. It's that glue between the view model we just discussed and the view that contains HTML and CSS. Declarative here means you don't have to write any code for this to happen. That's where the framework comes in. The framework does this magic for you. This component, the declarative binder, is the key enabler of the whole MVVM pattern. Without it, you would have to write all these bindings by hand, and the whole pattern goes out the window. Let's take a look at a diagram. So we know we have these three components that we spoke about. That is the view model, and the model. The view is our UI and our presentation. The view model is our presentation logic. Notice that the view is implemented using HTML and CSS in the web application, and the view model is implemented in JavaScript, as well as the model is also implemented in JavaScript. So what the usual thing happens is the presentation logic reaches out to the model to ask for some business data or for some sort of data. The model returns that data to the view model. At that point, the view model binds that data to certain components or certain things inside the view. That data binding happens declaratively, which means you don't actually manipulate anything inside the view. You don't manipulate the DOM in order to display that view model data in the view. Now, AngularJS is flexible enough to recognize that the model view model is not a one solution fits all. Since the framework didn't want to limit the developers to just one approach, some features of AngularJS allow you to break away from the mvvm pattern and do whatever other pattern you feel is most suitable for the situation. This is even to the point of letting you manipulate the DOM directly in your JavaScript code. This makes the framework extremely adaptable, as there's almost always an easy way to integrate other JavaScript libraries into it. For example, if you wanted to use AngularJS with D3.js, which is a very popular, custom, powerful graphing library, you can easily do that. And that's why Angular sometimes is also called model view whatever, or MV star, because it doesn't restrict you to the mvvm pattern, but lets you use it if you choose to, or not if you don't. Okay, so let's summarize. Design patterns are cookie-cutter approaches to common software development issues. One design pattern that we're going to be using is called mvvm, which stands for model view model. And that's a common design pattern for structuring UIs with some functionality together. The model in the pattern represents and holds raw data. The view in the pattern is the UI that never changes data and declares events, but doesn't actually handle them. The view model is the data representation of the state of our UI. The final part of this design pattern is the declarative binder, which declaratively binds the view model to the view. Now, Angular is flexible enough not to be restricted to mvvm, but allows other design patterns depending on the situation and the developer's choice. In general, the goal of design patterns, including mvvm, is to achieve high cohesion and loose coupling. In a couple of lectures, we're going to take the same name calculator example and re-implement it using AngularJS while doing a much better job achieving our goal of high cohesion and loose coupling. In this lecture, we're going to see how to install AngularJS into your HTML page and how to write our very first AngularJS application. So right now I'm located in my Atom editor, and I'm looking at Lecture 04 folder, which is located in the examples in the Full Stack Course 5 folder. I also pre-started my browser sync, so on the right you see the browser sync basically showing us so far just an empty page from our index.html that we started. So the very first thing we need to do is we need to download AngularJS library itself. So let's go to the browser and we'll switch to this tab, and I already preloaded angularjs.org. So what you want to do is you want to go to develop and click on download. And here we'll tell you all the different versions of AngularJS. Now, since this course is based on AngularJS 1, not AngularJS 2, do not choose anything that has 2 point and so on next to it. Instead, find the latest version of AngularJS 1 point something and click on that, and you'll see a whole bunch of different packages that AngularJS provides. What you want to look for is the one that just is very plain, says angular.js. Well, this is actually the unminified version, the one that has all the spacing in it and all the full named variable names. But in order to save bandwidth, we're going to go ahead and grab angular.min.js. And you can see here, if I right click and click Save Link As, I'll be able to point to the folder in which our lecture 4 is located. I already did that, so I'm not going to do that again. And you can see here that my angular.min.js is already in the lecture 04 folder. I also created an additional file where we're going to put our own logic, which is app.js. And in this point, it is just an empty JavaScript file. So the first thing we need to do is we need to reference those two files in our HTML page. Well, I already pre-made that, so I will go ahead and cut and paste it right here. So all we need to do is put two script tags. The first one is angular.min.js and the second one is app.js. And obviously we want our app.js to follow angular.min.js because this is HTML and browsers interpret these lines sequentially. So since we're going to be using AngularJS inside of our app.js, we want that to be processed first and then be available to use inside app.js. Okay, so let's go ahead and go to our app.js and we'll go ahead and hide the sidebar here and let's write our very first AngularJS application. So the very first thing we're going to start with is we're going to start with an IIFE, an immediately invoked function expression. And if you don't remember what that is, please look in the previous course where it explains in detail why we want to do something like that. But in short, we want to make sure that no local variables bleed into the global scope. So once we've defined our IIFE, we're ready to start our AngularJS application. And the very first thing we want to do is define our main app, the thing that's going to be responsible for some chunk of HTML in our index.html. So the thing that AngularJS exposes on the global scope is really just one particular object, and that object is called Angular. So Angular is we're able to now execute things on it. And one of the things we're able to do is say module and define our module, and we'll call it my first app. And the first thing that this module method takes is the name of our application. And the second is a list of dependencies that our module or our application is going to need in the form of an array. In this case, we're going to just leave it as an empty array because we have no dependencies at this point at all, just a regular plain AngularJS application. So when we go ahead and define that, we can now go ahead and hook up this my first app into our index.html. So if we go to index.html, there's a special attribute that we could place really anywhere we want, but usually you want to put it on the very outer tag that you want the Angular application to be responsible for. And the attribute is called ng-app, which stands for Angular application. And we want to name it exactly the same way we named it in our app.js, which is my first app. So when we save that, now it means that anything in this DOM tree from the beginning where we mentioned ng-app to the end of that tag, which in this case is beginning HTML and end HTML, our Angular application is responsible for. So this module has now been bound, this AngularJS app has been bound to our HTML. Now, almost in all cases, you don't want to just stop there. What we want to do is want to define another construct of Angular that will be responsible for a smaller portion of our page. For example, just this div. So what we're going to go is we're going to go to app.js and we're going to go ahead and remove the semicolon. And since module function returns module instance, we can just go ahead and chain the next call to .controller. And .controller function is really the way we define the view model of our view being index.html. So it takes two things. Number one, it takes the name of our view model or the name of our controller, and we'll call it my first controller. And it takes a function that defines the functionality for that particular controller. So when I save that right here, I now have my first controller available, being that its functionality is defined by this function, which at this point is empty. It's available to be bound to our view. So let's go ahead and do that. Let's copy that and go to our index.html and say ng controller equals to my first controller. So when I do that now, everything below this div and until this div is closed is being controlled by this my first controller, because Angular looks for this name inside of our app.js and sees that this name matches right here, this controller, and knows that the function responsible for that piece of functionality inside of our view is this function right here. So if I save that, and I should see no errors whatsoever, at this point we haven't really implemented any functionality, but we have at this point bound things in our JavaScript to things that are in our index.html. So if you think back to what we discussed about view and the view model, this is that relationship. This index.html is really the view, or in this particular case, just this div is really a piece of a view, and this piece of the view is being bound to app.js, and in particular being bound to this function defined by the controller. This binding, or this binder, is happening automatically, and it's done by AngularJS for you. There's one more best practice that I'd like to insert here that we should use from now on, and that is declaring our function with useStrict. useStrict. And when we do that, we're enabling certain things to just protect us from making mistakes. For example, we know that the entire ify construct that we've put in here is there to protect us from bleeding things into the global scope. But what happens if I say, and I'll go ahead and comment this useStrict for now, what happens if I say x equals hello? Well, according to the rules of JavaScript, since x has not been defined with a var keyword, it will go ahead and define itself on the global scope. Now, usually that's not what we want to do, and we don't want these type of mistakes by accident to kind of slip by. So if we use strict, let's uncomment that now, and go ahead and save that, you'll see that the browser is complaining and saying that x is not defined. In other words, it's seeing that x is really defined inside of a function, yet it has no var keyword in front of it. And if I put the var keyword in front of it, it will go ahead and not complain anymore. So from now on, we're going to use our ify immediately invoked function expression, and we'll use useStrict to make sure we don't make any careless mistakes that will probably hurt us down the road. In the next lecture, we're going to see a little bit more about what this controller can do and how it can directly affect the view that is the index.html. Obviously, it would be pretty boring if all we could do with our Angular application is somehow magically connect our JavaScript to some piece of HTML page and really do nothing else with it. So really, we need some sort of a mechanism for the view, which is our index.html, and for app.js, which has or contains our view model, to be able to share data. Right now, I'm located in the folder called Lecture 05, which is located in the fullstack-course 5/examples folder. And I've already set up my browser sync, so it's displaying the page that we're looking at, which is this index.html. In fact, let's give it a little bit of a better title than that. Let's give it an H1, and we'll tell it my first Angular JS app, so we could see something actually in the page. Okay, so let's go ahead and close the file browser inside Atom. And now what we're going to do is we're going to use a special object that AngularJS provides for us in order to share data between our view model and our view. And that special object is called $scope. Whenever, by the way, you see inside AngularJS $, in front of some variable name, it means that this is something that is reserved for Angular. This is something that Angular provides. There's nothing really stopping you from naming your own variables with a $, but the convention is for you not to do that because Angular is reserving kind of the $, for anything that it provides out of the box. So this scope variable right here, and we'll discuss later how the scope variable or how the scope object even gets here, can have properties defined on it that are going to be exposed to the view. So if I say scope.name and say Yaakov, this .name is actually now sitting on the scope, and this scope is available inside my ng controller or anything below it or inside of it that this ng controller is in charge of. So I could place an expression here, which is double curly braces or mustache or however you want to call these characters, and I could say name. If I place name over here, since name is sitting on the scope, and the scope is defined right here with a name, the Angular framework will assume that this is something that it should look for on the scope. So if I say that, you'll see that all of a sudden Yakov here shows up in my page because it looked on the scope, which is bound to this particular view model, which is bound to this particular controller, and it's being displayed therefore right here between these two divs. Now, the value of name is not the only thing that we can reference here. We can reference whatever we want on the scope and then expose that to our index.html. So for example, I could go ahead and create a function, let's say called say hello, and there's going to be a function that returns hello Coursera. So now I could go back to my index.html, and instead of name, I could call that function. Since again, scope is something that's assumed, I could just say hello, not to forget the parens, because this is a function, not just a value. And when I save that, and now we see it says hello Coursera. Now, a more interesting case is for me to show you that I could declaratively bind a piece of HTML to my scope. So let's go ahead and erase that and put an input field here. And in this case, it will be just a text box. And I'll use a special attribute, Angular attribute called ngModel to tell it that I want the value of this input attribute to always be equal to something on my scope, something called name. So it will now assume that there's something on my scope called name, and if we go back and look, there's in fact something on my scope called name, and it's equal Yakov. And if we go back to our index.html, we'll see that now we're binding that value to whatever the input value here is. And you see here in our HTML or in our web page, the Yakov showed up as the value of this input box. Now, in fact, if we keep changing that, this is something that is changing actually the value that is attached to the name property on our scope. One quick way to determine that it's actually true is to not only bind this name value or this name property to this input element, but also output it right next to it. Let's say inside my input is, and then we could just go ahead and output name. So if we save it, you could say, since we refreshed it, it said inside my input is Yakov. But as we change this, take a look as to what's going on with this variable. As we're going to change that, since this variable is completely bound to our scope's name property, the second we change it, which is what this is doing, it's looking for any changes on the name property of our scope, is going to automatically change this name as well. So I could say Coursera, and you could see as I type, the other value that is being output through this expression that we'll talk about a little bit later is also being updated. So in this lecture, we spoke about how we could bind the data and share the data between our controller, our view model, and our view, which is represented in index.html. In this lecture, we're going to go back to the application we originally wrote and rewrite the whole thing in Angular.js, seeing the concept of model view model architecture come alive right in our code. Right now, I'm in my editor looking at folder lecture 06, which is located in fullstack-course5/examples folder. And as you could see, I've already set up some things in my HTML file, as well as I started browsing so I could see my HTML already on the screen. Now, let me go to my editor and close the file browser. And as you can see, we already set up Angular.js here, and we've set up our app.js here as well. The rest of the HTML is fairly bare at this point. It just has name calculator as h1 and has one text box as an input field. So let's go to our app.js and start our application. Here I already preset up for myself the iffy, as well as saying that I'm going to use strict here so I don't make any mistakes. So the first thing I'm going to do is I'm going to create an Angular module. And the way I do that is saying angular.module, and let's name it something like name calculator. And as far as dependencies, it doesn't have any dependencies, so we'll just leave it as an empty array. Then we're going to create our controller, and we'll call the controller name calculator controller. And the function that's going to be responsible for that controller is going to be right here. We'll close the semicolon here, and we'll go ahead and specify scope in here, and that's that object that we're going to use to communicate with our view, which is index.html. Okay, so far so good. We've declared the two things, the module, the application, and the controller. And now what we have to do is we have to wire them into our view, which is an index.html. So where we specify the ng app, which is the application for the entire thing, really doesn't matter as long as it's really above the controller that we're going to also bind, and also kind of, encompasses a nice chunk of HTML that we're going to have to work with. So usually we could put it right in HTML, but this time let's go ahead and change it a little bit. Let's do ng app on the body itself, and we'll give it the name of whatever we specified in our app.js for module, which is name calculator. Let's copy that and paste it right here. So now name calculator app, the module, has been bound to the body, so it's controlling anything from beginning of the body tag until the end. And here we have a couple of divs here. It doesn't matter which one we bind the controller into. Let's go ahead and bind ng controller to that, and I believe that's called name calculator controller. Here the editor is helping me out a little bit. Okay, so as I saved it, I should have no errors, and I don't. And now we've bound the two things together. There are a couple of things that we want to share between our controller and our view. One is we want to share the name of the person that is going to be entering their name here. So we're going to go ahead and specify scope.name, and we'll initialize it. And at this point, it's just going to be an empty string. And the other thing is the value, the initial value that we want this to show. And since it's an empty string, the initial value should be 0. So scope.total value is equal to 0. Okay, so if we save that, we could at this point now output these things straight on the HTML page. So we could go to index.html and say that total numeric value of person's name is, and that's going to be our total numeric value, which is our expression, our handlebars, or mustache, or double curly braces, however you want to call it. Since scope is assumed, we're going to go ahead and say total value and save. The second we do that, the total value now is showing as 0 because it's pulling this 0 from our scope, dollar scope. The name we haven't really bound yet, so let's go ahead and do that right now. Let's go to index.html, and where we want to bind the name is into the input element. So the way we do this binding, as you remember from previous lecture, is we do ng model, and we say that ng model we want to bind to name. So as the name changes in this input box, the name in our scope, in our dollar scope object, will change as well. And if we want, we could quickly verify that that's the case by just putting yet another value right here called name. And now as we type right here, that value is going to show up beneath this total numeric value. So let's go ahead and remove that. So we need somehow, some way to let our controller know every time a user presses a key that we should go ahead and look at the model, recalculate, model meaning our name, recalculate the total value, and go ahead and output that total value right here simply by updating it on the scope. So the way we could do that, and let's go ahead and make a couple of indents here. The way we could do that is by saying ng key up. Ng key up, and we're going to bind something else on the scope. And in this case, let's bind a function, which we haven't really written yet, but let's call it display numeric. And we'll go ahead and give it parentheses. We could even give it a semicolon. And when I save it, nothing's really going to happen since we haven't really defined this function yet. So let's go ahead to our app.js and define display numeric on the scope so it's visible to our view as well. display numeric, and that's going to be a function. And the function is going to create a total name value, and we're going to get it somehow. Don't know yet how, so let's just give it a 0. And we'll just make a comment, get the total value. And once we get that total value, we're going to go ahead and update our scope variable, total value on our scope variable, to our local variable, which is total name value right here. So the only thing that's left is to actually calculate it. Let's go ahead and write a function that's going to do that for us. Here we could write a regular function, and we'll call it calculate numeric for string. And we'll pass it a string. And here I'll go ahead and copy and paste some of the code that I already pre-written before. And we'll go ahead and paste it right here. And all it's doing here is just saying I'm going to start with a 0. I'm going to iterate over the string, and every position in the string, I'll figure out what the character code is, add that to the total value, and return that total value. So at this point, we're good right here. And all we need to do now is substitute the call instead of the 0. So we're going to call that function, and what we're going to pass to that function is our scope.name, because that's what is going to get updated as I keep typing something in here. So once I get that, let's go ahead and take that comment out of here. Once we calculate that name, or calculate that numeric value, it's going to get saved in the total name value variable. And then we're going to copy that right into the scope, which is going to then update the scope and automatically update the total value in the view. So let's go ahead and save that. And right now, if we start typing in here, and let's put my name in here, you see as I type or as I erase things, the value is changing automatically. So let's take a look at our code a little bit in a more design perspective. So we have our app.js, and as you can see, we never really reached out into the view and try to figure out how the view is implemented. There's no even any IDs in the view at all. All we did was declaratively said that this input field should be bound to the name on the scope, to our view model, and whenever there's an event, meaning somebody presses a key or lets the key up, it should call this function that is also bound to our view model, which is our controller, and particularly the $scope. This allows us quite a bit of flexibility on our view or in our HTML, as we could change this whole thing around however we want and still have the functionality be completely untouched. In other words, nothing in app.js will ever have to change, no matter how you end up displaying that numeric value of that name, or how you even end up getting the name from the user. The code in app.js will stay the same. In the previous lecture, lecture 6, we were looking at the ng-app and how it got linked together with our app.js module with the same name, as well as in index.html, we were looking at ng-controller and how that got linked together with name calculator controller, again in app.js. And this linking or this binding was done for us by Angular. Sometimes when you're first beginning with a framework like Angular, or really any other framework, some of these things can become a little bit intimidating simply because it's a little bit of a magic as to what's going on here. How does this ng-app attribute end up with this name calculator module connected and bound together? So I find it that sometimes it's helpful to take a step back and just to figure out how does these things work, kind of pulling the curtain back and see what's behind the magic. And the truth of the matter is there's really nothing magical about this, and what we're going to do in this lecture is we're going to see how does Angular able to find this particular ng-app attribute and how is it able to deal with it. Let's go ahead and minimize this. And we have here a folder lecture 07 and just an index.html inside of it. So we're looking at lecture 07 folder, which is located in fullstack-course 5 examples folder. And we're looking at a very simple index.html page. So it's got a body, it's got an h1, and it has a div with a section and an article in here. And a div has an ID with the name target. And I already set up my browser sync such that it's actually showing me what is inside this HTML page. So what I'm going to do, I'm going to use JavaScript to try to select this whole chunk of HTML. And that's fairly easy, and we know how to do that. Let's go ahead and actually do it straight inside HTML. We'll write a script tag, and inside the script tag, we'll do, let's say, var element, and we'll say document.getElement by ID. Let's go ahead and close the file browser so you can see a little bit better. And we'll say target. Okay, so that's the element. We've selected this element right here, and really we've selected everything, the entire DOM structure that is underneath this div element. So we can actually console.log this and see that we were successful. Let's go ahead and do console.log, and we'll do element. And when we save it, it should pop out here. Right here pops out is that we see our div target. And if you open it up here in Chrome, you'll see that we actually have much more than just the div tag itself. We have all the things underneath of it as well. Now, what happens to our HTML page if right here, instead of putting, class or something else standard, what happens if I put something like greeting equals hello? So if I save this, let's see what happens to the HTML page. Well, nothing really happened. Why is that? Well, the reason that is because greeting is not a standard HTML attribute. And the browser, the software that runs the browser, tries to interpret every one of these tags and every one of these attributes, and it doesn't really know what to do with this greeting attribute. And therefore, it just ignores it. However, there are methods and functions in JavaScript to let us get at the actual attribute and at the value. So for example, we could go ahead and say element.getAttribute and give it the name of the attribute, which is greeting. So if we actually surround this with a console.log, so we could see what it actually is getting, and we'll save it. Once it refreshes the browser right here, you'll see that what we got was hello. And hello is the value of the greeting attribute. So you can see now that any attribute you place inside of an element, you're able to get at that attribute and also to get at the value that that attribute contains. So let's go ahead and actually replace it and replace this greeting one with ng-app equals, let's say, my test app. Now, ng-app attribute doesn't mean anything in this context because we didn't even load Angular.js into this HTML page. However, just like the greeting, we're able to take this ng-app attribute and get the value of it just like before. So if we save that, you'll see that the value is my test app. But there's more to it than that. We can, if we want to, suppose we are the Angular.js authors of the Angular.js framework, and we want to find where is in our HTML an attribute, or an element, I should say, with an attribute ng-app, such that we need to bind our module to that particular element and everything below it. And the same goes for the ng controller. So let's go ahead and try that. And we could do that very simply by doing this. Let's go ahead and erase all that. Actually, we'll just comment it out. And what we'll do is we'll call var element, called element2, equals document.querySelector. And what we want to do is create a query selector that finds an element with an attribute ng-app. And that's exactly what we're doing here with these square brackets. We're saying, find me an element, find me the first element with the attribute ng-app. Let's go ahead and save that, and we'll do console.log on the element2. And when we save it, and we see that we found the same element that we found before and everything underneath of it, and we found it by using our ng-app attribute. And obviously, once we have that element, we could say console.log, so we could see it, element2 dot get attribute, and we know which attribute that is. It is ng-app. And if we save it, we'll see that we now can get at my test app. And once we have my test app, it certainly is very feasible for you to understand at this point that if you have some code, which is AngularJS code, that is declaring a module with my test app, I could marry these two very easily since I have a handle on the element that is responsible for that ng app. And at that point, I would have a handle on the actual function that is responsible for the piece of content that is attached to this element too. I'll mention one more quick thing in this lecture. There's a new set of custom attributes that HTML5 introduced, and those are called data-star attributes. And really these, unfortunately, really have nothing to do with this ng app. You could go ahead and say data-dash, and that will be 100% compliant with the HTML5 specification. However, Angular does not require you to have that compliance. And you could look up in Google yourself what data-attribute-star actually means. It's just basically a much more convenient way at getting at custom attributes that hold custom data. But for AngularJS, just ng-app or ng something dash something really is good enough, and you don't need to use the new HTML5 data-star custom attribute setup. In this lecture, we're going to speak about one more very important concept that is actually used throughout AngularJS, and that is dependency injection. I'm sure by now you've seen this construct where we create the module that we're going to use in AngularJS, and we also create the controller with an associated function that is responsible for the functionality and kind of the glue code of that controller to the view. And you've seen the $scope that we pass into the controller's function. But where does this $scope come from? Who instantiated? We've seen that when we do console.log on this $scope, it's a pretty complex object. So who instantiates that object? And the answer is that AngularJS instantiates this object for us. And the way we get that object as part of our controller is through something called dependency injection. So dependency injection is yet another design pattern. We've seen one, model view, view model, and now there's another called dependency injection. So it's a design pattern that implements something called inversion of control for resolving dependencies. So inversion of control is a construct or an approach for resolving dependencies. To understand what inversion of control means, let's take a look at how we usually go about architecting a couple of components in, let's say, a shopping cart. So the regular control would be if we have a shopping cart, we can have a separate module called card proc bank 1, basically a card processing, credit card processing for bank 1 module, and it has one method charge given the number, the credit card number, and the amount. And the reason we have a credit card for a particular bank is because for that particular bank we might have a particular URL that we have to contact the bank through, and that particular bank can have its API. So we don't want to take all that code and stick it directly into the shopping cart, because our shopping cart would be very much and very closely tied, have tight coupling with a particular bank API. We don't want to do that. So the way we would instantiate the card processing is we would create that card processing module inside shopping cart, and then we would just call charge, and call charge giving it the number and the amount. And clearly in this diagram, we see that the shopping cart module depends on the card processing module for bank 1. But what happens if tomorrow we decide that we don't like this bank, or we want to use a different bank because it has better prices for credit card processing fees or something like that? Well, the way we would do that is we would have to write a separate card processing bank 2 that also would have the same type of charge with a number and an amount. And in that case, it means that our shopping cart code would have to slightly change, and now when we create the instance of the credit card processing module, we would have to create it with obviously credit card processing for bank 2. And then as before, we would call that charge method, passing it the number and amount, and here again you clearly see that the shopping cart again depends on this card processing for bank 2 module. But we have a huge problem here. We have to change the code inside the shopping cart, which means we have tight coupling again. Just because we switched which bank we process our cards through, we need to change the code inside the shopping cart. And how do you test this shopping cart? Let's say you only have a couple of simple methods, add to cart and remove from cart. In this scenario, you would have to instantiate a whole credit card processing system just to see if your cart, your shopping cart, can place something into the right array and remove something from that array, keeping counts of total value of the shopping cart, total taxes, and etc. That would be insane. We can, of course, create a fake credit card processing module and instantiate that instead inside the shopping cart. But that would once again require us to change the code in the shopping cart. And having to temporarily change the code in the very function that we're trying to test seems like a really backwards and a bad idea. Who says we won't mess up something while changing the code for the test and then putting it back the way it was? So what's the solution? The solution is inversion of control. And in this particular approach, our shopping cart function or module accepts a credit card processing module as an argument. And we still have that line where we call the charge method on that card processing module, but it now is using the instance that we were passed from somewhere else. We could still have those separate modules, but in this case, some overall system is going to be the one who is going to instantiate that credit card processing. So in this case, we want to instantiate the credit card processing for bank 1. And then we're going to call, the system is going to call the shopping cart, passing it the new instance of credit card processing for bank 1. So in this scenario, if we need a different bank for card processing, the shopping cart code is left completely untouched. It will not change. This is, by the way, why IOC, or inversion of control, is sometimes jokingly called "don't call us, we'll call you." Because as you could see, the shopping cart no longer calls out to instantiate the card processing module, but instead we, the system, calls the shopping cart module, providing the card processing instance to use inside of the shopping cart. So just to summarize, we learned yet another pattern called dependency injection. For short, it's called DI, dependency injection, which implements an approach called inversion of control. And if you read things online or in other literature, you'll see that inversion of control is oftentimes referred to as I lowercase o uppercase c, so IOC, inversion of control. And in that approach, client gets called with the dependencies by some other system. And in our case, obviously, that other system, that surrounding ecosystem, is Angular.js. And the whole point of it here is the client is not responsible for instantiating the dependency, that other code that it depends on. Now that we understand the idea of dependency injection, let's look at some code and delve a little deeper to understand how dependency injection can be implemented in JavaScript, and in particular, how it is implemented in Angular.js. Let's understand this magic that somehow allows Angular to figure out where to dynamically insert what type of object. In order to do that, we're going to build a small Angular.js application and explore a couple of special Angular.js services. Right now I'm located in Lecture 09 folder, which is in the Full Stack-Course 5 Examples folder. And it's a very simple app, and so far we just instantiated and bound the app to this DI app name. And we also have just one controller here called DI controller. And in it, we bound the name property of the scope. Remember that scope, the glue between the view model and the view, which is our HTML. That scope, $scope, is going to have a property called name. So it's going to be completely bound. So let's go ahead and take a look at our app.js. In our app.js, you can see that I am creating a module with the name DI-app, which is matching the ng-app attribute that I placed in my index.html. And I'm creating one controller, DI controller, and the DI controller, the function is going to be responsible for that controller, is called DI controller. And what I'm passing here is the value of the function. And in the next line here, I'm going to define that function with the $scope. By the way, anything in Angular, pretty much anything in Angular, with a $sign in front of it, not only does it belong to Angular, but it's also referred to as a service. So from now on, when I refer to $scope, I'm really going to just refer to the scope service. So as you could see, I'm defining a property on the scope service, and I'm giving it the string Yakov. And of course, since this is bound to our index.html, under model, the scope service is binding this property name. It automatically gets this Yakov right inside of the text box. So what I would like to do next is create a functionality such that when the text box loses focus, like that, whatever is inside this text box should get uppercased. And for that, I'm going to introduce you to one more service called $filter. And we can inject it the same way we injected the $scope. So the filter service is a service that lets us create filtering functions that are used for formatting the data that eventually gets displayed to the user. So let's go ahead and create a function that our view will declaratively call when the text box loses the focus. So for now, we'll just go ahead and call it $scope. We need to put it on the scope service since we need to be able to expose it to our view, and we'll call it upper. And upper is a function. We don't need a name. Put a semicolon here. And the first thing we'll do is we'll create the uppercase function using the filter service. We'll call it upcase, and that's the name of a function. And we'll call filter, and we'll just call it uppercase. That's the type of filter we want to get. And once we have that upcase function filter, we go ahead and say scope.name equals upcase. So we're calling that function we just created, and we're passing it scope.name. So at this point, scope.name would have been updated. So the only thing that's left is to go to index.html and go ahead and bind the ng blur, which is when the text box will lose focus, and we bind it to upper. And we'll call upper right here. And we'll go ahead and save it. So let's go ahead and see if it works. We'll go to our text box right here. We'll type Coursera. We'll go ahead and click out of it. And as you can see, once we clicked out of it, the ng blur, which bound our upper function on our scope, went ahead and called this upper function, which updated the name property of the scope service, which of course immediately got updated on our view. So the question still remains, how did Angular know that this is where the filter service should have been injected and this is where the scope service should have been injected? Well, let me go ahead and show you how that's done. First, what we're going to do is we're going to create just a completely irrelevant function to anything. We'll just call it function, and we'll call it annotate me, and we'll give it whatever name, job, and blah parameters. And the function is going to be fairly simple. It's going to just return some string. Let's call it blah. Okay, so now we're returning string blah. And if we were to go ahead and console.log whatever blah returns, so we'll invoke the annotate me function, and it doesn't matter what we pass since we're not using any of those variables anyway, and we're going to save that. Let's go ahead and see what it's going to come out here, and it comes out blah. Okay, so that got invoked. But what happens if we don't invoke it? What happens if you just console.log just the actual function value? Let's go ahead and save that. Look at that console output. It looks like it's just a string, which is the function definition itself. And if we actually do one better, we'll call toString on it. If we save that, we'll see that this is going to be just the string that represents the entire code of the function. Well, what does that mean? Well, one thing it means is that if we take that string and start parsing it, if we're smart enough here, we could go ahead and find the parentheses, find some string, find the comma, yet another string, comma. So what we could do is we could parse it. And the second we see this name here, we could match this name with whatever services we have available and then instantiate those services. Let's say we have a name service, and go ahead and call the annotate me with that service, and we'll know that we need to inject it, or we need to call annotate me with the name service in position 1 as an argument. And we could do exactly the same thing on this DI controller. Let's go ahead and replace this with DI controller. And when we save it, Browser Sync updated our console here, refresh the browser, and you see that the function DI controller now is showing up in its full glory as just a regular string. So what Angular does is it can actually go ahead and parse out these names and find a matching service and then go ahead and instantiate those services and then call GI controller with those instantiations. The service that does all this in Angular is called $inject, and we can actually even inject that service as well. So let's go ahead and do that and see what it can do. $injector, actually, I should say. So let's go ahead and maybe move this down here so it'll be a little bit easier to read. So what can this injector do? Well, we have this function called DI controller. Let's go ahead and console.log and have DI controller. And instead of just logging DI controller, what we're going to do is we're going to surround it with $injector.annotate. So if we call that, let's go ahead and close this and save it, you'll see that our $injector.annotate gave us an array of the argument names to the function DI controller. And this is exactly what Angular is using internally in order to figure out where to inject which services. And that's the magic. The magic has been revealed. Now that we understand how dependency injection works in JavaScript, and in particular how it works in AngularJS, we need to talk about protecting our dependency injection from minification. You'll see why that's necessary in just a minute. First of all, what is minification? Well, minification is the process of removing all unnecessary characters from source code, and what's here italicized here is without changing the functionality of the source code. So it should be clear that minification is going to be the process that's going to make our code completely unreadable, yet at the same time 100% functional as before. In fact, many minification programs actually call themselves uglify, so they uglify the code. So the minification process takes out a whole bunch of things. It takes out white space characters, new line characters, comments. It even removes some curly braces that we use for code readability. So what's the purpose of all that? Well, it's actually pretty simple. It reduces the amount of data transferred from the server. Once all these characters are removed from the JavaScript file, the file itself becomes much, much smaller. By the way, if you want a fun read, if you go to my LinkedIn page, which is linkedin.com/n/Yakov Heiken, and I will give you a link to that as well. You're more than welcome, first of all, to connect with me. I accept pretty much all the invitations from any of the students, but you can also look in my published by me articles, and one of them, if you want to have a fun read, is called Why is jQuery Min Code Such a Mess? Now notice that I did write this on April 1st, 2016. You can also read a little bit about me and what I do, as well as my boasting that the first course, HTML, CSS, and JavaScript for web developers, became #1 top-rated course on Coursera, and it stayed actually there for 3 weeks, and hopefully at the time you're watching it, it still remains a top-rated course. For now, however, let's go ahead and jump into our editor and see how minification can actually ruin our dependency injection and break our application, and what to do about it. Okay, I'm back in my editor and I'm located in the Lecture 10 folder, which is located in the fullstack-course5/examples folder. And this is the same application we've seen before, which basically just uppercases the contents of a text box once it loses focus. So if we click on it and click out of it again, you could see that it uppercased everything inside the text box. Let's go back to our code and actually select the whole thing. We'll copy it. And we'll go to a website called JavaScript Minifier. And you could Google for different minifiers out there, but I chose this one. It's javascript-minifier.com. And what you could do is you could paste your JavaScript code here and click Minify. And this is the Minify JavaScript. And you go ahead and copy that. If we go back to our code editor, we could comment out everything that we have there and just literally just substitute it with this new minified version and save that. And since browser sync is running already, we should be able to go back to our page Oh, look at that. It's not working. Why isn't it working? If we click on this link right here showing us an error, it will give us what the error message is, and it's error something to do with the injector. The injector in the DI controller is not working. Well, the reason it's not working is actually pretty simple. And that's because that $scope and $filter really disappeared. You can't see it anywhere here. And those are the names that Angular was looking for in order to know what to inject into this DI controller that is no longer called DI controller, but if you look closely here, it's now called N. It's the N function. So it just basically minified the entire name DI controller into N. So how do we solve this? Well, let's go ahead and erase this code again, and we'll select all of this code and uncomment it. And to solve the problem, we have a couple of approaches. Number one is, in the controller function itself, the second argument right now is a function value. But the truth is, it doesn't have to be. It can be an array, and it's an array of strings with the last element in the array being the function that is responsible to be the controller function. And in this case, we can actually specify what this controller function is supposed to expect. So if we say scope, and we also say $filter, what we've told Angular is that scope and filter in this order is going to be appearing as the arguments into this DI controller function, which is right here. The first one is scope, and the second one is filter. And the reason we can even have an array like that, which is a string and another string and a function value, is because arrays in JavaScript allow different types to be items in that array. Now, these strings are protected from minification because these are string literals. Similarly, this name Yaakov right here is a string literal, and it obviously will never get minified because it's real data. So the minifier doesn't really know that this is kind of our code data and not the real data, and therefore it will leave this alone. So let's go ahead and try that. Let's select all this, copy it. We'll go back to our minifier. We'll close this. We'll go back to our minifier. We'll select all this, paste our new code, click minify, and now we'll take this whole thing, copy it, go back to our code, comment it out, and we'll paste this new code in, and we'll hit save. And let's go back to our page and see if there's any errors. Doesn't look like it, so we'll click in here, click out. It's working 100%. So that's great, but I think we can improve it a little bit more in terms of style. Let's go ahead and erase all this, and again, we'll uncomment our code. And you should just know that when you look online, a lot of the examples online show you this technique in an even more uglier fashion. And let me show you what I mean by that. So here I'm passing a function value, but I don't have to. I could, if I wanted to, actually create a function right here straight in line and go ahead and specify scope and then specify filter right here in line, and I could just copy the contents of my controller function right here and paste it right there. So that's the same function. In fact, if I save that right now, it should probably still work. Let's take a look, and sure enough it works because now the code that's being executed is inside this function. So I just did this inline as opposed to taking it outside of the statement. And as you can see, it's very hard to read. First of all, we're mixing a whole bunch of things in an array, which is already hard to read. And even though that's legal JavaScript, readability really suffers here. So let's go ahead and undo all this real quick and do one better. Instead of specifying it here, we're going to leave this alone and leave it as it was before without the array construct in the controller call. What we're going to do instead is attach an extra property to the controller function value itself. So what we're going to do is we're going to say di controller dot $inject, and we're going to have that equal first scope and second filter, $filter. And if we do that, one Angular is going to look for this function, is going to also look and check to see whether or not we have a $inject property on the function that is supposed to be the controller. And if it finds it, it will use that array as guidance to see which service to inject into which argument on the controller function itself. So if we save this and go ahead and copy it, go to our minifier, Let's minify that, and we'll copy it again, go back, select this and comment it out, and we'll paste the minified code. And when we save it, let's go back to our web page to see if this works. And as you can see, it worked. In fact, let's uncomment this again. In fact, this is really a much more elegant solution, and the readability improves tremendously. So to summarize, we spoke about minification, which is the process of reducing the size of our JavaScript. And the way minification works is it removes extra characters, which are actually very important for us when we read the code, but completely irrelevant for the JavaScript engine when it runs it. And therefore, it's advantageous to actually minify your code, especially when you go to production, because the size of the file is going to be smaller, and therefore your web page will load faster because it will download a smaller file size. So the lessons learned from that is that dependency injection in Angular needs to be minification proof. And the way to do this is a couple of methods. Number one is we can have an inline array with function as the last element in the array. That works. But a more elegant way is to attach a $inject property to the function object that is being injected into. And Angular will look for that $inject property and will use that $inject property, or I should say the value it, which should be that same array we spoke about minus the last element as the function, just the array of the names of the arguments. It will use that as a guide to know where to inject which service. In this lecture, we're going to speak about expressions and interpolation. Now, what is an expression? Well, an expression is something that evaluates to some value. And in Angular, we've seen expressions already, and those are the things that sit in the middle of those double curly braces, or handlebars or mustaches, however you want to call those. Now, expressions are processed by Angular, and if you have to think about them, they roughly are similar to the result if you call eval on some JavaScript, except it's different in certain very key ways. Number one is it's executed in the context of the scope, and that's the scope, the $sign scope that we've been referring to, and it has access to properties that are placed on the $sign scope. Also, if the expression evaluates and results in a type error or a reference error, it does not throw those errors, it simply displays an empty string, an empty value. Also, unlike the eval statement, control flow functions like if statements and so on are not allowed inside of the Angular expression. It can also accept a filter or a filter chain to format the string output in a certain way. And we're going to take a look at filters in a later lecture. Now, the term interpolation is very computer sciencey, fancy speak for process of evaluating a string literal containing one or more placeholders which are then replaced with real values. So you have a string that has some sort of placeholders in it. You could parse that string, find those placeholders, and replace those placeholders with a value that corresponds to whatever that placeholder name is. So for example, in Angular, this string, messages with curly brace, double curly brace message, provided that the message is equal hello, the message property is equal hello, is interpolated into this string, which is message is hello. And one important note here is that message variable of that message property is still connected to the original message property that's sitting on the scope. And if the scope, $scope message changes in any way or by some other process, so will the interpolation result change as well. Let's jump into the code editor and see some examples of this. Okay, I'm back in my editor and I'm located in Lecture 11 folder in the Full Stack-Course 5 Examples folder. And here we're dealing with a very similar setup. We have an index.html, we have app.js, which is going to drive our app, obviously angular.min.js. So let me go ahead and close the file browser of Atom. That way we could see this a little bit better. Okay, so let's take a look at what we have here. So we've set up the application at ng-app, and the name of our app is message, MSG app. And we also have one controller, ng controller, that's called MSG controller, and it's controlling this piece of HTML right here, which for now just says message is with a break tag. In our app.js, we obviously created our module with our message app, and we've registered one controller with the message controller function as the driver for that controller. And in order to protect ourselves against the minification of this code, we're going to attach a $inject property to the function object that is our controller. And for now, all we're doing is we're placing a name property on our $scope service, and we're just gonna have that as a string Yakov. So we've seen this interpolation before, and at least the evaluation of this expression before. If we go to our HTML, we could just say double curly braces name, save that. Since I have my browser sync working already, it will just go ahead and update it. Message is Yakov. But we can do more than that. We can also define a method or a function that is going to be attached to our $scope service that is going to be exposed again for us to be able to use inside of an expression. So let's go ahead and define a scope.saveMessage, and that's going to be a function. We don't need the name. Let's put the semicolon right here. And it's just going to return Yakov likes to eat healthy snacks at night. Exclamation point. We'll put a semicolon here. Okay, so once that's done, we could go to index.html, and here we could say message, and we have to put the parens behind it because this is a function we want to execute that. And if I save that, you'll see here now it says Yakov likes to eat healthy snacks at night. So believe it or not, what's really going on here is that Angular is evaluating the strings that are right here between the beginning of controller and end of controller, and it's interpolating them. In other words, it's looking for these placeholders, and it goes ahead and evaluates them. In this case, it's evaluating a function call. So if you take a look at the page source, not the actual dump, but the page source, you could ignore this document.write because that's just an injection that browser sync does for you, so ignore that. But if you look at the page source, you see our ng controller, and you see it's in original state here, same message with those curly braces. But if we close that and look at elements and look at our ng controller right here, you could see that it's really two strings, messages BR and Yakov likes to eat healthy snacks at night, two strings concatenated together. And that's how we get our Yakov likes to eat healthy snacks as one string together with this messages. And we can obviously concatenate more than one placeholder. So for example, instead of messages, we could say something like name has a message for you, colon, and we'll save that. And now we'll say Yakov has a message for you, and Yakov likes to eat healthy snacks at night. And you could see here that we concatenated all these strings together to form the contents of the body of this div. Now, I also told you that if you place something that throws a reference error or a type error, it will just print nothing. So let's go ahead, instead of save message, we'll go ahead and put some nonsense in here that doesn't really exist, and we'll save that. As you can see, there's no errors thrown, and it's completely blank. And in fact, if we look at the elements, you'll see that there's just nothing there. It evaluated to an error. Obviously, this is an error because there's no such property sitting on the scope. And since this is a type error, or maybe it's a reference error, I can't remember, but I think it's just a type error. Either way, it's not going to output anything. It's just going to leave it as blank. And if we change it back and finally have something that does evaluate to a method, to a function on the scope, you could see that it's back and browser sync updated for us. Yakov likes to eat healthy snacks at night. So to summarize, we spoke about expressions in Angular, and an expression is something that turns into some value. And in Angular, it's denoted by double curly braces, or some people call them mustaches, and some people call them handlebars. Angular expressions are also tied to the scope they're in. So whatever the scope that you are currently located in within your HTML, or the piece of the HTML page you're in, the expressions in Angular will feed off of that scope. And also, the important point is the expressions in Angular don't display type error or reference error to the user, which is very helpful because if there's such an error, you certainly don't want that showing up right in the HTML page. We also spoke about interpolation, which is basically a process that takes these placeholders in a string literal and replaces them with some values. In Angular, these placeholders are usually expressions, and the result is automatically updated when the placeholder value changes. So if anything changes that property on the scope, the result of that expression in the HTML page will automatically be updated by Angular. In part 1 of this lecture, we created this message app that was able to use interpolation and expressions in order to output some messages that we set on the $ scope inside of our controller. What I'd like to do now is show you something a little bit more fun, but at the same time demonstrate that the expressions don't necessarily have to go only in the body of tag. They could also be part of tags themselves. And using that technique, you could actually achieve something pretty neat. So I'm still located in lecture 11, folder 11 in the full stack course 5 examples folder. And the only thing that I added is I added a couple of images. One is called Yakov_fed and the other one is called Yakov_hungry. Both of them are PNG files, so they're images. So what we're going to do is we're going to go ahead and create a div. Notice that our div is sitting inside our div that is annotated with attribute of ng-controller. It has to be inside if we were to communicate with that particular controller's scope object. And the only reason we're making a div here is just to separate visually these messages from what we're about to do. So what we want to accomplish is have an image displayed in the web page that is going to be something like Yakov that's hungry, and then we're going to have a button that says feed Yakov, and when you click that button, the image should flip to the other image that's Yakov fed. In other words, Yakov has been fed. So we're going to start with creating a button, and the button is just going to say feed Yakov. And on click of that button, we want to do something. But since we want the Angular and the controller to handle this on click, so we're going to say ng-click. So on ng-click, we want some functionality to occur, meaning the flipping or the changing of the image. So we'll just say feed Yakov, and that's going to be our function that we're going to have to implement. And so far, so good. So we'll go ahead and put maybe a break here. And usually I would style this very well, but since we're concentrating on functionality, right now, ugly web page is good enough. And now we need to have a placeholder for this image. So we'll say img, and the source, we'll leave the alt for now out of this. And the source is going to be images, since the images are located in images, and slash Yakov underscore, and here's where we don't know which image to display yet. We want to display the image that is kind of Yakov's state, right? And Yakov probably originally is hungry and then he's fed, but we don't know that. So we need to put our expression here, and that's what we're going to do. Here we're going to say state of being. What is Yakov's state of being? And of course, after that, since it's going to get concatenated, or otherwise known as interpolated here, we need to put the period and PNG. So it'll be Yakov underscore, if the state of being is fed, then it'll say fed.png, or hungry, it'll say hungry.png. So let's go ahead and take a look at our web page, and you can see the feed Yakov button is here, and we're getting an error here, and kind of makes sense since we don't really have an image yet, because it's just an expression and we haven't really set those variables on the $ scope yet. So let's go back to our code editor, and we need to define the state of being property and also define the function called feed Yakov. Let's go ahead and go to app.js, and we'll go ahead and add another property on scope called state of being, and we'll call that hungry. So that's the first state of being. We'll put another space in here. And if we save that and go quickly to our web page, you'll see that the image now is showing up. So we have the image, that's the Yakov underscore hungry image that's showing up. You'll see that we're still getting this 404 error, and because it can't find the image, and that's kind of strange, but we'll take a look at that in a minute. Let's go back to our editor and still need to define the message, because if we do this right now, let's go back. If we do this right now and click feed Yakov, nothing is really going to happen because we don't really have that defined yet. So let's go back to our editor and define the function feed Yakov. We need to obviously put it on the scope. So we'll say feed Yakov, there it is popping up here, and it's a function. We don't need the name. We'll put a semicolon here. And all we really need to do is switch our state of being variable to be fed after it gets clicked. So let's go ahead and say scope.stateofbeing is equals fed. So we save that. Let's go back to our browser. So let's minimize this a little bit more. And so when we click feed Yakov, now the different image shows up. Obviously Yakov looks all happy and the cookie is almost gone. But what's strange here is if you take a look at our console,
we're still getting this error that it's not found. So this image is not found. Now, why is this image not being found? Well, actually, that makes 100% sense. Because HTML gets processed sequentially. And when this HTML page is being processed line by line, by the time it gets to this image, the line, and processing the image, our state of being is not yet defined yet. In fact, AngularJS has not yet processed this chunk of HTML and hasn't yet looked for these placeholders and substitute these expressions with values. So what ends up happening is that the browser gets this line and tries to fetch this image at this URL. And of course, this is a bogus URL if it still has those mustache and curly braces in it, and therefore it gives you a 404. But once, of course, Angular takes care of this, it substitutes this URL for the proper one, and then we still see the image, but yet the 404 error message remains in our console. So how can we take care of this? Well, we cannot take care of this using regular HTML tricks, but we can take care of it using Angular. We need somehow to tell the browser not to try to fetch this URL, but at the same time fetch it only when Angular is ready for interpretation of these placeholders. Well, one way of doing it is to put an Angular attribute on here instead of the standard HTML one. And the Angular attribute is just ng-source. So if we save that now, go back, you'll see that there's no errors anymore because the image only got fetched once Angular got a hold of this HTML and translated all the expressions into their values. And now if we refresh the page again just to make sure, even though browser sync is working here, now you see Yaakov with a cookie, and if you click feed Yaakov, our state of being variable that is saved on the scope, on the $sign scope, will change its value to _fed. And now Yaakov is happy because he ate almost a whole cookie. So what we've seen in this part of the lecture is really nothing super new, but you've seen another expression or another idea of how to use expressions, and since you could use expressions even inside the attribute values, you can achieve pretty interesting behavior that otherwise would be pretty difficult to implement.
Congratulations, you've completed Module 1. I don't know if you realize this or not, but you can already build simple AngularJS applications. More than that, you now understand the why behind some of the Angular features you've learned. That will not only enhance you as a software developer, but will also help you appreciate and retain the information we're learning. As a side note, go and like this course's Facebook page at facebook.com/Coursera WebDev. That's a good way to connect with me, and I'll be posting some optional content on that page as well. I'll provide the link to that below the video. By the way, if you already really like this course and want to give it a 5-star rating, go ahead. I promise I won't complain. Fun, however, is far from over. So see you in the next module. Welcome to Module 2. We will start this module by learning how to use Angular filters to manipulate the data into the format we want and learn how to create our own custom filters. We will then dive deep into the digest cycle, which is the process AngularJS uses to magically update our web page with the bound data from our view model or the controller. Understanding this process is crucial to getting comfortable with AngularJS. We'll also see some cases where we'll need to assist that process somewhat and understand why that is. After that, we'll learn one of the most fundamental concepts in the JavaScript programming language, which is prototypal inheritance. Clear understanding of that topic is a must before we talk about inheritance between AngularJS controllers in our application. We'll finish off the module by learning how to create our own custom Angular services as well as how to configure them. With custom Angular services, we'll be able to share data across different controllers or other components in our application. We will also learn a few useful Angular directives that allow us to place looping and conditional logic directly into our HTML. You'll see that by the end of this module, you'll have the skills to create a fairly sophisticated web application that starts to use some of the more advanced software architecture techniques. So have a seat, grab a bag of cookies, and I'll see you in the module.
In Angular, you could use a special construct called a filter to change the output of an expression. And you could do that either in HTML or in JavaScript. So here we have an example of a filter being applied to some value, and it's an uppercase filter, which means whatever the value is, it will go ahead and take that string and uppercase it. Angular supplies us with some predefined filters, like the one you see uppercase. There's also lowercase, currency, number, etc. Obviously, we would need to inject the filter service, in other words, $filter, in our controller first so we could use that in our code. So the filter service is a filter function creating service. So in other words, this part of the statement creates a filtering function and then it gets executed using the parens right after it. So we just put the whole thing in one line, but really could have created the filtering function first and then called it with the parens value. Filtering functions sometimes have custom arguments that change the way the filtering function is filtering or changing the expression output. To change the way the filtering function changes the output, you pass it custom arguments, and the arguments are specific custom arguments to each particular filter. So in this case, we see the currency filter, and you could pass it a couple of arguments, which we'll actually see in examples when we jump to the code editor. A really neat feature in Angular is that you could also use these filters straight in your HTML file, just by placing a pipe between the output of some expression and the name of the filter. Now, obviously, the expression doesn't have to be a string literal as I placed here in this example, but it could be anything that is a $scope.value, whatever the value would be, which in this case will evaluate to hello in the controller. So you can attach a value to the scope service and then just output value right here instead of a string literal hello. And as I said, when you place an expression followed by a pipe and the name of the filter to apply, the output of this entire expression will be hello in all uppercase. We could likewise apply custom arguments inside the HTML as well. All we have to do is separate those custom arguments by a colon. So in this case, you see the currency filter is being applied with some custom arguments separated by a colon. Let's jump into the code editor and see some examples of this. So we're back in our code editor, and I'm located in lecture 12 folder, which is located in full stack course 5/examples folder. And since my browser sync is already started, I can take a look that my same app, basically a copy with feed Yakov1, has this message that we keep outputting from a method called Yakov likes to eat healthy snacks at night. Well, let's go ahead and in our app.js change this phrase, Yakov likes to eat healthy snacks at night, to all uppercase. And the way we're going to do that is we're going to use the filtering service. So the first thing we need to do is we need to augment our $inject property that we placed on our message controller. And we'll go ahead and do that and tell it that we're also going to inject a filter service. And obviously we actually need to go ahead and place the filter service so it gets injected properly. So now we're done. What we could do is we could create a var called message. I'll just call it for short MSG. And we'll just copy this whole thing and make that the message. Let's go ahead and copy that. And what we're going to do is we're going to use a filtering service to create a filtering function that will uppercase everything. But we'll go ahead and apply the message as a value to it at the same time. So we'll go ahead and say output. And now we need to create the filtering service. And the filtering service will use uppercase filter. And once we have this uppercase filter function, we can now execute it with our message as the argument. Now that we're done, we have to substitute this with our output. So that's going to be the output. We'll save it, go to our HTML page, and as you can see that everything now is in uppercase. So the question, of course, is how did I know? Where did I figure out this uppercase? Where did that come from? Well, let's go back to the browser and go to angularjs.org. And if you go under develop and developer guide, you'll see that a whole bunch of different topics here. One of them is filters. So if we click on this filters one, it will explain you a whole bunch of things about filter, but one of the things it will link to you is Angular comes with a collection of built-in filters. So let's go ahead and click on that. And you could see the names of all these built-in filters right here. And one of them is uppercase, as we've been using. And if you click on it, you'll get some documentation as to how to use it in JavaScript, which is what we did just now, and how to use it inside of an HTML template or inside of HTML. So let's go ahead and back out of this for a minute and go to the currency filter and take a look what we have available here. So the currency filter can be applied just like we applied the uppercase filter, with the first argument being the amount, then the symbol like a $, and then the fraction size like 0.00, 0.000, and so on. Let's go ahead and use this documentation, but let's use the HTML version of it and create a little line that will show us the cost of the cookie Yaakov is eating. So let's go to the HTML page, and right after the button right here, we'll go ahead and say cost, and we'll give it an expression. Let's say cookie cost, and we'll give it a filter of currency, and we'll just leave it like that for now. Of course, nothing is going to work yet since we didn't define what the cookie cost is on our scope service. So let's go back to the app and let's define the cookie cost. Let's go scope.cookie cost, and let's give it 45 cents, 0.45. Notice we're not giving it $45 or $0.45 as a string. We're giving it as a real number, so we can actually do then, let's say, some cookie calculation or something. If I'm eating 100 cookies instead of just one, it's possible if I try hard enough. So now that we've defined the cookie cost on the scope service, we could go to our web page and see that it updated with $0.45. So it knew to insert a 0 to that string, to keep the period, and then 45 and put the $sign in front of it. So let's customize this a little bit, and instead of the $sign, let's create a sign for my own currency, which I'm obviously going to make up, and we'll also extend the 45 to have a couple more zeros afterwards, so because my own currency is super exact. So if I go back to my editor and go to my HTML page, so I can use the colon to supply its first argument, or its first custom argument, which is the currency sign, and in my case it's going to be number sign blah. But we also wanted to extend the 0.000 and make it as exact as 4 decimal places instead of just 2. So we'll put another colon there, and we'll put number 4. We'll save that, we'll go back, and you can see now the cost of this cookie is number sign or hash sign blah 0.45, and we're going now to 4 decimal points instead of just 2. And all our previous functionality obviously still works, so let's go ahead and feed Yaakov just for fun of it. Cool.
Previously, we saw how to use a filter that Angular supplied out of the box. But that's not always enough. So in this lecture, we're going to learn how to create our own custom filters. There are a few steps in this process. First, we need to define the filter factory function. And just like it sounds, this is actually an example of a factory design pattern. A factory is a central place in your code that produces new objects or functions. In our case, this factory function, called custom filter factory, produces our filtering function. For the whole filtering mechanism to work, Angularjs expects us to create a factory that produces the filtering function. At a minimum, the filter function itself takes some input as an argument and then usually returns some manipulated version of that input, in other words, the filtered output. The second step in the process is to register the filter factory with our module. And we do it in a very similar way that we register controllers. For controllers, we call .controller on the module, and we give it a name and a function that's responsible for the controller. And for the filter, we call the filter method on the instance of our module, specifying the name for our filter and referencing the filter factory function that's responsible to create our filter functions. Now, the name of the filter must be a valid AngularJS expression identifier. A safe bet for naming the filter is to use anything that would be a valid variable name in JavaScript. The name of the function itself, which in this case is custom filter factory, can be anything you want. There's no correlation between the name of the function and the name we register the factory with in AngularJS. However, it's nice to name it similarly so you don't get confused down the road.
We now need to inject our filter into whatever construct we're planning to use it in. In this example, we're planning to use it inside of a controller, in other words, directly in the JavaScript itself instead of the HTML, so we need to inject it into the controller function. And we do it in the usual way we've done before, which is add one more value into the array on the $inject property of the controller function, and then specify that as an argument in the same position when we define the controller function. Obviously, the whole point of injecting a filter is to eventually use the filter, so in the last line you could see that we're using our custom filter, passing it our message as the input. Notice that the name of the filter we're injecting is not the name we registered the filter factory with. In fact, the name we use is the originally registered name plus the word filter, just as shown in red. Also notice that unlike the filter service that we've seen before, calling custom filter actually calls the filter function. If you recall, calling the filter service doesn't actually call the filter function, but simply creates the filter function for us. These two facts are not a coincidence. Let's go back for a moment. Remember, when we register our filter, what we're really registering is a factory that creates our filter function. On the other hand, we've seen before that when you call the filter service, specifying filter function you want to instantiate, like uppercase for example, the filter service calls the uppercase filter factory, which is already supplied by Angular, to create the uppercasing filter function. Having gotten the filter function, you can execute it with a supplied value. However, when we're injecting our custom filter straight into the controller, Angular calls our registered filter factory for us, for example, custom filter factory, and allows us to inject the product of that factory or whatever that factory returns, which is our actual filter function. In the process, Angular names the actual filter function we inject using the name we registered our factory function plus the word filter appended at the end. So if we registered a factory function called custom, AngularJS will execute our factory to create the actual filter function and name it custom filter, appending the name filter to the end of the registered factory name. As a side note, it's probably therefore a bad idea to register your custom filter factory with the name filter at the end of the name. So for example, if you registered the custom filter factory function with the name custom filter, Angular would append the word filter to that, and you would be forced to inject it with the name custom filter filter. Kind of awkward, so avoid that. Whew, that was a lot of background detail, but it does help you understand what's going on so you're not memorizing strange rules. But that was a lot, so if you didn't get it all on the first try, I suggest you go back and rewatch this part again. For now, let's review the essential steps again. The first step is to define our filter factory function. This is the function that creates and returns an instance of our filter function. The second step is for us to register our filter factory with the module, and we do that with calling the filter method, giving it the name of our filter, and specifying the filter factory function that is responsible for creating our filter function. The third step, at least if you're trying to use your filter directly inside of JavaScript, like in a controller or something similar to that, then you need to inject the filter with the name of the filter that you registered it, plus the word filter attached to it, as in this case, custom filter. Now in part 2 of this lecture, we're going to jump into the code editor and see these concepts in action. In part 1 of this lecture, we went over the process of how to create custom filters. In this lecture, we're going to go ahead and implement some of the custom filters in the application that we've been dealing with so far. So as you can see here, one of the messages we're returning from our controller is Yakov likes to eat healthy snacks at night. So let's bump it up a bit. Let's not say likes, let's say love. But in this case, we want to replace the word likes with loves using a custom filter. So let's go to our code editor, and the first step is to create our filter factory function. So let's go ahead and see where the controller ends, so we could put our function right underneath that. And we'll call this function loves filter. And since it's a factory function, it needs to return another function, and that function is going to take an input, and we need to put a semicolon here. And basically the first thing we're going to do is make sure that our input actually exists. So we'll say if it's input, or if it's not there, we'll just give it an empty string. And then we'll just replace the input by saying input.replace, and we'll replace the word likes with the word loves. Okay, and then obviously we need to return that newly created input. So far so good. Now we need to register our factory filter with the Angular application. So let's go back up, and instead of terminating the controller, we'll do one more statement. We'll say filter, and we want to call it loves, and give it our factory function, which is loves filter. Okay, so now we need to use this loves filter. Since we already have a function called sayMessage, we'll go ahead and copy that, and we'll create another one called sayLoves, or maybe sayLovesMessage. Okay, and in this case, what we're going to do is we're going to apply our filter. But before we can do that, we need to inject it into our controller. So we'll go ahead and append one more array item into the $inject array that's attached to our controller function, and we'll call it loves filter. And remember, this loves comes from the filter name, and the filter is going to be appended by Angularjs for us. So we have to name our filter loves filter. And we also need to give it as a second argument, since we placed it as a second item in the array of the injections. Okay, so now it's loves filter here too. And now we could use this loves filter inside of our say loves message. So what we're going to do is we're going to take this message, and we're going to call loves filter, pass it this message, and actually we'll just override the message using that, and that will return the message. So far so good. If we go to the index.html, we'll see our original message, which is right here. Let's call it original, and we'll put a break here. It's a little ugly, but it will do. Loves message will be similar, but this one will say loves message, and we'll give it a parent, so we'll execute that function. So when we save it, and since my browser sync is already working, I'll go to my browser. As you could see, love says Yaakov loves to eat healthy snacks at night. So far so good. And in this say loves message, what we ended up doing is using a custom filter inside of our JavaScript. And in part 3 of this lecture, we're going to take a look as to how to create custom filters with extra custom arguments, as well as how to use our custom filters straight inside the HTML template.
In the previous lecture, we saw how to create and use a custom filter with just the input expression as the argument and no additional arguments to the filter function. In this lecture, we're going to go over how to create a custom filter that accepts additional custom arguments as well. The process for that is pretty much the same as before.
The first thing you need to do is to define the filter factory function, except this time what you return is a created filter function with some additional arguments, besides the very first one, which is the input. The second step is exactly as it was before. You registered the filter factory function, except this filter factory function is the one that's now returning a filter function that has custom arguments besides the input attached to it as well. So in this step, there is no change. The third step is fairly similar as well. You have to inject your filter into your controller or whatever other JavaScript construct you're trying to inject it into. And obviously when you use the filter, you wouldn't just give it the input, which in this case is message, but you would also give it some additional value that would correspond to that extra custom argument. In this case, it's a string literal called someVal. We can also use our custom filter directly in our HTML templates. The process for creating such a filter is exactly the same. The only difference is the last step when you actually use it inside of an HTML template instead of inside of your JavaScript. You still have to create your filter factory function and then register it with the module. The name you register the filter factory with the module is the name you use inside of your HTML template. You do not append the word filter to it. And since we're inside HTML, there's no need to inject the filter into the controller at all. Angular takes care of these references for you automatically. Now, if you need to use extra custom argument inside of your filter inside of the HTML template, you simply follow the name of your filter by a colon and an argument, and then another colon and another argument, and keeps going until you satisfied all the arguments that you have in your custom filter. You can also chain filters by simply separating them with a pipe character, which will make the result of one filter be the input to the next one in the chain until the very last filter, which outputs a result that's displayed directly to the user. Now let's jump back into our code editor and see these concepts in action. Okay, so we're back in our code editor and we're exactly where we left off from the previous part. Well, let's create another filter and then use it inside of HTML. And since Yakov loves to eat healthy snacks at night, it's not exactly 100% accurate. Let's go ahead and create another filter. We'll start by creating the filter factory function, and we'll call this one function truth filter. And since it's a factory function, we'll need to return again a function, oops, not the fun, but the function. And this time, let's go ahead and specify some custom arguments. I will call one target and the other one replace. I want to be able to let the user of this filter specify what the target string is and what we should replace that string with. And it's easy enough to code up this function because it's exactly the same as this one. We'll just copy and paste right here. And instead of likes and loves, we'll just say target and replace. We'll save that. The next step is for us to register our filter factory with the AngularJS module. So let's go up again. And again, we'll, instead of terminating that line, we'll continue it. We'll say another filter. And this filter is going to be called truth. And the name of our factory is truth filter. We'll save that. And since we're going to be using it inside of HTML, we don't really need to inject it inside of our message controller. We could just jump straight to the HTML and start using our truth filter. Let's go back over here and let's create another BR and we'll say truth. And we'll say again, say loves message. And this time, since we're using the filter inside of HTML, we'll specify it using a pipe and the name that we'll register our factory function with, which is truth. And since we need to not just give it the name, but also the arguments that what we're looking for, the first one was target. And in this case, we'll say healthy. And the replace string will be at another colon and will be cookie. Let's put a space here. So when we save that and go back to our HTML page, we'll see now the truth is Yakov loves to eat cookie snacks at night. Much closer to the truth. But we're not done yet. It turns out that in Angular, you could do something even cooler than that. You could actually chain these filters one after the other. So let's go ahead and put another break right here. And we'll say big truth. Big truth. And in this case, what we're going to do is we're going to copy the same line that we had before, right here. We'll paste it right here. But instead of stopping at this replacement filter, our custom replacement filter truth, let's put a pipe over here, one more pipe, and we'll say uppercase. We'll call the uppercase filter right on the output of our truth filter. So now we're chaining our filters. There's one, there's actually a filter inside of that switches our message from likes to love. Then the truth filter kicks in and filters that message and takes out healthy with the word cookie. And then the uppercase filter should take whatever the output of this truth filter is and uppercase the whole thing. So let's go ahead and save that, go to our HTML page, and sure enough, the big truth is Yakov loves to eat cookie snacks at night. And he's looking a little sad, so let's feed him. That's much, much better. So let's summarize. We went over the steps to create a custom filter. The first thing you need to do is to define the filter factory function. That's the thing that is going to create the function that is actually the filter. Then we take that filter factory function and we register it with our module. Now, to use our custom filter in JavaScript, we simply need to inject the filter function registered name with the word filter attached to the back of it into our controller or some other construct that we're trying to use it in inside of our JavaScript. The registered name is the name you registered the filter factory function with. To use it inside HTML, we don't need to inject anything into the controller. We simply take an expression followed by a pipe and give it the name of our filter, and that's again the registered name that you registered the filter factory function with in the module. Now you can also create custom filters that take some extra arguments besides the actual input that the filter will work on. In order to do that, all we have to do is really specify those extra arguments on the actual filter function that we specify inside of our factory function. Otherwise, the steps for the rest of the procedure is exactly the same. It's the same registration and the same injection if you want to use it inside of your JavaScript. To use a custom filter with extra arguments inside of your HTML, all you have to do is follow an expression by a pipe with the registered name of the factory function, followed by a colon and an argument, colon and an argument, and so on. One of the really neat features in AngularJS is that filters can be chained. In order to chain the filters, you take an expression followed by a pipe, followed by the filter name, followed by another pipe, and the next filter name. And the result from one filter becomes the input into the second filter, and the result from the second filter becomes the input into the third, and so on.
AngularJS may seem a bit magical at first. How does it know how to update some part of the web page when I type something into a text box? Let's pull back the curtain and see a bit of how this magic works. It's always easier to understand how to use something when you understand how things work behind the scenes.
We've seen this code setup before. You declare some property using ngModel attribute on an input element. Now, when the user types something in, the interpolation of the name property in the div below is magically echoed. So how does that work? Let's take a look at a diagram to understand the process, and then we'll jump into the code and try it out. We're familiar with the event queue. When a user clicks something or types something in, those click and key press or up events go onto the event queue. If inside the Angular application you use the regular method of catching those events and handling them in a regular JavaScript fashion, the Angular app will not know that anything happened in our page. However, the process is a bit different if we use the special directives, as they're called, like ngKeyApp or ngClick, which are events that are synonymous with the regular click and keyApp events. When we use ngKeyApp or ngClick, those keyApp and click events will be handled by some handler that we bound to those events in the Angular context. In other words, those handlers that are declared on the $scope or the scope service. But things don't stop there. The Angular context or the $scope has a special array of watchers that goes through every property on which a watch has been set up to check if any of the properties have changed as a result of the event that just happened. Angular kicks off that process with a special function called $digest. There are a number of ways to trigger Angular to automatically set up these watchers for the properties we've defined on the $scope. One that we've seen already is when you surround a scope property with double curly braces in your HTML. Another is when you specify ng-model equal to some scope property. In both circumstances, Angular will set up a function to watch for these changes to those properties. That function is called a watcher. The digest goes through all the watchers and checks that everything is unchanged. If truly unchanged, the loop ends. If something has changed, Angular goes through the whole list of watchers once again. This keeps repeating until all the watchers report that no changes occurred. So most of the time, this loop runs twice. Once to detect that something changed, and another time to make sure nothing is changed. The iteration over the watchers is called the digest loop, and the whole procedure is called the digest cycle. So why does the loop have to run yet another time to verify everything is unchanged? Well, that's because one change can trigger something else to change, and the digest cycle won't be able to detect it on the first try. So for example, the change to property number 3 may trigger something that changes the value of property number 2. If at that point Angular already checked property 2 and didn't see any changes, it won't know that it actually changed until another time through the loop. This process is actually very common in game development and is called dirty checking. Once the final digest loop runs and verifies that nothing has changed in any of the watchers, Angular updates the DOM with whatever values have changed, repaints parts of the page, and you see the updated page in front of you. Well, that's enough theory. In part 2 of this lecture, we'll jump into the code editor and see these concepts in action. In part 1 of this lecture, we saw how the digest cycle works in theory. In part 2 of this lecture, we're going to dive into the code and see a bit of a practice of how this actually gets implemented. I'm located in lecture 14, which is located in fullstack-course 5 examples folder. In here, I have a very simple AngularJS app set up. It's called counter app, and I have one controller called counter controller. So far, all we have really in our page is a button that has an ng-click bound to this function called show number of watchers function. And if we go to the browser, nothing's actually going to happen because we haven't implemented that function yet. So let's go ahead and go to app.js and see that we already have the stub for this function here. And for now, all we'll do is we'll do logging of just the scope itself, the scope service. If we go back to our page and click number of watchers, you'll see that the scope service or the scope object was output in the console. So let's take a look inside of it a little bit. So one of the things we see here, you could see our show number of watchers function, but there's something else here. You see $$ watchers, and that's an array that at this point is simply null, and you see another $$ watchers count, and that's a count of how many objects are there in this watchers array. And you can see right now it's still 0. Now the $, the double $, is always indicative of something that is internal to AngularJS, which means you should never interact with this directly. However, in this lecture, we will interact with it directly just to see what is going on behind the scenes. Since we don't really need this entire object, we just need the number of watchers count, we'll go ahead and modify our code to say scope, $scope dot $, watchers count. And maybe we'll even put a little label here, number of watchers. Okay, so if we save that and go back and click this button now we see number of watchers is 0. For now, let's go back to app.js and declare a property on scope called onceCounter, and we'll equal it to 0 to start. In our index.html, we'll create a button, which I cut and pasted from before, that is going to have an ng-click bound to it with a function called countOnce that is obviously has to sit on the $scope. So let's save that. We'll copy this and we'll go back to our app.js and we'll actually create this function on the $scope. We'll create countOnce, and that's going to be a function. We don't need the name. And all that function is going to do is assign 1 to our once counter. When we save that and go back to our browser, you see that before we click the number of watchers at 0, after we click once counter, so now our once counter is equal to 1, we click the number of watchers again and it is still 0. So that didn't really affect the number of watchers we have. To set up the watchers, there's a couple of ways to do that. One way of doing it is doing it manually. For that, there's a special function on the scope service called $watch, and it takes 2 arguments. The first one is the name of the property we want to watch. In this case, it's onceCounter. And the second argument is the function that is going to watch these arguments, which has 2 values, new value and old value passed to it by the Angular context. So if we go ahead and log that now, we'll say old value, and it's old value, and we'll do it again and saying this time we'll say new value, new value. If we save that now, so now we've set up a watch for our once counter. If we go back to our app, you'll see that the second we refresh the page, we already see the old value being 0 and the new value being 0, meaning something already has executed one of our watches. If we click the number of watches right now, you'll see that the number of watches is now no longer 0, it is 1. And if we click the up once counter, you'll see that our watch gets triggered and the old value is 0, but the new value is 1. If we click the number of watchers, still 1. And if we keep clicking this up once counter, you see that nothing else is showing up. Well, the reason it's not showing up, the reason the old value and the new value is not being printed out anymore is because we only update this once. And once we update it once, our watch no longer sees the once counter as changing, and therefore this function is no longer firing. However, we could declare another property and we'll call it scope.counter, and we'll also start it with a 0. And this time we'll create a handler that when a button gets clicked, this property gets incremented by 1 every time. So let's go ahead and place this right here. We'll say scope.appCounter equal to a function. And again, we don't need the name. We'll go ahead and say scope.counter, and we'll say just plus plus. Let's save that. And then let's provide another button right here. We'll just copy this one. And this time we'll say appCounter. And we'll say increment counter. We'll save it. Let's go back to our page. As you can see, the once counter, when it got initialized, got its value of 0 and a new value of 0. Before there was no value. And if I say increment counter now, you'll see that nothing's really going on the page. And if I say number of watchers, it's still 1. Well, that's because we haven't really set up a watch for counter number 2. Let's go back to our app.js and actually set up a watch for our counter property. We'll go ahead and just copy that watch. We'll paste it. In this case, it's just going to be just counter, and we'll see its new and old value. Let's save that. And now you see the old and new value being printed out twice. We probably should differentiate and say this is counter old value and counter new value so you could see better. And this is once counter old value and once counter new value. Let's save that. And now you could see that once counter old value, once counter new value, counter, and then counter new value. So if we click the number of watchers now, you'll see that now there's number of watchers is 2. And if we increment the counter, you'll see the first time it says counter old value 0, 1. Click it again. Now it's for old value 1, 2. And if we keep clicking, it's going to keep changing every single time. So in part 2 of this lecture, we've learned how to set up watchers manually using the $watch function. In part 3 of this lecture, we'll see a couple more mechanisms that let us tell Angularjs to set up these watchers for us.
In part 2 of this lecture, we've set up watchers using the $watch function. But that's not the best way of setting up watchers inside of the controller function. Angularjs has a more automated way of going about it, which we will take a look at now.
Now, the way we've set up these watches is actually not a recommended way at all. You should never have these $watch functions executed inside of your controller. And the reason that is that controllers and the templates or index.html already have mechanisms that automatically set up these watchers for us. So how can we do this? Well, one way you could do this is let's go ahead and comment this out and save that. Let's go to index.html and we'll just open up another div right here. And inside the div we'll say once counter and we'll say interpolation with once counter. And we'll put an ugly break here, but that will work. We'll say regular counter, and again, we'll say just counter. So now when we go back, even though we don't have any more watchers that are at least manual watchers set up, if we go back to our HTML page and go ahead and click number of watchers, you'll see the number of watchers is still 2. And as we keep Doing the once counter, you see, will never change, but it changed once. And the increment counter, as you can see, is going as many times as we want as we're clicking our increment counter button. Now, there's a really cool trick to actually kind of tie into the digest loop and to see when it's actually getting executed. So far, all we've seen is how our watch is being executed. But what about the digest loop? Well, the way we could do is the following. If we say scope.$watch, and now instead of giving it a real property over in our scope, we'll give it a function, because this function is something that is supposed to return the name of the property to watch, which means every time through the loop, the digest cycle will want to figure out what property is that and execute it. So that means we could catch when the digest loop is actually going through all these watchers. So all we have to do is really provide one function, and we'll say here log digest loop fired. Let's save that. I'm gonna go back. You'll see the digest loop already fired twice before we even started anything. And the reason that is that when we go back and look as to what's going on here, since our watchers are being set up by the interpolation double curly braces, when we have the scope.once counter equals 0, that means this property gets changed, and so does this. So which means there's already a one time that the properties get changed. And since we know that one time things are changing, it will go once through the loop, and then we'll go through the loop one more time just to see that everything is clean, there's no dirty values, meaning nothing has changed anymore. That's why you see here the loop digest loop fired twice. Now, if we click once counter, you'll see that again it fired twice, because one time was for changing the actual counter and another time to see that nothing has changed. Now that I know that it's changed and it will not change again, if I click once counter again, you'll see that it's only changing once. Let's actually clear that, and you'll see that the digest loop is only getting fired once. Let's clear it again, and still only get fired once. And the reason that is that through the first time that the digest loop fires, it sees that nothing really has changed. However, if we say increment counter, well, it's going to fire twice. Once for checking that the counter actually got incremented, and once to see that nothing else has changed. If we click it, and we'll clear that again, click it again, it will once again see that the counter changed, and then we'll run through all the watchers once again to see that nothing else has changed. And therefore, every time I click, you'll see that the number of times this console.log will get printed out is going to be incrementing by 2. So 6, 8, 10, and so on. In other words, every time I click, there's going to be 2 times that the digest loop goes through the watchers to make sure that everything is updated properly. So now we've seen 2 ways as to how to set up these watches. One is to do it manually through these $watch functions, which are not recommended to be done inside a controller. However, you could do it inside of a service, which we haven't yet covered, or a directive or a component. And the second way is to actually just interpolate using double curly braces some property, and that automatically, or AngularJS automatically sets up a watch for you, because it knows that once this property changes, it will need to update the DOM and update your page. So therefore, a watch is required. There's a third way to set up a watch, and that is simply having an input element with an ng model. An ng model is what's called a two-way binding, and we're going to talk about that in a minute. So if I say ng model, and it's going to be equal name, if I save that and actually create a name right here so we could see something for that property, we'll say scope.name, and we'll equal to Yaakov, and save it. If we go back, you'll see the digest again fired twice. Well, that's because we've initialized things here. If we click on number of watchers, you'll see that number of watchers is now 4. So where did it get number 4? Well, let's go back and take a look at our code, and let's start counting. The first one is the input field that we set here with the ng model name. The second one is the once counter with interpolation. The third one is the counter, again with interpolation. And the fourth one is actually our trick that we made in order for us to watch the digest loop. This is also a watch that we're setting up. So that's the fourth one. And if we go back to our page, If I start typing in that field, you'll see that every time I type, the digest loop gets fired twice. In fact, let's go ahead and clear that. And if I start typing anything, you'll see that the digest loop fired twice. Again, the idea is the same. Once it fires because we changed something about the property that's being watched, which is our name property right here. And the second time it fires to make sure no other properties were triggered and changed as a result of the first change. So every time we type, the digest loop will run twice. Once because of the change, and the second time to verify that nothing else has changed in the entire list of the watchers that we have. So let's summarize. So in this lecture, we spoke about the digest cycle, which is basically running these digest loops over and over until all watchers report that nothing has changed. And this whole process is really not specific to AngularJS. It's really in general called dirty checking, to make sure that every one of the watchers is no longer dirty, meaning the values have not changed. We also saw several ways to set up these watchers that watch a particular property that is set on the $ scope. One way to do that is to directly call the $watch function on the $scope object. And you never want to do this in a controller. And the only reason we did this is because that's all we learned about up until this point. But it's not a good practice to do that. And the reason it's not a good practice to do that, again, is because controllers and templates have their own ways to deal with watchers and set them up. For example, another way we learned about it is simply to interpolate some property inside the HTML template. That alone sets up a watch. Also, if you have an input element that has an ng-model declared on it, that property that is declared in ng-model will have a watch associated with it because Angular will set one up for you. Now remember, everything we've discussed only applies to things done inside of the Angular context. If the event that triggered the whole process, even updating some property inside of the $scope, that is not an Angular type of event, it's not triggered inside the Angular infrastructure, the Angular digest cycle will not know to run, and therefore nothing will show to be updated until the next time the digest cycle runs because of some other events, and then it will repaint the browser with the proper values that are already sitting there. But it will not show up to the browser immediately because the digest cycle needs to be kicked off, and it only knows to get kicked off if it's inside the Angular context. In the previous lecture, we spoke about the fact that the entire digest cycle and the digest loops that go over the setup watchers is only triggered when the original event from our event queue is something that is Angular aware. In other words, it knows about the digest cycle and kicks it off as part of the process. But what about code that is not inside of our Angular application and sometimes still needs to affect the values inside of our Angular app? This is where the special $digest and $apply functions come into play. Let's take a look at a diagram. So we've seen this diagram before. This is the event queue that has an ng click on it that is set up to handle the click event, but at the same time is Angular context aware, and therefore it's going to eventually at some point call the $digest function. But what happens when you have other events on the event queue that are not AngularJS aware, like onClick, your regular onClick event, or a timeout that gets put on the event queue and then some functionality gets executed after a certain timeout? In these cases, we actually need to do something special in order to let Angular know that it needs to run its digest cycle. In practice, it's not the custom timeout events or on-click events that we deal with, but probably something like a custom library like jQuery that has to handle some jQuery specific functionality, and we want to kind of plug into that and affect some of the values and therefore our UI state inside of our Angular app. However, in our example, we're going to use a timeout simply because it's much easier to deal with than setting up a whole infrastructure with jQuery. So let's jump into the code editor and see how we can handle this inside of our Angular application. Okay, so here I am inside of my editor, and I'm located in lecture 15, which is located in fullstack-course 5 examples folder. And this is a very simple counter app that we had before, except we cleaned up a couple of things to make it even simpler. And all we have here is a single controller, counter controller, and it has up counter ng-click button here that is connected to the up counter function on the scope, and it's going to increment the counter, and every time it increments it, it will kick off the digest cycle and go ahead and update this counter interpolation, because obviously double curly braces sets up the watcher for us. Let's take a look at our app.js, and it's as simple as could be. It has the controller declared, and we have our regular injection going here with the scope, $scope. We initialize the counter to 0, and then in our up counter, we just say scope.counter++, and as we're just incrementing it. So let's go take a look at this inside the browser, and you can see here we have our increment counter button and counter 0. So if we keep clicking it, our counter keeps going up by 1. Let's go back to the code, and instead of implementing this right away, in other words, the second a person clicks up counter and invokes the up counter function, that the counter should go up, let's go ahead and set a timeout to do this in a couple of seconds. So let's do set timeout, and the timeout takes a function. We don't need the name. And right after the function, it takes how long should the function wait, or how long should timeout wait before it executes that function. In this case, we'll say 2000 milliseconds, which equals to 2 seconds. And we'll just go ahead and move that counter right inside of there. Okay, so now that we've moved it inside of there, and let's make sure that it's actually executing. So we'll, right after, we'll say log, and we'll say counter incremented. Okay, now let's save that. So let's go back to our web page, and we'll click the increment counter, and it should be a couple of more seconds, and bam, the counter got incremented. Except there's one problem. The regular counter here, the interpolation, still says 0. How come that is going on? Well, the reason that's going on is this timeout gets put in the event queue completely separately from this call of up counter. It really gets it taken out of the Angular context altogether. It's not being called inside the Angular context. And because it's not being called inside the Angular context, the digest cycle doesn't know to have to kick off at all. So in order for us to do that, what we could do is we could just kick it off manually ourselves. We could say $scope.$digest. And if we do that, at the end of this, the digest cycle is going to know to get kicked off, and the watcher for this counter will therefore be checked, and our DOM will get updated and repainted. The browser will get repainted. Let's go back to our browser, and in this case, we'll click increment counter. We'll count a couple of seconds, and bam, the counter is incremented, and now you see the counter is 1. So it did get incremented. That's all well and good, but there is a better way of doing this than calling digest. The problem with calling digest directly is that if there's any kind of errors or any exceptions that happen in the code we're actually executing, the exceptions thrown as part of this code will not be visible to Angular.js. So how can we make it visible to Angular.js? Well, there comes the special function called $apply. So let's go ahead and actually, maybe we'll just keep it for your reference. So we'll copy it, comment it out. Let's write it again, except this time, instead of the digest, inside the timeout, we'll say $scope, $apply, and it takes a function inside of which we could place our code. So let's cut the code out here, and we'll place it right inside of the $apply. So now when the timeout gets executed after 2 seconds, this function will get executed. And this function will call $apply and have another function as part of it and execute that function, which will have the code that we actually want to execute. But since it's all going to get wrapped inside the apply function, not only will we catch any exceptions, and Angular.js context will catch those exceptions, but also at the end of that process, the digest, the $digest, will get called automatically by Angular, and therefore the DOM will get updated. So let's go back to our browser, and let's click increment counter. Count to 2, and you can see counter got incremented and 1 is displayed. So we could do it again, and counter will get incremented again. Second time that log message is here, and now it's 2. However, in practice, you should always try to see if there is an AngularJS alternative that's available that is native to AngularJS. In our case, there's a service called $timeout that does exactly the same thing as setTimeout does, except it does it inside the Angular context already, so we don't need to do any of these tricks. So let's go ahead and rewrite this one last time, but this time we're going to use the Angular timeout service instead of the native setTimeout from JavaScript. So the first thing we're going to have to do is add one more value to our $inject property on our controller. So we'll say $timeout. And since it's $timeout, we know it's a native AngularJS service that AngularJS provides out of the box. And we'll add it as one of the arguments, $timeout. And we'll go ahead and comment this out. We'll copy and comment this out for future reference. And meanwhile, we'll just write a new one. And instead of saying set timeout, we'll go ahead and actually just erase that. And we'll say $timeout. And the first thing is the function that we need to execute. And the second argument is the number of milliseconds it should wait, which in this case, again, is 2000. And all we need to do is really just move our 2 lines that we executed before right here. We need to comment this out again. And now that we save it, let's go back to our web page and we'll click increment counter. We'll wait 2 seconds. And sure enough, the counter incremented gets displayed and 1 is displayed on our web page. So let's summarize. In this lecture, we spoke about the fact that the digest cycle does not get triggered automatically if the events are unaware of Angular and certainly unaware of Angular context and the digest cycle itself. There are a few different solutions that you could use to take care of this problem. The first one is you could call the digest $digest function yourself directly after your custom code. That will tell AngularJS to go ahead and kick off the whole digest cycle, and your changes that you've made to the scope properties will get detected. Number 2 is, and a better way, is to wrap your custom code inside of a $apply function. What that will allow you to do is if your code, your custom code, throws any exceptions, those exceptions will actually be seen by the Angular context, as opposed to if you just call digest at the very end, the exceptions that might have gotten thrown beforehand will not get registered in the Angular context. The third way is probably the best of them all, is to find Angular-specific service that handles the same functionality. In our case, we use the setTimeout, which is a JavaScript native functionality, but there is a equivalent $timeout or the timeout service that does exactly the same thing and is already Angular aware. So you need not do anything else but just use that timeout service.
In this lecture, we're going to speak about two-way, one-way, and one-time binding. The concept of two-way and one-way binding is something we've already seen, and the concept of one-time binding is something we're going to explore in a bit more detail in this lecture. Then we'll compare and contrast these different binding strategies to each other.
So you've seen this code before. The first line is an input element that has an ng model defined on it with a name property. That's an example of two-way binding. And what two-way binding means is that not only does AngularJS set up a watcher for your name property that is sitting on the $scope, but it will also set up some sort of listener on the input element such that if the value of the input element changes, that change will be reflected in the name property on the $scope. So in that case, you're really affecting the name property in both ways. You can affect it by the user because they're typing things into the text box and the $scope.name property gets updated. And likewise, if you update inside of your controller the $name property, that value will get updated and the UI, the browser, will get updated automatically, which means that text box will display the new value that you updated inside of your controller. The second line has our regular interpolation with double curly braces. That's an example of one-way binding. The only way this value will change in the browser is if something inside the controller will update the last name property on the $scope. There's no way for us to, at least directly through the double curly braces, affect the value of the last name from the browser, from the user, to the controller. So this is an example of one-way binding. It shouldn't come as a surprise to you that if we set up a lot of these bindings, a lot of watchers will get created for us by AngularJS. Well, as you remember, the digest cycle goes through the entire list of every watcher that we have and checks for any changes that occurred in the last loop. Well, these loops can go for a few times. And if you have thousands of these watchers, obviously that will take some time, and therefore the performance of your application will degrade. In fact, the rule of thumb is that you shouldn't have any more than 2,000 watchers per page. However, I've seen more than 2,000 and the app worked pretty well anyway, but it's kind of a rule of thumb. You could have more, you can have less, depending on obviously what type of machine the user is using, how fast it is, and how much it can handle. However, one thing is clear, minimizing the number of live active watchers in your watchers list during the digest loop is something that's desirable. So one way to do that is set up a special, what's called a one-time binding. The one-time binding looks very similar to the one-way binding, except in front of the property name, you put double colons. What that tells AngularJS is that it should set up a watcher for this property, but the second this property gets initialized, the AngularJS digest cycle will kick in. It will update that property in our UI, will repaint the browser, and the property will be seen to the user, and at that point, AngularJS will automatically remove the watcher for that particular property, so you'll have one less. Of course, the downside of that is this only happens one time. So if that property were to get updated in the course of your app, that update will not be reflected in your UI. However, for things like, let's say, full name of a user that is not expected to change throughout the lifecycle of your application, something that we still need to be able to somehow insert into our HTML template, but we don't need to watch that property and check that property every single time for the rest of the life of our application. Let's jump into the code editor and take a look at this concept in action. Okay, so I'm back in my editor and I'm located in lecture 16 folder, which is located in full stack-course 5 examples folder. And I'm looking at app.js. And it's basically the same binding app that we had before with that binding controller, except we cleaned it up a little bit and changed a couple of things. So we have a couple of properties. The first one is first name, and I initialized that up front to Yakov. The second one is full name, initialized to an empty string up front. We also have the function we've seen before, which basically shows us the number of watchers we have in our digest cycle. And we're going to go ahead and look into the Angular innards, so to speak, and look at the $$ watchers count. And that will tell us how many watchers Angular has in its digest cycle. And we'll bind this function to a button so we could click it at any time and see how many watchers we have. Another one we have is set full name. What that will do is it will take a property full name on the scope and it will combine it first name plus space and my last name Heiken. So that will update the full name property. And we also have a couple of functions just for us to see what's going on behind the scenes, which basically log the first name and also log the full name. So the $scope first name, $scope full name. If we look in our index.html, we have basically a couple of buttons here that say show number of watchers and set full name. The set full name is the thing that will set the full name to be the first name plus whatever that string that I added to it to be the last name. So basically my full name. We also have a one-time binding here for the full name and a couple of buttons to log the first name and then log the full name. In addition, we'll also have an input element that has a two-way binding set up using ngModel on our first name property, which means if we type something in here, the first name property will keep getting updated as we type. Let's go ahead and take a look at that in our browser. So here's our log number of watchers. So if we click that right now, we'll see the number of watchers is 1. That should already give us a bit of a pause. Why is that? Well, we want this property full name here to appear, and there's only one watcher. Well, if we go back to our index.html, we'll see that for sure this creates a watcher. which means that this did not create a watcher or something else happened because should have been two watchers. Well, let's take a look here. Let's go ahead and log the first name. That makes sense, Yakov. That takes it right from here, and this actually took it before from our initialized property on $scope. And let's log the full name. The full name right now is an empty space. Well, that's easy. We could set the full name. Let's set the full name right there. And if we log the full name now, you see it is Yakov Chaikin. It's the full name. The problem is this is still not showing up here at all. It's just an empty string. Why is that? Why is this happening? Well, part of the reason we kind of discussed, we didn't have an extra watcher that watched that full name property to output this once it changed. Let's go back to our code and see if we could find the culprit for this problem. And if you look at the very front here, you'll see that we initialized our full name already to an empty string. And that's where the culprit is. As I told you before, the second the property that is one-time bound gets initialized, that's when the Angular digest cycle goes ahead and loops over all the watchers and outputs this value to the browser and then removes the watcher for it. That means that the HTML template that has this property one-time bound to it will never get updated again because the watcher is no longer there. So the way we could fix that is simply by commenting this line out. And that means that the very first time that this property will get initialized will be inside of our set full name function, which gets triggered by us pressing the button. So let's go ahead and save that. Let's go back to our browser. Let's click number of watchers, and now things look much better. Now there's two watchers. If we log the first name, it's Yakov. Log the full name, it's undefined, which is exactly how we wanted at this point, because if it was defined already, it would have been too late. The watcher would have been removed. So now if we click set full name, you'll see it will appear right here. But if we click log number of watchers again, it's no longer 2, it's 1. Because once we one-time bounded to our HTML template, we no longer need that watcher. We could save that performance and remove the watcher from our watchers list. So therefore, that is why we only have 1 here. Meanwhile, the two-way binding will continue to work. So for example, if I log the full name right now, it's Yakov Chaikin, but if I update the name, let's say put AAA in here, that means that the first name property on the scope would have gotten updated with an extra 3 letter A's at the end, which means that if I execute set full name right now, it will make the full name property be Yakov with triple A's and then my last name Chaikin. That will not change what is displayed in our HTML template because that was a one-time binding. However, the full name, if we reset the full name, as you can see here, the full name property will actually contain the updated first name because that is something that we manually updated inside of our set full name function, making the scope $scope.fullname the new value of the first name, which was updated, plus the string the last name. So let's summarize. The two-way binding that is set up with the ngModel attribute on an input element means a couple of things. It means that Angular sets up a listener for change to the value on the input element, and any change to that automatically gets updated to the property on the $scope. The second thing it means is that any direct update to the property, like inside of a controller, any direct update to the property value is automatically updated in UI as well. And obviously that's done using a watcher. One-way binding, on the other hand, automatically set up by double curly braces around the property, means only one thing. The direct update to the property value inside a controller or something similar is automatically updated in the UI, and the watcher still stays. That's to contrast a one-time binding, which looks very similar to the one-way binding that is set up with the double curly braces and double colons in front of the property name. And what that means is the initialized value, not any value, but only the initialized value of a property is automatically updated in the UI. And the watcher for that property is then automatically removed by Angular, so the user interface never gets updated with any updates to that property again.
No framework on the level of Angular.js would be complete without some sort of construct to loop over our data and output the result of that looping to the web page. Angular.js certainly has that construct, and it's called ng-repeat. And that's what we're going to learn about in this lecture.
Now, we've seen directives before. For example, ng-app is a directive. Well, ng-control is a directive. ng-repeat is yet again a directive that we're going to learn about, a directive that comes packaged together with Angular.js out of the box. Right now, I'm in my editor, and I'm in Lecture 17 inside a Full Stack Course 5 examples folder. So let's go over this little shopping list app. We have the ng-app, naming the app being shopping list app. And we have the shopping list controller where all the magic is going to happen. Let's switch to app.js for a second and take a look as to what we have here. What we have here is two arrays. The first one is called shopping list 1, and it has 1, 2, 3, 4, 5, 6, 7, 8 items in the shopping list, and they're all just strings. And we also have shopping list 2, which has also elements in it, but the elements of shopping list 2 are actually objects. So it's 1, 2, 3, 4 objects. Each object has a name and a quantity property. When we declare our module and actually declare our shopping list controller, all we're doing here is obviously injecting scope as usual, but all we're doing here is placing those arrays as a property on the scope service. So now we have a shopping list 1 property and we have a shopping list 2 property that is now able to be referenced inside of our HTML template. So let's go back to index.html, and we see here the first shopping list, or the first version of a shopping list here, is that we have an unordered list, and the li tag has an attribute called ng-repeat. And ng-repeat is very similar to a for each type of for loop. So the construct of item in shopping list 1 means that we're going to be looping over a shopping list 1 array, or collection, or an array, and each time through the iteration, the item of that collection that is being iterated over is going to be equal to the item variable that we're setting up. And in this case right now, we're just interpolating that item as the value of the body of the li tag. So each time as it's iterating, it's going to output another item that is equal to one of the items in the shopping list 1 array. The rest of the code so far is just commented out, and we'll get to it in a second. So let's go ahead to our browser and take a look here. And you see here that we have our shopping list and all of our 8 items output to the browser. Let's go ahead and right-click on this milk item and inspect it and see what the code in HTML is actually looking like. As you can see here, what we have here is that this ng-repeat actually repeated the li tag 8 times over and over here, each time interpolating the item in the array as the contents of that particular li item. So in this case, it's milk, in this case, it's donuts, cookies, and so on and so forth. So let's close that up and go back to our code editor and uncomment a different shopping list. We'll just go ahead and comment this out for now and open the comments up for this one. In this case, we're also looping through the array, except in this case, we're looping through shopping list 2 array. But shopping list 2, as you can remember, let's go back to our app.js. You see shopping list 2 is a list of objects, not just a list of strings. So in this case, each item in the loop of shopping list 2 is going to represent the object, not just a particular string. So in this case, when we interpolate it and we say something like by item.quantity of item.name, we're able to traverse the JavaScript object in its usual way using the dot notation, and obviously interpolate it with double curly braces. So if we save that and go back to our browser, you'll see that now we're outputting buy 2 of milks, that's really not English, but it's close enough, buy 200 of donuts, and donuts spelled twice with an S. Again, kind of a little bit messed up here, but it doesn't really matter, you get the idea. And buy 300 of cookies, and obviously we're going to have a cookie party right there. Let's go back to the code editor and now comment this out and uncomment another way of traversing the shopping list. In this case, what we're doing here is we're doing exactly the same thing, Except this time around, I'd like to be able to number them one by one. Even though we're inside of an unordered list, I want to be able to get at the index of the iteration as we go along. So item in shopping list 2, the ngRepeat is set up exactly the same, except ngRepeat directive allows us to access the looping index variable by exposing it to the body of the tag that ngRepeat is an attribute of by the $index. So if we say $index and we try to interpolate that inside of the body of the tag that ngRepeat is on, it will give us the index or the iteration number through the loop of this collection shopping list 2. So we're able to say index $index plus 1 because obviously arrays are 0 based and we don't want to start counting to the user from 0. So we're going to do a plus 1. So the very first item will be 1, 2, and so on. And then we'll say the same thing by item quantity of item name. Let's save that and go to the browser, and you see now every bullet now has 1, 2, 3, and 4, and these numbers came from $index that is exposed by the ngRepeat directive. Now obviously, if we go look at our HTML, you'll see that we're setting up watchers for different items inside of our array that we're looping over, because double curly braces, as we learned before, sets up watchers. Which means that if we change things inside of the array, the changes should appear on the screen automatically. And this actually includes even if you're setting up a watch yourself for a pretty deep value inside of the array. Let's go ahead and create an input element with an ngModel that is going to watch, as I remember ngModel sets up a watch, is going to watch a shopping list 2, but not just the whole thing. We just want to watch the first item in it, and we want to watch the quantity of that first item, which means that the value inside the input element is going to directly reflect the quantity value of the first item in the list. Let's save that and let's go back to the browser. And you see here, it's already appearing as 2. And the reason it's appearing as 2 is because that's the first item on the list. So if I add a 0 right here, you'll see that the list automatically updates without me doing anything else. So I could add whatever really I want in here, and the list will update with that particular number. We can also update the entire list by removing or adding items to the list. ngRepeat also watches the entire collection as a whole and will then re-render the view with the updated data. So let's go ahead and do that right now. We'll put an input field here and we'll say its ngModel is equal to new item name. And we'll put even a placeholder so people know what that is, item name. And we'll put another input, and this time the ngModel is going to be new item quantity, and the placeholder will say as item quantity. Okay, let's close up the sidebar so we could fit it a little bit better. And one more thing is we'll add the button to be able actually to add that new item to the list, and we'll bind an ngClick, and we'll bind it to some function called add to list. We'll put the parens at the end, and we'll say add to list as the label for the button. Now what we need to do is we need to actually go ahead and implement this add to list function. We'll copy that, we'll go to app.js, let's scroll into our controller, and we'll say $scope, add to list is a function, we don't need the name. And inside that function, we'll need to create a new item. And the new item is going to be equal to an object. As we know, that's objects now. The name of which is going to be scope.newItemName, comma, and quantity is going to be of scope.newItemQuantity. And you could see these are the values that we pulled out from the newly created ngModel, right? The ngModel that we've set up here created new item quantity and it created new item name. So we're able to now reference it right here. So once we created that new item, we need to now place it onto our array. Our array is called scope.shoppinglist2. So we'll do that, scope.shoppinglist2.push, and we'll just say new item. Okay, let's save that. Let's go back to our browser. As you can see here, we have a couple of text boxes and add to list. So let's say rich cookie, and we'll get like 500 of them. And let's get add to list. And you can see number 5 now is buy 500 of rich cookies. Now actually spelled properly too. So now that we have lots of food, let's do Coursera course, and let's order like, 3 of those. And now we have buy 3 Coursera courses, even though you don't have to buy them, they're free. And even though we've changed this whole list, we could still affect the first deep value, which is the quantity of this first item, which is milk. So we could still say 200 more and more and so on. So we could still watch that item and it will get automatically updated by the watchers that were set up by Angularjs through the ngRepeat directive. So to summarize, we learned about the ngRepeat, and ngRepeat is a directive that extends the functionality of HTML elements it's applied to. And if you think carefully about it, that's an incredible idea that you're able to take regular HTML and actually extend the way it behaves, and AngularJS achieves just that. ngRepeat behaves very similarly to for each construct in other languages. The way it works is ngRepeat is an attribute on some element, and then you specify some item, which is a variable, in some collection, and collection should be some kind of a property on usually the scope service. And each item can now be used in interpolation as an item in the collection at a particular index of iteration. Now, ngRepeat also exposes a special $index property to the body of its host tag. And what it does is that $index holds the numeric index of the current item in the loop, and you're able to then use it in your interpolation or in some calculations inside of the HTML template. Before we jump into explaining yet another feature of ngRepeat directive, which is being able to filter it, let's talk about filters in general and how they work in JavaScript. I'm right now located in Lecture 18 folder, which is located in Fullstack-Course 5 Examples folder. And we have an extra couple of files here, filter.html and filter.js. So filter.html is a simple HTML page, and all we really need it for to include our filter.js script. So let's go ahead and go to filter.js. And at this point, all it has is a simple array with numbers 1 through 10. And all we're doing here is saying number array and just basically console logging it. Let's go to our browser and see that, in fact, it is logging 1 through 10. So the idea of filtering arrays is applying some sort of a function to this array such that only some of these elements make it to the new array and not all of them. So let's go ahead and go to the Mozilla Developer Network and we'll look up the filter function in the array.prototype. You can see the filter says filter method creates a new array with all elements that pass the test implemented by the provided function. So the construct is basically the original array, you call the filter function, give it some callback and possibly some extra arguments. So the return value is the new array with the elements that passed the test. And every argument into our callback is one of the items inside of the array. And you can even look at a couple of examples here that are going on. So let's go ahead back to our page and let's go back to the code editor and let's go ahead and write our first filter. We'll create a new array called filtered number array. And we'll call the original number array and we'll invoke the filter function and we'll put a semicolon at the end. And this takes another function. We don't need the name for it. And the value of this function is going to be each item inside of the number array. So what we need to do is we need to return whether or not this value, this particular value that is passed, is true or false, meaning does it make the cut or doesn't it make the cut. So let's return, for example, value greater than 5. In other words, if the value passed in is greater than 5, then that item will make it into the new filtered number array. And if it's less than 5 or equal to 5, it will not. So now if we go ahead and log that, we'll say filtered number array, and we'll call filtered number array. And if we save that and go back to our browser, we'll see that the filtered number array now starts with 6 and ends in 10. In other words, anything below 5 did not make it into this new array. In fact, we could make the code a little bit more elegant. Since we're having a function here inside as a value to another function, we could just go ahead and cut that out and create a new function. Let's call it above 5 filter. And basically, well, we don't need a whole function declaration here, and basically just have the return value here. And so now we could take that above 5 filter and as a value, this is now the function value, pass it into the filter as an argument. So if we save that, now the code looks a lot more elegant. We'll go back and we see value is not defined. And that's because we messed up. We forgot to put the value right here as an argument because that's what it takes. And now you should see the filtered number array 6, 7, 8, 9, 10. Okay, so that's as far as numbers are concerned. Well, what happens if we have a bunch of strings? Let me cut and paste an array that I've prepared that is the exact shopping list from the previous lecture. And you can see here it's got, again, a shopping list of 8 items, and we logging the shopping list just to the console. We'll save that. Let's go back to our browser, and you'll see that the shopping list contains these 8 items on the screen. So let's go back to the code editor and try to create a filtered shopping list. So for that, we'll start with the search value. That's what we're looking for, and we'll call it bismol. That's what we're searching for. That's the string we're searching for. And we'll create a function, call it contains filter. And the value, again, is going to be the value through the iterations of the filter function. So in here, we're going to do a simple comparison of saying value.index of, and we'll say the search value. And if it's not equal to -1, it means that we found that search value as part of the string that the value will be. And the value, again, is one item inside of the array. So now we have our function one more time. So now we could go ahead and say var searched shopping list. We're going to invoke the filter function on the original shopping list and provide it the contains filter that we created just a second ago. So now we could log this searched shopping list, and we'll log it and say search shopping list. And let's take a look. So we're looking for bismol. We go back to our browser. We see that now only the items that contain the word bismol are actually in fact part of our array, which is 1, 2, 3 items. Okay, so let's apply that knowledge to Angularjs and ngRepeat. We would like to be able to filter the array that is being output by the ngRepeat on the fly. So the first thing, if we go to Angularjs, which is our angularjs.org, and go to develop and developer guide, and you'll see here filters. We've been to this website before. And one more time, we've been to this link, which is the built-in filters. In other words, filters that we don't need to build ourselves. If we click on that, you'll see there is a filter. Kind of a repetitive, but it selects a subset of items from an array and returns it as a new array. Sounds just like our filter function, and in fact it is. And if we click on that, you'll see there's a couple of ways of declaring it inside HTML binding or inside JavaScript. We're interested in the HTML template binding one. And we see here that it's a filter expression followed by a pipe, just like any other filter, then the word filter, then some expression. Well, what can that expression be? Well, if that expression happens to be a string, it says here that the string is used for matching against the contents of the array. All strings or objects with string properties in array that match the string will be returned, and so on. And there's a whole slew of different options here besides just the very basic one. Well, all we're concerned about at this point is just the basic one. So again, it's going to be a filter followed by a colon, as you remember, followed by this expression, which if it's a string, it's going to start filtering on that string, filtering the array expression on that string. So let's go back to our code editor and let's introduce the application that we're actually going to be working with, which is, let's close those two, which is index.html and app.js. Inside of index.html, we have a simple ngRepeat that basically looks over this shopping list. And if you look at app.js, the shopping list is nothing more than that same shopping list we've been working with before, is just an array. So if we save that and go back to our browser, and let's go back to the actual index.html instead of filter.html, you'll see that we have our shopping list here. Let's close the console. So here's our shopping list. That's that same shopping list we had before. Well, let's go back to our code editor, and inside the index.html, right above the actual list, we'll go ahead and create an input element with ngModel being bound to a property that we'll create right now on the fly called search. So that's going to be our property. So now since this is an array, we can now filter this array using this search string right here. This is a two-way binding, which means as we type, the search property will get updated automatically. So we could say pipe filter, that's the name of our filter, colon, and then search. So now what's going to happen is that as I type in this field, the filter will kick in automatically since all these things are registered with watchers inside the digest loop, and our shopping list will automatically be filtered based on whatever the search string that we're providing through this input element. Let's go to our browser and see that in action. So here's our shopping list, and as we start typing, for example, Bismol, you could see that Bismol is the only thing that's showing up, the three items. And if we go back, as we erase, it's again getting bigger and bigger because we're filtering this on the fly. So if we just say milk, so milk is the only thing that's going to show up. So to go back to our code editor, you see that using the filter is doing basically the same thing that we've done in our filter.js file, where it is using the search string to figure out whether or not an item in the shopping list array matches that search string. But since we're updating that search string using our two-way binding, the shopping list ngRepeat gets filtered on the fly, and this is the way we can have a user searchable list where the user just types in a search and the list automatically gets filtered based on that search. So let's summarize. We spoke about a special function called filter that exists on the array object. And what it does is it creates a new array where each item of the new array satisfies some condition of a comparison function that is passed into the filter function itself. Now, Angular has a special filter called filter. Now, it's a little repetitive, but it represents the filter function we spoke about on the array object. Now, provided a string as the first argument to that filter, that AngularJS filter function, it will filter the original collection or an array it's applied to, matching all string items against the provided one that you're searching for. And as you saw in the code, we applied it using ngRepeat item in collection, and then we filtered the collection by putting a pipe, filter, colon, and the search string that is actually filtering our array that is signified by the collection. And as you can remember, we actually bound search string to a text box input element, which allowed the user to type in whatever string they wanted into the text box, and that string would be served as the search string that would filter the collection of our ngRepeat. That way, our ngRepeat would update the UI depending on what the person is typing in into that search box that translates into that property search string.
Up until now, we've been using a simple controller declaration inside of our HTML. We use something like ng-controller equals some name of the controller that we declared in our Angular module. But there's a better syntax to follow, and that is controller s syntax, and we will be building up to that in this lecture. However, to truly appreciate what controller s syntax is accomplishing for us, we need to first understand a pretty fundamental concept in JavaScript in general, and that is prototypal inheritance. Without understanding this basic concept in JavaScript, we would simply be memorizing strange rules instead of understanding why things work the way they do. We don't want to do that, so in part 1 of this lecture, we will delve into prototypal inheritance and see how it works.
The first question is, what is inheritance in general? Well, inheritance is when an object or a class is based on another object or a class, the parent object, using the same implementation and or the same values. So for example, if you have an animal object or class, it might have some properties like number of legs. It might have a method called walk. You can then have another class or object called dog that inherits from the animal class or object. One way or another, the dog object or the dog class has access to the number of legs property and also to the walk method. Different languages have different types of inheritance that they implement, but in general, this technique is used for code reuse as well as logical entity structure. Now note here that I'm not trying to be super accurate with my terminology and differentiate between subtyping and inheritance, is a relationship, etc. For our purposes, these definitions will suffice without throwing more theoretical complexity into the mix. So that's inheritance. Unlike object-oriented inheritance, which is based on classes and is much more complex and has a lot of rules that you have to memorize and has different intricacies, prototypal inheritance is based on object instances and is very simple and straightforward. The original object instance becomes the prototype for all subsequently created objects. In this example, we have an object called parent, and it has a type property that is equal to the string parent and a method with the name method. Then, if we create a child object that is going to be based on our parent object, that child object will start off with being simply an empty object. However, if we try to evaluate an expression child.type, the JavaScript engine will look into the child object and look to see if it has the type property. In this case, it doesn't. So what it will do, the JavaScript engine will then look to the prototype chain to see which object is actually the parent of this child object. And in this case, it's the parent object itself. And we'll ask that parent object whether or not there's a type property that belongs to it. In this case, there is one, and it evaluates to the parent string, so therefore it will get resolved. The type property will get resolved to the parent object, which means child.type expression will then get resolved to the string parent. Now, the reason it's called the prototype chain is because it doesn't have to be limited to just one object and its subsequent child. It can have grandchildren, great-grandchildren, and so on and so forth. In other words, you could create yet another object that is based on the child object, and therefore the current parent will then become the grandparent of that newly created object. However, what will happen if instead of evaluating child.type expression, we set a type property on the child object? What will happen is that the child object will no longer be empty. It will actually have a property called type that will evaluate to the string child. What will then happen if you try to evaluate child.type in this case? What will happen is that since the child.type property actually masks the type that is inherited from the prototype of this object, which is the type property of the parent object, this will get evaluated and resolved immediately, which means it will not go looking up the prototype chain to the parent object. And therefore, in this case, child.type expression will get evaluated to the string child. In part 2 of this lecture, we're going to jump into the code editor and see how these concepts work in action. Okay, so I'm in my editor and I'm located in the lecture 19 folder, which is in the full stack-course 5 examples folder. And what we're going to do here is I've pre-written some code and we're going to start going through this code chunk by chunk, and I'll explain to you what's going on as we go. The first piece is right here, as we're declaring a parent object. So it's a simple object literal declaration. It has a value property, which is equal to parent value, an object property, which itself has a property called object value, and it's equal to parent object value. And it has a walk method or function that basically just, if you invoke it, will log the walking string to the console. Next, let's go ahead and create a child object that is going to be based on our parent object. That is, the child object will have prototypal inheritance from the parent object. And the way to do that is to call object.create, passing it the object you want to base your new object on. Object.create is something that should be supported by all the modern browsers. So after line 12, our parent object is now the prototype for our child object. And what we're going to do now is we're just going to go ahead and console log some of the things that we see inside the child object and the parent object. So the first one is we're going to go ahead and say child.value. Now this value really comes from the parent object. And what's going to happen is that JavaScript engine will go ahead and go up the prototype chain and look up this value inside the prototype of the child object, which is the parent, and should print out parent value. Then we're going to do something similar, except this time we're going to say child.obj.obj_value, which means we're going to once again go up the prototype chain and look up the obj, which is just a property on the parent prototype object again, and look up its obj value property. Now, just to compare, we're going to go ahead and access the parent properties directly as well, and say parent.value and parent.obj.obj_value. And then just for good measure, we'll go ahead and log both objects, the parent and the child. Since I have my browser sync already working, and it's actually pointed to prototype.html, which is just a simple HTML file that references prototype.js, which is what we're writing here. So once we're saved and we go back to the browser, we could see that the child.value is parent value, and that's because the JavaScript engine went up the prototype chain to look up this value in the parent object, and child.obj.obj_value is yet again parent obj value for the same reason. You could also see that the parent value, parent.value, and parent.obj.obj_value are also exactly the same as the ones that we got from the child. Now let's take a look at the objects themselves. Well, here's the parent object, and as we expect, it's got the parent value, and if we open it up, it's got the value, the walk function, which if you hover, you'll see that it's just console.log, and it's got that obj property, which itself is an object, which obviously has the obj value, parent obj value. Now, if we close that and look at our child object, you could see that it doesn't really have any properties of its own. But if we open it up, you'll see that it has one special property called __proto__. And that's a special property you shouldn't be accessing directly for performance reasons, but that is where the JavaScript engine, in its kind of behind the scenes, holds a reference to the parent prototype of the child object. So if you open that up, you'll see that it looks very familiar. It's got the obj property, the value property, and the walk property, which is a function. So you could see that we're still referencing our parent object using this __proto___ property. Let's go back to the code editor and we'll uncomment the next chunk of code, which is the one right here. And what we're going to do now is we're actually going to declare our own value property on the child object, and we'll call it child value. And we'll also say child.obj.obj_value and change the value to child obj value. Now, what should happen here is, since we're declaring a value property on the child, when we reference it later in a console.log, the JavaScript engine will not access the parent's value property, but it will access the child's value property, because the child's value property is masking the parent value property. However, since this obj property is still not a property of the child object, but is still requiring the JavaScript engine to walk up the prototype chain in order to look it up, this obj value will actually get changed and changed to the string child obj value on the parent object itself. So what we're going to do is we're going to declare that we change stuff, and we're going to actually just copy and paste these lines of code right in the console.log so we could see what we're changing in our console in the browser. And then we'll again go ahead and log the child.value, child.obj.value, and we'll log parent.value, and we'll log parent obj value. And if everything works right, the parent.obj.obj_value should be equal at this point to whatever comes out from child.obj.value. They should really point to the same object. And then for good measure, we'll go ahead and output the parent object and the child object. Let's go ahead and save that. Go to our browser, and we could see after we changed things, we changed the child value to child value, and now this value is masking our prototype's parent value property. So if we go to the child, we'll see it will indeed say child value as we set it. And if we go to the parent, you could see that the parent did not get changed simply because we are masking the value now in the child, and we're not affecting the parent value when we're setting it right here to this string child value. However, since when we access or set the obj value, which is itself a property of the obj property, that obj property requires the JavaScript engine to walk up the prototype chain and look it up on the parent object. And therefore, when we change it, this string will now get recorded in the parent.obj.obj value directly. And now if you look at our objects that we actually output to the console, you'll see that our child object now has its own value called child value. And if we open it up, you'll see it has a child value, and its prototype is still pointing to the parent. And the parent has a value, but its value is still saying parent value. Again, that's because the value got masked by the child property that is of the same name. Let's go back to the code editor and actually verify that the child, let's uncomment this line right here, and verify that the child obj is actually equal to the parent obj, meaning that when we resolve the .obj on the child, the JavaScript engine actually walks up the prototype chain, and it is the exact same instance of the object that is attached to the parent one. So we're going to go ahead and say if one equals the other, it should output true. We'll save this. We'll go back to the browser, and indeed, child.obj is actually equal to the parent.obj. Okay, so let's go back to the code editor once again. And let's see here that we don't have to get stuck on just one child. We could create a grandchild of the parent. And the way we could do that is yet again call object.create, except this time our prototype will be the child, which means the grandchild is created based on the prototype of the child object, and the child object is still an object that was based on the parent object, so therefore the grandchild. And you could tell that this is still working just fine because we could first of all output it to the console and see what that object holds, and certainly we could call grandchild.walk, which is something that is not even coming from the child object, but coming all the way from the parent. Let's go ahead and save that. Let's go back to our browser console, and you see here the grandchild object is an empty one, but if we open it up, you see we have a prototype. Open that up. That prototype, which was our child object, has its own child value, or the value property with child value as the string, but it also has a prototype as well. If we open that up, you'll see our familiar parent object with its walk method. And sure enough, when we call grandchild.walk, it will print out walking because this function is console logging the walking exclamation point string. So that's prototypal inheritance, and it's really very simple. It's either the JavaScript engine will look for a property by walking up its prototype chain and looking on its parent objects for that particular property, or if the object already has that property is really masking the prototype's property, and therefore it gets resolved immediately. So as you've seen, there's a bit of a contrast here between a primitive value like a string that gets inherited through the prototypal inheritance and a property that is itself an object and gets inherited through the prototypal inheritance. The obvious difference here is that changing the values of the properties of the inherited object does not mask those properties from the parent prototype. Let's go back to the code editor and see one more very important concept before we jump into the controller as syntax explanation. In fact, let's go ahead and comment this whole thing out so you could have it for reference. And what we'll comment out is this particular piece right here. Function constructors. Now, if you don't know anything about function constructors at all, I highly suggest that you look into my other course called HTML, CSS, and JavaScript for Web Developers, in particular Lecture 48, that explains all this in much more detail. However, here we'll just quickly review. Since functions at the end of the day are just objects themselves, you could create new objects and treat them sort of like classes using functions, and you could use the functions as a constructor for that object. In this case, we have a function called dog, and it takes an argument called name, and we're able to say this.name equals the name that whatever the name is being passed in. And inside of this function, we're going to go ahead and log the this keyword to see what it actually points to and what's inside of it. Now, in order to create the object using a function constructor, you need to actually give it the new keyword before you invoke the function. So the invocation of the function is not the regular invocation where you just give it the name, put parens behind it, passing some arguments, but you actually need to put the keyword new in front of it. When you do that, when you log my dog, you will see that this will be the dog object, which will have a max as the name property on that object. Now, if you make a mistake and try to invoke the function constructor simply without the new keyword, this keyword inside of the function constructor will no longer point to the function constructor object, or the dog object in this case, but will point to the outer scope. And in this case, the outer scope is the global scope. And the global scope in a browser is nothing more than the window. So let's go ahead and save that and go back to our browser. And you'll see that this is pointing to the dog, and the dog is actually a name of our object. And again, my dog is exactly the same thing. And in the second case, where if we go back to the code, where we actually invoked the function constructor directly without the new keyword, you'll see that inside of that function constructor, that this keyword resolved to the window object and not to the dog object that we expected. One quick tip is that when the functions start with a capital letter, it's just a little reminder that this is not a regular function to be used as any other function, but is actually a function constructor. In part 3 of this lecture, we'll look at some AngularJS specific concepts that are built on top of the concepts that we just learned.
Now that we understand how prototypal inheritance works, let's talk about another concept called scope inheritance.
It's not common, nor is it a good practice, to have one controller that handles everything in your page. It's much easier to code smaller pieces of functionality that are responsible for smaller parts of your page. As you know, Document Object Model, or the DOM, is a tree of nested HTML elements and nodes. When you declare that a controller is responsible for part of your page, some natural nesting of controllers will occur. Therefore, the scope service, or simply the scope of the outer controller, is available to the inner controllers. However, Angular makes it even nicer than that. The scope of the inner controller prototypically inherits from the scope of the outer controller. Since you now know what prototypal inheritance means, you understand that the properties declared on the outer controller scope, controller 1 in this case, are accessible to the inner controller scope, controller 2 and 3, without any extra effort. That is, of course, if the inner controller doesn't mask those outer parent controller scope properties by declaring those same properties on its own scope. So if we declare a property called prop on the scope of the first controller and make it equal to a string ctrl1 to signify that it comes from the first controller, and then try to access that same property on the scope of the second controller and the third controller, which are inheriting from the controller 1, the JavaScript engine will go up the prototype chain and will look up the value of the property in the first controller, which is going to be again ctrl-1. But what would happen if first, inside of our controller 2, we retrieved the prop value inherited from scope 1, evaluated it somehow, and then wanted to change it in such a way that both scope 1's prop value and scope 2's prop value would be identical? Better yet, we would want them pointing to the same memory location. However, without manually going up the prototype chain and retrieving the instance of scope 1 object, we can't achieve this with primitive types. Every time we set the prop property on scope 2, we end up masking the prop property of scope 1 from the view of scope 2. So in this scenario, $scope1.prop would still be unchanged and be equal to that same ctrl-1. However, as you may remember from the previous video, when we're dealing with prototypically inherited objects, things work out very differently. The reason for this is that just to get to the property of the inherited object, we already have to walk up the prototype chain. So when we change the property of such an object, we're changing it at its original source. Therefore, all controllers reflect the change and no masking occurs. As you can see in this case, even though we changed the object's property prop through the reference of scope 2, which is an inner controller scope, scope 1 with the same object property prop changed its value as well. So you can see it's very advantageous when we have scope inheritance to work with objects that are properties of the scope and not with primitive properties that are directly sitting on the scope itself. And this is where controller as syntax comes to help us quite a bit. The controller as syntax provides us with a very convenient object we can use to attach all of our properties to, so property masking does not get in the way. It lets us specify a label in our HTML template. The name of this label is attached to the corresponding scope service as a property. So in this case, for the first controller, it's scope.ctrl1, and for the second, $scope.ctrl2. Those properties, in this case ctrl1 and ctrl2, point to objects that are instances of the controllers themselves. In other words, the controller instance gets attached as a property on the $scope. That means that when it comes to implementing the controller function, or the function that is responsible to implement the functionality of our controller, we can attach our properties directly to the this keyword inside of our controller function and not even have to inject the $scope into the controller. So the this keyword becomes synonymous with the name of the label given in the controller as syntax in our HTML template. The reason we're able to accomplish all that without much code is because Angular does a lot for us behind the scenes. Here's about what it does. Obviously, what Angular actually does is much more involved. So this is just a rough idea of what happens behind the scenes. So in our case, we have two nested controllers. The outer controller, controller1, declared as ctrl1, and the inner controller, controller2, declared as ctrl2. After AngularJS creates the scope for our controller1, which we'll call $scope1 for now, AngularJS attaches a property called ctrl1, the same as our label, and then instantiates it using our controller function as a function constructor, which means ctrl1 is now equivalent to the this keyword inside of our function constructor, represented by that function that we specified as our controller function. Since we want prototypal inheritance, scope 2, which is the inner scope, is going to get created based on $scope1, which is the outer scope. Then we're going to go through a similar process where we're going to create a property for scope 2 with the name of the label that we assigned our controller 2 as, which is ctrl2, and we'll initialize it with the instance of the controller 2 function that is created using the new keyword, therefore using controller2 function as a function constructor. So yet again, the ctrl2 is going to be pointing to the same thing that the this keyword will point to inside of the controller2 function constructor. But things don't just get better and simpler inside of our JavaScript. The controller as syntax makes the HTML templates simpler as well. Not only does it allow me to access properties that are named the same from the parent scope without masking any properties, it also makes for a much more readable code. So now when I look at this interpolation, ctrl2.myprop, I know that this property is instantiated and belongs to controller2, and ctrl1.myprop is a property that is instantiated on controller1, and that's where it belongs. Okay, enough hand waving for now, and in part 4 of this lecture, we're going to jump into the code editor and see these Angular concepts in action. So I'm back in my Atom code editor, and I'm located in lecture 19, which is located in full stack-course 5 examples folder. And here I've set up a simple app called controller as app. And what it has here actually has a couple of things. The first thing we're going to look at is we're going to use the controller as we usually used it without the controller as syntax, but we'll play around with the prototypal inheritance between the nested controllers. And then at the end, we're going to go ahead and take a look at the controller as syntax that we discussed. So the first thing is we have a couple of controllers here. One is the parent controller called parent controller 1, and the other one is child controller called child controller 1. And the child controller, as you can see, is nested inside of the parent controller 1. Let's go ahead and take a look at app.js. And app.js just declares our application, and then it declares our 4 controllers. And the last two, parent controller 2 and child controller 2, we're not going to use just yet, so these two you could ignore for now. But meanwhile, we have the parent controller 1 and the child controller 1. The parent controller 1 sets up a few values. Number one, it sets up a parent value property equal to 1, which means it's a primitive type value. And then it sets up a PC property, standing for parent controller, that is equal to this, meaning this is the actual parent controller 1 instance. Now, the reason this is going to point to the parent controller 1 instance is because when we call the angular.controller method, the function value that is passed to it as the controller function is treated as a function constructor. So therefore, at some point, there's going to be a new, and it's going to new up this object. And when we use a new in front of a function, it becomes a function constructor. And therefore, this, the keyword this, is going to point to the instance of parent controller 1 in this case. So here we have the $scope.pc. That's another attribute on the scope service. And we're going to equal it to this. But we're not going to stop there. We're also going to attach a parent value to the actual PC, which is our controller. So the controller instance is actually going to have a parent value property, and we're also going to equal it to 1. Now, the child controller is not going to declare anything of its own. Instead, we're just going to use the scope, which is declared on the child controller itself, and ask it for the parent value. Now, it doesn't really have a parent value of its own, which means it's going to try to look up the parent value up the prototype chain and should give us number 1 here, the primitive value 1, since the prototype for the scope of child controller 1 is the scope of the parent controller 1. And to begin with, we just go ahead and dump the scope to the console so we could see what's sitting inside the scope, and we could see if we could perhaps traverse the prototype chain ourselves in the Chrome Developer Tools. So point is, the first thing we should see, so the logging statements are only coming from the child controller, so there are no logging statements in the parent controller, and the child controller is going to try to say, my scope, that parent value, what is that equal to? And then it's going to dump the actual scope to the console, the scope of the child controller. So let's save that and let's go to the browser and let's take a look. So scope.parent value is 1, and this 1 is clearly coming from the parent controller, since we as a child controller don't even have a parent value property at all. Well, let's take a look at the $scope object that we printed to the console. Let's open it up a little bit, and we could see that we don't really have any kind of values here. Certainly don't have the parent value property. But we do see the __proto__. And if we open that up, that's supposed to be the prototype for our child controller. And you can see that it has the parent value attribute, which is equal to 1, which is what we retrieved in our child controller. And you can also see that it has the PC attribute that is pointing to the parent controller 1, which is the instance of actually our parent controller. And if we open it up, actually you could see that it also has a parent value property on it, also equal to 1. So now we understand and kind of ourselves traverse the prototype chain to see where the parent value on the scope service came from in our child controller. Let's go back to the code editor and uncomment some more statements that I prepared here. Let's uncomment this piece. And what we're doing here now is on the child scope, we're setting a parent value. Since we created an identical property name on our child scope, it means it will start masking that property name from our prototype, which is our parent controller 1. So the next line here, all we're doing here is just console logging the fact that we're changing or actually adding the parent value property to our child scope. And what we're going to do is we're going to go ahead and print out or log the scope, again, the child scope's parent value. And that should be the new value right here. But what we're going to do again is we're going to go ahead and log the scope object and see if we could again traverse the prototype chain to see if the prototype's value, the parent value, has changed because of us changing this value right here. So let's save that and go to the browser. And we could see here, we changed the value to 5. So now scope.parent value is 5 because this parent value is now belonging to the child controller, the scope on the child controller. So if we open up our child controller scope, we'll see that we should have now a parent value that is sitting directly on the child controller. And if we go ahead and look at the prototype of our child controller and scroll down here, you'll see that the parent value that we used before is still 1. And the reason for that is because our child controller scope is masking the parent value property. So the JavaScript engine is not going up the prototype chain to look up the parent value. Let's go back to the code editor and see a couple more things here. What we're going to do now is we're going to start messing with the actual parent controller object that we declared on the parent controller scope. So let's uncomment this chunk of code right here. And now we would want to retrieve the parent controller object, which, as you can remember, is actually pointing to the instance of the parent controller itself. So we're kind of mimicking the whole idea of controller as syntax, but we're doing it all by ourselves without the Angularjs help. So what we're doing here is we're traversing the prototype chain and looking up the PC, the parent controller object, and we're retrieving the parent value property of that PC object. And here it is, we're just console logging it. After, we're going to go ahead and change that value. And remember, since in order for us to even get to this object, we need to, right here in this dot, we need to actually traverse the prototype chain to our parent object. It means that when we change the property parent value, it will actually change not only here in the child scope, but it will actually change at its root, at its parent controller 1. And all we're going to do is basically log the fact that we're about to change that. We'll print the value back out, which at this point should be 5, and then we'll dump the scope again onto the console to see if we could again manually traverse the prototype chain to see if we see what the differences were. Let's go ahead and save that, and let's go to our browser. And you can see here, what we're doing here is we're saying the scope PC parent value is 1. After we change that, the scope, our child scope, that PC parent controller parent value is now 5. So if everything went according to how we understood it, there should not be any extra properties on the child scope, and the parent, the prototype of our child scope, should still contain the PC object, and that object should contain the parent value property with the new value 5 that we updated. Let's go ahead and open that up. If we take a look, our parent value is 5. That's again the local parent value of the local child scope. If we look at the prototype, we'll see that the PC is still pointing obviously to the parent controller 1. If we open that up, you'll see that the parent value here is 5. So we did update it in the same location as the actual prototype object. As a side note, if you take a look here, and we'll close this up for a second, let's open it back up, you'll see that not only do we have a prototype underscore underscore proto underscore underscore, but we also have this $parent object. Well, I told you before that it's bad practice to access the underscore underscore proto underscore underscore because it's kind of an internal JavaScript object. However, AngularJS exposed, at least if not all of it, but certainly part of it, of that object, to us as a $parent, and that is not an object that you should avoid. You could actually use that if you wanted to. So for example, I could go back to my code editor, I can actually traverse that object, and let's say I could log and say I want to log scope dot $parent dot parent value. And if I save that, we go back to our browser, you'll see that the $scope dot $parent dot parent value is 1, and that is being retrieved from the parent, meaning going up the prototype chain and retrieving it from the parent, which is the parent controller 1 scope object. In the final part of this lecture, part 5, we'll continue our example, but this time we'll explore using the controller as syntax, as well as go through a quick summary of concepts that we've learned in this lecture. In part 4 of this lecture, we explored a coding example that showed how the $scope inheritance works in Angular. In this lecture, we'll continue with that coding example, but now use the controller as syntax. Okay, so let's go back to the code editor, and what we'll do, not to convolute our logging statements, let's go ahead and comment this whole thing out. And what we'll do this time is go to our index.html and we'll uncomment the couple of controllers that we have here. So what we do here is we have a couple of controllers. One is a controller called parent controller 2, and in this time we're using the controller as syntax and giving that controller a label, and we'll call it parent. We could call it whatever we want. And then if you look down here, we have another ng controller, which is child controller 2, and we're giving it a label of child. So since any properties that are going to be added now to the scope are not going to be added directly to the $scope, but going to be added to the $scope dot parent property or dot parent object, and since we know that we don't need to actually mention $scope, that property that is sitting on the $scope, which is the parent property, can now be referenced directly in our HTML template. So we could say parent.value, assuming there's a value property on that parent object. And we could also say here child.value. Let's go to app.js and take a look as to what our controllers look like. So first of all, here we have our parent controller 2. And it's kind of a best practice to try to name this variable that we're going to kind of attach all kinds of properties to the same as the label inside of your HTML template. You don't have to do it. Some people actually name it VM for viewmodel, but I like to keep it at the same name as the label I gave in the HTML template. But what you name it here makes absolutely no difference because this is just a local variable and you're just using it instead of having to say this everywhere. Some people say this everywhere, but this is a little bit more clear to read. So what I'm doing here is I'm saying parent.value equals 1, which means I'm assigning a property called value to the instance of this parent controller 2. Now note that even though I have this scope here injected, I really don't need it here, and it's probably actually left over here because I was doing console log statements. But since I have no console log statements that in the parent controller 2 that I want to log the $scope to the console, I'm just going to go ahead and take it out altogether. We don't really need it because the scope is provided, we're just not using it anywhere because we're attaching the properties directly to the instance of the controller itself. And it's Angularjs that is taking the instance of this controller and assigning it to the $scope for us behind the scene. Now let's take a look at the child controller 2, and the only reason again I'm injecting scope here is because this time I'm actually going to log the scope so we could just look at it. But really I don't really need it here at all unless I'm specifically using it for something. And here the construct is exactly the same. We're declaring a local variable that is the same name as the label that we declared our controller with in the HTML template, and we're creating a property on that object called value, which is exactly the same name as the property of the parent. However, since we're assigning it to the instance of the controller in both cases, this value in no way is going to mask this value, which means as long as we reference the proper controller, these values can work independently. And all we're doing here is we're going to go ahead and dump the scope object to the console so we can take a look. Let's save that for a second and let's go back to the index.html and see what we're doing here. As you can see, it's much easier to read as to what's going here as well. Since parent is being assigned as a property on our $scope by Angularjs, I can now reference parent.value and reference child.value here as well. Let's go ahead and save that and go to the browser. And you can see that the parent value here is 1, as we expected it to be, and the child value of the child inner controller is 5. Now let's go ahead and take a look at the child's scope object. If we open it up a little bit here, we could see that we have a child property that is equal to the child controller 2 instance. And we could see here, if we open it up, that is value equal to 5. Now if we go ahead and traverse its prototype chain, right here, we'll see that its prototype has a parent property, and that parent property is equal to parent controller 2 instance. And we could see here that its value is 1. So if we go back to the code editor, you'll see how much easier it is now to even reference properties of our parent controller in our inner child controller. So for example, I could say here parent value, and I can reference now the parent controller, since parent is something that got inherited as part of the prototype chain. So parent.value. And if we do this and go back to our browser, you'll see that the parent value is 1, and it's the same parent value that we retrieved right here, even though this parent value is being mentioned inside of our child controller. So this way, it's much easier to read. You see here that we're actually referencing some property that belongs to this particular controller. So it's easier to read, easier to debug, and you could see where these properties are coming from. So let's summarize. First of all, please don't think that all these numerous concepts that we learned as part of this lecture are only applicable to understanding the controller as syntax. What we learned is applicable throughout AngularJS framework and really throughout JavaScript in general. So let's review. Inheritance in general is used for code reuse and sometimes to express a relationship between entities. Prototypal inheritance in JavaScript is based on object instances rather than classes. In general, prototypal inheritance is much simpler than a class-based inheritance, having only a couple of rules to know. First, the child's object's properties are inherited from the parent and are looked up through the prototype chain, so they are actually not sitting directly on the child. Second, the property can be local if it's declared on the child object itself with the same name as the parent and therefore masking the parent's property. Now when it comes to AngularJS, the $scope is based on prototypal inheritance, which means that a child controller's $scope inherits from the parent controller's $scope. So if you have two nested controllers, the inner controller's scope is prototypically inherited from the outer controller's scope. Now when it comes to controller as syntax, it's very simple. It's the controller name ng-controller equals controller name as, and you give it a specific label. Angular then creates a property with that same label name on the $scope that belongs to that controller. The label name becomes a reference to this keyword, in other words, the instance of the controller function. Now the reason that works is because when we call .controller to declare our controller in AngularJS, the .controller treats our controller function as a function constructor. So when you start declaring properties that you want to share between your view model, the controller, and the HTML template, you attach them directly to the controller instance. In other words, you attach them to the this keyword, not the $scope. With the controller as syntax, the syntax in our HTML templates as well as our JavaScript code becomes much simpler, and we no longer have to deal with the masking that can occur with the prototypal inheritance, making the code much simpler to write.
In this lecture, we're going to learn why and how to build custom services in AngularJS. Remember that controllers are the view model in our model view model design pattern that we've discussed before. The job of the view model is to represent the state of the view. Obviously, the way we represent that state is through the data that's dealt with in the controller's instance. As we've learned, that happens through the $scope object. We also discussed that the controller should not contain much, if any, business logic functionality itself. Instead, it should pass on the responsibility of handling business logic to some other components.
When we speak about controller's responsibility, the controllers are supposed to set up the initial state of data on the $scope. They're also supposed to add behavior to the $scope. Now, when we speak about adding behavior to $scope, we don't mean to say that the controller should be responsible for business logic there. What it means is that the controller is responsible for handling any events and updating the view state. In other words, affecting the values on the $scope object as a result of some event bound to one of the methods on the $scope. On the other hand, we do not want to use controllers, among other things, to handle business logic directly. The code that handles the business logic should be factored out into its own component, which we're about to talk about. And also, controllers should not be used to share code or state across other controllers. We spoke previously about the fact that it's rare for a web application to only have one controller. With multiple controllers in the same app, it's inevitable that some data will have to be shared across those controllers. Controllers shouldn't be used for this type of sharing. The answer to all these things is to use a custom service. Now, how do you register a custom service? Well, it's actually very similar to the way you register a controller. The module instance in Angular has another method called service. And just like a controller, it takes the name of the service and the function value that is to be the function constructor used to create that service. Note my terminology. I do mean that the function value they provide to the .service method is treated as a function constructor. And we've already discussed before what that means in the previous course. Also note that the string name that you give to the service is the name that you use to inject into other services or controllers, not the name of the function that is used as a function constructor to create the service. There are a couple more very important properties of creating a service with the .service method. The service Angularjs will create for us using this method is guaranteed to be a singleton. Now, what's a singleton? Well, that's yet another design pattern. And the loose definition of a singleton design pattern is that it restricts an object to always having a single instance. What that means is that each dependent component will get a reference to the same instance, which means also that multiple controllers injected with that particular service will all have access to the same service instance. That enables us to share data between different controllers or other components within our application. So if you place some data into the service in one controller, you can immediately retrieve it in another controller injected with the same service. That's why services are very convenient for sharing data across your application. There's another property of a service that we need to know about, and that is lazily instantiated. What lazy instantiation means is that the service is only created if an application component declares it as a dependency. If no components in our application are dependent on the service, it will never even get created. Okay, so that's enough of theory. In the part 2 of this lecture, let's jump into the code editor and see these concepts in action. Okay, so I'm back in my editor and I'm located in lecture 20 in the Full Stack Course 5 examples folder. And here we have a very simple shopping list app. And what this app will do is will let us add things to our shopping list. But what we did here is we broke it up into 2 controllers. In fact, let me go ahead and close the file browser so you can see this a little bit better. So there's 2 controllers here. The controller 1 is called the shopping list add controller, and you could see that we're using the controller as syntax. So anywhere within this controller right here, we're going to be referring to our controller as item adder. So this is the thing that's going to let us add items to our shopping list. And you could see that we have a couple of input text boxes here, and each of them is bound to a property that is sitting directly on the controller, just as they should in a controller as syntax. And one is called item name, and the other one is called item quantity. We also have a button here with an ng click bound to item adder.add item. What that's obviously going to do is going to read these particular properties and create an item and then place it into some data structure like an array to keep a list of all items in our shopping list. The second control we have here is this one right here, and this one is nicknamed as showList. That's its label. And all we're doing here is, let's scroll up a little bit, all we're doing here is we're doing ng repeat, and there's apparently inside of that controller a property called items, and it's a collection, probably an array, and we're looping over those items, and every time through the loop we're saying I want to list the item.quantity of item.name. And we're doing this inside of an ordered list, so it's going to call 1, 2, 3, and so forth. Of course, these are two separate controllers, so we can't exactly share data directly between them. But what we can do is have a service that shares data between them and also has some methods that help us keep track of the items in our shopping list. Let's go ahead and go to the app.js and see how we did that. So the first thing you see is we declared both of these controllers. This is something you've seen before. There's nothing new here. And then what we've done here is we've declared a service. Service is called shopping list service. And just for convenience, the function value that is representing that shopping list service is also named shopping list service. Let's go ahead and jump and take a look at that shopping list service. Well, it's a regular function, and since it's going to be used as a function constructor, we know that we can attach things to the this variable in order to expose it to the outside world. So here we're doing a regular pattern that we've learned in a previous course, with just basically renaming the this variable to something that's more readable and will not have issues with inner functions. So now everything from now on that's called service is really just this. And you see here we're declaring an array of items, and we're not exposing it through the service. So it's going to be internal to our shopping list service. And we have this one method here, or a couple of methods. One is add item, and add item takes an item name and a quantity. All it does is it creates an object item with a name and quantity properties, and then pushes that item, that object, onto our items array. And the last method here is called getItems, and all it does is actually expose our internal items array to the outside. So if you call getItems, you're actually going to get our items array. So if we ever decided to represent the items not as an array but something else, or maybe something more complex, this getItems method helps us hide that data structure from the outside world, meaning outside of our shopping list service. So let's take a look at our two controllers. The first one we called the shopping list add controller. That's the guy who is going to be responsible for adding things to the shopping list. And as you can see, we're injecting it with the shopping list service, and obviously repeating it not only in the $inject array, but inside of the argument list of the actual function that represents the shopping list add controller. And again, the same pattern, items header, that's our label from the HTML template. And items header is going to initialize the item name to be an empty string, and item quantity also to be an empty string. And here we only have one method, which is add item. And what that's going to do is going to use our shopping list service and call our shopping list services add item, which is going to pass it the item name that is bound to our HTML input field, and the item quantity, which is also bound to the HTML input field. Now, when we look at the controller that is responsible for displaying the shopping list, we see here that we have a very similar construct here. We also are injecting this shopping list service. And as you remember, it's the same instance of the shopping list service that AngularJS created for us in this particular call right here, service. When AngularJS creates that, it only creates one of them, and every time it injects it, it injects the exact same instance into wherever you try to inject it to. In this case, a couple of controllers. So our shopping list service is injected into the shopping list show controller. And again, the same pattern, show list equals this, because this is a controller as syntax. So we're attaching all the properties directly to the instance of the controller that is automatically attached to the $scope for us by Angular, the controller as syntax. So shopping list here, all it's doing is exposing the items list. And the way we get the items is again from the shopping list service that get items. So whatever that was placed into the items array that is internal to the shopping list by the other controller using that same shopping list service instance is going to be returned right here by getItems, because the instance of the shopping list is one and the same. Let's go ahead and save that and go to our browser, since I have the browser sync running already, and I could start entering my item names. Let's see, cookies, very important. Let's get like 3 bags of that. Click add item to shopping list, and you could see it's showing up immediately in the other part of the page. And this part of the page is something that the second controller, the show controller, was responsible for. Let's go ahead and add something else good, like chips. Let's get 4 bags of that and add that to the list. You can see again, it's immediately showing up since we've bound the items collection that is being output through the ng repeat. We've bound it to the shopping list items that is internal to the shopping list. And for good measure, let's go ahead and do sugary drinks. Let's get like 10 of those, 10 bottles, and add to the shopping list. Here we go. So we're good to go here. The only minor problem here is that we don't have any way of removing anything from the shopping list. So let's go back to our code editor and code up a remove method on the service and then propagate it throughout the components that use that shopping list service. Let's go ahead and add method right here. We'll say service.remove item, and it's a function. And what we're going to do is we're going to ask for an item index from whoever is using it, because we have a list after all. So it should have whatever the item index that you want to remove. And we'll say items.splice. Splice is a special array method. And it takes an index that you want to remove from and how many you want to remove from that index. And since we only remove one, we're going to remove just one. Okay, so that's the remove, or not the remote, remove item method. Okay, so we've got the remove item method. Next, let's go to our show controller, or the shopping list show controller, and code up a method that we'll be able to use in the template. We'll say show list.remove item equals to function. Don't need the name. And we'll also ask the HTML template to pass us along an index on which the user clicked. And we'll see how we're going to do that. So we'll say item index. And here, since we're using or reusing the same instance of the shopping list service, we could say shopping list service right there dot remove item, and we'll just pass along the item index. And I misspelled here, it's index. Okay, so we're good to go, semicolon, right there. Okay, let's go to the index.html, our template, and actually make sure that it invokes our remove item method. The way we'll do that is we'll scroll down to each item here. This is where each item is being displayed. And right next to the item, we'll create a button that will have ngClick bound to, and our show list is the label. So we have to use the show list.remove item. And as you remember from our discussion of ngRepeat, it exposes the index through the loop using the $index property that is available to the body of the element on which the ngRepeat is declared. So that's exactly what we're going to do. We're going to say remote again. Let's do remove, not remote. Remove item, and index is going to be $index is what we're passing it along. So it should point to exactly the item, the index of the item in our array. So let's go ahead and save that. And one more thing is forgot to put the label in here. We'll say remove item. So that's going to be the label of our button. So let's go back to our browser. And you can see now when we add stuff like cookies and 3 bags of it, we'll click add. You see the remove button now shows up. Let's go ahead and add something else like chips again. That's 4 bags again. We'll add that to the list. And let's go ahead and add what we're really going to need after all that type of food is Pepto-Bismol. And we'll get 2 bottles of that. And we'll add that to the list. Okay, so now we have 3 items in the list. And we have the remove buttons. And if we click the remove button, the 4 bags of chips will go away. Let's take a look. And sure enough, it goes away. And we could actually remove every single one of them one by one. So the item list is now empty. So let's review. Controllers are not supposed to handle business logic. They're also not supposed to be used to share code. So if you have common code between different controllers, it's not a good idea to try to reuse the controllers. Rather, you should refactor that code into a service and then share the service between the controllers. Controllers are also not supposed to be used to share data across different components. Now, custom services instantiated with the .service method are singletons, which means there's only one instance of the object that ever exists, which means you could share data between different controllers or other components using that service because, again, only one exists, so therefore it's going to hold the same data across all of your components of your application. Also, services that instantiated with the .service method are lazily instantiated, which means they're only created if something actually depends on them. If nothing depends on them, they're simply not instantiated at all. And last but not least, the .service method that you supply the function to as your custom service treats that function as a function constructor. And we've spoken before That what it means is that the AngularJS internally will actually new up your function using the new keyword, which has ramifications for what this keyword means inside of your service function. In this lecture, we're going to talk about creating services and really just about anything else with the .factory method. First, it's a good idea to review the characteristics of the design pattern, which is what this method is based on. The factory design pattern characteristic is that it's a central place that produces new objects or functions. Now, this is not an official definition of the factory design pattern, but I think it communicates the idea without too much of the computer sciencey lingo. For our purposes, the point is that a factory can produce any type of object, not just a singleton. And it can also be used to produce dynamically customizable services, which is what we're going to end up doing in this lecture. Now, there's quite a bit of confusion in the AngularJS community regarding factory versus service. After all, the .factory method is sometimes called a service factory, which actually makes sense because the factory is something that can produce a service. But there's some very important distinctions. The .factory method is not just another way of creating the same service you create with the .service method, but it can be. The .service method is also called a factory, but a much more limited one compared to the .factory method. The .service method is a factory that always produces the same type of service, a singleton, and without an easy way to configure its behavior. The .service method is usually used as a shortcut for something that doesn't require any configuration whatsoever. Now, the way you register the service factory function is very similar to the way we registered the service and the controller. You call the .factory method on the module, you specify the name of your factory, in this case custom service, and then you specify the factory function. Now, the factory function is the thing that's expected to produce a service when you execute it. Note the very big difference. If we made the same exact call with the .service method, the custom service would be expected to be the service, not produce a service as a result of either direct invocation or invocation of one of its methods. Also note that in this example, we named the factory function custom service, and its name that we registered with the .factory method as the same custom service. But the truth is, what we name our function doesn't make any difference. However, what we register that function with, which is what is in quotation marks, is the name that we use to inject into other services, controllers, etc. So it's not the name of the function, it's the name that you register that function with the .factory method. Now, when it comes to writing the factory function itself, in this case, the name custom service function, there's a couple of different implementations you could go with. The first one is the one you see here, is the one that returns a function as a result of the execution of our factory function, which is custom service. As you could see, the local variable that's returned factory is actually a function value. What we're ultimately after is creating a service called someService. Note that we're the ones calling new. In other words, we're the ones in control of how and what gets created. Once we create whatever we want, we can return that as a result. The execution of the custom service function, in other words, our factory function, itself returns a function because the returned local variable factory refers to a function. That's one way of implementing this factory function. A different way of implementing the factory function would be to return an object literal. Here we're creating an object literal with a property called getSomeService. The value of the property getSomeService is a function. So the return value of the execution of the custom service factory is an object literal. We can then retrieve that object literal's getSomeService property, whose value is a function, and execute it, obtaining an instance of some service that we could then use. Even using this implementation, again, we're the ones responsible for newing up the service called SomeService. We're in control of how it gets created, and that's the biggest point of using the .factory method. So to highlight the differences between two equally valid approaches, I've pulled out just the body of the factory function. On the left, you see one approach, which is an object literal with a property method that calls new SomeService. That object literal is what is returned as part of the execution of the factory function. On the right, we're returning a function that returns a reference to the new SomeService. The value of that function, the factory, is what gets returned when you execute the factory function itself. There are obviously differences in how you use the factory depending on which implementation you chose. If you go with the object literal approach, then the way you would use it is by referencing your factory function as an object that AngularJS created for you and then accessing the method property, which is .getSomeService. Since the custom service refers to an object literal, you would then access one of its properties called getSomeService in the same way you would access any property of an object literal through the dot notation. However, getSomeService property is a function, so in order to execute that function, you simply put parens behind it. Once that's done, you can then use the service that's produced inside of the function that's referenced by the property getSomeService. So it's SomeService, .method, and so on. In the case of implementation that uses a function as a return value from the factory function, unlike the object literal approach where the custom service factory function actually refers to an object literal, in this case custom service will refer to a function. So all we need to do is put parens behind it and execute it in order to get our created service. And then use it just like before, SomeService, .method, and so on. Okay, so now that we understand the process of creating these factories, let's go to the code editor and see an example of how to create and use these factories. If you have never heard of the factory pattern, this overview may be a bit difficult for you to digest on the first try. My suggestion is for you to move on to part 2, see a coding example of these concepts, and then come back and watch this video again to grasp these concepts on a deeper level. Okay, I'm back in my code editor, and I'm located in Lecture 21 folder, which is located in fullstack-course 5 examples folder. And this is a similar application to what we've written before. In other words, we're going to be creating a shopping list, except now we're going to be creating two separate independent shopping lists that are going to be sitting side by side. So we're going to need a shopping list service, but we don't want it to be a singleton anymore because we don't want one shopping list affecting the other one. So the way we're going to do that is basically create two separate controllers. One is going to be responsible for list 1, shopping list 1, and the other one is going to be responsible for shopping list 2. Except we want to enhance the shopping list service just a little bit. We want to be able to tell the shopping list service that there might be a max number of items that we might ask it to limit itself to. Obviously, we're going to be creating the shopping list service using a factory because in every single controller we need to create a new one, and sometimes we'll need to create one that doesn't have a max item limit, and sometimes it will have a max item limit. So let's go to our app.js and see how we did that. The first thing we want to do is actually scroll down to our shopping list service and modify it a little bit. In this case, we want to specify that there might be a max number of items that we want to limit the shopping list to. So the code is almost identical except for the service.addItem method. And in this case, just before adding our item, we actually need to check. If the max items is undefined, which means the caller of our service didn't even bother to redefine the max number of items, in which case we're going to go ahead and assume that there is no max items, it's unlimited, and we'll go ahead and push the item onto our list. Or we have to check if there is in fact a max items specified, meaning it's not undefined, we need to check that the number of items in our list is less than the number of max items allowed. And if that is the case, we can then go ahead and add that item to the item list, our items array. If this condition is false, then we're going to have to throw an error. And here you see an example of throwing an error. An error is a built-in JavaScript class, and we'll give it a message, max items of max items is reached. So the user knows, or the user of this service knows, that we've reached our limit. Everything else about the service is exactly the same as we've done before. Now we need to create the factory. Well, the first thing we need to do is scroll all the way up and look at our factory declaration. So the factory declaration is .factory. We're going to give it the factory name, which is our shopping list factory, and the function that is going to be our factory function, which is in this case, again, shopping list factory. Note that we don't need to register the shopping list service here with the .service method. And that's because we don't want Angular to create the shopping list service for us. We want to create that service ourselves. Let's go ahead and scroll to the shopping list factory. And you can see it's very simple, and you can see also that we're using the kind of the function approach here instead of the object literal approach. And our factory is a function that takes the max number of items, and it will return a new shopping list service passing it the max number of items. And so what will get returned as part of the execution of the shopping list factory is a function that takes these max number of items and returns the shopping list service. Now all that's left is to take a look at the code of the controllers. Let's go ahead and scroll up to the first controller, which is called list1. That's how we nicknamed it in our template, because we're using a controller as syntax. You can see that we're injecting the shopping list factory into our shopping list controller 1. And in order for us to get a new shopping list, you could see that we're using our shopping list factory and simply executing it. Note, well, we're not passing anything into it, which means the max number of items is going to be undefined. But since the shopping list factory refers to a function that is being returned out of it, putting parens behind it will execute that function and will execute the new shopping list service. And that's why we have shopping list as our local variable here as an instance of the shopping list service. Once we have that, we obviously can now start calling methods on it like get items. And you can see here when we add the item, we could just say shopping list.add item, list1.item name, list1.item quantity. So very similar to the way we used it before. In the shopping list controller 2, you could see that we're likewise injecting the shopping list factory into the shopping list controller 2. But this time, when we execute the shopping list factory, we pass it the max number of items as 3, which means our shopping list, the local variable, the shopping list that's referring to the shopping list service, is now going to be limited to 3 items only. So therefore, we need to change our add item method slightly. We need to make sure that if an error is being thrown from our shopping list, that we catch it and do something about it. Well, that's the try-catch block that you see here that exists in JavaScript. So we're going to try to add the item, and if the number of items in the shopping list is going to exceed 3, it will throw an error, in which case we're going to catch that error, and we're actually going to set a property on our scope, or really on the instance of our controller, since we're using the controller as syntax, that is going to get exposed to our HTML template, and we're going to set the value of our error message to error.message that is going to come from that error that we threw from the shopping list service. Okay, let's save all that, and since I have my browser sync running, let's go to the browser and take a look. So we basically have both shopping lists side by side, and we could start filling it out. So we'll fill it out with cookies again, 3 bags of cookies, and we'll say we want chips. We'll get 4 bags of that, 4 bags of that, and we'll say sugary drinks. We'll get 10 bottles of that, and we'll say Pepto-Bismol. We'll get 3 bottles of that. As you can see, I was able to add the fourth item without any problems. Let's see if we could do the same thing for shopping list 2 that is supposed to be limited to 3 items. Let's go ahead and again say cookies, 3 bags, and we'll say chips, 4 bags. Let's make it 5 bags for good measure. And we'll say sugary drinks, 10 bottles, and we'll say Pepto-Bismol, 2 bottles. Ooh, and look at that. When we add the next item, you could see that the error message displayed max item 3 reached. And you could see there's only 3 items in our shopping list. So point is, you could see that they're acting independently. The number of items here does not affect the number of items here, and also the items are differently, which means there's a different instance of the shopping list service being used in our controller 1 versus our controller 2. Now we do have a little bit of an ugliness here, which is this error message that is sitting here no matter what. If we refresh here, you'll see that the error message is already here. Ideally, we would really like it not to show up here at all until an actual error occurs. We're going to take care of that in a future lecture. Let's summarize. The .factory function allows us to produce any type of object or function. That includes a service in even a singleton, but it's not limited to that. The .service, on the other hand, is just a more limited factory. It limits us to creating a service that is a singleton and also one that's very hard to custom configure. The way you invoke the .factory method is very similarly to the way you invoke the .service or really .controller method. You give it a name and a factory function. The name you give to your factory is what gets injected into other components. The injected factory function refers to whatever is returned in the factory function. It can be an object literal with a property that's a function that creates something for us. It can also directly be a function that itself creates something for us.
The .provider method is the most verbose and at the same time the most flexible method of creating services in Angular. Not only can you create a factory that's dynamically configurable at the time of using the factory, with the provider method you could custom configure the factory just once at the bootstrapping of your entire application, and then use that factory throughout your application with your custom settings. In other words, you could configure this factory before your application starts. In fact, as the Angular documentation tells us, the provider method is what actually gets executed behind the scenes when we configure our services with either .service or .factory methods. Let's go over the steps of using the .provider method.
The first step is to define the provider function. You'll notice that this is a special function that has a particular property on the actual instance of the function. Here you see that the var provider is equal to this, so therefore provider.$get, the $get property is a function that is directly attached to the provider instance. That function is a factory function. In other words, it's just like the one that we used to provide to the .factory method. In that function, you create your service. In our case, we're creating a new service called service. This $get property that's a function is what makes the provider a provider. AngularJS expects the provider to have a $get property whose value is a function that Angular will treat as a factory function. But what makes this whole setup very special is the fact that you could provide some config object inside the service provider, and that usually comes with defaults, that you can later override in the step where you configure the entire application, which we'll see in a minute. So in this case, we're saying provider.config, which means the config property again is sitting on the instance of service provider, and it's equals some object literal that, for example, can have a prop property in it. Step 2 is to register the provider function with the module. And the way you register the provider is very similar to the controller, the factory, and the service. You just say .provider, it's a method on the module instance, and you supply the name of the service that the provider will produce and the service provider function that has a $get as part of its properties. Now notice that the name that you're supplying in the provider function is the name of the service as it will be injected into other services, controllers, and so on. The name of the function or the service provider function does not matter at all. The third step is to inject our service just as usual. And you'll notice here that what we're injecting is we're injecting whatever the .provider defined name was, not the service provider function. Our .provider declared that we're going to have a service called service, and therefore what we're injecting is also called service. Well, so far we haven't really configured anything. So that's why we're on optional step number 4a. That is registering the config function. Now, config function is the special function that you can invoke on the module instance that is guaranteed to run before any services, factories, or controllers are even created. Which means that's a step for us to be able to tap into configuring these services before they're ever created. Now, the reason it's optional is because you don't have to configure it. You could just have the defaults take effect. However, for some services, there doesn't make any sense to have any type of defaults, so sometimes this is simply required by the business logic or particular service that needs to be configured. The optional step 4b is to actually define the config function. As you could see here, in defining the config function, we're injecting service provider into the config function. Now, we cannot inject any regular services into the config function simply because it gets executed before any services, factories, or controllers are even created. Therefore, what we need to do is get at the provider function of a particular service. And if the provider has been declared with a particular string, the thing that we inject into the config function is that string plus the string provider. So in this case, our provider has been declared with service. Therefore, what we inject into the config function and then use inside of it is service provider. Once again, the name of the actual provider function is completely irrelevant. Last but not least, we can then use the service provider instance to get at its properties like config and the config properties to go ahead and configure it for a particular application. Okay, so now that we went through the process, in part 2 of this lecture, let's get into the code editor and see how this works in action. Okay, I'm back in my code editor and I'm located in lecture 22 folder, which is inside fullstack-course 5 examples folder. And here we have again our shopping list app, and it actually looks just about the same as our shopping list app that we used in the factory lecture. So we have a couple of input fields, text fields that we're going to be typing in the item name and item quantity, and we'll be able to click the add item button, and that will immediately get displayed in our ordered list that is powered here by the ngRepeat directive. However, this time our shopping list service is going to be created using a provider. Let's go ahead and take a look. Let's go to app.js. Scroll all the way up, we're right here, and we could see here that we have a .provider instead of .service or .factory, and the name of our service, again, that's not the provider, it's the name of the service that we're going to be using, is called shopping list service. And the name of the provider function is called shopping list service provider. So I just tacked on the provider name on there just so it would be clear, even though the name of this function makes absolutely no difference. So let's go ahead and scroll down all the way to see what our shopping list service provider function looks like. And you can see it's very similar to what we had in the slides. And the most important thing here is that we're basically assigning this keyword to the local variable called provider. And then we're attaching the $get property to the instance of our shopping list service provider, right? That's really a substitute for this $get. And that is a function that's going to create our shopping list service. and is going to return our shopping list service to whoever is asking for it. Now what we've also done here is we created a defaults object that has a max items of 10. So when we create our shopping list service, we simply look up the provider.defaults.max items to create a shopping list that is going to allow only 10 items inside of it. So let's take a look at our controller. It shouldn't be really anything different than we've had before. Our controller, shopping list controller, is going to inject. Notice it is injecting the shopping list service, not shopping list provider, but shopping list service, meaning the service name that we gave to our service when we declared the provider, because the providers provide services, or is a factory that provides a service. And the rest of it is basically about the same. We're injecting that shopping list service here, and we're getting the items straight from the shopping list service instance. That's because we returned that instance as part of our generation of the shopping list service. And the rest of the code is exactly the same. We add the item, making sure that we are not exceeding the number of items, the max number of items, because if we do, we're gonna throw an error from inside of the shopping list service itself. And we're going to catch that error right here, displaying that error message on our list, this error message property that is going to get attached to the instance of the controller, because once again, we're using controller as syntax. Okay, and the remove is exactly the same as before. The shopping list service itself is once again identical to what we had in the previous lecture. It just has some special logic to make sure that the max items are defined, and if they are defined, the number of items in our items array is less than the max items. Otherwise, we are not going to push a new item onto the items array. Instead, we're just going to throw an error saying the max number of items has been reached. So since I have my browser sync already working, I'm going to go ahead and save that and go to our browser. And here I have my shopping list, and I could start saying cookies, 5 bags of cookies, and we'll add that item. And we'll say chips again, and we'll take 10 bags of that. Okay, great. In fact, let's add a couple more 10 bags of chips. As you can see, we could add quite a bit here. You know, we could do more cookies again. And let's get 10 bags of cookies. And we could keep adding this until we hit 10. And if we add one more, since 10 was something that we defined in our code, let's go back and take a look at our provider. Since the max number of items was 10, that's our shopping list service was created with the max number of items being 10. So therefore, when we see in our browser we're up to 10, if we try to add any more, it's going to throw an exception. The exception is going to get caught inside of the controller, and the controller is going to set this error message to be displayed in the browser. Okay, so the one thing we haven't done is we haven't really configured it ourselves. We're relying on the default values. Plus, if you leave the shopping list up to me, it's going to be a bunch of 10 bags of chips and cookies, and we need to save me from this type of shopping list. So let's go ahead and limit our shopping list to much less than 10 items in the list. Let's limit it like to 2. So let's go back to our definition when we're defining our module, and we'll go ahead and define one more function called config, and we'll call our configuration function config for lack of creativity, which probably doesn't need to be here. So let's go ahead and define our config function. The first thing we need to do is define our inject array, and that inject array is going to have our shopping list service followed by the word provider. Okay, now that we did that, we could actually define a function that is going to be called config, and what we're passing in here is shopping list service, the same thing that we declared the provider with, plus the word provider, the string provider. Okay, so once we define that, we can now go ahead and get at the provider properties. In this case, it's shopping list service provider dot defaults dot max items, and let's limit it to 2. So now, for the duration of the entire application, the shopping list is going to be limited to the max number of items being 2. And here we could say save Yakov from himself. Okay, let's go back to the browser and let's go ahead and try to get cookies. Let's get 10 bags of that. And here we could add 10 bags of cookies. Let's get another 10 bags of cookies. And if we try to get yet another 10 bags of cookies, it doesn't work because we only limited our shopping list service to have only 2 items in our shopping list. to save Yakov from himself. However, that doesn't really work since I could just remove that and say, let's get 100 bags of that. So there we go, 110 bags of cookies. So that whole saving thing didn't really work at all. So let's summarize. Among the service and factory type of functions, the provider one is the most verbose, but it's also the most flexible of them all. And that's because you could configure a factory not just at the time of use, but also at app bootstrapping before the entire application even starts. The way the provider works is you give it the name of the service that you will be using and the provider function, the function that is the provider. That function has to have a $get property as part of its instance. Whatever the name is, that's what gets injected into other components, not the provider, but the actual name in the string name that is given in the .provider function. The .config function, which is optional, but very often used, is the one that gets called before any service factory control is instantiated, which means that we can't inject any regular components into the .config function like other services or factories. But we can inject the provider of the service by simply putting the name of the service and appending the string provider at the end of it. And that is the service that we inject into the config function that we're able to configure our provider such that the factory that produces some service is configured only once at the beginning of our application.
In the last few lectures, we displayed an error message if the shopping list exceeded a certain number of items. The error message was a property attached to the controller instance, which itself is attached to the scope service. However, we displayed the error label at all times. If there was no error, we simply displayed an empty string next to the label. What we would really like to do is hide the entire containing div if there is no error message and show it if there is one. We have seen Angular directives like ngController, ngapp, ngRepeat. In this lecture, we'll take a look at another few directives called ngIf, ngShow, and ngHide. There's not much theory behind these directives, so let's go straight to the code and see how they work.
Okay, we're back in our editor, and we're in the folder Lecture 23, which is located in Full Stack Course 5 Examples folder. And this is our shopping list app that we've seen before. And we have one controller here called shopping list controller, and we're using controller as syntax to have a label called list for it for the inside of the controller body. As you remember, when the user clicks on the Add Item button, if the items array inside the shopping list service exceeds a certain number of maximum items, it will throw an exception. Let's take a look at that code in app.js. So if we scroll down here to the list.addItem, you'll see that if this particular statement throws an exception, we're going to catch that error and we're going to assign list.errorMessage, and we'll assign the error message from that thrown error object to the error message on the list. So if we go back to index.html, you'll see that we're displaying the word error, the label error, and then displaying the message that is supposed to come back from the controller. As I said, what we'd really like to do is not show this whole div at all if there's no error message. Well, one way of doing it is to use the ngIf directive. The ngIf directive takes a condition as its value. If that condition is true, the entire div is shown. If that condition is false, evaluates to false, then AngularJS takes the entire div out of the DOM tree. In other words, it's as if this div does not exist in our HTML. Let's go ahead and save that and go to our browser. And we could see here, let's bring up the Chrome Developer Tools, and we'll go to Elements. Let's take a look to see if we could see that div in our HTML. So if we open that up, we could see here that instead of our div, right after the ordered list, we see the comment, the HTML comment called ngIf list error message. And you can see it's commented out. There is no div existing. And the reason there's no div existing is because list.error message evaluated to false. However, if we start adding, at this point, we'll just add some bunch of nonsense here. We'll start adding some items. And finally, when we add more than 5, you'll see that that div all of a sudden sprang up into action, and it's now part of the DOM, the document object model. You see the div here, you see the ngIf, and that's class error, and the error is something class that we assigned to it. As you could see, it's coming from styles.css, and that's why the color of our text is red. And you can see that the div showed up. However, there's a different way to hide this message. Let's go back to our code editor, and we'll go to the HTML template, and instead of the div with the ngIf, we'll go ahead and comment that out. And I have some pre-written code here, and we'll use that right there. And what we're using now is we're using ngShow. ngShow does exactly the same thing as ngIf does, except that it will not remove the div from the document object model. It will simply put special classes on it that Angular will know to have the div hidden. Let's save that and go back to our browser, and let's go ahead and put some bunch of nonsense in here and add 5 items. And if we take a look here, before we even added 5 items, we'll see that the div is here, except it has some ngHide on it as one of the classes, and that is why it is hidden. In fact, I'm sure if you look at ngHide here, you'll see it says display none, and that's why it's hidden. So as we keep adding the more and more items, add one more, you'll see that the ngHide class goes away from this div, and therefore it's now showing up in the browser. Now, the other directive is called ngHide, and as you could probably guess, it's the exact opposite of ngShow. The only difference between ngHide and ngShow is whether or not it's going to hide or show the element based on the true or false. ngShow will hide the element if the value assigned to it is false. ngHide will show the element if the value assigned to it is false, and vice versa. Let's go ahead and save that. And we could see here that we're putting a condition here, not list error message. In other words, we're going to hide it when list.error message is false. And since an empty string evaluates to false, that's when we're going to hide this whole div. Let's go back to our browser, and you could see, if we scroll down here, we could see that the div is still showing up here, and again we have ngHide already applied to this div, and that's because this evaluated to false, false reversed with an exclamation point becomes true, so ngHide is true, so it's hiding the div. So again, if we put some bunch of nonsense here and add 5 items, you'll see on the 6th item, this ngHide class will get removed because list.error became true. The opposite of true is false, so therefore it's no longer hiding our div. So let's summarize. ngIf is a general purpose if statement-like attribute directive. If its value is false, Angular removes the containing element from the document object model entirely. ngShow and ngHide attribute directives automatically attach CSS classes to the containing element that either show or hide the element, depending obviously on their value. The containing element, however, does not get removed from the document object model. So if for some reason you still needed to manipulate that element while it's hidden, you can do that with ngShow and ngHide, but you would not be able to do that with ngIf, since when its value is false, the entire element gets taken out from the document object model.
Congratulations on finishing Module 2. Time for a short reflection. If you have followed me in understanding the concepts behind features taught in this module, you're already ahead of a lot of AngularJS developers that simply mess around with Angular features without understanding why they work the way they do. That's not a small accomplishment, and you should be proud of yourself for that. Take a quick look back. It's only Module 2 and you already know quite a bit. So don't stop here, keep going to Module 3. There's much more fun ahead, I promise. Oh, and if you haven't visited our Facebook page at facebook.com/Coursera WebDev, please click on the link below the video and like our page. Oh, and if you have followed my cookie advice and ate the whole bag of cookies, Congratulations, you have gained much more than AngularJS knowledge in this module. Alright, that's over. And if you have followed my advice, by taking a bag of cookies at the beginning of this module, you've gained much more than just AngularJS knowledge. You've gained some weight. I'm busy recording. Oh, can you put cookies in the shopping list? I think we're going to be out soon. Is that thing still recording?
Welcome to Module 3. Excuse me, I gotta take a drink.
That's better. Welcome to Module 3. In this module, we'll go over a lot of the essential features of AngularJS. We will start with learning about the Promise API. While promises are essential to Angular, this topic reaches far beyond Angular. It's really an essential topic to understanding modern web development with JavaScript. We'll also learn about making calls to the server through the built-in Angular service called the HTTP service. We'll finish off the module by spending a considerable amount of time on the crown feature of AngularJS, directives. Directives are really at the core of the entire framework. They not only allow us to extend the functionality of existing HTML elements, which is already pretty amazing in and of itself, but they also allow us to create our own elements with custom view and custom behavior. Pretty exciting stuff. See you in the module. In this lecture, we're going to talk about coding and dealing with asynchronous behavior with promises and the $Q service.
Before promises, we had callbacks, and we actually still do. And the way you would execute asynchronous behavior is you would have some asynchronous function, and you would pass as an argument a function value that would get executed once the asynchronous behavior was complete. The problem with this model is that there's not really an easy and straightforward way to pass the results of the asynchronous function back to the caller. Now, this is especially if the real recipient of the result is a few layers away. In other words, one service can call some other service, and that service may call your asynchronous function. The result should really propagate all the way to the top function if that's what you choose, but it's very hard to achieve this with the callback approach. In addition, what would happen if you needed to chain a few asynchronous pieces of behavior together? For example, when asynchronous function 1 would complete, instead of returning the value, you would still have to call asynchronous function 2. When that would complete, you would finally call asynchronous function 3 and only then deal with all the results combined together. Right off the bat, you could see that it's very hard to read this code. And that's not even showing the error handling. With error handling, this would look like a complete mess. Also, what if we wanted all these asynchronous functions to execute in parallel? And then, if every call succeeded, execute our logic, but even if one failed, fail all of them and execute some error handling. That's not a very trivial thing to accomplish with the callback approach. But with the Promise API, we can actually get all these things accomplished fairly easily. The Promise API is actually part of the new ES6 API. However, not all browsers implement ES6 API just yet, so Promise Object might not be available. But AngularJS implements its own Promise API that is very similar to the one that's coming in ES6. So what is a promise? A promise is an object which can be passed around or returned that holds references to the outcome of asynchronous behavior. In Angular, promises are created through this special service called the $Q service. Let's take a look at some templates as to how you would go about doing that. So here we have an asynchronous function, and the very first thing we would do is call the $q.defer method. That service creates an object that represents the asynchronous environment with all the hooks into it, including the promise object. Then, after we implement some behavior, that object has a special method called resolve that marks a successful completion of our execution and then wraps the data for the promise to retrieve later on. In this case, we're wrapping the result object or some result as part of our resolve method call. If something goes wrong, we could call deferred.reject, which will mark unsuccessful completion and will also wrap some data for the promise. In this case, it will be probably some error object or some error message. Last, but certainly not least, we have to return our promise to the caller of this function. So therefore, we would say return deferred.promise. That sends back the promise object to the caller, which is really a hook back to the lifecycle of this entire process. Now remember that even though this sample code looks synchronous, and it probably is looking at it right now, the parts that ultimately call deferred.resolve and deferred.reject can be part of something that truly runs asynchronously. For example, if we wanted to simulate that in this example, we could wrap the highlighted lines of code in a setTimeout function. The next step is for the caller to call our asynchronous function and to capture a reference to the promise object. You can clearly see here that a promise is something I could pass around into other APIs in my application. Then, wherever in my application it's appropriate, I could call the then function on my promise and extract the results or handle the error. Note that the then function takes two arguments, both of which are functions themselves. The argument that the promise API will send into these functions is what we resolved or rejected the deferred object with accordingly. Obviously here I'm referring to the result object and the error object, which could be just a simple string. The then function is also chainable because it itself returns a promise. We'll demonstrate the power of this chainability in an example of part 2 of this lecture. The Q service also has the capabilities to resolve multiple promises asynchronously, so no promise has to wait for another to complete in order to even start running. The $Q all method accomplishes that, plus the ability to have a central place to handle all of the results or to handle any errors that come from any of the promises. In part 2 of this lecture, let's go back to the code editor and see some examples of how to use this API. By now, you should be fairly familiar with our shopping list application that we've been building. You can enter the name of the item, the quantity of the item, click Add Item, and it will appear in a list right below this form. In this version of the shopping list, number one is we're going to assume that the quantity is actually just a number, and that's why I put the word boxes right here to signify so many boxes. And number two, in order to prevent me from gaining weight, we're going to have a special service that's going to examine the item name and make sure there's no word cookie in it. If there is, it will prevent me from adding that item to my shopping list. Likewise, we will also examine the quantity, and if the quantity is anything greater than 5, the service will likewise prevent me from putting that item on the list. Now, since analyzing the item name could be a very complicated process and therefore can take a long time, we're going to implement that in an asynchronous fashion. Analyzing the quantity will also be asynchronous. What that will mean is that when we click Add Item, the item will not immediately appear below the form, but will first get analyzed and then decided whether or not it should even appear, and if it does, only then will it appear a couple of seconds later. Let's take a look as to how I implemented that. Okay, so I'm in my Atom editor, and I'm located in Lecture 24 folder, which is in Full Stack Course 5 Examples folder. And this is our shopping list promise app. And as you've seen before, it's just one controller with two bound text boxes for item name and item quantity, and a button that's bound to list.addItem. Right below that, we have our ordered list that will go ahead and loop through our items, our item array, and will give us the quantity, boxes of the name of the item, and a button to remove that from the list. Let's take a look at our app.js. In our app.js, besides declaring the controller and the shopping list service, we also declare one more service called weight loss filter service. Well, let's take a look at the shopping list service first, because that is what our controller is going to directly invoke. So here's our shopping list service, and you can see we're injecting it with this service called weight loss filter service. Don't worry about the $Q for now. We're not going to be using it for now, but we will use it in a minute. So you could see that the add item method inside of our shopping list service is something that's using asynchronous behavior by calling weight loss filter service.check name. So what we're doing is we're checking the name to make sure that we're allowed to put that on our shopping list. So we could use the then method and say promise then and get the response. And before we use the response, we want to make sure that the quantity is likewise acceptable. So we're going to call the weight loss filter service again inside of our then function, the success then function, and we're going to get the next promise. The next promise then will call the then function again, and only then, if that everything is checking out, we will go ahead and push that new item that we're going to create onto our items array. If this next promise fails for whatever reason, we're going to go ahead and output the error message to the console. Likewise, if the outer promise fails, we're going to do the same thing. We're going to output the error message to the console. So far, so good. Let's go ahead and check out our weight loss filter service. We scroll down. There's lots of commented out code, but here's the weight loss filter service. And it depends on the queue service and the timeout service. The timeout service is the same as the set timeout of JavaScript, except it's angularized, so you don't have to manually call $apply or $digest. Here's our method check name. And the check name method first acquires our deferred object that contains the environment for the entire asynchronous behavior, and sets up this result with a simple message, which in this case is just an empty message so far. Then we're going to go ahead and execute our timeout function that's going to simulate our asynchronous behavior. And we're going to do this very complicated algorithm of figuring out whether or not Yaakov is trying to put anything that has to do with cookies as part of his shopping list. Basically, we're not really doing anything complex. I was just joking. All we're going to do is we're going to lowercase the name, the item name, and then see if the word cookie appears anywhere in that name. And if it does not appear, then we'll go ahead and resolve it, meaning it's going to be successful with the result, which in this case is just an empty object really with just one message property that is an empty message. However, if we find a cookie as part of the name of the item, we're going to set the result.message to stay away from cookies, Yaakov, and then we'll call deferred.reject, which will complete our promise unsuccessfully, passing it the result so we could retrieve that error message from there. Note that what you name these arguments makes absolutely no difference. It's just going to get retrieved from the promise inside of the then function. And the timeout is going to wait 3 seconds before this entire functionality is executed. Last but not least, we need to return the promise back to the caller of this function, so they can have a hook to tap into, whether that's going to be a rejection of our asynchronous behavior or a resolution of it by resolve or reject method. Note that the check quality method is basically identical. The only difference here is we're checking the quantity to be less than 6, as opposed to checking whether the word cookie appears as part of the item name. The only other difference is that we're going to wait only 1 second instead of 3 seconds to execute this behavior. And the error message is going to say, that's too much, Yaakov, instead of saying stay away from the cookies. Let's go ahead and save that and go back to our browser, and we'll try to put something like chips, and we'll say we need 3 boxes of chips. And let's go ahead and click add, and we'll count about 3 seconds. And another second after that, and 4 seconds later, we see that we have 3 boxes of chips. Now let's try to go ahead and get around the system by saying we're going to have cookie flavored chips, and we'll get 3 boxes of those. We'll click add item, and about 3 seconds later, we see that it says stay away from cookies, Yaakov, in our console, and there's no item that is added to our list. Now what happens if I say chips again, But this time I'll say 6. So one more than 5, and click add item. It will go ahead and check that cookies are not part of the item list, and then it will check and see that 6 is really greater than 5, and therefore it's going to say that's too much, Yakov. It will reject the promise, and therefore we're not going to see another item on our list. Okay, so far so good. But let's go back to our code that we use to handle the promise. And let's take a look as to how we're handling that promise. It's a little bit messy, right? Even though this is not callbacks, it still kind of looks like callbacks. There's just a lot of indenting and just a lot of code, and it's hard to understand what's calling what. Let's go ahead and rewrite this function and make our code much cleaner. We'll comment this out, and I already have a second version of it sitting right here. We'll uncomment that, and let's go over this code. This is that same add item method on our shopping list service, and I'm still calling the weight loss filter service check name, but I'm grabbing this promise, and when I call the then method on this promise, I don't even supply to it the second function that's supposed to handle an error. The reason I don't do that is because if there is an error, it will go ahead and bubble up and propagate, and I could call the then method on that again, which will once again return a promise, and then I could call the special method called catch, which will get executed when deferred.reject gets invoked. Now, in the original promise.then, all I have to do is execute our weight loss filter service that checks the quantity now of my item in the returned item. And since that returns a promise, I could just return that, which will then get picked up by the next then method. The reason I don't really need to do anything here is because I know that my response object is just an empty object with an empty message. In other words, if we're in this code block, that means we succeeded and we need to do nothing else other than check the quantity for validity. The next then method treats the response the same way, because if we got to this code block, it means that the check quantity passed and we're allowed to add the item or push the item onto our array of shopping list items. So note what we did here. We no longer have to handle the error condition or the rejection of the promise in every single case. We only have to do this once, and we could do it centrally. So certainly that's much easier to read code and much cleaner. Let's go ahead and save that and see if this works. Let's go back to our browser, and we'll say cookies. We'll give it 4 boxes of cookies. We'll click add, and that will be an error condition, and therefore we'll stay away from cookies. If we say chips, and click add, about 3 to 4 seconds later, it should go ahead and add that 4 boxes of chips. And if we leave it as chips, but put, let's say, 7 boxes, click add, that will also resolve, but resolve with a rejection. And then therefore it will say that's too much, Yakov, because our catch method right here is catching any errors from any of the promises that were chained above it. Okay, so far so good, but we can improve it even more. Let's take a look as to what's going on when we try to add a valid item but with too many boxes. Let's go ahead and clear this and click add once again. Take a look as to how long that takes. It takes about 4 seconds. Now why should it take 4 seconds? Checking this item takes 1 second. Checking this item takes 3 seconds. We know that if either of these items isn't valid, I want to go ahead and output an error message and just forget the whole thing about adding it to my list. So why should I wait to execute the validation of my number of boxes after I validated the item name? They really should be executed in parallel. So let's go ahead and code that up. Let's go back, and we'll go ahead and once again comment out this version of the add item method and uncomment yet another version of the add item method. And this one does both things in parallel. And the way we do that is by capturing the name promise, which is the return result of the weight loss filter service check name method that returns a promise. And then we're going to capture the quantity promise, which is the result of executing weight loss filter service check quantity method. And here we're going to use our qservice.all. And what that takes is an array of promises. We can then call the then method on that, which will only get executed once every single promise in this array is resolved. However, if any of the promises in this array result in a rejection, meaning deferred.reject, all promises will be canceled immediately, and the execution will jump into the catch method, outputting this error response message. That means that if this promise takes much faster to execute and much faster therefore to fail than this promise, I don't have to wait for this promise to finish in order for me to just cancel the whole execution and output the message. Now, the quantity promise takes about a second to execute, whereas the name promise takes about 3 seconds to execute. Let's go ahead and save that, and let's go back to our browser. If I now enter chips in here and quantity 3, meaning a valid item with a valid quantity, when I click add, that will take about 3 seconds to execute, not 4. Since we're doing both validations asynchronously, the longer one will run its 3 seconds, but by the time it's done, the one that takes shorter amount of time would have finished already. Now, if I enter cookies in here, that will also take 3 seconds, and 3 seconds to actually fail. And you can see it fails, rejects it, and says stay away from cookies, Yaakov. And that's also because that's the longer one, and therefore the 3 seconds it took to fail is the all-encompassing time. But look what happens if I say chips and then enter something invalid like 7 for quantity. When I click add item, take a look how fast that fails. It fails almost right away, which about a second later it says that's too much, Yaakov. We could actually do that again. Click add, and you could see that it fails right away. So with the construct of $Q all, we're able to put multiple promises, actually as many as we want, and they will all try to execute asynchronously, making our entire app potentially much faster as well. Okay, let's summarize what we learned in this lesson. First of all, let's remember that promises give us a lot of flexibility when dealing with asynchronous behavior. The queue service is the Angular implementation of the promise API. The new implementation of JavaScript ES6 has its own promise API and will likely use that once it's supported by all the major browsers. Promises either get resolved or rejected. Resolved is considered a success, and a rejection is considered a failure. The then method that you could call on the promise takes 2 arguments, both of which have function values. The first is a function to handle the success or the resolve outcome, and the second is a function to handle the error or the reject outcome. In addition, then method itself returns a promise, so you could chain it with other promises and make the code a bit more readable as well. Finally, we spoke about the queueService all method. That method allows us to execute multiple promises in parallel, making things faster, and at the same time, we're able to handle success and failure of all of those promises in one central place in our code.
Now that we understand how asynchronous behavior is handled in Angular.js, it's time to turn to a core utility service that comes with Angular out of the box, and that's the HTTP service. There's nothing complicated about the service at all. In fact, the whole idea behind the service is to make communication between your front-end application and the server super simple and straightforward. Since the HTTP service is in its essence asynchronous, it's based on the deferred and promise API exposed by the queue service that we spoke about. When invoked, the main methods in this service return a promise, which is then up to us to process.
Calling HTTP service is very simple. The HTTP service is itself a function, so you can actually call it directly. It takes just one argument, a configuration object, which Angular expects to have some predefined properties such as method, URL, and so on. As I mentioned, it returns a promise, so that's why you can invoke the familiar then method. The only required property of the configuration object is the URL. If the method property is not specified, the HTTP method get is assumed. Another property worth taking a look at is the params property. That property can take an object whose property names become parameter names and their corresponding values become the values for those parameters. The parameter values are automatically URL encoded. If you don't remember what that means, a URL is not allowed to have spaces and other special characters. If the parameter value you're trying to pass to the server contains those special characters, the process of URL encoding replaces those special characters by replacing them with a % followed by 2 hexadecimal digits. Spaces turn into plus signs. The 3 properties you see on the slide, method, URL, and params, are certainly not the only properties that the configuration object can have. There's a lot more properties for more specific cases, and you can look them up in the Angular documentation that talks about the HTTP service. The arguments that you would pass into the then function are the usual arguments that you would pass into the then function when you deal with a promise. The first argument is a function value of a successful response, meaning a resolution of a promise. And the second value is an error response, meaning a rejection of a promise. Here in the slide, I actually named these functions success and error, but in practice, you could keep them anonymous when you use them in line like this. Probably the most used property of the response object will be the response.data property. That's the property that holds the response body. Now, if Angular detects that the response body contains JSON, it will automatically transform the response body into a JavaScript object using the JSON parser. As I said, the same response object gets returned if an error occurs. However, its data property will probably contain some server-generated HTML page explaining the error message, so it's usually not as useful for our programmatic needs. Before we move on and look at some coding examples, let me warn you to avoid a fairly common mistake. A fairly common mistake goes something like this. If you look at the slide, it starts with declaring a local variable called message as an empty string. Then we call the HTTP method, providing some URL, and then we successfully resolve it, and set our local message variable to the response.data. Then we take the scope object and create a message property on it, initializing it to the value that the message holds. So what would you say is the value of the $scope.message? If you guessed an empty string, you are correct. Why is that? Well, remember that we're dealing with an asynchronous call. The local variable message will not get set with the response.data until after the last line on the slide executes. That last line will set the $scope.message to whatever the value of the local message variable is right now, which is an empty string. So what's the fix? Well, it's actually quite simple. The proper implementation will be to set the $scope.message to the response data directly in the function representing a successful resolution of the promise. The setting of the message on the scope service will then occur only when the data is returned and the promise is resolved. Okay, time to look at some live code examples of what we've discussed so far, and that's what we'll do in part 2 of this lecture. Before we embark on making any kind of remote calls, we actually need to have some kind of remote server set up. And since the previous course built a restaurant app, which we're actually going to re-implement using Angular.js, that server is still set up and actually exposed to the entire internet, so we're going to go ahead and use that as our resource. The instructions and the URLs of where that server is actually deployed and what APIs it supports can be found on github.com/dhu-ep-coursera/restaurant-menu-server. And if you scroll down, you'll see some documentation regarding this particular server, and you'll see that the URL patterns it supports is to show me all the categories of the menu of our Chinese restaurant, show all the menu items, and show me all the menu items for a specific category together with information about the category. Okay, and here are the URLs that are deployed on Heroku for us to be able to retrieve this data. And for our purposes, all we're going to use is this one /categories.json and this one /menuitems.json with a category for whatever category we specify. So I actually opened up both these URLs in my browser. you could see this one is /categories.json. And if we actually reload it again, we'll see what the categories.json response was. And we could look at the response itself. It's just an array of a bunch of object literals. And if we look at the preview, it will show us that array in a little bit more of a nicer fashion here. And we can open up the object and you could see that it contains a couple of properties. Well, it contains a few properties. One is name and the other one is short name. And these are going to be important because these are the ones we're going to display and use. Also, if we look at the other REST API that we have here is /menu_items.json for a particular category, and that is that short name that we were looking at before. That's the same type of short name that is being specified to identify our category. And let's go ahead and reload that as well. And let's click on that URL and let's go to the preview. We can see that it gives us categories and also gives us a list of menu items for that particular category. And what it's inside of it doesn't really matter for our purposes. So what we would like to do, going back to our code editor, is code up an application that simply lists all the categories that our menu contains. And obviously, we're going to use the HTTP service to accomplish it. So right now, I'm located in my editor in the Lecture 25 folder, which is located in the fullstack-course 5 examples folder. And here's our Angular app called Menu Categories app. And it's a fairly simple app. Let's go take a look at the HTML template. That consists of just one controller called Menu Categories Controller with a controller as syntax with a label menu. And then what it's going to do is going to create an unordered list and use ngRepeat to loop over menu.categories. So we're going to have a categories property on our menu label that's going to be attached to the $sign scope for us automatically using our controller as syntax. In each list item, we're going to list the category short name in parentheses and the category name. And that's really all we're going to do. Let's go ahead and take a look at our app.js. Let's actually close the file browser so it'll be easier to see. Okay, in our app.js, we obviously declare our controller, but we also declare the service called Menu Categories service. Let's first take a look at the service that we coded up. So the Menu Categories service is injecting the HTTP service, as you could see. And it's really structured just like a regular service would. It creates this service local variable that is equal to this. And it has this method called getMenuCategories, which is our main method that we're going to use in order to accomplish our use case. Inside of that function, we're going to use our $HTTP, the HTTP service, and we're going to configure it using this config object, which is an object literal, with a method of get, which will tell the HTTP service to issue an HTTP GET request, and a URL to our API, the categories.json API. Once we capture that response, which is of course a promise, we're going to go ahead and return that response to the caller. Now let's take a look at our caller, which is our Menu Categories controller. Well, it's going to use that promise to initialize some things on the $sign scope. Obviously, the first thing it's going to do is actually call Menu Categories service dot get menu categories. That's, as you remember, going to return a promise. Then we're going to resolve the promise using the then function, expecting a response, well, actually response.data to be that JSON that is converted into an array of object literals, and will assign that array to the categories property of our menu, which is obviously the this reference. And instead of dealing with an error if it occurs right here by putting a comma and yet another function, we're just going to go ahead and use a catch all kind of function called catch, and we'll go ahead and do that here, since that looks a little bit more cleaner in the code. And here we're not going to do much, we're just going to log something went terribly wrong. So let's go ahead and save that, and let's go back to our browser. Let's go to our HTTP service. It's already running using browser sync, and you can see that it listed all of our categories with a short name in parentheses and the category name right after that. Okay, so far so good. Let's enhance this just a little bit by having these short name letters be a link that I could click and have my app reach out yet again to the server, which should return the data about that particular category. In other words, all the menu items that category contains. Let's go back to the code editor. And the first thing we want to do is create a link around this category.short name. And the first thing we're going to do is surround our category short name with an A tag. So we're going to go ahead and say href just so it appears to be a link. And we're going to close that. And we need to surround it, so we'll put the closing A tag right here. So the only other thing is left to do is to do ng click, not double click, just click, and set that to our menu.log menu items. And pass to it what we're going to need to log. We're going to need to log something with a category.short_name. Once we do that, this category.short_name is going to get passed to our log menu items function or method that is sitting on the controller instance. So let's go ahead and save that, and let's go to the app.js, and let's actually create that method. Well, actually, it's already created. All I have to do really is uncomment it and talk a little bit about it here. So as you could see, it's taking a short name as an argument, and we're doing the same thing we did before. We're calling menu category service that get menu for category, passing it the short name, meaning that identifying label for a particular category. And then all we're doing here is really logging it on success and logging the error on failure. The important thing is to look at this get menu category method. So let's go ahead and scroll down to the menu category service. And here I have this method already coded up. I just need to, yet again, uncomment it. And let's go over it a little bit. So the get menu for category is a function that takes a short name. So the HTTP call, the $HTTP is very similar, except now we have a params property as part of our configuration object. And the params property is an object literal that has category and short name. This short name, the value of our category in that params, comes from the short name that is passed into this function. And the category is the name of the parameter that should really go right here after a question mark. So question mark category equals whatever it is that the category, the short name that they passed in. So since we want that done for us automatically by Angular, we need to just provide this params object or params property with an object where the object property names become the request name parameters and their values become the values of those request parameters. And as usual, we return the response, which is nothing more than a promise. Okay, so let's save that, and we should really be good to go. Let's go back to our browser, and you can see now every single one of these things is a link. Let's go ahead and open our console so we could see what happens when we click on one of these. Let's click on L, and you see an object got returned with menu items of 27 menu items for that particular category. Let's click on another one. Let's click on C, and you can see once again that object in the category is chicken and the short name is C. That's how we identified that particular category when we used it to request it. So if we look at the network right now, and let's clear that, go ahead and clear that, and click the C again, you'll see that we're making an Ajax call to this URL, which is /menu_item.json with the question mark category equals C. So question mark category equals C is the result of us providing that params object as a configuration property. If we click that and look at its response or the preview of the response, you can see that's the same thing that's coming back that we're actually seeing in the console right here. Okay, so that looks pretty good, except one little thing. Let's go back to our code editor and see if we can notice something that kind of is bugging me a little bit. In every single call of our menu category service, we're providing the full URL, including what our REST API endpoints are going to be. What happens if tomorrow, the next day, we decide to deploy the same service but at a different URL? Let's say we wanted to give it a custom URL, not a herokuapp.com URL. Well, we would have to change this URL in every single place that we're calling out to it. That seems kind of dirty and inefficient. Instead, it would be great to be able to define the base URL once and then reuse it in every single circumstance. And we could do that with a special function that gets invoked on the Angular module called constant. Let's go ahead and define that now. Called constant. and the constant takes the name that we're going to inject that constant with. Now let's call it API base path, and what that path is. Let's go ahead and scroll down and grab the base path, which is right here. Let's copy that. And that's going to be the constant that we're going to use every time when we inject it into different types of services, or at least in this case, was going to be injected into the menu categories service. So let's go ahead and inject that right here. And that one is called API base path. And we obviously need to also inject it into the actual function. And now, instead of providing the entire URL, what we're going to do is we're going to shorten that a bit and say that's the only part of it. And then we're just going to say API base path plus that categories slash categories.json. In fact, if you look in the actual URL property here, I see that I have left my parens here. The parens really aren't needed here at all until I actually erase this part and need to make an addition or string concatenation here, which is again API base path plus that string. And actually in this case, I need to surround that with parens so it knows it's one value. When I save that now, you can see that now we have a one API base path constant that we're able to reuse everywhere else. So if we were to redeploy the server at a different URL, we would only have to change that constant in one place and wouldn't have to worry about the rest of the application because it will automatically work by just appending the actual REST API endpoints to that base path. Well, let's go ahead and save that and go back to the browser, and you can see that everything is still working just fine. When I click, I get that object, and obviously I get the entire list of my categories that comprise the total list of the categories in this Chinese restaurant's menu. Okay, so let's summarize. The HTTP service is based on the promise API exposed by the $Q service. The $HTTP is itself a function. It takes a single configuration object parameter, of which URL property is the only required property. And then it returns a regular promise to be resolved with the then function. Now, when that promise gets resolved inside the then function or the success then function, response.data property will hold the server data response, sometimes referred to as a response payload. If the original response.data is JSON, Angular will automatically detect that and then will transform that response into a JavaScript object. So the JSON string will be turned into a JavaScript object we can immediately use in our code. Now, one more thing we used in this lecture is module.constant, and that can be used as an injectable constant that we could define once and it will never change for the duration of the application, and then we can inject it into controllers, services, or other types of components.
Perhaps the most defining feature of AngularJS is the idea of directives. This is so much so that the front page of angularjs.org hints to directives when it answers the question, why Angular? It's worthwhile reading their answer.
It states as follows: HTML is great for declaring static documents, but it falters when we try to use it for declaring dynamic views in web applications. AngularJS lets you extend HTML vocabulary for your application. The resulting environment is extraordinarily expressive, readable, and quick to develop. The keyword in this description is extend. Angular allows you to extend the standard HTML into whatever suits your particular application. That is incredibly powerful, as you'll soon see. So when it comes to HTML and HTML templates in Angular, it's nothing strange to see something like this. As you can see here, we have a tag called list item appearing right in the middle of regular HTML code. That's an Angular directive. It's certainly not a standard HTML tag. But how does this code become quote-unquote regular HTML code? Remember from a previous lecture when we tried to understand how custom HTML attributes work and therefore demystify how Angular is able to find placeholders in HTML? Once Angular was able to find ng-app attribute on an element, it got access to the entire document object model that was attached to that element. The Angular functions are then free to manipulate that tree of HTML nodes however it pleases. It can then replace the variables surrounded by double curly braces with values it looks up in a $sign scope. It can also examine any node, be it content, tag, or attribute, and decide if it should replace it with something else, attach some function or behavior to it, etc. In Angular, this process is called compilation. If you've done programming before, when you hear the word compilation, it usually means translating your source code into some other code that the machine can understand. Usually, this is done before you actually execute your code. In Angular, most of the time, the compilation happens at the beginning when you load your page or a particular HTML template, and sometimes even later. But the process is the same. Angular compiles and links your custom HTML code. You can also combine directives together. Here you could see that we're using the familiar ng-repeat on this custom list item directive. Okay, so let's define what a directive is. A directive is really just a marker on a DOM element that tells Angular's HTML compiler to attach a specified behavior to that domain object model element. The compiler can also transform or change the DOM elements and its children. The marker itself, as we're calling it, could be one of four things. It could be an attribute, an element name, a comment, and even a CSS class. However, it's not a best practice to use comments or CSS classes in order to use directives. So most of the time, you will stick to elements and attributes when you define your custom directives. Okay, so let's go over the steps of creating your custom directive. The first step is to register the directive with the Angular module. And as you could see here, it's almost identical to the way you register controllers, services, factories, and so on. Here, we're using a special module method called directive, and we're defining a directive name. Now, the directive name that we're specifying here is a normalized name that will appear in HTML. And I'll explain what's meant by normalized shortly. The second argument is the factory function that returns what's called a DDO, otherwise known as a directive definition object. The DDO is basically a configuration object that tells Angular compiler how this directive should behave when Angular finds this tag or element or attribute in our HTML. The factory function, myTag in our example here, will execute only once and not every time it finds our directive mentioned in our HTML. And since it's only going to get executed once, you could use that function to perform any initializations you need, besides obviously returning this special object, DDO, the directive definition object. The second step is to define our factory function. And note, just like a controller service, we can inject other things into the directive. We can inject other services, controllers, etc. as usual. The most important thing about this function is for us to return our DDO, the directive definition object. The directive definition object consists of multiple properties that are defined in the Angular.js documentation. The template property defined here is just an example and it's not a required property. However, in this example, every time we use myTag in our HTML, the words hello world will be displayed to the user. The third and final step is obviously to use the tag in our HTML. Note that the name of the element is not myTag, but my-tag. In order for Angular to match your element or attribute to the name of the directive, it first needs to normalize the name it finds in the HTML. The way it normalizes the name is by removing the dash and then capitalizing the next letter. In other words, it replaces the dash delimited notation with camel case notation. If you're not familiar with camel case notation, it's actually very simple. It's basically a way to name something in programming where you take a number of words, concatenate them together, leaving the first word all lowercase with each subsequent word capitalized. So when Angular.js sees my-tag in our HTML, it will look for a directive that was registered with the name myTag with a T capitalized. And obviously, it will find our declaration of a directive called myTag with a T capitalized, thus connecting the two pieces together and providing the functionality that is defined in the myTag factory function. Okay, time to get back to our code editor. In part 2 of this lecture, we'll be creating our first custom directive. Exciting! See you in part 2. Okay, in this lecture, we're going to write our very own first custom directive. And in order to do that, we're going to reuse the application that we've written previously. If you remember, we had an application where we had two shopping lists that worked independently from each other, meaning they each had their own instance of the shopping list service, and therefore each shopping list was saved in a separate instance, and they did not interfere with each other. What we're going to do now is look for opportunities to reuse pieces of HTML so we don't have to write the same HTML over and over. Let's go back to the code editor, and I'm located in lecture 26, which is located in Full Stack Course 5 examples folder. And here we have the shopping list directive app, and it's really just a renamed app. It's exactly the same as we had it before, with just the minor differences. Obviously, the title is a little bit different, but also I changed the label. Instead of list 1 and list 2, I just kept it as list. These two list labels do not interfere with each other simply because this list label is only exposed to the body of this controller, and that list label is only exposed to the body of the first controller. So as you remember, as a user clicks to add a new item into the list, it gets output using this interpolation right here. So this is in the first list. If you take a look at the second list, well, it's exactly the same thing again. Well, it would be nice that we wouldn't have to rewrite this over and over, but only really write this once, and then just use some element to signify that we are describing an item here. So let's go back to our app.js, and I'll minimize the file browser on the right, and let's define a list item description directive. So we'll put enter here, and we'll call directive, and we'll say list item description. Notice that I started the name of my directive with a lowercase l, and that is because we are using this as a camel case notation that will be later matched with an element in our HTML. Next, I need to name the function that's going to be responsible for this, and we'll just name it the same, list item description. Change the first letter to lowercase. Okay, now we're ready to actually define this function. So let's go ahead and say function. We'll say list item description. We don't need to inject anything into this function, so we'll just leave it at that. And we'll define our DDO, and a DDO is going to be an object literal with one simple property called template. And that template is going to be, and let's go back to our index.html, that template is going to be just this string right here. Let's go ahead and copy and paste that right here, and that's really all we need. And we'll go ahead and return, not to forget to return our DDO. Okay, so now that we've registered our directive and we defined the factory function that returns our DDO, and every time this particular tag or this particular element is going to be in our HTML, it's going to output this to the HTML for us, because that's the template of this directive. Okay, so what's left is to go to index.html and wipe this out, and instead write list item description. And notice that the list item description is using dashes in between because I need to leave it in a non-normalized notation, so AngularJS can then take that, normalize it, and match it with a list item description directive declaration. Okay, so that's one, and we use the same thing in the second one, so we'll wipe that again, and we'll paste that, we'll save it. Let's go back to our browser and let's try it out. We'll just put a bunch of nonsense in here just to test it out. And you can see as we keep doing this, it's working. This one is going to be a little bit separate, but as you can see, this one only has limit to 3, but our item description, meaning this piece right here, is working very well. Let's go ahead and take a look as to what this looks like in the DOM. What does the DOM look like for these particular elements? Let's expand this out a little bit and let's take a look. You could see that Angular left the list item description right in place and actually placed our value right in the body of that particular custom tag. But let's go back for a second to the code and take a look at our template that we've defined for that particular tag. You could see that the template is using interpolation and it's using item.quantity and item.name. Where is Angular getting this item.quantity, item.name? When we were inside our controller, item referred to the item that was part of the ng repeat. And that was pulled out of the controller's scope, the local controller scope. So how is it that we are able to access this item inside of our directive? And the answer is that unless you specify otherwise, the scope of your directive will be the same scope of the containing controller. So if we go to our index.html, you could see that this list item description directive is sitting inside of our shopping list controller 1. So the scope that is available to the body of this controller is the exact same scope that is available inside of our list item description directive. That is how we're able to, if we go back to app.js, that's how we're able to say item.quantity and item.name, because ultimately all these properties are part of the scope that this particular directive lives in. Let's go back to index.html and see if we can find other opportunities to create a template expanding directive for us. Well, one of them is right here. We see this li item, and this li item repeats again in the shopping list number 2. Well, what if we make this li item as a list item for our shopping? In other words, the shopping list item. Well, let's go back to our app.js and let's create another directive. And this time we're going to call it directive. We're going to call it, again, starting with the lowercase, list item. So not description, but the whole list item. And we'll specify its factory function as list item. Okay, so all we need to do now is actually define it. Let's go ahead and say function list item. We don't need to inject anything into it, so we're good here. We'll create our DDO object, the directive definition object, put a semicolon here, and again, we'll say template. Except that, let's take a look as to what we would actually have to place into this template. Let's take a look at the index.html. So we were really going to be expected to place this whole string into our template. That's kind of difficult. Not only is it kind of a large string, but also notice there's got quotation marks in here, which means we're going to have to escape those quotation marks or make sure that we don't use the same ones so they don't conflict. So instead of a template, we're going to use something else called a template URL. And a template URL allows you to point to an HTML template or HTML file and place your entire template into that file. Much more convenient for things that are a little bit longer than just a line of HTML code. Let's call it list item.html, and let's go ahead and not forget to return the DDO. Let's save that, and let's go ahead and create this file called list item.html. Let's open up the file browser. We'll go ahead and create a new file, and we'll call it list item.html. There it is, and let's go to index.html. Let's actually close the file browser for a second. We'll go to index.html, we'll grab this whole string here, we'll actually cut it at this point, and we'll go back to list item, paste that there, and here we are. Let's save that, and let's go back to index.html, and now what we need to place here is we need to place our list item. So we'll say list dash item, the denormalized name, and there's our list item right here. And every time this appears in our HTML, it's going to get substituted, or at least it's going to get implemented as this li item. Let's go back to index.html and actually replace that over here as well. We'll say list item, and we'll save that. And one more thing. While it would be okay to leave this ng repeat right on the inside of the directive template, it's much easier, I think, to actually pull it out so we could see a little bit better as to what's going on. Let's go ahead and cut that out of here, save this, and go to our index.html and actually place this ng repeat straight on this list-item. And I'll do the same thing for the first one, and we'll go ahead and save that. And I believe now we're all ready to go. So if we go back to our browser, let's make this smaller again. And if we start, we'll just enter some garbage for now. And you can see nothing's working. Why isn't it working? Let's take a look as to what we messed up. List item is not defined. So if we go back to our code, let's take a look at app.js. Oh, we forgot to put quotes around our HTML template because this is just a string. The HTML template URL is just a string. Let's save that. This should fix it. and it does fix it. Let's go ahead and close that. We don't need that, and we'll say, let's put some cookies in here. It's always a good idea to put some cookies in here, and let's get a few of them. So that's working, and we'll put some other cookies, another cookie in here, and we'll put a lot of cookies here. And as you can see here, it's limiting us to only 3 of them. Let's go ahead and inspect the element here actually as to what got placed inside of our list item here. So let's take a look. So you can see here, we start with a list item, and these list items keep repeating because we put ng repeat on them. Inside of the list item, you see an li followed by our list item description, yet another custom directive that we created. So what we're able to accomplish here is create a directive that we are reusing in multiple places in our application, and if we change something in that directive, it changes in every single place because the functionality obviously travels together with that directive. And that's really an amazing concept. We're now doing code reuse right inside of our HTML templates. Note one more thing. If we take a look at our code, and specifically index.html, you could see that the HTML code itself became very semantic. If you remember from the previous course, course 4, HTML, CSS, and JavaScript for web developers, we discussed the reason for having semantic tags in HTML5. But even the semantic tags that exist as part of standard HTML5, section, article, and so on, are such generic terms. In Angular.js application, we could create our own semantic tags that actually make sense in the application that we're coding. So list item is clearly one list item in our shopping list. How cool is that? So let's summarize. A directive is really just a marker in our HTML that Angular compiles into some behavior. It can also change the HTML elements themselves because it gets a hold of the entire document object model tree that is under the control of the directive. Remember, when you register the name of the directive, when you use the .directive method on the module object, you have to use the normalized camel case name because that is the name that the AngularJS compiler will then look for when trying to match your custom element or attribute back to the registered directive. The function that you register with the .directive method is a factory function that must return what's called a DDO, a directive definition object. That factory function will get executed only once, so you can use it to initialize whatever you need for the directives that are going to be in your application. The coolest part about custom directives is that our HTML coding becomes reusable. We can actually employ code reuse directly in our HTML coding. And last but not least, the HTML code itself becomes semantically relevant to the actual web app that we're building.
In the previous lecture, we saw a couple of properties of the directive definition object, or the DDO. We saw how to use the template and the template URL properties. In this lecture, we're going to see another DDO property called restrict.
The restrict property tells AngularJS compiler where to detect your custom directive. Should it try to detect it as an attribute to a different element, or should it look for an element with the name of your registered directive? If you don't specify the restrict property on the DDO, Angular will default its value to be AE. The A stands for attribute and E stands for element. That means that Angular will look for your directive as being either an attribute or an element. So that's the default. If you wanted to restrict your directive to be only an attribute to a different element, you would specify an A as a value for the restrict property. It's a best practice to restrict your directive to an attribute if that directive is extending some behavior of some other element. For example, think of ngRepeat. It doesn't have any content of its own, it's just extending the behavior of any element that you place that particular ngRepeat attribute on. If you wanted your directive to be an element only, you would specify an E for the value of the property. The best practice to restrict a directive to be an element if that directive is defining a component with some associated template. Think of the previous example we had that had a list item in it. It had some content to it, it had a template to it. So it would only make sense that that template and that content with some behavior would be an element. It's a best practice not to use the class and CSS-based directives, so obviously don't restrict your DDO to that either. Now, if you restrict a directive to be of one type, and then you use that directive in a different fashion, Angular will not match that directive and will simply ignore it like anything else in your HTML that it's not supposed to process. So if you specify the directive to be an element and then use it as an attribute, Angular will ignore it completely. Okay, let's jump into the code editor and see these concepts in action. Okay, I'm back in my code editor and I'm located in the Lecture 27 folder, which is inside Full Stack Course 5 Examples folder. And here I have the exactly same app that we had in the previous lecture, the shopping list directive app. And as you remember, we created a couple of custom directives, one of which was a list item directive. And the list item directive basically just corresponds to this list item.html, which is its template. And it's just an li with yet another actually custom directive inside of it and a button we can click on. If we take a look back on our HTML, we see that the list item is being used as an element. Now, if we look at app.js, we'll see that our list item does not specify the restrict property. So that means that we could use it as either an attribute or an element. But let's go ahead and specify a restrict property here, and we'll call it AE. So for attribute and an element, so we could use it either or. And we're going to go ahead and save that, and we're going to make sure not to forget the comma here. Now, if we go to our browser, we could see that we could still add whatever we wanted to add into the list, and it will work just fine. Going back to the code editor, let's go ahead and change our list item, at least in the first controller, in the first shopping list. Let's change this to an attribute instead, since it's allowed to be one. Let's go ahead and erase this part, and we'll erase this part. Conveniently, it shortens to li, and we'll go ahead and list item as an attribute on the li element. Let's go ahead and save that. And let's go back to the browser and see what happens if we add some cookies in here and 4 bags of cookies and we click add. Well, that's a little weird. If you notice, we have this 1 and 2 kind of looks like at the same time. So if we keep adding it, it will keep looking like there's like 2 numbers in our ordered list. Well, let's go ahead and crack open the code here, the DOM element, and see what's really going on inside. And if we take a look, this is our ordered list. And this is our li, and if we open our li right here, you see there's another li inside of that. Well, how did that get here? And that li has the list item. It looks like we have really 2 nested li's in here. Well, the reason this is happening is because when we listed the list item on this li, the list item, as you remember, let's take a look at the DDO, the list item lists the list item.html as its template. And the list item.html already has an li in it. So that's not really going to work. In other words, for this to actually work, we would actually have to remove this li out of this template. Let's go ahead and do that now just to test this out. Save it. And now if we go back to our browser, let's close the Chrome Developer Tools. The browser sync should have refreshed it. And let's do this again. Cookies, 4 bags of cookies. We'll click add. And throw 3 bags of cookies, and then chips, 5 bags of chips, and we'll click add, and it's still working just fine. So if we again open up our elements here and take a look, we see that an ordered list has an li, and inside of that li is the list description and a button and so on here. All the code that we expected to be there, and we're using an attribute instead of an element in order to produce that. Now, if we close our Chrome Developer Tools and try the same thing on the shopping list 2. Now remember, shopping list 2, let's actually go ahead and take a look at the code real quick. Shopping list 2 has the list item being used as an element. So if we go to our browser and start adding here, cookies, 4 bags, and click add, and it says 4 bags of cookies, but for some reason we don't see a number next to it. So if we keep adding stuff, it's not really looking like there's the proper formatting going on. Well, let's go ahead and crack open that code and see what actually is going on here. And you see here our ordered list, and we see our list item, and then we see list description. So what seems like is going on is that we don't have an li element. And obviously we don't have an li element because we removed it from our template right here. So point number one is, whether you restrict something to be an attribute or an element, the associated template that comes with that particular directive has to make sense within the context of your HTML. Okay, so far, if we look in the app.js, we restricted the list item to be either an attribute or an element. Well, let's try to restrict it to be only an attribute. Let's go ahead and save that. Let's go back to the browser. It will get refreshed by browser sync, and we'll again add some cookies in here. 5 bags of cookies. Notice the number of bags keeps going up. And here it is, that works. We could do it a few more times. And if we look here, inspect the elements here, this should be just like before. We have an li item that has a list item as an attribute, which produces this whole template in the middle, or in the content of the li element. If we go to our shopping list number 2, however, and put in some stuff here, 6 bags of cookies, and add that, you see nothing is going on. If we click this a couple more times, this shows up. So the functionality is actually working, but nothing is showing up right here. Let's take a look at maybe just somewhere here as to what's going on in our DOM, so we could see that. So we see the list number 2. Let's open that up. That's the list number 2. That's the H1, the shopping, and that's the input elements, and there's our ordered list. And if we take a look at here, our ordered list still has these items, and they're repeating, but they're not showing up at all. Why is that? Well, that's simple. The reason they're not showing up is there's nothing inside of them. And the reason there's no content inside of them is because AngularJS compiler completely ignored list.item. It doesn't even know what that is. It doesn't recognize that, and the reason it doesn't recognize it is because we used it as an element when we in fact restricted that particular directive to be only an attribute. But as we said in the lecture, something that has a template is probably much more suited to be an element than an attribute. So let's go ahead and change that here, and we'll save that, and we'll go back to our index.html. And the second list, the second shopping list, is going to be using that as an element, while the first will leave it as an attribute. However, this is really not going to work because we're sharing the same list item.html. And for this directive to work as an element, we actually need to put the LIs back. Let's go ahead and do that now, because we don't have an LI without this, because it's not being used as an attribute. So if we now go back to the browser, the second list should work just fine. Cookies, 4 bags, and we'll add that, we'll add it again, we'll add it again. It's working just fine, except it reached a maximum of 3 items. But if we go here and try to add stuff, it will not work. You could see the numbers are showing up, but if you look inside, let's inspect the inside, it's an LI, and we have a list item as an attribute, but the content of LI is empty. And the reason the content of LI is empty is because AngularJS compiler cannot even find the fact that there's a custom directive as an attribute sitting on LI, because we told AngularJS that the only directive that list-item can be is an element. And since this is an attribute, it is simply ignored. So let's summarize. The DDO's restrict property determines what AngularJS compiler should look for to detect your custom directive. Using directive as a different restrict type than defined will cause the compiler to simply ignore it, and therefore your tag with custom behavior will simply not work. Best practice number 1 is use E for element when directive has content along with possible behavior. Also, the best practice is to use A for attribute when your directive has no content and only extends the behavior of your host element. Finally, another best practice we talked about is that while it's possible to use class and comment directives, that's only for older browser compatibility and is really not used anymore. Therefore, just avoid defining your custom directives as a class or a comment.
Previously, we spoke about the fact that without any additional configuration, our directive is functioning with the scope of its parent. In the examples we've seen, that meant that the $scope inside of our directive was the exact same object as the $scope of our directive's parent controller. While this setup seemed fine, if we look closer, we have a bit of an architectural problem here. That type of setup makes the directive dependent on our particular controller. In other words, there's too much coupling going on between the controller and the directive. Let's examine this issue in the code editor.
Okay, I'm back in the code editor and I'm located in lecture 28, which is located in fullstack-course 5 examples folder. And this is just a copy of the previous application we had, the shopping list directive app. The only thing I change here is the title. And as you remember, we have a couple of shopping lists here. Both of them are marked as list in the controller as syntax. And both of them have this line right here called list item, which is our custom directive that has an ng repeat in it that's looping over our list items in our shopping list. The trouble is that we have two lists here, and when you look at this code in the code editor, it's sometimes hard to understand which list you're looking for. I guess you could look for shopping list number 2 in labels like that, but it'd be much nicer if I actually labeled our controller as syntax as a list 1 or list 2. Let's go ahead and try to do that. Let's multi-select the lists, and we'll say list 1. And here there's also a list 1, and this is a list 1, and we'll save that. Let's see, we're not missing anything, and let's go to the second list and call it list 2. Let's again try to multi-select as much as we can, and we'll say list 2, and we'll say list 2 over here and list 2 over here. So let's save that, and let's go back to the browser and see if everything's working so far. So let's add cookies as usual, 3 bags of cookies, and 3 bags of cookies are working. And then let's add some chips. We'll get 5 bags of chips, and we'll add that. Okay, you know what? Actually, let's remove the chips and add some drinks instead. Let's click the remove item. Oh, look at that. It's not working anymore. Let's take a look at our Chrome developer tools, and we see absolutely no errors either. So what is going on here exactly? Let's go back and take a look at our code real quick. And we know that the list item right here, the directive, actually uses this list item.html template. And the problem should be pretty clear. We're using this list.remove item. We're relying on the fact that list is available to us on the controller scope. The problem is our list is no longer list. It's actually list 1. So let's change this to list 1. Let's go back here and we'll add, actually we'll just add a bunch of nonsense for now, and let's try to remove that. See, that works. Well, let's try to add to this list now and add that item. Let's try to remove that item. But this item doesn't work. Well, why not? List, is there any errors? Yet again, no errors. Why isn't this item working? Well, the reason this item is not working is because we're using list 1. List 1, again, is coming from the first controller, but the second controller doesn't know anything about list 1. So in order to get the second controller to work, we would have to change that to list 2. Well, then the first controller wouldn't work. Clearly, we have a problem here. What we actually want to do is re-architecture our custom directive such that it functions independently from its environment and have the environment around it pass certain values into it, just like it would pass arguments into a function. And we could do that with a concept called isolate scope. Let's go back to the slides and learn about this concept first, and then in part 2 of this lecture, we'll go back to the code editor and code up a different solution using the isolate scope concept. As I mentioned, without additional configuration, the scope of the parent is the scope of our directive. However, as I just showed you in the code, it would be better to break away from this inheritance and create an isolated scope for our directive, or as it's termed, isolate scope. The way this is accomplished is through specifying another property on the DDO called scope and assigning it some object. Without any properties, all we've done was isolate the directive scope from the parent. But if it's isolated, how do we get the data that we need into our directive? The answer is that we explicitly bind predefined attributes to the isolate scope properties. Here you see the first type of binding we're going to discuss in this lecture. We're specifying a property on the scope object called myProp. That's the name of the property that you're mapping something outside of your directive into. The value of myProp is going to be an equal sign followed by some attribute name. The attribute name is the HTML template attribute name. In the HTML template, the object value you specify here in your HTML template will be evaluated in the parent scope and passed into our directive. In this example, myProp property will be a reference to that object inside of our directive scope. There are a few ways to bind and pass the outer values into the directive. Bidirectional is probably the most communicative way. Bidirectional binding means that if you change the parent value, the value in the directive will change automatically, and vice versa. If you change the value in the directive, the parent value will change as well. If you leave the value as simply an equal sign and you don't specify the name of the attribute, AngularJS compiler will assume that the name of the attribute in the HTML template is the same as your directive's property name. In this case, myProp, or when it's denormalized for the HTML template, it will be my-prop. Also, if you follow the equal sign with a question mark, that will signify to the Angular compiler that the attribute is optional. Obviously, the code in your directive has to be aware that it's possible that the user of your directive will not supply a value for the scope property. So you cannot rely on that value to be there, as it might be undefined. In our HTML template, we specify my-prop attribute using the same normalization rules we use for the element name. In other words, we lowercase the name of the attribute and then separate its parts with a dash. AngularJS will normalize it to match it with our myProp property in the directive. Using the @ sign is yet another way to bind external values to the isolate scope of our directive. Using the @ sign tells the Angular compiler that we want to bind myProp property to the domain object model's attribute myAttribute that's located in the same element as our directive. Note that even in this case, our directive can itself be either an element or an attribute. The name of the actual attribute appearing in HTML will be denormalized version, which is my-attribute. The result value that's assigned to myProp in our directive scope in this setup is always a string. In the HTML template, we simply specify my-attribute attribute and give it the value of some interpolated string. This type of setup behaves as one-way binding, meaning that the outer value change affects the inner value. But if we explicitly change myProp that's bound to my-attribute inside of the directive, the value of my-attribute DOM node will be unaffected. Also note that there's nothing stopping us from doing the regular interpolation inside of the my-attribute. Here you could see we're concatenating the string hi and also concatenating an exclamation point sign using the plus operator directly inside the double curly braces. Okay, in part 2 of this lecture, we'll go back to the code editor and try out these features. Okay, so I'm back in my code editor in lecture 28 folder, which is located in full stack-course 5 examples folder. And this is the same app we discussed in part 1, except I reverted everything back and I removed all custom directives from the application so we could start anew. And what seems to me that we should do is we should just create a directive called shopping list. And the template for the shopping list directive should encompass all of this, in other words, the actual list. So let's go ahead and start coding that. Let's go to app.js and let's create a directive with a directive method called shopping list. And notice the shopping list, the S is lowercase, and the function we're going to create is called shopping list. Let's go ahead and create that function now. And that function is going to have a DDO, which is going to be an object. And let's just set up the framework here, and it's going to return the DDO, so we don't forget to do that. Okay, inside of our DDO, we need to, first of all, point to a template that's going to be responsible for this directive. So we'll call it template URL and we'll give it a path. Let's call it shopping list.html. Let's save that for now and let's actually create shopping list.html. And what we'll do is we'll place that whole piece that we wanted to replace right here. We'll just actually cut it out of here, make a little bit of a space here, and we'll go and place it right here. Now it's still referencing these labels from the controller, and we don't want that. Let's just call it something generic like list, and that actually looks pretty good, so we'll save that. And now, in order for us to isolate our directive from the parent controller and at the same time pass this list of items into our directive, we need to create the isolate scope with a directive local property called list. Let's go ahead and do that. First, we'll go here, we'll put a comma, and we'll say scope. So that's going to be an isolate scope. And our directive property will be list, and it's going to be bound to something we'll call my list. Let's go ahead and save that. And now what we need to do is we need to go back to our index.html and say shopping list right here as a tag and specify my list. And again, my list would be with a dash because we need to have it denormalize. So then Angular will go ahead and create this property out of that. Okay, and my list is going to be equal to, and in this case, since we're in list 1, my list is going to be equal to list 1. Let's go ahead and save that. And now if we go back to the browser, the first list should work. Let's give it cookies, 4 bags. We'll add the list, and you can see the list is working. We could add multiple number of those. And if we click the remove item is working as well because again, the list that is being mentioned in our template right here when we click the remove is actually the passed-in object, the passed-in object list 1 actually in this case, through the property myList. So we could do exactly the same thing by copying this over and going over here in the second controller and just copying that over right here. And except now we're going to be passing a list 2. Let's save that. We'll go back to the browser and let's call cookies, 2 bags of cookies. And as we edit, it will all work until we obviously hit the limit, which is 3 for the second list. Okay, so let's change something a little bit about how our list is constructed. The title of our list is kind of sitting on top of all the controls to add things to the list. What I really like to do is actually have the title of the list as being part of our list. Seems like they should go together. And at least for the first list, I would like to have a total number of items in parentheses in the list so far. Obviously, we want the parent controller to decide what the title would be, even though the parent controller wouldn't know where the title goes, but the actual title words, it's something that the parent controller knows about, and it should be in control of that, but the directive should be the one displaying it. Sounds like a perfect use case for the one-way binding with an @ sign. So let's go back to the code editor. We'll go to our app.js, and we'll add one more property here, put a comma here, and we'll say title. And the property is going to be @ and we'll just call it title. So this way, the shopping list directive will require a title attribute that we're going to give it from the parent controller. In order for that to happen, let's go to the controller code and initialize that property. We'll go ahead and remember what the orig title was. Orig title, and we'll get that title from our HTML. The original title was shopping list number 1. Let's go ahead and copy that. Go back to app.js and say the original title is shopping list number 1. And we'll construct list.title, which is our scope property now. We'll call it original title plus, we'll give it a space, parentheses. We don't need this parenthesis here yet. Plus list.items.length. That's the number of items in our list. And we'll go ahead and close the parenthesis right here. Say items, the other way around, items, close parens. And obviously we need to do this again in a couple more places when we change the number of items when we edit and also when we remove it. Let's go ahead and save that. And now let's go back to our shopping list, and right on top of here we'll say h3, which is the same type of title, and we'll interpolate our title right in here. The title, this title name, is coming from, let's save that, it's coming from our directive when we gave it the title property on our scope. All that's left is to go to index.html and specify the title, or at least the original title. So let's go ahead and remove this h3 out of here. We'll go to our shopping list directive and we'll say title equals to, and in this case, we're going to interpolate what we have from the controller, this list1 controller. So list1 controller will be list1 dot title. We'll save that. Let's verify that that's the name of the title in the list1 controller. And it sure is the title. So list.title is what we needed to place in here. And this list.title is marked with a label list1. So if we'll go back to our application in the browser, I see here that I forgot to put a space after the number. So let's go back to our app.js and actually put a space between the number and the word items. And I also need to change it in the other two places that I mentioned it right here. So we'll save that. Let's go back to the browser and we'll start adding cookies again. 3 bags of cookies, and we'll add that. And as you can see, if I keep adding, the number of items is changing and the entire title is changing because of that as well. So if I remove things, it will also get updated because the parent controller's scope title property is being updated, and therefore our attribute value that is holding this actual string gets interpolated again and gets passed into our directive over and over again. So one more thing we need to do not to have any errors is to specify the title for the second controller that we have. And we could go back to the index.html and we'll go ahead and copy that second title right here. We'll cut it over here. We'll take out of here and we'll actually put it right on the shopping list. We'll say title equals to, and we'll just cut and paste that string right there. There's nothing wrong with that. And we'll go back to our browser. And you can see that the string is just straight up right there. And we don't have any logic in the second controller to update this because this thing is limited to 3 items anyway. So we could again put cookies in here and misspelled cookies. That's very important to spell cookies correctly. So we're going to respell that again. And as we keep adding, obviously we'll hit our limit of 3. And that's it. So we were now able to create a reusable directive, a reusable component, so to speak, that we're able to use in 2 separate controllers without the controller's properties affecting how we implement our directive. So we're able to pass a list of items from the controller number 2 that has list2 label and from the controller number 1 that has list1 label. Okay, so let's summarize. Having isolate scope in the directive breaks the prototypal inheritance of the scope from the parent, but it also makes the directive more independent, therefore less coupled with the controller or whatever parent component the directive is living in. We pass values into the directive using the scope bindings. There's a couple that we learned. The first one is the bidirectional binding, which is signified by the equal sign. And in that type of scenario, the directive scope property change affects the bound property and vice versa. The other one we learned about was the DOM attribute value binding, and that's signified with an @ sign. And in this scenario, it always results in the directive property being a string. The add property also acts like a unidirectional binding, meaning changes to the DOM attribute value are propagated to the directive property, but not the other way around.
It's very often the case that we want our directives to do more than just serve as a template holder, which does simplify our code, making it more readable, semantic, and reusable. It's often the case that we want to bundle behavior with the directive. We have a couple of options as to how to get that accomplished, but one of those options is to declare a controller directly on the directive. Let's take a look at a few required steps to get that done.
The first thing to do is to provide yet another property called controller on our directive definition object, or DDO. The value of that property should be a function that will implement that controller. The way this function works is exactly the same as any other controller we've been coding so far. Now, if we left it at just specifying the controller function, the properties that are declared on our isolate scope would now be available on the $scope inside of our controller. Obviously, we would need to inject the $scope on our controller, just like you would need to do that for any other controller to access the properties on the scope. However, remember when we first introduced controllers and we explained that it was a best practice not to place properties directly on the scope, but place them on the instance of the controller itself and have Angular attach that controller instance as a property on the scope? That was the controller as syntax. And this is what the other two properties here are about. The first one, the bind to controller property, tells Angular to place our isolate scope properties onto the controller instance instead of directly on the scope. The other property specifies the label in our controller as syntax, so we can use that label to refer to scope properties and methods in the HTML template. In this example, in our template.html, we would refer to properties using myCTRL label. Implementing the controller function should be familiar. Since we use the controller as syntax, we should follow the best practice and attach any additional properties and methods to the this variable. Here, I'm using yet another best practice, and that is to store a reference to the this variable in the local variable first, and then use that local variable to attach properties and methods to the instance of this controller. I can now use and manipulate the declared isolate scope properties as well as other properties I defined here in the controller myself. Note one obvious point. Since we declared our directive scope to be isolate scope, anything we attach to that scope is still inside the isolate scope and not just what was mapped through the scope declaration in the DDO or the directive definition object. The last step is to use our properties and methods in the directives template. Note that I'm using the label myCTRL that I declared as the value of the controller as property on the DDO or the directive definition object. One more thing worth mentioning before we jump into the code editor. We have been declaring non-string values with an equal sign. That's bidirectional binding. In the case of bidirectional binding, both sides, the property in the directive and the property in the parent, are watched for changes and then those changes are synchronized. However, it's a best practice to try to avoid changing the values inside of the directive. Either way, certainly if we have no plans of changing the bound value inside of the directive, we're wasting resources because Angular is setting up extra watches inside of our directive that will be always checked but never used. So we will use one-way binding symbol, which is a less than symbol whenever possible. One-way binding watches only the identity of the parent property, not the property inside of the directive. Obviously, one-way binding does not change how JavaScript fundamentally works. So if you pass in a primitive like a number using one-way binding can guarantee that the value outside of the directive will not be affected by anything you do in the directive with a passed-in value. However, if you pass in an object and your directive changes the value of a property of that object, while no watchers will be set up or triggered as a result, the context outside of your directive will definitely be affected since the change will be visible outside of the directive. Remember that in JavaScript, objects are passed by reference, and both your directive and the context outside of your directive point to the same object. So while setting up one-way binding will help with performance because Angular will not set up extra watches, it simply cannot guarantee that the object's properties aren't changed by the directive. Okay, let's get back to the code editor and see these concepts in action. Okay, we're back to our code editor and we're located in lecture 29, which is located in Full Stack Course 5 examples folder. And this is the same shopping list application we've been working with, except this time we're going to combine some behavior together with our shopping list directive. Now, the shopping list directive basically lists all the things in our shopping list. And prior to this lecture, we used to have another div right here that used to be the error message. So if something was detected that's wrong, the error message would be outside of our shopping list. Well, if you think about this a little bit more in a component type of fashion, really the error message should be part of the shopping list directive. After all, the shopping list knows about the items in the list, and it can decide whether or not an error message should be displayed. So that's exactly what we're going to do. And to do that, we're going to declare our own controller on the shopping list. I already removed the error message from the main index.html. Let's save that and go to app.js. So here, the first thing you see is it's basically the same directive we had before, except we changed the items from an equal sign to the less than sign, which is a one-way direction. We're not really planning to change anything about the items, so a one-way binding is plenty. Okay, so the first thing we want to do is declare a controller. We do that through a controller property, and we'll call it shopping list directive controller to distinguish it from the other controllers. And we also want to follow the best practices, so we'll say controller as, and we'll give it a label called list. So that means in our shopping list.html, we'll be able to refer to the shopping list directive controller instance through this label called list, and that's where the items and title properties will show up on. They will show up on the instance of the actual controller, which we're going to call list inside the shopping list.html. One more thing we need to make sure is to tell Angular that we actually want to bind all of these scope variables or scope properties to our controller. And for that, we'll just say bind to controller, and we'll call it true. We'll say true, so now it's bound to controller. Obviously, we now need to implement our shopping list directive controller. We'll go right below the actual function that declares the directive, and we'll say function. We'll give it the name, and inside we'll do the best practice of storing this keyword inside the local variable. So now it is list, and again, this list obviously has absolutely nothing to do with this one other than the fact that this is a local variable named the same as this list that is going to be a label on the shopping list directive controller when we reference it inside the shopping list.html. But here inside of our controller, it's nothing more than a local variable. And the functionality we want to implement is that if there is a cookie as part of our shopping list, we want to display a warning. Yeah, I know I'm obsessed about cookies, but what can you do? And we want that functionality to be sitting inside of the controller, not outside of our directive. So this will be a place to define it. And the way we define it, just like we define anything else in the controller, we define it through the this keyword. In this case, it's going to be list. It's one and the same. So we'll say cookies in list, and we'll define a function. Don't need the name. And it's going to be a boolean. It's going to return a boolean. Either it has cookies in the list or not. And I actually prepared some code right here. And all we're going to do is, let me copy and paste it right here. All we're going to do is we're going to loop over our list items, the items that got bound to the scope right here. So, and we're referring to them by this keyword, which is now list. So list.items.length, we're basically looping over all the items in the list, and all we're doing is just checking whether or not cookie string is part of it. If it is, then we're going to return true, and if we go through the entire list and it's not there, we'll return false. Okay, so let's save that, and the last thing we need to do is actually use it in our template, which is shoppinglist.html. And you see here, this is leftover code from a previous time. We're still referring to our scoped properties directly without the label of the controller as syntax. And we remember that the label was list, so we could just start saying list dot, and it's item in items, or actually it's list dot items. And the rest we can just leave alone. This button right here that I commented out, we're going to deal with in a different lecture. So let's go ahead and save that. And we should be able to go back to the browser. And now if we go ahead and say something like chips, 4 bags, and we add something, so that's working. We could keep adding some stuff in here. But we didn't actually activate our special function here, which is cookies in list. So in order to do that, we're going to put another div right below that. And we're going to say class error, actually, because we defined an error class, which is in the styles. You could look at the styles, just makes the whole thing bold and red. And we're going to do one more thing. We're going to say here, warning. Let's close the file browser so you can see it better. Cookies detected. Very dire warning right here. So point is, we want this warning to show up only when there are cookies inside of our list. So how do we do that? Well, we could do it easily with ngIf. And we could say if list.cookies in list, and we need the parens so Angular knows it's a function, and we're going to save that. And now if we go back to our browser and we'll say chips, you know, 2 bags of chips, and everything is good. But if we say cookies, let's get 10 bags of that. And when we do that, the warning shows up immediately right here that it's warning us that the cookies have been detected inside of our shopping list. Now let me go back to the code editor for a second, because there's one more way we could have declared our controller. Let's take a look at this controller right here. We see that we declared the controller directly as a function value. We didn't really have to do that. We could declare our controller on the module itself and then use it right here. So let's try to do that just to see how that works. Let's say controller, and we'll give the controller a name. We'll give the controller exactly the same name as the name of the function, so we don't get confused. And now we have a controller that we can now reference through this string anywhere inside of this Angular module. So then when we say controller here, what we could do is we could put it in quotation marks right here, and we don't even need the controller as, we could just say as list right here, and then we could comment this out right there and save it. So we're binding everything to the controller, and the controller as list is now being done through a string, because Angular will look up the string to see if there's any such component exists in its module. And now it will, because we just declared one. And let's save that. And now we can actually use this controller in more than one place. We could use it in this directive, but we could use it somewhere else as well. So we could definitely have a reusable controller, and not just in this file, because here, obviously, in this file, we could reuse this function without any problems. But if it was in a different file and we're still working off of the same module, if we left this just as a regular local function inside of this ify function, it wouldn't be visible. However, once we stuck it as a declared controller on the Angular module, anywhere this module is being referenced, we can actually retrieve this controller and reuse it. So let's save that and go back to the browser, and let's see if that actually works. Let's say chips, 2 bags of chips, and it's adding the bags of chips. Let's say cookies, 2 bags of cookies, and we add it, we see the same warning. So basically you can declare it either way you want. For our purposes, I will just comment this out so you have this code, but I will actually put it back the way it was. Maybe I'll just comment this out as well and put controller here, and we'll say shopping list controller, and put a comma here, and we'll comment this out as well. And now let's go back to the code editor, and we have it exactly as it was before. Now if we say chips, 2 bags, it works, and we say cookies, and the dire warning shows up that cookies have been detected. So let's summarize. To add functionality to the directive, one choice is to use a controller that's declared directly on the DDO, the directive definition object. In order to do that, you use the controller property on the DDO to declare that controller. Since the best practice is to use the controller as syntax even inside the directive, you have to use the bind to controller and controller as properties to bind the declared properties in isolate scope directly to the controller instance. Then you define the controller function as you usually would. One last point. Whenever possible, use the less than sign for a one-way binding to save resources instead of the bidirectional binding with the equal sign. The one-way binding is not only preferred for performance reasons, but also architecturally, because it is usually a bad practice to change the objects that are passed into the directive.
There are times when it makes sense that the directive should invoke a method on its parent, passing it some data only our directive would know about, like what item was clicked in the list based on the original data given to the directive. For example, say you have a directive like the one we've been working with, the shopping list directive, that's responsible for displaying the shopping list. It may also be responsible for providing a button to remove an item from the list. However, it's the parent that's in charge of that data. The shopping list directive only displays the list. It has no idea, and shouldn't have any idea, what should happen if someone wants to remove something from the list. Maybe some side effect needs to occur that has nothing to do with the responsibilities of our directive. The actual data manipulation, like removal of an item, needs to happen in the parent controller. In other words, we need to set up a link from the directive to some method on the parent and then provide some data from the directive to that parent's method for execution. However, we must be careful. The parent has to execute that method in the parent's context, not in the directive's context. That means that when we call the parent's method and that method tries to use the $scope, it should refer to the parent's scope, not the directive's isolate scope. This is accomplished with the reference binding, signified by the ampersand sign and some additional syntax that we'll see in the following steps.
Obviously, we need to start with the requirement to call some parent controller's method. In this example, we're calling the method, which is a function that takes one argument. Note that we're using the this keyword to define this method as a property of the controller's instance, and that it is obviously very important that the this keyword stays referring to the instance of this controller. The argument declared here as arg1 needs to come from the child directive. In the DDO, the directive definition object, we declare a myMethodIsolateScope property, which will serve as the property name we can reference the passed-in method that exists on the parent controller scope. The reference with the ampersand sign will be followed by the name method, which is what we'll need to use in the parent's HTML template to pass in the reference to the parent method. Again, not much new here. The property name is used by the directive, and the value of that property is used by the parent controller that references that value inside of its HTML. In step 3, we'll use our directive in the parent controller's template, specifying the method attribute, we declare it in the DDO, and providing a reference to the controller's method as a value. Note here that myArg argument passed in here is simply a key which we'll later use to assign something from the directive's isolate scope. We are not actually passing in the myArg argument from the controller to the myDirective as it appears here. I know, it's a bit of a weird syntax because that's exactly how it appears. But remember, with the ampersand sign reference binding, the argument name in the call is simply a key we'll later use to map a value from the directive to that key with which Angular will then call our controller's method. This can get a little bit confusing, so don't get frustrated too quickly and wait for the coding example to put it all together in your mind. We still have one more step. Finally, in the directives template, we trigger the map controller's method call by using our directives controller as a label dirctl and invoking the method myMethod as declared on the isolate scope binding. But notice what we're passing into the method. Not your regular argument. Instead, we're using the name of the argument that parent made the call with and mapping some value to it from our directive. So what we're passing into the method is a map object, not a single argument myArg. The keys in that map object have to correspond to the argument name or names the parent controller declared the call with. So just to be clear, the name of the argument we used in the controller's template HTML, shown at the top, is the key we use to map a directive internal value to by passing in an object with the argument name as that key. Okay, so let's try to visually put it all together to make things as clear as possible before we jump into the code editor. You have some functionality in your controller that you want executed when something happens inside of your directive housed in your controller's template. After all, the controller has the handle on the data, and you want your directive to only display that data, not manipulate it. The controller has a method called method that takes one argument. we need to pass our method into the directive as a reference so that the directive can delegate the call to this method whenever something happens inside of the directive that only the directive will know about. For example, whenever somebody clicks on a button inside of the directives template. The way we pass a reference to the controller's method is by using an attribute that matches what we've declared to be in the DDO. In this case, the attribute name is method. That means that our directive's internal way of referring to that method is now my method. If we wanted to call the controller's function passed into our directive, the name we have to use is my method. And since we're using controller as syntax inside of our directive, my method will be bound to the directive's controller instance, not directly to the directive's scope. So when we call my method inside of our directive template, it's going to be prefixed with the label that our directive's controller is declared with. Now, inside of our directive, when a user clicks on a button, we can invoke my method, which is just an alias to the outer controller's method that was passed into our directive. The last task is to make sure to properly pass the data from our directive to the outer controller's method. We do that by passing in an object whose property names must match the argument names of the method call in the controller's template. Shoo, that was a lot. My suggestion to you is to go through this lecture again once you've seen an example in part 2. And then all these connections between different parts should feel a lot more comfortable. Okay, let's jump into the code editor and see these concepts in action. Okay, so we're back in our code editor, and I'm located in lecture 30 folder, which is located in fullstack-course 5/examples folder. And this is again our shopping list directive app. And the goal of our task right now is to provide a button next to each list item and let the user click it and it will get removed. Except we're going to try to accomplish this task in a little bit of a wrong way first. And what we're going to do is we're going to supply this bed remove attribute on our shopping list directive, and we're going to pass the actual function directly as a reference to our directive. If we go to app.js, we'll see here that on our directive itself, we're going to create a bed remove property, and we're going to use an equal sign. So it will be a bidirectional binding, and the function value of that remove that we're going to pass in is going to be equal to this bed remove property. In the actual service remove method, or controller I should say, in the actual controller remove method, we're going to have one more thing. Let me actually close the file browser so it'll be easier to see. But what we're going to do is we're going to have one more side effect here that I'll uncomment, and we're going to create a property under this keyword, which means, since we're using controller as syntax, is going to be attached to the controller's instance. And it's going to be called last removed. Basically, whenever somebody passes us an item index, we're going to look that item index up in our this.items array and save the name of that item in the last removed property. In the index.html, we're going to place a real quick span here, and we'll say last, or list, I should say, dot last removed. So now we're going to output whatever it is that was last removed right inside of our controller. This list is the label for our shopping list controller. If we go to the shopping list.html, which is the template for our directive, we're going to see here a button, and the button says list.bedRemove, and bedRemove is our function, and we're able to obviously take a function reference, which is what this is, surrounded with parens, and execute it, passing it our $ index, which is the index in the list that somebody is clicking to remove, and the button name is going to be bed remove. Just to look back at index.html, we have our bed remove attribute mapped to list.removeItem. So it's the remove item function value that is being assigned to this bed remove, and then that bed remove gets called right here inside of our directive template. Okay, so let's save that and let's go to the browser and let's try to add item test1 We'll just say test for now. We'll click that item. We'll see the bed remove button. Test 2, click add item button. Test 3, and click the add item button. One more thing let's go take a look at when we go to the code is that I printed out this console.log this is, and I'm printing out what the this variable is pointing to. Just important so we'll be able to look at the console and see when we attach the this.last remove and this.title, where's this actually pointing to at the time that we call it. Let's go back to our browser and let's go ahead and actually open the console so we could see what's going on. Open the console here and let's go ahead and try to click bed remove item number 1. When we click here, we see that for some reason we don't have any kind of announcement here what the last removed item was. And if we take a look at our console, I think it's going to give us a clue. This is, and remember this right now is being called from the remove item method that is sitting on our controller, that is the main controller. And if we take a look, this is shopping list directive controller. So it's not the shopping list controller, it's shopping list directive controller, which is not what we want because shopping list directive controller is the controller for our isolate scope. And we wanted this to execute in the parent controller scope. As you can see, all these things that we thought were being assigned on the parent controller scope are actually being assigned directly to our directives isolate scope. And that's why you see that the title still says the list number 1 has 3 items in it. And so what happened to the title? Well, when we said this.title and updated the title with 2 items, it went ahead and created .title, the title property, on our shopping list directive controller. Meanwhile, the actual shopping list controller doesn't know anything about this. Let's go back to the code editor and actually take a look as to why something like that is happening. I actually created this.html and it's just referencing this.js, so we'll be able to see what's going on. Here's a quick example on a microcosm as to what's going on here in our controllers. Suppose we have this function called person and it says this.full name is Yakov, this.fave is cookies. And we have one method on this object, which is the function, and all it's doing is logging to the console and says this.full name likes this.fave. If we now go ahead and create this Yakov object with the call to new person, as we should, that this variable inside of this object will be pointing to the person object. And when we call Yakov.describe, in other words, this method, this will still be pointing to the person object, and therefore you'll be able to reference full name and fave. So let's go ahead and actually comment this out for a second. Let's go ahead and save that, and let's open this.html in the browser. And you'll see that the console says Yakov likes cookies. Very true. Now, if we go back and go to this.js, what we're going to do now is we're going to pull out the method from this Yakov object. After all, Yakov.describe without the parens is just a function value. So we could grab that value and stick it in a local variable. And then, since that local variable is pointing to a function value, we could actually execute it just by putting parens behind it. If we save that and go back to our browser, let's refresh that. You can see here already says that undefined likes undefined. How come this is going on? Well, the reason this is going on is if we actually put a console.log right inside of here, let's put a log statement here and say what exactly is this variable. Let's go ahead and say this is, what is this variable? Let's go ahead and output this. You could see that the first time we go around, this variable is the person. But the second time going around, this variable is actually the window. And the window doesn't have a full name and a fave. The reason this is happening is because we took that method out of its context, and its context became the window because we were sitting, after all, in a global scope. There is actually a JavaScript solution to that, and it's called the call method. If you take the method that is out of context, in other words, the this variable is pointing to whatever the surrounding context is, you could actually give it context, and basically it will get that this variable assigned to whatever object that you're passing in the call method. So if we invoke describe with the call method and pass it the object Yaakov, then this variable will all of a sudden once again be pointing to Yaakov. So if we save that and go back to our browser, you'll see that even though the first time it says undefined, undefined, the next time this is actually pointing back into person, and it actually will say Yaakov likes cookies. And this is what's happening in our controller. If we go back, we could close this now. What's happening in our controllers is that when this call is being made right here, this call is being made just with a function reference. It's like a variable that was yanked out of its context and now sitting in a different context. In the case of the describe function in our this example, it was sitting in the context of the window object. Well, in the case of this bad remove example, it's sitting in the context of the directives controller, not of the parent controller as we want it. So the solution is to use the at reference and then pass a map of arguments that is mapped to how we call this method to begin with. So let's go to app.js. And what we're going to do now is we're going to declare yet another attribute. And another attribute is going to be called onRemove. And onRemove is going to have an ampersand binding, which means it's going to be a reference binding. We'll go to index.html. And we'll add one more button right here, or one more attribute, and we'll call it onRemove. And this time we'll call list.remove item, and we'll pass it an index. Except as I told you, as you remember, this index is not something that the shopping list controller will be passing. This index is just a key for our directive to be able to find and assign some value to it. So all of this will get executed in the context of the shopping list controller, not of the shopping list directive controller. Let's go ahead and actually put this back there. It'll look a little bit better that way. We'll go back to our shopping list.html, that is the template for our directive. Let's close the file browser so it'll be easier to see. And we'll actually uncomment this button right here. And if you take a look, it's list, which is the list of my shopping list directive controller. OnRemove, that's the property we mapped onRemoved into the controller on our isolate scope. And then you could see we're passing it an object that is a map. It's mapping the index. If you take a look at the index.html, this is the index that we're mapping. So it's taking that index and it's saying it should be equal to, at the time that you call this, it should be equal to $index, which is the index through the loop at the moment. Now when we save it and go back to the browser, we'll close our this example and we'll close this as well. And here's our directive with isolate scope. Let's go ahead and add test. Well, first of all, it's not refreshing for some reason. Let's refresh it. Here we go. Okay, so let's add our test1, add 1. So we have bad remove and remove item. We'll do test2, add that item, and test3, and add that item. And let's go ahead and try to click remove item. Let's say remove test2. If we click remove test2, you'll see that the last item removed showed up here, which means that property did show up in the parent controller. And if we take a look in our remove item method, we logged what the variable this pointed to. In this case, it's pointing to the shopping list controller, which is exactly what we wanted. We wanted to execute that method in the context of the shopping list controller, which is the parent of our directive. And if you take a look, all the things that we need are here, and you see the last remove property is here, and the shopping list title also got updated to 2, and therefore it's right there. If we remove it again, this time we remove number 1, so it's number 1, and so on. So this is working. So once again, what allowed us to be able to call this method in the context of the parent of this directive is the reference that we declared onRemove property with, which is the ampersand that is giving us a reference to the function such that it's going to get executed in its parent environment, evaluating all the properties like they should be. Okay, so let's summarize. The ampersand binding allows us to execute an expression, such as a function value, in the context of the parent scope. The way this is done is the following. The parent template must declare an attribute providing the method reference for the directive to call on the parent, and an argument keys for directive to bind values to when it needs to pass the data from the isolate scope back to the parent scope. The directive, on the other hand, calls the reference method and also provides an object map of argument key to value pairs. This allows the directive to pass data back to the parent from the isolate scope.
From the very beginning of discussing Angular, we introduced the model view model architecture, or the mvvm design pattern. Part of this architecture has been a clear indication that we do not want to directly manipulate the DOM ourselves. Instead, we wanted Angular to do it for us while we simply use declarations of property bindings and so on. I also told you that Angular is called the MV star framework because sometimes it simply doesn't work to stay the purest and never manipulate the DOM directly in our code. Angular allows for such occasions, and that is one of the reasons why it's so much easier to integrate Angular with other neat libraries like D3.js, for example, which is an advanced JavaScript visualization graphics library, and the like. But Angular doesn't just allow you to manipulate the DOM. It helps you to do that by exposing a watered-down version of jQuery right out of the box called JQLite, and also allowing you to use the full version of jQuery library by simply including it without having to configure anything else. Angular also provides a special window into the DOM manipulation through the Directives link property, which holds a function. This function is where you typically manipulate the DOM by directly updating it and registering native event listeners. When we were playing around with setting up custom watches, I warned you that setting them up inside of a controller was a bad practice and promised to show you a more appropriate place for setting up watches. Well, the link function is one of those places. Let's take a look at some sample code.
In the DDO, Directive Definition Object, we declare our link function through the link property. The link function can work alongside the directives controller, or since it has access to the same scope and properties that a controller does, it can take over all of the controller's responsibilities. Link function is always called with specific parameters, so we don't inject anything into the link function directly. However, if we wanted to use some service, we can inject it into the directive factory function, in our case, myDirective, and then use it inside of our link function. Once we've declared the link function in the DDO, we have to define the actual link function. Note the parameters here. First, the scope. Note that it's not $scope, but just scope. You could certainly name it $scope here too, but the reason we usually omit the $sign is to remind ourselves that the scope is not injected into the link function. Remember that the $scope or $anything is just a valid name of a variable in JavaScript. The link function is simply passed the scope of the directive as the first argument into the function. You can read and attach properties on the scope just like you would inside of a controller. The second parameter, the element parameter, represents the top-level element of the directive. In other words, either that custom element that this directive defined, or the element this custom directive is declared as an attribute on. On top of that, this element is a wrapper around the regular DOM element object with special functions that come from JQLite, which is a watered-down version of jQuery again. If jQuery is included in the main HTML page before the Angular.js main file, this element is the jQuery object itself, in which case it supports many more selector query functions that jQuery supports, plus some animation methods like fade in, fade out, slide down, slide up, and so on. We'll see those in a minute when we get to the actual code example. The third parameter, the attributes parameter, is an object that contains references to the attributes declared on the element. The fourth parameter, the controller, is a reference to the controller declared for this directive if there is one. There is one more parameter at the end which has to do with transclusion that I'm not showing because we haven't covered transclusion and because it's JavaScript. So I could leave off parameters I won't be dealing with anyway. Okay, time to jump into the code editor and see these concepts in action. And that's exactly what we're going to do in part 2 of this lecture. Okay, so we're back in our code editor, and I'm located in Lecture 31 folder, which is located in Full Stack-Course 5 Examples folder. And this is again our shopping list directive app that we looked at before. In the previous versions, if cookies were detected as part of the shopping list, we displayed an error message underneath the shopping list. What we used to display that message was ngIf. So if one of the shopping list items included cookies in it, ngIf would detect that being true and then would display that particular div with a warning. In this version, we're going to do something similar, except we're going to use DOM manipulation to achieve that. And then we'll upgrade it to jQuery and use some animation effects on that as well. So the first thing I need to do is declare my link function where I'm going to be able to call these DOM manipulation methods. So I'll put a comma here and I'll say link, and I'll say the name of the link function, which will be something like shopping list directive link. Let's save that. And let's go right here and actually define this shopping list directive link. I actually have some of the code pre-made a little bit, so I'll go ahead and copy and paste it here to save some time for us. And here's our shopping list directive link, which has a scope, an element, attributes, and a controller. And again, I'm omitting one parameter here at the very end that we're not looking at right now. Okay, so far we have our shopping list directive link, and we're logging to the console the scope, the controller, and the element. Okay, so let's go to the browser, and let's go ahead and open up the console and see what it's telling us. Okay, so the link scope is, and we can open it up, and then we could see that the link scope is exactly the same thing as what we've injected into our shopping list directive controller. In fact, you could see that the list here is that shopping list directive controller. If we open it up, we'll see all of our cookies and list, items, my title, unremove, and so on. Okay, so that's the link scope. The controller instance, you can see again the shopping list directive controller as we thought it was. And the element is, if we take a look here closely, is the shopping list. So the shopping list is the parent element that this element parameter represents. Let's go ahead and minimize that, and let's go back to the code editor. So what we want to do here is actually set up a watch on our shopping list directive controllers function, and we have a controller function for the shopping list directive, which is called cookies in list. So we really want to have this as the property that we are watching. So let's go ahead and copy that, and let's set up a watch here. We'll say scope $watch, and we'll give it the property name, which in this case is our list.cookiesInList. Well, since this is a function, we need to indicate that as such. So that's the property where we're watching on our scope. And then we're going to give it a function that is going to take a new value and an old value as its parameters. Let's put a semicolon right here. And we're going to even actually log the old value. And this is a Boolean function, so it's going to say either false or true. And we could go ahead and do it again. Say new value. Okay, so now we're watching our list.cookiesInList. So when cookiesInList changes its value, either from false to true or from true to false, this function right here will fire. So what we want to do here is we want to actually display a warning, a cookie warning. So we're going to say if new value is equal to true, then what we want to do is we want to display cookie warning. And we're going to write that function in a minute. Else, we want to remove the cookie warning, since if it came false, it means that the cookies have disappeared. We maybe remove them from the list. Remove cookie warning. Okay, so those are the two functions that we need. Now all we need to do is define the function display cookie warning. And we need to define a function called remove cookie warning. Okay, so now we've defined these two functions. Let's take a look at our template. And in our template here, we want to set up a placeholder for our error message. So we'll create a regular div, and we'll give it a class error as before, and we'll give it the message. Oh, the horror, cookies detected. Okay, that sounds like a good message. Another thing is we need to make sure that at the beginning, this div right here is invisible, because we certainly don't want this message to show up to start with. So if we go to our styles.css, we see the error class, and this is exactly what we declared our div with. So what we could do is simply add one more property called display, and we'll give it a none. So at the beginning, it's not going to display that div to the user. So it will be just an empty space. Let's go ahead and save that. Let's go back to our browser just to make sure. We could say cookie, 3 bags, and nothing really should happen so far, right? Because we did not activate showing this cookie warning at the bottom. Okay, so let's go back to the code editor. Let's go to our app.js, and let's write this display cookie warning. Okay, so first of all, we need access to our element object here, and I already realized that I made a minor mistake. If you take a look as to where these curly braces end, I actually defined my cookie warning, display cookie warning, and remove cookie warning outside of my link function. I don't want to do that. I want to go ahead and grab these, cut them out, and put them right back inside, so I'll have access to the element that I'm going to be using in order to manipulate the DOM. So let's go to the display cookie warning now that we're now inside of our shopping list directive function. And the first thing we're going to do is we're going to try to use just regular using Angular JQLite. Actually, if we save that for now, go back to the browser and we'll just search for Angular JS JQLite. It should take us to the angular.element documentation. Let's take a look at that. And you'll see here, if you scroll down a little bit, you'll see that Angular JQLite provides the following jQuery methods. You could see a whole bunch of methods here, not that many, but a nice amount. And one of them is a find function. If you take a look here, there will be a find function right here, and it says limited to lookups by tag name. So we can't just use find and use regular selector API. We're limited to only looking things up by tag name. If we were to use jQuery, we would not be limited to that. But for now, let's just use tag names to look things up. Let's go back to our code editor and let's create a var warning element, and we'll say element.find, and we'll say we want to find the div. Now, what is going on here? Why am I saying find this div? If we go back to the shopping list.html, you'll see that this is the only div in this shopping list.html template. And here's point number one about element.find. When you're using the element.find, it is only going to look starting at that element in the DOM and below, which means it's only going to look right here. This is actually great news because if you have a huge HTML page, it's not going to have to look through the entire DOM. It's only going to have to try to find that div in this small little snippet of HTML. So this is a very performant way of actually looking up elements inside of your HTML templates. And at this point, once we have this warning element, all we really need to do is call its CSS class. And if you take a look at our list of classes, this is one of them. We could have a CSS class. By the way, if you click on that, it will take you straight to jQuery API documentation. And you'll see you could provide the property name and the value as part of its method signature. So let's go back to the code editor and let's say CSS. And we need to say display. And this time we're going to show it. So we'll say block. We'll go ahead and end it with a semicolon. Okay, so for the remove cookie, since things are going to evaluate to false at some point, again, we're going to say using Angular JQLite. And what we want to do is, again, we want to find that same element as we did before. We'll just copy and paste it right here. And we'll actually copy and paste this as well. And instead of block, we need to turn it back to none. Not done, none. We'll save that. Let's go back to our browser. Let's go to the actual application. We don't need this anymore. So let's go ahead and say chips. We'll do 5 bags of chips. We'll add that. You see there's no message, but the second we say cookies, 5 bags of cookies, all the horror, cookies detected. And if we remove the chips, for example, let's just remove the cookies right away. If we remove the cookies, you'll see that the cookie warning disappears. Okay, so that was fun, but let's go ahead and try to use jQuery instead. Before we do, let's go ahead and log what does this warning element look like on the console. Let's go ahead back to the console and let's go ahead and add something that will trigger it, cookie, 3 bags, whatever. And let's open up the console and let's take a look at what we have here. We have this U, and let's take a look at its prototype. And you can see its prototype. Look at all those methods that we spoke about and we saw in the documentation. So you see the find here, you see the CSS we used. So a whole bunch of methods. Pretty good. Let's go ahead and go back to the code editor, go to our index.html. I already pre-downloaded the jQuery 3.1.0.min.js, and I have it here just commented out. Let's go ahead and uncomment that. So now what we have is we have jQuery mentioned before our angular.min.js. If we save that and go back to our browser, we've done nothing else, just mentioned jQuery before we imported the actual AngularJS. Let's just refresh it just in case. And let's go ahead and say cookie, 3 bags. Let's add that. Let's take a look as to what we have now. Let's open that up. And let's go look at its proto again. What is its prototype? Let's see, can we scroll it up a little bit more? Look at that. Do you see how many more methods all of a sudden showed up on that same element? We have a whole bunch of methods, and some of them, look at that, says fade in, fade out, and I'm pretty sure there's a slide on, slide down, and slide up, which I can't see them at the moment, but I know they're there because they're part of jQuery, and they're all the way down probably, right? By S, slide down, and slide up. There they are. So let's go back to the code editor, and now that we have jQuery installed, let's go to app.js and use jQuery to do that. We'll actually just leave this alone. Maybe we'll just comment that out and comment this out as well. And let's use jQuery to get the same thing done. So let's say if jQuery included before Angular. Okay, first of all, the warning element, as we had it before, can now be found by a much more precise selector because the find of jQuery supports much more than just looking for tags. So we could say div, we could say div.error. So I want to find a div with a class called error, which is exactly what our div is. And now, instead of simply showing a display block, what we're going to do is we're going to say warning element dot slide down. I want a slide down effect, and I want 900 milliseconds. I want it to take 900 milliseconds to slide down. Okay, that's all we're going to do to display the cookie warning. And to display or remove the cookie warning, we're going to do something similar. Again, we're going to find that same div.error, except we're going to say slide up to remove it from the view. Let's go ahead and save that. Let's go back to our browser. We could close that, and we could say chips, 2 bags or 3 bags of chips, and nothing's going on. And then we could say cookies. Let's say 5 bags of cookies. Why not? And when we do that, you see Ohoro cookies detected kind of slid down and gave us that effect. Now, if we remove the cookies, take a look what's going to happen to this Ohoro cookies detected. It's going to slide back up. Remove, bam, it's gone. So now we are able to manipulate the DOM and actually affect it and even use third-party libraries like jQuery and obviously any other library we want directly in the DOM, and it's all compartmentalized inside of our directive. So the code is not spread all over the place. It's very nicely segmented only to the part that deals directly with DOM manipulation. Okay, so let's summarize. DOM manipulation is usually done inside of the link function. You declare the link function directly on the DDO, the directive definition object. The link function does not support injection itself, but if you wanted to use injected components, services, or other controllers, you can inject them directly into the directive declaration. The scope parameter, that is the first parameter of the link function, is the exact $ scope in the directives controller. It doesn't have the $ to remind us that it is not injected, it is simply passed into the link function. The second parameter is the element object, and that represents the element of the directive. It actually represents the top level element of the directive. That object is either the caculator object, which is a watered down version of jQuery that Angular provides out of the box, or it is the jQuery object itself if jQuery is included before the Angular.js is included in your main HTML page.
In the previous lectures, we passed in regular strings into isolate scope of the directive, interpolated strings, as well as objects and function references. However, sometimes what's needed is to pass an entire template rather than a string or an object. A fairly common use case is when you're coding a dialog box as a directive. That dialog box has to have the behavior of a dialog box, be able to close, perhaps provide OK and cancel buttons, but it also has to be generic enough to let its users provide the actual content for the dialog box to display. This is what yet another property on the DDO called transclude allows you to accomplish. Using transclude allows you to wrap arbitrary content with your directive, including expressions and function calls in your HTML template. The really neat part about all that is that the expressions wrapped in a directive that has its transclude property set to true are evaluated not in the directive's isolate scope, but in the parent scope. Let's see how that works.
Step 1 is to define the property transclude on the DDO and set it to true. Step 2 is to use your directive and wrap some content with that. Note that any properties, interpolations, and such are evaluated in the parent controller, not in our directive. The last step is to use ng-transclude attribute inside of the template of our directive. That attribute tells Angular where in the directive's template to include the evaluated content that was wrapped by your directive in the parent template. That's pretty much it. It's that easy and that powerful. Let's jump into the code editor and see a live example of this. Okay, I'm back in my code editor and I'm located in lecture 32, which is located in fullstack-course 5 examples folder. And yet again, I'm back in my shopping list directive app. And what we would like to do now is actually provide two separate shopping lists side by side, except the warning that's going to be displayed by the shopping list directive is something that we would like to provide ourselves, instead of having the directive decide what the warning should be. So first things first, we're going to give separate IDs for shopping list with ID list1 and the other one shopping list with ID list2. And the way we're going to have them side by side is simply floating both of them to the left and having a margin left on the second one so we could separate the two a little bit. Let's go back to index.html and take a look. The first one has the span with a class warning and says warning warning and says the list.warning. And list.warning is yet another property that we defined on our shopping list controller, the main parent controller. And we could see that if we scroll down all the way to the shopping list controller, and it's right there, the shopping list controller. And you see we defined another property or initialized another property called cookies detected. So that we know, we just don't know what kind of warning we want. And that warning we're going to customize depending on which directive we use. So the first one, we're going to use the span with a warning. And if we look at our styles.css, warning just makes the font style italic, really nothing more. The second shopping list that's going to sit side by side is going to have a little bit of a more of an involved type of display for the warning. First, it's going to have this title called "Oh the Horror," and then it's going to display the list.warning in a separate div. And again, the title here, the class title, is defined in styles.css, and it just gives this kind of a dark gray background to it. So in app.js, obviously we need to turn on our transclusion. So if we go to our directive, if we scroll up here, we'll see that transclude has already been specified to true. Now, all we need to do is to tell our directive where in the shopping list.html template that is responsible for our shopping list directive, where we want that wrapped content to appear. So we go to shopping list.html, and we see here that error message that we have here with an arrow class, and we stick ng-transclude right on it, which means that when the content of the parent is going to get evaluated, it's going to get inserted right here as the body of this div. Let's go ahead and save that. Let's go back to our browser, And let's go ahead and say something like chips, and say 2 bags of chips, and edit. And you see they're being edited on both sides. And we say cookies. If we say cookies, let's get 5 bags of cookies. When we enter that, the first list gives us this italicized warning saying warning, warnings, cookies detected. And the second one has this whole setup here where there's a title or the horror, and cookies detected is the body of this warning. And if we remove the cookies, it will get removed from both sides, and you could see our jQuery effects are still working from the previous lecture. So the main point to notice here is that even though we have interpolation going on directly inside of a directive with isolate scope, since the content of our directive is being inserted through transclusion, the interpolation and in general resolution of scope and properties of the transcluded content does not look at the directive's isolate scope, but instead uses the scope from its original place. So in this case, even though the warning property was declared on the parent controller, it could still be viewed inside of our directive because we're not simply placing it there, we're using the transclusion to place it there. That means Angular will resolve the warning property against the parent controller instead of the isolate scope of the directive. So that's how you use transclude with custom directives. So let's summarize. The transclude mechanism allows whole templates to be passed into the directive, not just a string or an object. However, the big thing about transclude is that the wrapped content is evaluated in the parent's context, not in the directive's context. The way you declare the transclude is in the directive definition object, you include a transclude property and set it to true. In the directives template, however, you use the ngTransclude attribute that designates a place for the evaluated wrapped content to be inserted into.
Congratulations on finishing Module 3. Armed with directives, promises, and so on, you're now well on your way to AngularJS mastery. But don't stop here. The topics in the next module will truly complete the AngularJS picture for you. Besides, you're just one more module away from gaining enough skills to sit right next to me as I code an entire real web application for a real client. That will definitely be a lot of fun. But you do need the skills taught in the next module to truly understand what we're going to be doing. You're now more than halfway through the course. Another couple of weeks and you're done. To stay in touch and get some more optional material I'll be putting out, be sure to go to facebook.com/Coursera webdev and like our page. Also, follow me on Twitter and LinkedIn. The links to my profiles on those networks are below the video. See you in the next module.
I think I'm done. What's going on with my voice again?
Well, that's okay.
Welcome to Module 4. In this module, we start by introducing the idea of component-based architecture. We will then delve into the AngularJS Component API. The Component API is something that was just recently added into Angular 1, and it's not only supposed to improve your application through the use of component-based architecture, but also prepare you for an upgrade to Angular version 2, which uses components almost exclusively. We will then learn about the AngularJS event system and how to split up our application into smaller modules that can then be glued together to produce our final application. We'll finish off the module by diving fairly deep into routing between views in your application, and specifically into the use of the UI router module, which is one of the most popular open source routing solutions within the AngularJS ecosystem. In fact, it's so popular that even the main Google documentation for routing in Angular links to UI router. Routing is a very important topic. Without it, your single-page application is stuck displaying just one view without an elegant way to display other views. Now, as a side note, I know that by now a lot of you are wondering about all this talk about cookies, chips, sugary drinks, but fear not. I actually like vegetables as well. In fact, I'll be finishing this bowl of vegetables by the end of this module. See you in the module. Here's to rabbit food, healthy food. Angular 1.5 introduced a new way of implementing directives: components. A component is a special kind of directive that uses a simplified configuration that assumes some defaults which are best practices anyway. While components don't restrict you to component-based architecture, using components makes it easier and more natural to structure your application code that way. Writing your application using components also brings you closer to the style of programming that Angular version 2 uses. First, let's go over the principles of component-based architecture and how it expresses itself through Angular components.
The first principle is that components only control their own view and data. They never modify data or DOM outside of their own scope. Because of prototypal inheritance, it's possible for your code to modify data pretty much anywhere in your application. While that can seem like a really convenient thing at times, it very quickly leads to chaos, as no piece of your code in your application can be assured that its data is safe from side effects it knows nothing about and it doesn't even control. This is the reason why Angular components always use isolate scope. The second principle is that components have well-defined public API. That is data inputs into the component and data outputs from the component. In order to carry out this principle to be true to the component-based architecture, component code should follow some simple conventions. These conventions are designed to further discourage manipulation of data that doesn't directly belong to the component, which can happen even with isolate scope. For example, if you pass a value using the equal sign bidirectional binding, any changes you make to the data in the component will reflect in the parent as well. That's why the inputs, so to speak, into the component should be defined only with one-way binding and DOM attribute value binding. Even with one directional binding, if the bound value is an object, changing that object's property values will impact that object outside of the component. This is simply because objects in JavaScript are passed by reference, and while you're not modifying the actual reference to the object, you would be modifying the value attached to that reference. And that's why another convention is for you to never change the property value of a passed-in object or an array. And that's why we really said the words well-defined API. APIs are contracts. You expect to give a certain input, and you expect to receive a certain output. In the case of component-based architecture, if I'm a user of a component with an API, I have to give the API certain data, be guaranteed that my data is safe from being modified, and then expect the API to produce some defined output. The output of the component is defined with the ampersand sign as callbacks to the component events. The data is passed back to the caller through the key value map object that maps the caller's argument name with the key in the map. We have seen this before with directives. Another principle is that components have well-defined lifecycle. That means they have a number of predefined methods that we could tap into at different times of the lifecycle of the component. One of the methods is $on_init. That method is used for you to initialize things for your controller's functionality. Another method is called $onChanges that gets a change object passed into it. And that method is called whenever one-way bindings are updated. The change object itself has a current value and a previous value, among other things, and you're able to see how the value changed and respond accordingly. Yet another method is called $postlink, and that method is very similar to the link method we had in the directive. Another method is called $onDestroy, and that method is called when scope is about to be destroyed, meaning when it's getting unloaded from memory. You can use this hook to release external resources, watches, and event handlers that were set up in the other methods. There are a couple of more methods that I'm not showing in this list, so feel free to go online and look at the documentation for the component API lifecycle methods. Another principle in the component-based architecture is that application really should be viewed as a tree of components. So it means that the entire application should be comprised of components. And as we said, each one would have a well-defined input and output. With the two-way data binding minimized, it's easier to predict when and where the data changes, so you can be confident what the state of your component is. Okay, so let's go over the steps in creating a component in Angular. As promised, it's even simpler than a directive. Step 1 is to register the component with the module. You will notice that the format is very similar. The first thing you do is you give it the name of your component, and that's the normalized form, which means in this case, my component in HTML will be seen as my-component. However, instead of providing a function or a factory function as the implementation of your component, you provide a simple object. In this case, it's a simple object literal. This is the typical configuration object. It just has properties and values to those properties. That's it. The next step, obviously, is to configure the actual component. One of the most common properties of a component is template or template URL. This is because most components have a template that is associated with them. You're not required to provide a controller for the component. You only specify one here if you actually have some functionality to add. Otherwise, Angular will provide an empty object automatically and will also automatically place the instance of this component onto the isolate scope with the label of $CTRL. Speaking of scope, you don't see it defined here at all. That's because in a component, the scope is always isolate with no ability for us to change it. Instead, we have a property called bindings. Bindings object is the isolate scope parameter mapping definition. It's actually exactly the same thing we used before, but the property name before used to be scope, and now it's bindings because we are assuming isolate scope all the time. In our component template, we'll use the properties that were passed into the component. Note that we're using the Angular automatically generated label $CTRL, which refers to the controller configured for the component. In the HTML that uses the component, in this case my-component, its use is exactly as you would use the custom directives that we've coded before. Again, note that the camel case naming of the tag name and the attribute name declared in the bindings should now convert into all lowercase with a dash in between. Okay, in part 2 of this lecture, we're going to go to the code editor and see these concepts in action. Okay, so we're back in our code editor, and I'm located in lecture 33, which is located in full stack-course 5 examples folder. And this is basically a copy of lecture 30, but with some cleaned up code. So we named this one shopping list component tab. And you could see it's pretty much the same as before. We have our controller. We have this list.lastRemoved, which is something that the controller will display once something gets removed from the list. Now, things get removed from a list using this shopping list directive, or at least it's a directive for now. We're going to take that shopping list and turn it into a component. And you can see we're passing in items, passing in the title, and passing in unremove, and we'll discuss that this looks exactly the same as we actually did before, where index is something that is an output from the component or from the directive in this case. Let's go ahead and go to app.js. And the first thing you see is that we forgot to change this into component. It's a component shopping list component app. Okay, so the first thing we want to do is we want to change the shopping list from being a directive to being a component. Well, let's go ahead and change this out to component. And now instead of having a function as the definition for our shopping list, we're going to have a simple configuration object. So make it much easier. And we could even do this straight in line since it's just a bunch of configuration properties and that's about it. Okay, so the first thing our component will have is a shopping list.html, which is going to be our template. So that stays exactly the same. We'll also need a controller because we're going to put some behavior into it, and let's call it shopping list component. Let's say component app component controller. So we have our shopping list component controller. We're not going to define the controller as, and we'll let Angular just define the $CTRL for us automatically as the label that's going to reference our controller instance. And the next thing we need to do is what are our inputs and outputs, which are called bindings instead of scope. And this is all sitting on the isolate scope. And really all we need to do is copy these three things because it's exactly the same as before. So we have the items, which is a one-way binding object. We have add title that is going to be mapped to my title. And you can see since the @ sign, it means it's a DOM attribute value binding. And we also have onRemove, which is going to get mapped to onRemove or on-removed in the parent HTML. And it's going to be a reference function. So this is going to be a callback back to the parent controller. And that's pretty much it. We can actually take this function right here and we could comment it out because we don't need it anymore for now. In fact, we could just simply erase it. We don't need that anymore. And we need to define this shopping list component controller. And in fact, what we're going to do is we're going to just copy some code here. This used to be a shopping list directive controller. We'll make it into a shopping list component controller. Except this time, instead of calling it a list, since we know that it's a $CTRL, let's go ahead and call it $CTRL equals this. Now, make sure you don't make a mistake. This is just a local variable. I could call it whatever I want. It doesn't make any difference. But since it's named exactly the same as the one that we're going to be using in our shopping list.html template, we might as well call it the same so we'll know it's referring to the same thing, which is the instance of our component controller. The only thing is we need to change that now everywhere it says list. It should now become $CTRL. And I believe that's pretty much it. So let's save that. And we see that our component controller has that same method we used before called cookies and list. And what it's doing is it's looping through all the items that are attached on our bindings and looking that any name of any item has the word cookie in it. It will signal this to true and a warning message will pop up on the screen and will slide out or something like that. Okay, so let's go to the shopping list.html, which is our component template. And we know that we don't have list pointing to the instance of the controller for the component. We now have $CTRL pointing to that. So let's go ahead and copy that and substitute anywhere we see list with $CTRL. And I believe that's pretty much it, these two things right here. And we could save that. And now if we go to our browser, we should see the title right here and we don't. So we messed up somehow, or I should say I messed up somehow. And it says here that it cannot read length property of undefined in app.js 22. Well, let's go back to our code editor. App.js 22 is right here. So it says it cannot read the length property of this item. Somehow the items array is not really being passed in, even though we passed it in right here as a one-way binding. Oh, well. What do you know? It's bindings, not binding, so that would make sense. Let's go ahead and save that. Let's go back. Oh, no errors. Well, that's good. It's always good not to have errors. Okay, so now we could start entering things in. Chips, 4 bags of chips, and there's one. If we say cookies, when we say cookies, the warning will pop up since we have an ngIf statement right on the div that has the warning in it. Okay, so let's take a look at this button here. It says controller onRemove and it's passing this thing right here. It looks a little bit ugly for the HTML template to have stuff like that. So instead, why don't we go ahead and change that and let's say control remove and actually just pass the index in it instead of having all that. And we'll actually write the remove method on our controller. So let's go ahead and save that. Let's go back to app.js. Let's find our controller. That's shopping list component controller. So we already have one method called cookies and list. Let's go ahead and put a couple of spaces here. We'll say $controller, and we'll say remove, and that's going to be a function. We don't need the name. Let's put the semicolon here. And this function has to call whatever function that we defined in our binding. So on remove. So therefore, it's going to call $controller on remove. And we need to provide it the index. Well, we forgot actually to put the index in here. So that's what's getting passed in from the template. And instead of just saying index here, that wouldn't really work. We actually have to give it an object, the key value here, whose key has to match whatever it is the name that we used in the binding, on remove binding of our shopping list component. So this case is just index. So let's go back to app.js and actually let's call it something else. Let's call it my index. That way at least it will be a little bit more understandable. So this index, the key comes from index.html. That's that index right here. That's the name that we're mapping. And the value is going to be my index. Okay, so now we have it a little bit cleaner. In the shopping list.html, the button just calls onClick and it calls a method on the controller directly, passing it the $index that is provided by the ngRepeat directive, which then gets passed into my remove function that I defined here right on the controller, which calls the reference function that was passed in from the parent controller with a map of key value. Let's put another space right there. Well, let's save that. Let's go back to our browser and let's say chips, 4 bags of chips. We'll add that. And when we say cookies, let's make 5 bags of cookies. And add, once we add, you see that the warning shows up immediately. And then when we remove cookies, the warning disappears and the cookies item gets passed to our parent controller. And that is why we're able to display as our parent controller that the last item removed was cookies. Okay, so that's how simple it is to create a component. In part 3 of this lecture, we're going to look at the lifecycle methods that the component API provides and use it to enhance this little shopping list application a little bit. In part 2 of this lecture, we converted a directive that we previously have written into a component, and we saw how much simpler the whole component is. There's no function, there's just a configuration object, and so on. But the controller of the component is now enhanced with some lifecycle methods, and we're going to use them right now. Let's go back to our code editor, and let's go to the shopping list component controller and add a couple of more methods that Angular knows about. We add those methods, again, directly on the controller's instance. So one of them is that we discussed was onInit. And onInit is a function. Again, we don't need the function name. And in this case, we're just going to log that we are in $onInit. So that way we could see that it's getting executed. Let's go to our browser and let's open up the console. And you'll see that it is in fact being executed right here. This is only going to get executed once when the controller gets instantiated. Let's go back to the code editor and let's add one more method called $control $onChanges. And that's also a function. And that is a function that is going to have a change object that is going to get passed into us by the Angular framework. Let's go ahead and console.log what that change object is. Let's go ahead and console.log that, and we'll save that. Let's go back to our browser. And you see up front here, it has a couple of things in it. It has my items, or my title, and items. Those are the things that actually first arrived, so to speak, when the whole thing got initialized. Well, let's actually take a look at this object as we keep changing stuff. Let's go ahead and put chips in here, put 3 bags, and we'll add the item. Now you see it got fired again. So what got fired was the changes, right? We could actually go back and actually put the word changes here so we can see what's going on a little bit better. Okay, let's go back to the browser. And we see now it says changes. So now when we put chips, and we'll put 3 bags of chips, and we edit, the changes fires again, the $onChanges fires again. And if we open it up, you'll see that my title is the thing that changed. Let's open that up a little bit more so we could see it a little bit better. And the current value is shopping list number 1 item, so it's right there. The previous value was shopping list number 1, 0 items. Now, what happened to our items array? Why didn't that get changed? Why didn't that get passed in here? Well, the reason it didn't get changed or it didn't get detected here is because the only thing that is being watched on the items array, let's go back to the definition of our component, is the reference to that items array. And the reference, no matter what items we add into the array, the reference to the entire array stays the same. If we were to change the reference of the array, not inside of our component, but outside of our component, that onChanges would fire and would include my items. But since the only thing that changed outside that it's actually watching very closely, so to speak, is the title or my title, that's the thing that fired, and that's the thing that got included in the changes object that we're looking at right here. Okay, let's go to yet another lifecycle function called control. We're putting it to control, and it's called $post link. And I told you that $post link is basically the same thing as the link function that we've used before. So let's go ahead and use it in the same way we used it before, and that is we're going to make the shopping list.html have the error message slide out and slide up to disappear. In other words, this is the place where we're going to manipulate the DOM. Now, please note, this is not necessarily the best way to have animations in your template HTML. However, my only purpose in showing this to you is to show you that you can manipulate the DOM from the $post link. You might not necessarily want to manipulate it in the way I am doing it right now. Might want to have something much more complicated before you go to manipulating the DOM in this way. Okay, so what we're going to do is we're going to display the warning message when somebody uses cookies as part of their shopping list. The first thing we need to do is we want to make sure that this div is actually not visible to begin with, and then it's going to slide out. So what we need to do is we need to remove this ngIf right here and save that, and then go to our styles.css and add one more property here called display none. So it will not get displayed up front. Only we're going to display it through the code. Then we're going to go to our app.js and we're going to set up a watch on the cookies in list function. And the way we would do that is we need the scope variable because we need the scope.watch is the function. The only problem is we don't really have a scope variable here. We haven't really injected it yet. So we're just going to go ahead and create an inject array, $inject array. And so we could protect it from minimization, and we'll say scope here. That's what we need to inject, and obviously inject scope right here into the actual shopping list component controller. Okay, so now the scope is available. We can actually call the watch function, and what we need to watch for is $controller, that's the label, that cookies in list. And we need the parens to make sure it understands that this is not just a property, this is a method that will need to get executed. And we're going to watch it with new value and old value that's going to be passed into us. Okay, so if new value is equals true, if that's the case, then we need to do something else. We need to do something else. So here we need to basically show warning, and here we need to hide warning. Okay, oops, we don't need it uppercase. Here we go. Now the problem is that this function doesn't actually have, the scope element. It's not exactly the same as link. So how do we get at the actual element that is our component? Well, there's yet another service called $element. And in order to get that, we need to inject it. So let's go back and put a comma here and say $element, and we'll put $element here as well. And we'll go back to our $post link, and let's go ahead and first of all, we'll go and just log it so you could see what that is. We'll say $element. Okay, so let's save that. Let's go back to our browser, and you can see what it outputted. It outputted the shopping list.ng isolate scope. That's our item right here, and that is coming from the $post link. So that's how we get at the parent item or the top item of our component. Let's go ahead and use jQuery to slide it down to show it, and then slide it up to make it disappear. We need one more thing in order to use jQuery. You guessed it, we actually need to download jQuery and put it in our folder and then reference it as part of our libraries that we reference here with the script tag. Okay, so I'm going to pause the video for a second, get the jQuery, and we'll continue in a second. Voila, magic. jQuery 3.1.0.min.js. We don't need to look at that code. It's ugly anyway. One more thing. Let's delete these couple of things that we don't really need here. It's from the previous lecture. Let's move them to trash. Okay, so we have the jQuery file here. All we need to do now is reference it, and we need to make sure to reference it above our Angular import. So we'll say script, we'll say source equal, and here it's jQuery 3.1.0 min.js. Okay, we did that. Okay, so now jQuery is available for us. We'll go back to our app.js, and we could show the warning by saying var warning element is equal to, and again, we're back to jQuery. So $element actually represents an element as a jQuery object. So we could say that find, and we could say div.error. So it's going to, again, look only in the template of our component. It's not going to look through the entire HTML of our page, which is really good because it's going to be much, much faster. And then we need to say warning element dot slide down. We'll give it 900 milliseconds to slide down, so it'll be a little bit slower. So that's to show it. And we could copy this over to hide warning. And we need to get the element again, except this time we're going to slide up to make it disappear. Okay, let's save it. Let's go back to our browser. We can make this minimized, and we'll say chips, 3 bags of chips, and you see that's fine. And if we add cookies in here, we'll give it 3 bags of cookies. When we do that, you see it slides out or slides down to show us the warning. Warning is cookies detected. And if we remove the cookies, it will slide back up and remove the warning from our HTML. So this is how you use the lifecycle methods inside of your component controller. In the previous lecture, we spoke about $post link, and you saw how we were able to set up a watch for is cookies in list, and then use jQuery in order to output a message, an error message on the screen. The reason we had to set up a watch in post link is because our $onChanges, our changes object, did not include any changes to the array, even though we put more things into the array, because onChanges does not watch when elements are added to the array, it's only watching the actual reference to the array itself. Now, as I was coding that example, I myself did not realize that I was using a little bit of an older version of Angular 1. I was using Angular version 1.5.7. Now, there's something that happened in 1.5.8, and that is that they put in one more lifecycle method as part of the component lifecycle methods. So right now I'm located in the documentation for Angular 1, and it's docs.angularjs.org/guide/component. And just to make it more fun for us, if we click to 1.5.8 and we scroll down to those lifecycle methods, let's take a look. You'll see that there is the onInit, the onChanges, onDestroy, and postLink, but we're missing another method that actually works in 1.5.8, but it's not listed in the documentation. So let's go back to the default one, unfortunately, the snapshot documentation, and we'll scroll down to those lifecycle methods, and we'll take a look because there's yet another method that they released called $doCheck. And that's a method that gets called on each turn of the digest cycle. So as the digest cycle executes, it will call this method with no arguments. And it tells you there's hook is invoked with no arguments. And if you're detecting changes, you must store the previous values for comparison to the current values. So basically, you have to check them yourself. Okay, so that's what we're going to do. We're going to try to set up our own watch, which just hooks into the digest cycle. And instead, we'll use the standard lifecycle method called doCheck. So let's go back to our code editor. And if you see here, I created a new lecture, and right now I'm located in lecture 33-1.5.8. And again, even though the documentation says this method doesn't exist, I tested it and it actually works, so it certainly does exist. And this is the exact same application we saw before. The only difference is that I added a couple of things and removed a couple of things as well. Number one is I added this local variable to the shopping list component controller called total items. And that local variable total items is going to get initialized in the $sign on init. So the total items I'm speaking of is the total items in our shopping list. So it's going to on init get initialized to 0. Now, we'll leave this $sign on changes, even though it's not really going to be useful for us just to see the console log of it that it's happening. And what we did here, if you take a look, is we removed the $sign post link. We actually removed the $sign on destroy as well because we don't need it right now. And instead of setting up a watch, we know that this gets called every time the digest cycle runs and every time the digest loop is looping. So what means, what we could do is we could ask, hey, if the control.items, that link, that array, because our bindings watch only is looking at the items reference itself, it's not looking at the items of the actual array. So if we could take a look and see, is the length of the array the same or not the same as the number of total items? If it's not the same, we need to remember the number of total items that is contained in the array right now. And since it changed, obviously because it's not the same, we're going to go ahead and invoke this is or cookies in list method. And if cookies is in list, that's going to return true. We're going to have those same jQuery methods that we're going to call in order to basically slide down an error message. And if total number of items is equal to the length of the array, which means nothing's changed in the list, we're going to go ahead and make sure that the error message slides up and goes away. Okay, and just for our own sanity, let's put a couple of console log statements right here. So the first one we're going to log inside of this if statement, which means that the total number of items is not equal to the length of the array. It means that the number of items changed in our shopping list. Either it went up or went down. So let's log and say something like number of items changed, checking for cookies. Okay, so that's going to be one log statement. Another log statement, if the cookies are indeed in the list, besides the error message, let's go ahead and log this. Oh, no cookies. And if there are no cookies, we'll log this here and we'll say no cookies here, move right along. Okay, so now we have a couple of console statements, or 3 console statements in here. Let's save that. And one more thing. If we take a look here, we are not any longer using the $sign scope. And that's kind of a good thing because we really want to get away from using $sign scope. And according to the component architecture, which is what actually is Angular 2 is all about, and components are part of kind of Angular 2 vision, scope isn't something we want to depend on, so we're going to remove that from here. So by having this doCheck method, we were able to eliminate our injection of the $sign scope. It's not the end of the world, certainly we're not in Angular 2, we're in Angular 1. But if you inject the $sign scope and start attaching properties to it, which is a bad practice, this is kind of opens up the window for that if you inject it. So if it's not even there, then you stay away from it. Okay, so let's go back to the browser and let's go to I already have my browser link working. So let's go ahead right here. You see it's going to print out our changes to begin with. But if we put chips and we'll do 3 bags of chips, when we add it, it says number of items changed. I misspelled change, but it doesn't matter. Checking for cookies. It says no cookies here. Move right along. So we're good. So if we put in cookies in here, keep it 3 bags and put the cookies in, it's going to say, oh no, cookies. And we need to scroll this down a little bit. We could see that the warning is there. So if I remove the cookies, let me clear that. If I remove the cookies, again, it goes away. Number of items changed. No cookies here. Move right along. And cookies are no longer part of our shopping list. Okay, so just to summarize, this is just another way to hook into some lifecycle events that are happening around the component. And one of them is doCheck, which is what we used here, which gets fired every time through the digest loop, which gives you a chance to look into your bound items a little bit deeper, or bound objects a little bit deeper, such that you could do kind of a much deeper check on things without having to set up your own watch, which might actually slow things down a little bit more in terms of performance. But either way, it's certainly a better practice since we can get away from injecting $sign scope which is prone to errors because somebody, some other developer, obviously not you because you know better, but some other developer might start attaching properties on the $scope once it's available and it's injected already. Okay, let's summarize. Components in AngularJS encourage component-based architecture, but they don't enforce it 100%, so we must follow conventions such that our architecture stays a component-based architecture. One of the main things in the component-based architecture is that components should never modify data or DOM that does not belong to them. That's why it always has isolate scope and well-defined API to give us the inputs into the component and the outputs that lets the component return the data to the outside world. The way you register a component is very similar to how you register controllers, services, and so on. You provided a name, except the difference is the second argument into the component function is not a factory function, but just a configuration object. Usually we just provide an object literal with properties, controller, template, bindings, and so on. One of the properties called controller is for you to specify what controller you want to use as the component's controller. Only provide that if you are actually adding extra functionality. Otherwise, Angular already provides an empty function for us that is used as kind of an empty controller.
We have seen a few ways that components within your applications can communicate with each other. For example, through prototypal inheritance, child components can communicate with the parent components. Note that I'm using the term components here loosely. This obviously applies not only to components, but to directives, controllers, and so on. Another way components can communicate is through shared singleton services. Shared services that are created with the .service method are singletons, and therefore different components can share data between each other using that single instance of the service. However, there are situations where such communications are just not elegant enough and create too many dependencies between different parts of your application. Let's take a look at some illustrations.
Take a look at this diagram. Suppose component 2 wanted to communicate some data to its parent component 1. We have a couple of ways of achieving that. First, we can access component 1 from component 2 by simply going up the scope chain and accessing the parent controller. Angular makes this easy for us with the $parent property on the $scope object. This is obviously not the end, since we still have to make sure that either we set up mechanisms in component 1 to react to the new data, or somehow invoke something from component 2. In other words, we still have to make sure that component 1 is aware of our communication. We can also use the ampersand method callback method binding and call the parent's components method, passing it some data. So that's communicating with the parent. In the flipped scenario, we want to communicate with the child component. One quick way of doing this is for component 2 to provide some way for us to send the data into it. Again, component 2 would have to have some way to react to the new data. Things get a bit more interesting if you wanted a component to communicate with its grandparent component. An elegant solution to this is a bit less obvious. Should you use the $parent property twice to crawl up the scope chain to get to your destination? I don't know. Look at the dependency we're creating with that move. Another possibly more elegant solution is to use a singleton service and inject it into both components. You would still need to set up some watch for the value stored in the shared service in component 1 so you can react to any changes in the shared service value. When the target is reversed, we're faced with a similar dilemma. Should we send the data into component 2 and have component 2 send data to component 1? Or should we use our shared service again? Not sure, but doesn't really feel elegant quite so much anymore. And what about communicating with multiple components at once? Here, the components we want to communicate with seem scattered all over the DOM. Component 4, for example, is neither a descendant nor an ancestor of our component 2 where we're sending the messages from. Yes, we could still use our shared singleton service approach, but would have to use it everywhere and things are getting a bit messy. A similar scenario is when multiple components want to communicate with one central component, but its location within the DOM is not known to those components. Again, we could use the shared service approach, and again, this would be a messy way to approach reacting to some data change or UI change that we need to respond to. Luckily, there's actually a software design pattern that could solve all these issues in an elegant way, and which Angular implements through its event system. The design pattern is called Publish Subscribe Design Pattern. And basically, there are two components to this design pattern: publishers and subscribers. Publishers send messages to subscribers on some common channel. So when we speak about publishers, publishers mark messages with some classification. Publishers also don't know the subscribers of their messages, nor do they know if there are any subscribers out there at all. Subscribers, on the other hand, sign up to listen for messages with a particular classification. They also don't know publishers or if there are any publishers for these particular messages at all. In Angular, the common channel in which these messages communicate over is scope. Messages that we're speaking about in this design pattern are called events that can hold data. There are two types of publishers in Angular event handling. The first one is called emit, and emit goes up the chain scope. So if component 3 wanted to emit an event called greet with the data with message equals hi, that event would keep going up the scope until it reached all the way the top scope in the application. The other way to publish messages in Angular is to broadcast them, and that's done with the $broadcast method. Using that method, events go down the chain scope. So for example, if the very top scope broadcasted an event with the name greet and the data with a message equals hi, that event would propagate all the way down the chain scope to the very last leaf in the scope chain. The way you subscribe to an event in Angular is by calling a special method on the scope service called $on, and you provided the name of the event you're subscribing to and some handler function that deals with what to do once you caught that event. You might be wondering the following question: what happens when the target of your broadcast is not in the direct path of your broadcast call down the chain? Or the other way around, if you're emitting an event, the target is not in the direct scope chain of your event going up the scope chain. The answer is that you can broadcast your event from the parent scope of everything in your app, otherwise known as the root scope. You may not have realized up until now, but the ng app that we have declared on some top element like HTML in our HTML page is actually the parent controller to all controllers, directives, and components that live under it. Angular has a special service called $root scope that you can inject into anything in your application in order to refer to the highest scope in the chain possible, meaning the root scope. Therefore, if your component 3 is trying to reach component 4, which is not in a direct scope chain up the chain tree, you can use the $root scope $broadcast inside of your component 3, and what that will do is that will reach the very top of your scope chain and will propagate down, reaching component 4. Note that when you broadcast from the root scope, every single node in your application gets the event and has a chance to respond to it. Okay, let's look at some syntax. The call to emit and broadcast can be done from a controller, service, a component, or anything really. Don't forget the $sign as part of the emit method name. As we said, $emit sends an event up the scope chain. $broadcast, on the other hand, sends the event down the scope chain. Note that it's a best practice to namespace the event name string. This is useful for code readability down the line when you try to understand what part of the system the event is targeting. In both cases, you could send an object along with the event containing some data which can be unwrapped when the event arrives at its destination. The last step is to register a listener for your event. This is done with the $on function that's executed on some $scope or $root scope, which is really just the top scope in the application. Obviously, we need to use the same event name string we broadcasted or emitted the event with. The handler function is automatically passed two arguments. The event, which holds the event information, including that event name string, and most importantly, the data object. This data object is what contains the data that we wrap together with the event when it was emitted or broadcasted. Okay, time to get back to the code editor and see these concepts in action. Okay, we're back to our code editor, and I'm located in lecture 34, which is located in full stack-course 5 examples folder. And this is once again our shopping list application, which is now called shopping list events app. There are many times in applications when there's some asynchronous communication going on, and while that's taking place, because usually that takes a little bit, you need some sort of a spinner or some sort of graphic to tell the user that something is going on and he should wait. So what we're going to do is when a shopping list item is added to the shopping list, we're going to kick off a whole bunch of asynchronous actions, each of which will check whether or not a particular item in the list contains the word cookie or not. Now, since there could be more than one item in that list, we're going to have more than one asynchronous action being fired. However, while those asynchronous actions are being resolved, we would like to show some sort of indication to the user that something is going on, so we're going to display a loading spinner that is actually going to be our Flickr button. And if you heard of Flickr.com, this is what their loading icon is like. And since we don't really know where this particular behavior is going to reside, we're going to place our loading spinner component, yet another component we're going to have in our application, we're going to place it outside of our controller. So it's not even inside of our shopping list controller. As you can see, the div ends right here. It's actually sitting completely outside of it, but it is still sitting inside of the ng app directive, which means it's inside of our Angular application. So let's go to our app.js and take a look at the code. Let's actually minimize the file browser, so there'll be more room here. So as you can see, we have one more component called loading spinner, and all that component has is a spinner.html template URL and a spinner controller. Well, the template URL for spinner.html is very simple. It's just an img tag, and it has an ngIf in it, meaning it will get shown, this img will be part of the DOM if this $ctrl.showSpinner is true. Otherwise, it will say false, and the entire img tag will be pulled out from the DOM rendering. Going back to our app.js, you'll see we have a starter here. We started our spinner controller, and we already injected the root scope, and you'll see why in a minute. And this is just the starter one. Well, let's take a look at a very important part of the code, which is inside the shopping list component controller. That's the thing that displays the shopping list. And we injected a couple of things here. We injected our queue service, if you remember from when we spoke about promises, and we also injected this weight loss filter service. That's an asynchronous service that checks for names of the shopping list to check to make sure there are no cookies in it. And we're going to invoke that service inside the $docheck. Again, $docheck gets invoked every time through the digest loop. And therefore, we could check whether or not our number of items in our items array changed. And if it did, it means it's time for us to check whether or not there are cookies inside of our shopping list. Before, however, we make that asynchronous call to our weight loss filter service, we're going to broadcast an event. And notice that we're broadcasting an event using the root scope. And the reason that is because the component that needs to catch that is loading spinner, and it's completely not in our path of up the scope chain. So therefore, if we go back to app.js, we're using root scope, so we're starting from ng-app, starting from the very top component, and we're broadcasting that event down. And the event is called shopping list :processing. And the only data we're passing, really mostly for show here, is on, the property on in the object, and its value is true. So what this event should trigger somewhere in our application, we don't know where and we don't care, is it should show some sort of a spinner to the user saying, hey, we're processing, or maybe do some other things as well. But for our purposes, all we needed to do is actually show the spinner so the user knows something is going on. Then we're going to use our $Q all. And the way we're going to do that is we're going to loop over every item inside of our items array. And for every item, we're going to call this weight loss filter service and call its method called checkName, which returns a promise. And we're going to push every single promise into this promises array. As you can remember, the Q service, $Q service, all takes an array of promises and then it can deal with them all at once. And that's actually what we want. We want them to be asynchronous and all of them to be parallel at the same time. And the reason we want that is because even if one fails, which means, even if one fails, it means that we detected a cookie in there and we're going to go into this catch block, the rest of the promises will get canceled automatically right there on the spot. So the first time it detects a cookie, the rest of them will get canceled. And what's going to happen is it's going to do this jQuery stuff that we've seen before, where it's going to find the element with that error message and go ahead and slide it down. And if all of them come back with a positive result, which means none of the items in the shopping list actually contain the word cookie, then we're simply going to remove the error message if it's even there. In either case, however, whether it's good or not, we have a finally block that will broadcast yet another message using the $root service, and it will broadcast shopping list processing and on with a value of false, which means we've completed all of our asynchronous communication, nothing else is being processed, so therefore go ahead and turn off that spinner. Okay, so we've set up broadcasting the on event when the spinner should turn on, and we've set up the broadcasting of the event that the spinner should turn off at the end of all this asynchronous processing. Let's go to our actual spinner controller and implement the event listener to catch those events. So the first thing we're going to do is we're going to go ahead and use our root scope that we injected right here into our controller. We're going to call this $on method, and the $on method is going to look for shopping list, all lowercase, processing. That's the name of our event. And we need the handler function, we don't need the name, and it's going to pass us event and data. Okay, we'll put a semicolon here, and now we could actually log what the event is. So event, and we'll log what that is. And let's go ahead and also log what the data is. Okay, now let's go to our browser, and browser sync is already started. Let's go ahead and open up our console, and let's go ahead and add something like chips, 2 bags of chips, and we'll click add. When we do that, you could see a couple of things happen. Number one is the first event gets fired, and that event is an object. You could see it has a name. The name of the event is shopping list processing, and you could see the data as well that was broadcast to the entire tree, really, which is this object with the value, with the property on and a value of true. But you could see that there's yet another event that got broadcast, and another event that got broadcast was, again, shopping list processing, except with the object that it broadcasted was on false. So the first time when we started processing was this event. When the processing was over, this event was broadcast. Both of these events, however, were caught inside of our spinner controller right here. That's where we printed that out. The next step is fairly simple. We just have to check if data.on, because that's our on property. If it's true, it means we want to turn on the spinner. And that's easy. It's just controller value that's a controller.show spinner equals to true. And otherwise, else, our controller.show spinner is equal to false. Let's go ahead and save that. Let's go back to our browser and let's go ahead and try it. Let's say chips, 3 bags of chips. We'll click add, and we could see right there it's processing, so it's showing us. And once the second event comes in, that icon disappears. And if we say, let's move this down a little bit, and if we say cookies, the dreaded cookies, 3 bags of the cookies, and we click add, yet again it's processing. Now it's processing 2 events or 2 items in the shopping list, and it comes back with cookies detected. So if we remove that, again, once I remove it, it has to once again trigger the whole broadcasting, which is what it does. And again, it's checking to see that there's no cookies in here, and once it comes back, it turns off our animating icon. There's actually one more thing to do. If you take a closer look, this spinner controller and this spinner component altogether, this loading spinner component, will work very well in this view. But what happens if I switch views and come back to it, and then switch and come back to it? Every time I come back to it, we're going to have this $rootScope.on. So which means every time we will register this event listener, and there's really no code to go ahead and destroy this. This would be different if I just said something like this, scope. Why? Well, because every time that this view gets destroyed, the scope gets destroyed with it and anything that's attached to it. However, root scope is never destroyed until the entire application is destroyed. And here we have a potential for a really nice memory leak, because every time we come here, this on is going to get executed, but nothing actually deregisters it. Well, we learned of this handy method in the controller nowadays in the components called controller.$on_destroy. So when this is going to get destroyed, when the scope of this controller gets destroyed, we want to trigger the destruction of this listener as well. And the way we could do that is to say this is a function. We don't need the name of it. And what we need is we need to somehow get a hold of the function that registered this entire listener. And the way we could do it is fairly simple. The $on function actually returns a deregistration function. So all we have to do is say var cancel listener, and we'll make that equal to that. And in here, since it's a local variable that we can access, we'll copy that. We'll just say cancel listener, and now that we know that it's a function, all we need to do is put parens behind it, put a semicolon, and save that. And now every time this view gets destroyed and the scope, the $scope that belongs to this controller and belongs to this component gets destroyed, we'll also at the same time deregister our rootScope.on. So it will not hang around even though we're no longer using the scope. Let's go ahead and check it out to make sure things are working. Let's put chips, 4 bags of chips, and add that. That seems to be working. It should turn off in a second. Yes, it did. And now we're going to put cookies. Let's make it 5 bags of cookies. We deserve it. And there you go. That's spinning. And at the same time, at the end, bam, it says cookies. If we remove it, it will once again start spinning to check the items in the shopping list. You will see that the cookies are not there anymore. The spinner will stop and the warning will go away as well. Let's summarize. In Angular, the publish-subscribe design pattern is implemented using the Angular events system. You can publish events from anywhere in the system, and likewise, you could listen for those events and catch them anywhere in the system as well. There's a couple of ways of publishing events. One way is to use the $scope.$emit. That method sends the event up the scope chain. The other way is to call $scope.$broadcast, and that method sends the event down the scope chain. Obviously, your message or event reachability of a particular node will depend on where it is located in the scope chain structure, whether or not it's in the path of the broadcast or emit methods. So if it's not in the path, or to really reach all nodes, you use the $rootScope.$broadcast. What that does is broadcasts the message from the very top where you declare ng-app, which is really the root controller of our entire application, and therefore everything in our application inherits from its scope, and therefore everything is on its scope chain path. To listen for an event, you either use the $scope.$on or the $rootScope.$on. In either case, what you pass into those methods is the name of the event you're listening for, and you register a function that should be executed when that event gets triggered. While if you're listening for an event using the $scope.$on, there's really nothing left to do, because when you destroy the particular view, the $scope will get destroyed with it. That is not the case with the $rootScope, because that always lives throughout your application. So you must deregister the listener when using the $scope.$on. The way you deregister the listener is simply capture the return value of the $on method, which happens to be the deregistration function, And then you hook that into the destroy method of your component and then calling that deregistration function inside of that. If you were to skip doing that, you would leave the listener function registered in memory basically for the rest of the life of this application. And what's worse, as you keep coming back to this view, new listener functions would be registered and more of them would keep sitting in memory without any way to reach them and unload them from memory by deregistering their listening to the event.
Whether you realize it or not, we've actually been using modules pretty much from the beginning of the course. However, we haven't really talked about them and therefore haven't really used their power. By far, the biggest advantage of using modules is the fact that they allow us to modularize our application. In other words, modules allow us to split up our application into smaller parts that can then be glued together. This is a huge advantage because it allows us to work on different parts of our application independently. It also drives our thinking towards approaching our software projects as smaller parts of the bigger whole. It's always easier to code up something small and simple than to attack an entire development effort all at once. Using modules, we can also wrap up our controllers, components, directives, or whatever, and offer it up to the world for others to use in their applications. Now, unlike regular applications that have a main method from which everything starts, in Angular there is no main method. Instead, we use the module API to declare artifacts of our application, components, controllers, and so on. Let's take a look at the syntax of declaring modules.
The first step is for us to declare or create a module. You declare a module by calling the method module on the Angular object itself. The string name you give to the module should be unique across your entire application. Another important note to make is that if you specify a second argument in the module method, you're actually creating the module instead of simply retrieving an existing one. Note that you can create a module without any dependencies on any other modules, like in the case of module 1 and module 2. Or you could declare that a module depends on one or more modules. In the case of module 3, it depends on modules 1 and 2. The second step is to declare module artifacts. We've done this step before in just about every lecture the entire course, so you should be very familiar with it. However, note a crucial difference between creating a module and retrieving the module instance in order to attach a controller or something else to it. Note that the second argument to the module method is omitted. This assumes that we have previously created this module 1. If we haven't, the call to retrieve the module 1 will cause an error. The last step is for us to wire in the name of the main module into our HTML using the ng-app directive. And that's pretty much it. Now, just like it's easier to deal with individual modules with their related components, in real-world development, it's also much easier not to place all of your JavaScript code into one file. It's a best practice to place one artifact, like a controller, into a single JavaScript file. Now, sometimes this best practice rule is broken when the code is small and it's easier to understand what's going on if you place a couple of artifacts into the same file. It's very common to simply declare or create a module in its own JavaScript file. In this case, judging by the name of the file, it looks like we're creating and declaring module 1. Remember that this would be done by using the angular.module method with the second argument of either an empty array or some array of module names that module 1 depends on. Then, in controller.js file, you retrieve module 1 you created by using the same angular.module method but without the second argument and call the controller method on it to declare a controller. And the same thing would work for module 2 below. If you're not used to seeing JavaScript split up like this, just think of how this works in the browser and you'll get more comfortable with it. Since, as you know, the browser processes HTML sequentially, That means that conceptually, the browser will combine all of your JavaScript files into one JavaScript file. The contents of that file will be the contents of the files you declared in your HTML one by one. So in this case, you can visualize creating a new JavaScript file, then pasting the contents of module1.js into it, then pasting the contents of controller.js into the file after that, and so on. Note that it does not matter in which order you declare modules in your HTML or in your JavaScript file if you think of the whole setup as one gigantic JavaScript file put together from the smaller ones. Here, we're declaring module2.js before module 1. Internally, once Angular reads in all the module declarations, it will figure out which module depends on which other module and will instantiate them in the proper order. However, what you absolutely cannot do is declare an artifact for a module before you create that module. The reason why this is going to result in an error is because pasting the contents of those two files in that order would roughly produce something like the following. As you could see, we are retrieving an instance of module 2 and declaring a component on it as the first step. However, the module itself isn't even created until the second line of code. This would obviously result in an error. Let's discuss one more thing. There are a couple of special module methods, and we've seen one of those already, the config method. Config method runs before any other methods on the module. As you remember, the function value passed into the config method can be injected with a provider or a constant. Since providers are used to configure services, the restrictions of not being able to inject services into the config method makes sense since we don't want to instantiate a service before we had a chance to configure how it would be instantiated. The other method is the run method that's executed on the module. The run method is executed right after the config method. You can only inject instances and constants into the run method, but not providers, because we want to prevent the system from being reconfigured during runtime. In the case of a module that depends on other modules, all the config methods of dependencies will execute first. So in this case, the config method of module 1 and module 2 will execute first, then the config method of module 3 will execute. Then the same pattern will repeat for the run methods of these modules. Module 1 and module 2 first, then the run method of module 3 executes. Okay, let's jump back into our code editor and split up our application into a couple of modules and multiple JavaScript files. Okay, we're back in our code editor, and I'm located in Lecture 35 folder, which is located in Fullstack-Course 5 Examples folder. And this is our good old shopping list application. Except this time, as you could see on the left here, we kind of cleaned it up and split it up into different folders so it'll be much more organized than before. The index.html is, as before, pretty simple. The ng-app is pointing to this module, this app module, that's called shopping list. So that means that we have a module with the name shopping list. And you can see it's the same shopping list app that we had before. And at the very end, we have this loading spinner right here, which is what we're really going to concentrate a little bit on. And the way we're now importing our artifacts is through separate script calls. So we're clearly putting the jQuery and Angular itself into the lib folder. And if you could take a look here, those are the two files right there. So those are the things we need to load first, obviously. And then we're loading modules. You can see we're loading the source spinner, spinner.module.js. And if you take a look at the source, you'll see we have a shopping list folder and a spinner folder. Well, the shopping list folder where all the shopping list artifacts are located, the component, the controller, the factory, and the service. And these are all services and factories we've seen before. The shopping list factory, the weight loss filter service, we've seen all of them before. And it's actually a best practice to call them by the name of the service, then followed by period, followed by the name of the artifact. So in this case, I could clearly see that this JS file contains the component that is a shopping list component. So if I go to the shopping list folder and open up the shopping list.component.js, I could see that I am including, or I'm calling that component on the module called shopping list module. Well, where does the shopping list module come from? Well, there is a file called, as you could see at the beginning here, when we said that we're importing the modules up front, there's a file called shoppinglist.module.js. That's the file where we create and declare our module. Let's go take a look at that. So that's all it is. We're just simply creating this module, calling it shopping list, and giving it, for now, no dependencies. In every other file that we look at, we're simply retrieving that module. Notice that there is no second argument here that's an array. That would be declaring the shopping list module again, which would erase basically everything that's been placed into that module from before. So we're not declaring the module, we're retrieving the module and then calling the component method on it. And basically, in this case here, we have this shopping list component controller sitting right inside of the same file, which is sometimes people break that out and make that into a separate file altogether, and then somehow glue them together again by possibly declaring this as a controller on the module itself and just simply having Angular putting those two things together. And you can see that there's a factory here, and it's exactly the same thing. They're just separate files, but really they're all using this Angular module, Angular.module, retrieving the shopping list module to go ahead and declare on the very same module those same artifacts that we've declared before. Now we also have a spinner module, and you can see here spinner.module.js. Also, all it does is just declares or creates the module, and then let's say something like spinner.component.js actually attaches a component to the spinner module. And this whole thing, this whole spinner folder right here, contains everything we need for our loading spinner implementation. So you can see here, if we'll move this a little bit, not only do we have actual JavaScript, but we also have template.html, and that's where this comes in here, where we declare source spinner, loading spinner, template.html, and it's sitting right here in that same folder, and it's that same img tag as it was before. Okay, so I have my browser sync started already. Let's go to our browser, and let's go ahead and try this out. So we'll say chips, we'll say 4 bags of chips, we'll click add. As we click add, you can see that there's no spinner going on here. It's not really working. We can even put cookies here and add that. And something's definitely happening asynchronously because this doesn't show up right away, but still there's no spinner. Well, what's going on? What's going on is actually kind of simple. What's going on is if you look at the shopping list module, we're not dependent on the spinner module. So all we have to do is really take the name of the module, spinner, and go to our shopping list module and say the shopping list actually depends on the spinner module. Once that happens, this declaration right here at the very end, loading spinner, the tag, the element is actually going to be activated by Angular. Before, Angular didn't know what to do with it because it didn't know how to interpret it. So it basically just ignored it. But now, loading spinner will all of a sudden mean something because in the spinner module, loading spinner is a component. Loading spinner is a component, so it will look in the HTML for loading dash spinner as the element. So let's save that. Let's go back to our browser and let's go ahead and say chips, 4 bags of chips. Let's click add, and you can see now our spinner is showing up, so everything is actually working, and even the log methods are firing here, so you can see the events that are flying back and forth. Now, I told you that it doesn't matter how you declare the modules as long as you declare the module that you're using before you try to declare something that is already using the existence of that module. So therefore, if I wanted to, I could take this line right here, cut it out, and as long as I put it in front of the line that actually uses that module, so the script of loading spinner.component.js, well, it uses this module right here. So I can't really put this above that. But as long as I put it this way, let's go back to our browser, it will still work. We'll just put some nonsense here just to test it real quick. As you can see, still working, no problem. But if I go back and try to put this line right here, and try to put this line below this line, which means that the first thing that the browser will try to interpret is trying to retrieve our spinner module and attach a component to it. Well, that's not going to work because the spinner module at this point hasn't even yet been created. So let's save that. Let's go back, and you can already see we have an error. And if we click on that, actually, it will tell you something like module spinner is not available. So because we tried to create a component on a module that didn't really yet exist. So let's go back and fix that. Let's undo that and actually put it all the way back to where it was before. The next thing I want to show you is the config and run method blocks. Let's go to our spinner module.js and let's go ahead and declare the config and run blocks. I actually have it already pre-coded, so I'll cut and paste it here. And you can see here I've created the spinner module, and now I'm retrieving the spinner module in the next line. I could have just actually put it as a .config right here, but it looks a little bit nicer if I do it as a separate line. So as you can see, I'm declaring the config function, which basically just going to say the spinner config fired, and a run function that is going to just say spinner run fired. And I want to do the same thing for the shopping list. And again, I have this pre-coded, so it's the same thing, it's the same config, the same run, except now we're saying shopping list config fired and shopping list run method fired. Let's go ahead and save that. And let's go to our browser and let's go ahead and take a look. Let's close this page and let's take a look. You can see here, spinner is something our shopping list module dependent on. So spinner fires the config of the spinner fired first. Then the config of the shopping list fired. Then again, the spinner run fired because our shopping list depended on spinner. And then finally, the shopping list run method fired. Now, if we go back and change which module is declared first, you may think that this is because the spinner is declared first. That's why its config is firing first. If we go ahead and flip it and save it again, so now the shopping list module is getting read by the browser first, and the spinner module is getting read by the browser second. If we go back to the browser, you'll see that it's exactly the same thing nevertheless. The spinner module config gets fired first because it's a dependency declared on the shopping list module. So that's why the shopping list has to configure itself after all of its dependencies. And the same thing with the run method. The spinner run method gets fired first since it's a dependency on the shopping list module, and then the shopping list run method gets fired at the end. Okay, so let's summarize. Angular.module method takes two arguments to create a module. The first one is the name of the module itself, which is just a string. And the second one is an array of string module name dependencies. Angular.module method with just one argument, which is the name of the module, retrieves the previously created module. Then, once it's retrieved, you could declare components, controllers on it, and so on. The module.config method fires before module.run method. And in fact, all of the dependency modules get configured first, and then the module that declares a dependency gets configured. And the last thing to remember is it does not matter which modules are listed first in your HTML, as long as module declarations, that's where the modules are created, are listed before the artifact declarations like controllers, components, directives, on that module, because those declarations use the existing module which needs to be created beforehand.
In this video, we're finally going to address a topic that takes up the majority of the title of this course: single-page applications. Even in a simple app, you'll probably have at least a couple of different views where the majority of the content on the page will have to be replaced with some other content. One way or another, users need to be able to get from one view in your application to another view. Let's first take a look at some diagrams of traditional approaches to this feature, and then talk about the single-page application approach.
In a traditional client-server communication, as they started calling it Web 1.0, any update whatsoever that the browser needed was handled by the server. For example, the browser would start out by requesting a resource at the URL /page1.html. The server would evaluate the request, find the resource at that URL, and then respond with the contents of some file, probably named page1.html. If the user clicked on some button that required some minor update to the page, even as little as updating someone's name and some greeting, the browser would make another request to the server, this time attaching some data, or request parameters, to the end of the original URL, in this case ID equal to 3. The server would process the request and then send the entire page1.html content all over again, but with an updated name probably corresponding to the ID with the value 3. Such updates are called coarse-grained updates because of the large chunk of data that had to travel through the network for even the smallest updates. As you can imagine, this was a slow experience for the user and also clogged up the networks quite a bit, passing around essentially the same content over and over. If the user clicked on a link pointing to /page2.html, the browser made another request to the server. The server would process the request and then return the contents pointed to by the URL as page2.html. You can see that in this model, the routing from one view to another was clearly a server-side responsibility. With the introduction of Ajax, this picture improves quite a bit. Now when the browser needed a small update to the content it already downloaded from the server previously, it used Ajax to make a background request to the server, which only returned the needed data. This obviously improved user experience quite a bit. Updates felt faster and the server was considerably less taxed, no longer trying to serve thousands of users by reserving the same content to the same user over and over. It was now the browser's job through JavaScript to take the data in this fine-grained update and dynamically insert it into the page that was already on the user's screen. However, there was a disadvantage with this approach. First, if the user wanted to go to the previous state of the view before they clicked on something that made a relatively minor UI update, the good old back button on the browser would not work. In fact, if there was something in their page browsing history already, they would simply leave this page altogether and move to the previous page they were on. I don't want to harp on this too much since this is not a user experience class, but this is a big deal. It's a big deal because it breaks the way pretty much any user expects to interact with your web application. The reason this was happening was because it was still the server, not the browser, that was responsible for the routing from view to view in the web application. So it was still the case that if the user clicked on a link that requested /page2.html, the server had to find that route and return the content pointed to by that URL. In the single-page application, or SPA model, the beginning of the client-server interaction is the same. The browser requests some index.html, and the server responds with the content which comes along with CSS and JavaScript. When the user clicks on a URL that's supposed to take them to a new view, the URL is constructed with the same index.html as before, but it gets followed by a £. That does not cause the browser to request anything from the server, but can be detected by JavaScript and thus processed. Part of that processing might be making an Ajax call to the server to retrieve the relevant template for the view, but it doesn't have to be. Same goes for another click, which can encode some data like ID equals 3 onto the URL. The JavaScript in the browser is what processes the URL change. Using the £, or the hashtag, works for a browser-only routing because the hashtag on the URL does not cause the browser to re-request the resource from the server. Traditionally, the hashtag was used to cause the browser to automatically scroll to a section of the page where the element with the ID or the anchor tag was marked with the name of the hashtag. We discussed this topic in my other course called HTML, CSS, and JavaScript for Web Developers. So look there if you're interested in learning more on this topic. Note that the hashtag also changes the URL in the browser's address bar, thus adding another entry into the browser's history. This is why the browser's back and forward buttons work naturally with this type of setup. The truth is that nowadays these URLs can even work without the hashtags when you configure the server to be in what's called an HTML5 mode. We're not going to mess with the server in this course, so we'll stick with using the hashtags, but just so you know that that is possible. There's another way to approach navigation from one view to the next. This approach does not depend on the URLs whatsoever. In it, we represent each view as a view state. In other words, we represent the view using some JavaScript object that holds the data to reproduce the same visual setup over and over, including the data associated with that state. This is a much more generic way of approaching the whole idea of representing the state of a user interface at some particular point in time. If you think about it, all URL did was encode the state of our user interface with a unique string called a URL. But we shouldn't get stuck on that. We can encode the same data using a JavaScript object and simply tell our navigation system to recreate a user interface based on that object. So the point in such a setup is that URL on the browser address bar is not updated. Only programmatic state of the view is updated. Now, there are options when it comes to which package you use for your routing implementation in an Angular.js app. I'll describe two of the most commonly used ones. One is called ngRoute and the other UIRouter. ngRoute gets installed into your application as a separate JavaScript file. It is not part of the core of Angular.js. It is developed by Google and the community, meaning it's open source, but it has no concept of a UI state. Every route must be represented by your URL. There's also no concept of a nested view. And those couple of features really kind of leave it for an okay router to use for prototyping projects. However, for a more full-featured type of implementation, UIRouter is the choice. It is also made as a separate JavaScript file, and it is not developed by Google, but simply is an open source project that's developed by the community. In UIRouter, UI state is a central concept. In fact, you can have a route with no unique URL for that route whatsoever. However, URL routing is also supported, so you can have a state that is associated with a particular URL. Now, our UI state is updated based on that URL. Also, nested views are supported. And if you don't know what that is, you will see that in a few lectures, and you'll understand their power and why they're so important to use on a day-to-day basis. So all in all, that's really a better choice for more serious projects. And that's why we're going to cover UIRouter in this course. Truth be told is that once you know how to use UIRouter, using ngRoute package will be very easy and familiar, as well as possibly a little bit more frustrating since it lacks some of the really nice features we just described. Let's go over the steps of using some of the basics of UIRouter. The first step is to reference the UIRouter package in our HTML. Since UIRouter depends on the core Angular package, it needs to be referenced and loaded by the browser after the core Angular package. Step 2 is to designate some part in our HTML page where our interchangeable view can be dynamically placed. When the view of a particular state is loaded, it will be inserted into the body of the UIRouter provided custom directive called UI-view. The third step is to declare the UIRouter as a dependency. This is fairly straightforward, and we have seen how to declare other modules as dependency before. Note that the name of the module is UI.router, slightly different than the name of the project itself, which uses a dash. Since UIRouter handles UI states and routing through a URL as two independent functions, it only makes sense why it comes with two essential services, $state and $UIRouter. However, before we can use the state and UI routing services, we need to pre-configure them with some knowledge about the states and URLs in our application. You already know how to do this. You use the angular.config method and inject the provider versions of those services into it so you can configure what data those services will be instantiated with. First, we configure our UI states. We give each state a unique name that we will be able to refer to throughout our application. We can also optionally associate a URL with a particular UI state. Finally, we specify an HTML template, the contents of which will be inserted into the UI view tag in our HTML page. You can also specify a template URL property, and just like in other configurations, the contents of this URL will be retrieved from the server using Ajax if and when this state is activated, and then inserted into the UI view tag. The state method is chainable, so you could continue to specify other state by simply executing another state method right after the first one, and so on. Now, it's very common for users to mistype a URL or have an outdated or just a garbled URL for something. A very common practice is to configure the URL router service provider by executing its otherwise method. This configuration tells the UI router that when it tries to match a browser URL with a URL associated with a particular declared state and it can't find any matches, it should default to the URL declared in the otherwise method. In this case, any URL that the URL router cannot match will default to the URL /view1, which happens to be associated with the view1 state. Okay, that's pretty much it for the configuration. Time to jump into the code editor and try this out in action. Okay, I'm back in my code editor and I'm located in Lecture 36 folder, which is in fullstack-course 5 examples folder. And the first thing we need to do is download the UI router JS file that I specified here that's supposed to be sitting in the lib directory. Well, it actually is already sitting in the lib directory because I downloaded it already, but let me show you how to do this. Now, the annoying part, funny Google, the annoying part about downloading UI router, if you just type in download UI router, is that all the links that will first come up, in fact, if you click on any of these links, will be all the wrong versions. And the version that's constantly coming up is 0.2.14. Well, that's the wrong version. That's not the latest or the latest version that is stable. The latest version that is stable is actually 0.3.1. So how do you get to it? Well, instead of clicking on all these official UI router links, what you should look for is a CDN, a content delivery network. So look for anything that says CDN in it. For example, here's the first one, says the best FOSS CDN for web-related so on. If you click on that and you take a look, the version that is going to be sitting here, or at least one of the versions, is 0.3.1. If you choose that version, and then in this case, I could just have the min, so that it gives you a couple of URLs. One is for the full version. That's if you want to go and kind of read the code of the actual UI router. And the second one is the min and the minified version, and that's the version we want. So we could go ahead and copy this URL, open up a new tab, paste it there, and this is the entire minified version of the UI router. Make sure that if you see the version, or make sure that you do see the version, and the version is saying 0.3.1. Now there's a newer version that is 1.0 that's using kind of more of an Angular 2 approach, even though it could still be used with Angular 1. But that one is still in beta or in alpha or beta at this point, and it keeps updating with breaking changes, so we don't want to go for the one that keeps breaking yet. It's not really stable released. So the way you would get this file is just once you load it in a browser, just right-click it and click Save As. And once you do that, you could go to whatever folder that you're in that you need to place it in. In my case, it's Lecture 36, the lib folder. I really already have it here, so I don't need to click Save again, but that's what you would do when you download it. So I'll click Cancel and go out of this again, and let's go back to our code editor. So this is a very simple app, and it's called Routing App. That's the name of my module. And the first thing we need to do is obviously reference the angular.ui.router.min.js, and we already did that right here. The second thing we need to do is place some sort of placeholder in our HTML where our views are going to be inserted into. In this case, it's UI view right here, and it's going to be inserted somewhere in the body here. And I can see here that I have a div here, a placeholder for something that has a class called tabs. And basically what we're going to do in this application is we're going to have two tabs. If you click on one tab, it will show you the contents of one tab, and if you click on another, it will show you the contents of another tab. Okay, so the next step is to go to our app.js. That's the one that declares our routing app, and actually declare a dependency of our app or of our module on another module called UI.router. Notice the dot, it's not a dash like the actual project name is. And we need to configure our UI router or the UI router services, and we're going to configure them in our config method with this function called routes config. The routes config is going to inject two things, the state provider and the URL router provider. As we discussed, the providers are the ones that are going to be configuring the state service and the URL router service. Okay, so far we really have absolutely no code in here. So if we save that and go back to our browser, we could close this tab, and I already have my browser sync running, and really it's doing nothing more than just displaying our h1 tag at this point. And take a look at the URL. The URL is just a regular, whatever it is, the host is /index.html. If we go back, and the first thing we'll do is go ahead and uncomment this. So URL router provider, the otherwise method is going to say /tab, meaning that if you don't recognize anything that is matching your states, and in this case we have no states, and they have no states that are associated with URLs, go ahead and try the /tab1. If we go ahead and save that, and go back to our browser, you can see that it automatically forwarded us already to /tab1. If I remove that, delete it, and try it again, it automatically will jump right back to /tab1. So that's working. The next thing we need to do is to set up our states. And the way we do that, let's say set up UI states. And the way we're going to do that is using the $state provider. And it's going to have, we'll indent it, a state, and we'll start with the name. We'll call the name tab1. And then we're going to have a configuration object that's going to represent that state. And we're going to associate it with the URL /tab1. And another parameter we'll provide is template. And its template is going to be super simple. It's going to be just div, and this is tab1 content. And that's pretty much it. Let's put a semicolon right here. When we save that, go back to our browser, you could see that this is tab1 displayed because it automatically went to that state. Well, let's go back to the code editor and define one more state. And I'll give it a little bit of space called state. And this time we'll define tab2 state, again with a configuration of a URL of /tab2. And the template we're going to have is going to be another div, but this time it's going to say this is tab2 content. Let's save that. Let's go back to our browser. And now when we manually type in tab2, you'll see that the content switched to tab2 content. If we inspect that, we'll see that UI view contains this div that says this is tab2 content. And if we switch this back to tab1, you'll see that the UI view is now going to contain this div with a this is tab1 content. We can achieve the same thing by using the template URL property, and in this case specifying the URL to a tab1.html template, which already contains these words. So at this point we could just say source, because it's sitting in the source directory, tab1.html, and the second one will say source tab2.html. So if we save that, go back to our browser, we'll see that tab1.html is working, and if we put tab2.html, it's not working. Let's take a look as to why that's not working. Well, pretty simple. We forgot to say URL in the property. So it's treating it as the actual content of the template instead of the URL. So now that we saved that, let's go back to the browser. So now it's actually saying tab2. This is tab2 content. Now, the URL router comes with a very convenient directive that lets us create links and actions in order to go from one state to another. If we go back to our index.html, we could provide those type of links right here. We'll call an a tag, and instead of href, we'll say uisref. And uisref stands for UI router state reference. And we'll give it a state reference of we need the state tab1. And this tab1 is matching directly with the name of the state tab1. So it's looking for the name of the state in this particular attribute value. And we'll go ahead and give it the name called tab1. And we'll do the same thing. We'll copy it. And we'll do the same thing for tab2 since we have a state called tab2. Go ahead and save that. Let's go back to our browser. And now you see we have a couple of links. So if we click on tab 1, this is changing to tab 1. Click on tab 2, it's changing to tab 2. If you take a look as to what actually that UI sref directive did for us, we could take a look right here and see that what it's actually doing is it's creating the href for our anchor tag such that it's pointing to the right URL to invoke this type of behavior to changing from state to state. However, it does way more than that. We can go ahead and omit the actual URL that's associated with the state. For example, the tab2 URL can be commented out, and now our state is only referenced by its state name. But this will still work. Let's go back to our browser. And even though the tab1 is looking like a link and tab2 is not, well, the reason it's not, let's take a look, is because it doesn't have an href attribute anymore as part of it. And the reason it doesn't is because we removed the URL that is associated with the tab2 state name. However, it is still clickable just like anything else. And in fact, if I click it, you'll see it will still change to tab 2. And the reason it's clickable is because of this uisref directive that knows that when I click on this, I expect that my UI router should switch to the state with the name tab 2 that is specified in the uisref. Obviously, this looks a little bit ugly, so we could go back to the code editor, and instead of having a link right here, we could change it to, for example, a button. And a button is certainly something that is clickable. No matter what its href is, which is not even a valid attribute name for it, and we'll save it. I'm gonna go back, and now you see I have a button. If I click the button now will invoke the state transition and will transition us to the state with the name tab2. So you can see we're not bound to just the URL mapping. We can also have simple states. Notice that we're sitting at tab2 state, but yet the URL is still saying tab1. And the reason it's saying tab1 is because that's the only URL that got recorded. So if we go ahead and press and refresh, you'll see that it's still going back to tab1. But tab2 really means absolutely nothing to it because tab2 is not mapped to anything. So therefore, it's going into the otherwise method and then jumping back to tab1. However, there's such a state called tab2. So when I invoke it using my uisref directive, it will still switch our UI router to the state with the name tab2, yet keep the URL exactly the same as before. Let's go back to the code editor, and actually we'll go ahead and comment this out, and we'll place the anchor back to where it was. We'll just change this to tab2. And let's learn about one more UI router directive, and that one is called uisref active. And that directive lets us specify a class, a CSS class, that should be applied to this particular tag when that particular state is active. So I want the class to be active tab, and I'll do exactly the same thing for the second one. So this will get activated, or this active tab class will be attached to this A tag when our state is tab2. And in this case, it will be attached to this A tag when our state is tab1. Now, I already pre-made this class called active tab, and if you take a look at my CSS style, all this active tab doing is just bolding the text, making the text bold. So since we've defined our uisref active, we just have to change the label here, and we also have to go back to our app.js and actually re-enable our URL so we could see the URL changing as well, because we don't want to keep these two states without a URL. They both should have a URL, at least in our case. And now we could go back to our browser, and you could see that tab 1 is bolded, and the reason it's bolded is because we are at that state. If we click tab 2, tab 2 becomes bolded, and tab 1 is no longer bolded because the active state or the active tab class got removed from it. We could actually take a look at it right here, and we'll take a look right here, and you could see that class active tab got placed under the class attribute got placed on the USRef tab 2. If we click tab 1, it will get placed on the USRef tab 1 because that is the active state at the moment. Okay, so let's summarize. UI router uses independent concepts for URL mapping and UI state representation. And therefore, you could really think of those two things as two subsystems that exist inside the UI router package. Now, the way you configure UI router in angular.config is first by providing an alternate URL mapping with the URL router provider service with the method otherwise providing some other URL. That's in case the URL is garbled or the user typed in the wrong URL. This rule will kick in and go ahead and forward the browser to the correct URL that actually does exist within your system. The second way is you configure states with optional URLs, but usually you do use them, but sometimes they're optional, using the state provider.state method. And you provide the name of the state and a configuration object that has a whole bunch of properties. Some of the ones that we've used so far is the URL property that maps the state to a particular URL, and a template URL which maps a particular URL of the actual template that contains some HTML to that particular state. So when the state is activated, the contents of that template are inserted inside of the UI view tag. And you use the UI view tag as a placeholder for your state-based user interface portions. Now you can also use a special directive called ioslate, which stands for UI state reference, as opposed to just an H hyperlink reference. And that is an attribute that you could place on an A tag or really any other tag, and it constructs links for you and actions to configured states. So such that you could, for example, place that on a button, and when you click on the button, whatever state that you specified in your UISref attribute, that state will be activated when you click on the button or you click on a particular link. If you're specifying this attribute on an anchor tag, and your state actually defines a URL that's associated with it, the UISref directive will create the href attribute on that tag for you. So when you click it, it will go ahead and update the browser address bar.
Just like with any template, the HTML we provide in the file pointed to by the state's template URL property, we can declare a controller as responsible for the view model or the behavior associated with that HTML.
Suppose we have a state defined with a template URL pointing to an HTML template, home.html. The home HTML template will then declare a controller using our controller as syntax, home controller as home. This setup is inefficient and perhaps not as elegant as it can be. You could see that the only reason we have the wrapper div tag is to declare the controller. It doesn't seem to have any other value. UI router allows us to pull out this declaration and define our controller directly on the state definition. You could see that now we're declaring the controller using controller as syntax directly as part of the state definition. Since we're not using a function value for the controller in this example, you can assume that we actually declared the home CTRL controller using the angular.controller method. We also have the option to specify the function value instead of the controller's string name if we have access to that function value at this point. The controller as syntax can still be achieved using the controller as property that's also available to be declared as part of the state definition. Note that our home.html became slimmer. While not that common, we can even potentially reuse this home.html template with a different controller somewhere else. And that's due to the fact that we pulled out the controller declaration from the actual template. So this is definitely a much more elegant solution. Let's jump into the code editor and see an example of how this works. Okay, I'm back in my code editor and I'm located in lecture 37, which is located in fullstack-course 5 examples folder. And this is a different version of our shopping list module. In this version, we're going to use some of the UI router features that we've learned about. you could see that index.html that we're looking at right now doesn't really have much in terms of content. It just has welcome to pre-made no cookie shopping list. And then it has a bunch of scripts, Angular.js, Angular UI router, our shopping list module, which is the main module of the entire application, our routes, which is going to contain our state and URL routing, and also some shopping list component, main shopping list controller, and the shopping list service right here. This application is fairly simple. It just has one screen, the home screen, and that home screen contains a link to a main shopping list, and that main shopping list is this pre-made no cookie shopping list. In other words, we are pre-making a shopping list for our users, and it's already containing no cookies whatsoever, so our users wouldn't even be tempted to get one. Let's go ahead and take a look at the routes.js. As you can see, it's using the module.config, and this routes config sets up a couple of states. First of all, it reroutes anything that doesn't match a particular URL in any of the declared states to just a slash, and the slash is actually the home state or the home page. So the first state we're defining is the home, and it is going to be accessible through just a slash. And its template URL is sitting right here, source shopping list templates home.template.html. And we can actually take a look at that. It's a very short template. All it has is one link tag and says CR pre-made no cookie list shopping list. And it's using UIsref, so the state reference, to main list. So main list better be a state that we defined inside routes.js. And in fact, it is. Right here, this is the pre-made list, and it's called the main list, and it's accessible through a URL /main list, and its template URL is pointing right here to main shopping list.template.html, and that is it right there. As you can see, it consists of this wrapper div tag, which declares our controller, main shopping list controller, and gives it a label of main list. Let's dive a little bit deeper into what this is doing, because we're going to be reusing this code in the next few lectures as we learn a little bit more about the UI router. So besides declaring a link that lets us get back to the home screen, again with the UIsref home, because home is a state, it uses this shopping list component, and this is the shopping list component right here that I'm pointing to, and it's using the shopping list component to basically output our list. Let's go ahead and take a look at the shopping list component. I believe it's right here somewhere, shopping list component. And the shopping list component just passes along the items, which is the list of our shopping items, and it is pointing us to the shopping list.template.html. So if we go to shopping list.template.html, we see that we're just going to loop over the item quantity and the item name to output our list. Now, if we look at the main shopping list controller, which is what's outputting this whole list to begin with, you see that we've injected shopping list service into it, and we're using the shopping list service in order to initialize this main list.items. You'll notice that we're using a promise. The get items is clearly returning a promise, since we're using the then method, and only when the promise returns are we setting the main list.items to the result that it's returning. In other words, if we look at the shopping list service, it is done on purpose such that it's delaying the answer and not returning the actual items right away, but returning it 800 milliseconds later. So a little bit of a delay. You could see also that we predefined a whole bunch of items here. You could see that we're creating items, and items now have a description to them. And there's the sugar item, there's the flour item, there's the chocolate chips item. So there's 3 items in our shopping list. And the reason we're using a promise is because we're basically simulating a call to the server. So suppose this something was sitting in a database and we're pulling out this list out of a database. We need to make a server call. So that's what basically we're doing. We're simulating the server call. That server call comes back to our shopping list controller right here, and the main list.items gets set, which then goes to our main shopping list controller or main shopping list template, and is able to then pass the main list.items into the shopping list component. That goes ahead and outputs the shopping list. So let's go ahead and make sure everything is saved. Let's go to our browser. We could see that our welcome screen is just starting with #/, which is our home state, and we could click on this CR pre-made cookie shopping list, and there's a little bit of a delay, as you could notice, before it outputs the entire list. And you can see here we're at /main list. And obviously, since the state has a URL map to it, we could go ahead and copy this URL, open it up in a different tab or really a different browser, and we'll still get exactly the same UI state as this URL is indicating, being that it is the main list that is pre-made list with absolutely no cookies in it. Okay, let's close this and let's go back to our code editor and let's go ahead and pull out this whole div because, as we said, it's a little bit superfluous. In fact, we're just going to go ahead and copy this item, which is the declaration of our controller, which we're going to reuse. So let's go ahead and actually comment out this item and comment out the last div. So this is just going to be just this as part of this template. Let's save that. Let's go back to the routes. And instead of just declaring the template, we're going to declare one more thing. There's already a comment there. We'll say controller, and we'll paste that in here. So now our controller is declared on the main list state that is associated with this particular template. Let's go ahead and save that. Let's go back to our browser, and you can see it's already working here. But if we click back and we'll click again, and there it is, it's showing up, and everything is working as it should. Okay, so let's summarize. We can declare a controller that is responsible for the state's template right in the state's declaration, not just in the template itself. In the state declaration, we can use a syntax of controller as the property of the state declaration with a string of controller as syntax, in this case, for example, ctrl name as some label, and the whole thing would be a string. Or we could use controller and reference the controller function value and also use controller as property and give it a string label that we could later use to refer to the controller in the template. In the template itself, we could use the label that we declared in the controller as syntax and then access with the dot notation the data as usual with controller as syntax that we've done before.
In the previous example, we had our routing switch to a state which was configured with a controller. Inside of that controller, as part of the very first action in the $ on a init function, we reached out to an asynchronous service to retrieve the data we needed for that controller to function. There's some disagreement in the community if this sequence of events is backwards or not. Some say it would be definitely better if part of the transition to the next view, the next state, we first retrieve the data needed and then simply pass that data to the controller. Well, with the state's resolve property, we could do just that and more. Let's take a look at the syntax.
You could see that here we're declaring a state by the name of view1. You can also see that we're declaring that state with the controller view1 controller as view1. But now we have a new property called resolve. Resolve is a configuration object that has some key and value pairs. The key myData has something that we haven't really seen since the very beginning of the course, and that's because we've been using a much more elegant injection that I'm using here in this example. But all we're doing here is protecting our function that gets the service injected into it with some minification protection. So if you remember from the very first lectures that we had, if you provide an array with a bunch of strings, the last value of which is a function, those strings in the order that they are declared are going to be considered the items that you want to inject into that last value, the function value, and its arguments will match up to the declared injection artifacts that were listed in the same array. So here we have an array with the first value, which is the string service, and the last value, or the second value, is a function value that takes a service as an argument, which means Angularjs will inject the service into that function. Note that service.getData returns a promise. At the end of this, myData is going to have a value which is going to be injected into the view1 controller with a key of myData, which means just like we inject a controller with a service called myService, for example, we will be able to inject our view1 controller with yet another artifact by the name of myData, which matches exactly the key inside the resolve object. Now, if the resolve property, in this case my data, gets assigned a promise, which is also the case in this example, the router will not advance us to the new state, in this case view1, until the promise is resolved. If the promise gets rejected altogether, the router will not advance us to the new state at all. Inside of our controller, the view1 controller, we inject my data just like we would inject anything else that needs to be injected into our controller. We protect it from minification by declaring it on the $inject array and then simply list it in the same order as one of the arguments to the function view1 controller. The resolve properties don't have to be promises. They can actually be anything we want to inject into the corresponding controller, even a string as this example shows. Okay, let's jump back into the code editor and rewrite our previous example using this resolve property. Okay, I'm back in my code editor and I'm located in lecture 38, which is located in fullstack-course 5 examples folder. And this is really the identical application that we left off in lecture 37. As you can see here, in the main list state, we have a controller called main shopping list controller. And if we go to that controller right now, we could see that on the $init, we're calling this shopping list service that we know to be an asynchronous service, and then when the promise gets resolved, we set the main list.items to the result, meaning the array of the shopping list items. Let's go to the browser and see how it behaves. When we click on this link, you'll see that it goes to main-list. You can also see that this list pops in a little bit about 800 milliseconds later after the entire view, the main list view, comes into the browser. And that is because we're switching the view first and then going to get the data. That's not necessarily the best thing to do. It also looks a little bit weird that we switched to a view before we know whether or not there's any data in that view to begin with. So let's go back to our code editor and create a resolve property on our route. Let's go back to the routes.js, and besides for declaring main shopping list controller as main list, we're going to put a comma here and we'll call another property called resolve. And the resolve property is going to have one item, or actually it's going to have one item called items. And the items property is going to resolve to a promise that it gets returned by the shopping list service. So let's go ahead and declare an array because we want to protect our shopping list service injection from minification. And we'll say shopping list service. There it is right there. We'll put a comma and now we'll put the function. The actual function is going to retrieve that shopping list and we'll inject it here again, shopping list service. And inside here, we need to return our shopping list service .get items. So now this will immediately return a promise and the UI router will then wait for the items property to get resolved before it takes us to this main list UI state. Okay, so now that we're retrieving this data up front in the actual state transition, let's go ahead and save that. Let's go back to our controller and we really no longer need this. We'll go ahead and comment that out. What we do, however, need is, and we'll actually comment this out as well, and maybe just duplicate it because we do need this, but we need to inject something else in here. We need to inject our items from the resolve. Let's copy that. Let's go back and inject the items right here. We'll also need to inject these items here as well. Let's go ahead and duplicate that. That way we could at least keep it for our records. So you'll see the difference. And we'll just copy and paste it right here. So now here I need to inject items. Those are the same items that are here. And all I really need to do here is just say main list that items equals to items that are passed into our main shopping list controller. Let's go ahead and save that. And let's go back to our browser. And we could see something's not working. Let's go ahead and take a look as to what's not working in the console. And nothing seems to be appearing. So let's go back to the code editor and see what we might have messed up here. We have the main list that seems to be working. Oh, and I see that I said item instead of items. Okay, let's save the items here. Let's go back to the browser, and it already switched us to the next transition. So let's go back to home. And when we click on pre-made no cookie list, you see it's not going anywhere until the entire data is there, and then the whole thing shows up immediately. We could try that again. We click, 800 milliseconds later, the entire thing shows up. So the actual getting of the data, the asynchronous communication, is happening when you click this link, not after you click this link. So by the time we click this link and the controller gets invoked, it already gets invoked with all this data and it gets displayed immediately. And coincidentally, I just noticed that list here is spelled with lowercase l, which is probably not a good idea for consistency's sake. So let's go ahead and change that really quickly. Main list is now going to be uppercase everywhere. And I think we're good to go. Let's go ahead and test it one more time. And you see that's still working. So we're all good to go. Okay, so let's summarize. The resolve property can be used to inject values directly into the controller responsible for the state, and that is declared on the state's configuration. If the resolve property is a promise, the router will wait for it to resolve before transitioning to the new state. If that promise is rejected, the router will not transition to the new state at all. The name of the key in the resolves property object is what is to be injected into the corresponding controller's function. Also note that while it's very common to use resolve to resolve a promise before you transition to the new state, resolve properties can contain anything, objects, strings, etc.
URLs often encode a state of the view that requires more than just a name. It may require some actual data that can change how the view is constructed for the user. For example, imagine a weather forecast web application which displays the forecast based on a zip code. The view showing the weather forecast for a particular zip code would then contain that zip code as part of the URL. With UI Router, mapping URLs with parameters and retrieving those parameters is very straightforward. Let's take a look at the syntax. First, we declare the URL property with a slash and the name of the parameter wrapped in curly braces. Next, we inject the special state param service that UI Router provides either into our controller directly or into the function that populates our resolved property data. Then we can retrieve the value of the passed-in parameter by using the state param service with the dot notation and the name of the parameter. In this case, it's .param1. Now, when it comes to mapping the URL, the rules are pretty straightforward. There's no special treatment of the trailing slash, so the pattern on the left will match a simple /view1/ with the parameter 1 being equal to an empty string. This type of mapping will also map to /view1/hello or /u1/12. On top of all this, UI Router has syntax for being more specific on how a parameter is matched. It even has support for regular expressions, so you could specify the match for your parameter using a regular expression. Going back to our example, once the parameter is matched, some data is retrieved based on a parameter and stored in the MyData resolve property. The MyData property is available to be injected into the View1 controller, just like we've done before. If you wanted to use the UISREF directive to construct a link or an action to transition to the state that expects parameters, the value of the UISREF would be the state name being invoked like a function. Its argument would be an object which contained parameter name value pairs, where the names would have to match the expected parameters exactly. Okay, let's go back to the code editor and see if we can display some details about each item in our shopping list. Okay, so I'm back in my code editor and I'm located in lecture 39, which is located in fullstack-course 5 examples folder. And right now we're looking at routes.js. And the way this application stands right now, it's basically a copy of lecture 38, which is one lecture before this one.
Let's take a look at the browser. So here we have welcome to pre-made no cookie shopping list. If we click our pre-made no cookie shopping list, you'll see that the list will appear right here. What we would like to do is we would like to be able to have each one of these items right here clickable, and when I click it, it should show me the details about this particular shopping list item. If you remember, when we look at our shopping list service.js, you'll see that besides the name and the quantity, we also have a description of each item. So we should be able to get at that description, but one item at a time. Let's go ahead and close this and let's go to routes.js. So the first thing we need to do is we need to add that state that displays the item detail. Let's go ahead and scroll all the way to the bottom here, and we'll open up and make one more state, and we'll call the state item detail, and we'll configure the state with a URL, and the URL will be /item-detail / and we'll give it a parameter because we need to know which item ID 0, 1, or 2, because we have 3 items and this is an array, so it's 0 based. We need to know which index in this item array we're trying to look at, and we'll call this parameter item ID. Okay, so now we have the URL mapped. Let's go ahead and create a template URL, and we'll point it to something I already have, which is the item detail.template.html, which is sitting right here. And basically all it is a couple of links, one taking you to the home state, the other one taking you to the main list. And basically all this does is says, here's the item name, and the item name is, for some reason, repeated here twice, which I'm not sure why, but maybe we styled it a little bit different. But point is, we're outputting the item name, the item quantity, and the item detail all at the same time, so we see a very detailed list. Let's go back to the state configuration. It will give it the URL for our template of source shopping list /templates /item-detail.template.html. Okay, we'll put a comma over there. And we'll also specify a controller, and the controller will specify called item detail or detail controller, and we'll say it as item detail. And we also have the controller, the item detail controller here, just started right here, so we just registered it. We didn't really do much with it yet, so we'll do that in a second. So now that we have the controller, we need our resolve property, because we're going to have to pull those items from our shopping list service and then pull out just the item that we need based on this item ID parameter. So we'll say resolve. We want it to be resolved before the state is activated, and we'll call it item. Before it was items, and now it's just one item. And again, we'll put a square brackets for an array. And what we need to inject here is, number one is state params. That's what's going to give us the value of this parameter. We're going to pull it out from the state param service. And we also need our shopping service, shopping list service, because that's where we're going to get the entire list of items. Okay, we'll put a comma here, and then we'll say function. And we'll probably just actually put it on the next line so it won't be so messy. And this function now is going to take state params, because that's what we specified, and shopping list service. Okay, in fact, let's just put it right here. There's no really good way to format this properly, but maybe we'll just move this like this, so at least it'll be a little bit more legible. Let's maybe one more time. Okay, so what do we need to return here? Well, we need to first return the promise, and the way we return a promise is by calling return shopping list service dot get items, but we don't need all the items. We need to say then. And we need to, since then also returns a promise, as you remember, those things are chainable, we're going to have to open a parens, and we'll close it right here with a semicolon. But inside, we need another function, the success function. And the success function is going to return our items, right? So let's maybe indent it one more time here. Let's create then. Here we go. So then this is where the function ends. Maybe we'll leave it right here. And so inside of that function, we need to return the items that were passed to us through this asynchronous shopping list service, but we need to look up this specific item that is being referred to by the item ID. And the way we could do that is by using our state param service, state params, dot item ID. So now this item ID, whatever it is, 0, 1, or 2, is going to get placed inside of these square brackets, and therefore we'll find the right item in our items array, and that's the item that's going to get assigned to the item resolve property. Okay, let's put a semicolon here, and let's save that. Okay, so we're good to go here. We have the item, and we're ready to inject this resolve item into our controller, and our controller is item detail controller. Let's go ahead and copy the item. Let's go to our item detail controller. So the first thing we need to do, well, we're going to put an item right here, but we also need to make sure that we protect our controller from minification. So we'll say $inject, and we'll open up an array, and we'll say item right here. So now we're injecting this item into this item detail controller. And what we need to do here is we need to expose those properties of a particular item that our template expects. Let's take a look at our template again. Our template expects the name, the quantity, and the description. So let's go ahead and do that. We'll first say item detail.name equals to item.name. That's the item that was injected into our controller. Then item detail.quantity equals item.quantity. And also item detail.description equals to item detail or item.description. Okay, so now we've injected that item and we've copied the item's properties onto our item detail, which is the instance of our controller, which is what we're using inside of the template. Okay, so far so good. We should be able to save all this and then go back to our browser and be able to invoke this item details with a particular ID. Let's go there and let's go to our browser and let's go ahead and say it's #/item detail. We ended up having 2 slashes here. We don't need that. And instead of slash with a curly braces, we'll say 2. And when we do that, you see we get all the item details for number 2. Now the only thing we don't have here is that these things are still not clickable. We can make them clickable using our UISref directive. Let's go back to the shopping list template. And the shopping list.template.html is something that belongs to the shopping list component, and that's a thing that loops over our items when we display our main shopping list and puts them in these bulleted list. Okay, so what we want to do is we want this item to be clickable. So let's go ahead and enter our UI-sref, and we'll have it equal to, we have our name of the state, which is item detail. Let's copy that. We'll place it right here, and we're invoking it as a function with an object, and the object is supposed to have our item ID, and the item ID is going to be whatever it is right now through the ng repeat loop, which we could specify by using just $index. That's the index, and let's maybe clean it up a little bit so we could see it a little bit better. There we go. So now we have this as a clickable item. The only thing that we don't have yet is how do we display it to the user that it's clickable? In other words, when the user rolls over this item, we want some visual effect to kick in. Well, actually, I already pre-coded that, and we're using this attribute UISref as the selector in our CSS. So if you look at our styles.css, scroll down here, we say that any li that has a UISref, on hover, we're going to make it block. We're going to make the cursor the pointer. We're going to highlight the border around it with black 1 pixel, and we're going to increase the padding a little bit left and right. Okay, let's go ahead and save all that. Let's go back to our browser. Let's start from the very beginning. When we click on the cookie, it will wait about 800 milliseconds. It will get here, and now as we scroll over each item, the cursor turns into a pointer, and now we could click on it. And if we click on it, take a look what's going to happen. Well, we clicked on the first item, which is item 0. Now our URL is item detail/0, and we see the item 0, which is sugar, and get our description here. Sugar used for baking delicious baked goods, right? And if we click back to the list, it's going to take 800 milliseconds. It will take us back to the list. We'll click the second item. It will take a little bit, and we get item 1, which is the second item in our array. And again, we get all the names and descriptions. And that, by the way, that initial span that we spoke about, let's go back to our template and see that initial span that's displaying this? Well, that's just part of the breadcrumbs that we're creating as kind of on top as to where we are. We're at home, list, flower item. So we can go back all the way to home and everything is working as it should. Okay, so let's summarize. The state's URL property can be declared with parameters. Parameters are wrapped in curly braces after a slash. Parameters can also have more complex matching rules other than just a string, and in fact, UI Router supports even regular expression matching. Once the browser goes to the URL that is matched by a URL with parameters, in order to retrieve those parameters, you use the $stateParam service. And the way you retrieve it is by specifying stateparams dot the param name that's declared in the URL of the state. When you're trying to construct a URL with the UI-sref directive, you specify the state name as a function name and then pass an object into that function such that the keys in the object are the parameter names that have been declared in the state's URL property.
Sometimes it just doesn't make sense for a view to be declared and treated as its own UI state. For example, it's quite common to have a list of some items, and when the user clicks on one of the items in the list, the user would then see the details about that item without leaving the view that displays the entire list. The two views, one being the entire list of items and another being the details about a particular item, is often referred to as the master detail view pair. Not every master detail view pair is suited to remain on the user's screen at the same time, but some certainly are. A really useful feature of UI Router is that child states inherit resolves and custom data properties from the parent states. Among other things, what this means is that if the parent state already made the call to the server and retrieved the data, the child state need not repeat the process. It can simply use the parent's existing data without making another server call. Let's take a look at the syntax of declaring a child state.
The child state is usually declared with a dot notation specifying the parent state name dot child state name. When set up this way and the child has its own URL assigned, its URL is concatenated to the URL declared for the parent. So for example, if the parent's URL was /view1, this child's URL would be /view1 /detail /some value for param1 parameter. Having a child state also means that somewhere in the parent's template there's a declaration of the UI view into which the child template can insert its own template. This setup is really no different than the UI view directive that's placed directly in the main HTML page. As far as the inherited result properties, they would work as follows. Suppose the parent state declared a resolve property called byData. If there was a child state declared with a controller named childControl, that would mean that we can inject the myData property directly into the childController function. In a lot of scenarios, this type of setup allows us to avoid extra server-side calls as we can reuse the data already prefetched when the parent state gets activated. Let's take a look at an example of how to use child states by displaying the details of a clicked shopping list item right inside of the main shopping list template. Okay, so we're back to our code editor, and we're located in lecture 40, which is located in fullstack-course 5 examples folder. And this is pretty much a carbon copy of where we left off in lecture 39, plus I simplified a couple of minor things. What we see here, if we scroll down and look at the states, is that we have the main list that we were working with, which basically lists all of our shopping items, and we have this item detail state, and the item detail state takes one particular item based on the state params and based on the item ID and displays all the details about that particular item. The problem is that it displays those details in a completely separate screen, so you don't see the complete list of the items, you just see the detail about this particular item. Also notice that main list already has a resolve property called items, and it's actually calling the shopping list service getItems method. If you look at the item detail state, we're basically doing the same thing, except now we're filtering that list down to one item using the state params item ID. Let's jump to the browser and see how this works again. So we click on this link and we see a list of these items, and if we click on one of them, you can see that the /item-detail 0 shows up in the URL, and we notice that we see the description of the item, but we don't see the entire list. And it's because we went to a completely different and really unrelated UI state. Let's go ahead and fix that by making the item detail state a child state of the main list state. So the first thing we're going to do is we're going to copy the name main list, and we're going to place it right in front of item detail and put a dot in between them. So it's main list dot item detail. So now this state became a child state of the main list. We can now remove the resolve property from our child list. And the reason we could do that is because we're already going to get all the items from the parent, so we don't need to ask for them again and then filter them. We could directly inject the items resolve property into our item detail controller. So let's go ahead and scroll down here and remove this whole resolve property altogether. Okay, let's take the comma out as well and save that for now. So now we could go to the item detail controller and go ahead and inject the items property and then find the item we actually need using our state params. Let's go to the item detail controller, which is right there. And instead of injecting the item in here, we're actually going to inject items, because items, as we spoke about, is coming from the parent state. Okay, so let's go back, and items it is. And in this case, we need to inject one more thing, and that's state params. So the state param service, $state params. And we need that because we need to look up the item ID that is on the URL. And we'll go ahead and put it here as well, state params. Okay, so now what we need to do is we need to find the item based on the item ID that's on the URL. So we'll say var item equals, and we'll use state params dot, and we'll go back to the route, and we'll see that what we're actually looking for is this right here, item ID parameter. We'll go back to the controller. So we'll place the item ID right here, and this is the index into our items array. So really all we need to do is say items array of index of, I should say, of state params dot item ID. So now our item is the object with the index that was passed in through the URL. And now we could set the item detail of name, quantity, and description. Okay, let's go ahead and click save. There is, however, one more thing we need to do before we move on. When the user clicks on the list item, the URL needs to be constructed properly, and that is sitting inside the shopping list template.html, which is the template for our component. Currently, what we have from the past here is just item detail. Well, that's no longer going to do because the name of our state is no longer item detail. The name of our state is mainList.itemDetail. So we'll copy that. We'll go back to the UI sref and we'll go ahead and replace that with mainList.itemDetail. Let's go ahead and save that. And before we can do anything else, we do need to go to our main shopping list and go ahead and place this UI view holder right here. So our main shopping list will be handled by this shopping list component, and then the UI view is where the child will insert its template when it is selected, right there. Okay, so let's go back to the browser and we'll click our link to see our list. And now we should be able to click on one of these links right here, and we messed something up right here because it's not interpolating properly. So let's go back to our code editor and take a look as to what's going on here. And let's see, this looks pretty good. The controller, the item detail controller, seems to not be setting these names. Oh, and you can see the reason why, because we injected items and yet we're not saying items, we're saying item. So we need to actually reference the items that we injected into the item detail controller. Let's save that. Let's go back to our browser. And you can see now it's all working. So let's go back to home and we'll click and you can see it's right there. And when we click one more time, you can see that now inside of this template, we have one more template inside of that that is being displayed, and that is the detail of the item that we clicked on. And as we click on different items, you can see it's happening instantaneously. And the reason it's happening instantaneously is because we're no longer requesting any items from the shopping list service. Those items were all loaded right here in the parent state, which was the main list. Also notice our URL. main-list/item-detail/0. And I can actually manually change it if I want. And you can see it's manually changing right there. Our item detail URL became sort of like a sub URL to the parent main-list. Now I told you before, URLs are optional. So technically speaking, we could go back and go to our routes and comment out the URL of the child. There is, however, a caveat to this. If we comment out the URL of the child and it happens to have a parameter, UI router will not know to expect a parameter like that. Therefore, it requires us to give it one more property called params, and in the params, it requires us to give the UI router the name of the parameter with some value. So in this case, we'll give it, I don't know, null. It really is good enough. Once we do that and we save it, notice that our child state no longer has a URL that we're going to be able to identify the child by, but we'll still be able to get to the state of the child because of the link that we made inside of our shopping list. Main shopping list, we made the link, or I should say inside the controller, we made the link. We're making the link right here, and even though that link is not necessarily going to be a URL, but it will be an action type of item where somebody clicking on it will invoke the state transition into our child state. Let's go back to the browser and let's check that out. Let's click on this one first, and you can see here it says main-list, that's correct. And if we click on 2 bags of sugar, you'll see 2 bags of sugar show up, and we are in that state of UI, but if you look at the URL still stays at main-list. And that is because we've invoked the UI state, but we did not associate a URL together with that state. We simply commented it out and provided it a hint that we are expecting an item ID as a parameter into that UI state. Okay, so let's summarize. Nested states allow us to logically represent nested views. The parent state template has a UI view placeholder in its template for the child's template to insert its HTML. The child state name is usually declared with the syntax parent.child. In other words, the parent name, then dot, then the child name. The optionally declared URL of the child gets concatenated to the declared URL of the parent. So if the parent URL is /view1 and the child's URL is declared as /detail, the full URL of the child will be /view1/detail. Also, a very important feature that UI Router implements is that the parent's resolve property is inherited by the child and is injectable directly to the child's controller. Among other things, this allows us to avoid multiple server-side calls that keep fetching the same data over and over. Instead, the child simply can inject the data that is already prefetched by the parent directly into its controller.
Since the router does a lot of things in the background, including potentially reaching out to a server and fetching data, it's very useful to be able to plug into different events that occur as the router performs its functions. All your router events are fired at the $root scope level. In other words, all events broadcast down the document object model tree for any node to potentially respond to the event. I'm not going to go over every event that the UI router provides, but let's take a look at some of the events UI router exposes that we will make use of in our example. For a complete list of the events and when they're fired, please see the UI router documentation.
The first one is called $state change start. And that event fires when the state change transition begins. So if you know that's going to be somewhat of a long running transaction or it's going to wait for some server responses, probably this is the time to fire off some sort of a spinner to let the user know that we're waiting for something. If you started a spinner when the $state change start event fired, now would be the time to turn it off since the transition is complete. The same goes for the $state change error. That fires when an error occurs during the transition. Now the UI router documentation points out an important point. If any errors occur in your resolve function, they will not be thrown traditionally. In other words, you will not see any errors in the console and everything will appear normal when in fact there's an error. You have to listen for the $state change error event to catch all errors that occur during state changes. If you wanted to catch the transition right when it starts and based on some data evaluation stop the transition from occurring, you can call prevent default method on the event object to stop the transition from going forward, essentially canceling it. Okay, let's get back to the code editor and enhance our shopping list application with some router events. Okay, so we're back in our code editor and I'm located in lecture 41, which is located in full stack-course 5 examples folder. And this code sample is basically the same as lecture 40, but we're bringing our spinner back. Except we're bringing our spinner back and it's now going to respond, instead of to the custom events that we're throwing, it's going to respond to the events that the UI router is throwing. So the first thing we need to do is go to our shopping list module.js and import our spinner module. And we see here we're importing the UI.router and we're importing the spinner module as well. Now the spinner module is going to be slightly different. Let's go ahead and go to the component.js, which is where the main logic is located. We're declaring the component loading spinner, and the component is going to have the spinner controller. In this controller, we're going to do the following. On the $init, we're going to go ahead and listen for some of these events. Number one is we're going to listen for the state change start event. And when the change state start event fires, we're going to respond by setting the controller show spinner to true. Well, show spinner equals true will turn on our spinner image and make it visible. If we look to our components template, and you'll see that we have an ngIf with the controller and show spinner. So if the show spinner property is true, this image will show up. Let's go back to the component.js. So point is, if we detect the $state change start, this is when the UI router is starting the transition, it will turn the show spinner to true. It will also remember the function that the on method produces, because that function is something we could cancel listening for this event later. And what we're going to do is we're going to have outside of our $init function this cancelers array, and we're basically going to push our cancel for this particular event, our cancel function, onto this cancels array. And you'll see in a second why we're doing that. We're also going to listen for $state change success. That means that the transition has finished, and therefore we can go ahead and turn off the spinner by setting show spinner equals false. Once again, this listener will get pushed onto our cancelers array that we'll use later. And the last but not least, the state change error. So if any error occurs, we don't want our spinner to keep going on and on forever. We want the spinner to stop. And therefore, we're listening on this state change error, and we're also setting our show spinner to false if that occurs, because that means the transition really has ended, unfortunately, unsuccessfully. And once again, we're taking the canceling function for that listener, and we are pushing it onto our cancelers array. Okay, so the very last part is that we're using the lifecycle method $onDestroy when this scope is getting destroyed. We're going to go ahead and take our cancelers array. That's what we've been pushing everything on since it's sitting outside of the $init. we're going to take this cancelers array, and for each member of that array, we're going to go ahead and invoke this function and take the item in that array, which is what is going to get passed into it through each iteration, and we're going to invoke it, canceling listening for that particular event. Okay, so all that's left is to save, go to our browser, and let's try this out. We'll click, and you can see it's spinning, showing us that something is working. So if we click on here again, it's so quick, and since we're not really reaching out to any asynchronous services, it's so quick that we don't even see that at all. So as we keep clicking here, we're not going to see the spinning, but if we go home again and click on this, we'll see the spinning again, and that is an indication to the user that something is going on while the next state is loaded. Okay, so in a nutshell, that's pretty much the features of UI Router. And believe it or not, we actually went pretty deep on that topic as well. Before we finish the entire UI Router topic, I do want to show you where to get documentation for this UI Router. Go ahead and Google UI-Router. You can even Google Angular, and you'll see that you'll get to this GitHub page, which is going to be the UI Router GitHub page. What you want to do is, it's a little bit unfortunately confusing the way they've set it up here because there's so many versions flying around, and most of them, again, unfortunately, are pointing to the wrong one. What you want to do is you want to scroll all the way down on that page, and you'll see an in-depth guide link. If you click that in-depth guide link, by and large, this documentation is pretty accurate, and it's actually pretty good. Another thing to point out is that very soon, hopefully, the UI Router is going to release its 1.0 version. And the 1.0 version is going to be very much component-centric, which is something that Angular is really moving towards in Angular 2 and in Angular 1 as well. It's moving to the component-based architecture. So watch out for that, and once it actually is released, you will no longer even have to specify controllers in your states. You will directly be able to specify components that are responsible for handling the entire state that you're defining. Okay, so let's summarize. UI Router exposes numerous state change events that our code is able to listen out for. All UI Router events are fired on the $root scope. There are several events in particular that we probably are interested in almost all the time. One of them is $state change start. That is the event that signals that the state transition has started. You could call event.preventDefault to prevent the transition from finishing. State change success indicates a successful transition end. And state change error indicates that the transition failed, including having some errors in the resolve. Now you need to listen for this particular event, $state change error, to catch all errors during state transition. For example, the errors that come out from the resolve functionality are not displayed in the console and are basically swallowed, and the only way you could look at them is to actually listen out for the state change error event of the UI Router.
Congratulations on finishing Module 4. The skills you now possess are enough to produce really nice and elegantly designed single-page web applications. All that's left is to practice. In the next module, we're going to leave the classroom behind and get out into the real world for a bit. You will get to go on a fun field trip with me to meet with our real customer and get familiar with their business. Then you'll sit right next to me as I code up a real Angularjs application that will be used by real users. While I'll still be the one writing the code, you will get to observe a step-by-step creation of a real web application using Angularjs up close and personal. See you in the next module. This thing is hard to open. What? Come on. It's corn. Corn is a vegetable. Yeah, corn is a vegetable. Corn is a vegetable.
It's very important. See you in the next module. They're really good vegetables.